89. Translations from Europe and the beginning of Ming calendar reform. In December 1610, the Astrocalendric Bureau predicted a solar eclipse that was challenged in and outside the Bureau. The prediction was 2 marks late according to the observatory chief in the Bureau, or 3 marks late according to a high official in the Ministry of War, who had also sent in a report on the eclipse. Diego de Pantoja, in China since 1599, had made a more accurate prediction, which Chinese associates of the missionaries knew about. The supervising Ministry of Rites called for imperial approval to study calendar reform, but, as before, the Wanli Emperor's court did not act on the request. In mid-1611, however, the Ministry of Rites again urged the court to initiate calendrical reforms. 82 In its report, the ministry this time noted that for the 10 eclipses reported during the Wanli reign the error in prediction usually ranged from 1 to 2 marks and rarely exceeded 4 marks. To keep such errors from getting worse, however, reforms were needed, according to the ministry. Officials should be appointed to compare alternative systems with the Ming calendar, they urged. Moreover, the ministry reported that the Astrocalendric Bureau Director, Zhou Ziyu, had recommended translation of some relevant overseas works in the possession of 2 foreigners from the Great Western Ocean, Pantoja and Sabatino de Ursus. The report justified this recommendation by citing a 1382 precedent for translating Muslim works. 83 Xin Yunlu, who had called for calendar reform in 1597, and Fan Shaoji, who had noted that the 1610 eclipse prediction was off by 3 marks, were recommended for appointments to supervise the reform. In addition, the ministry put forward the names of 2 officials who also wished to work on the translation of foreign works on astronomy. They were Su Guangqi, by then serving in the Hanlin Academy after taking his palace degree in 1604, and Li Zhizao, a 1598 palace graduate and the former vice-director in the Nanjing Ministry of Rites, then in mourning for the death of his father. Both Su and Li were convents of the Jesuits and admirers of Matteo Ricci. Su had been baptized in 1603. Along with Li Zhizao, whom Ricci baptized in 1610, Su had studied under Ricci continuously from 1604 to 1607. They were RST impressed in 1600 with Ricci's revised map of the world and its VE continents, completed after his 1582 arrival. It was published in Chinese as the complete map of the myriad countries on the earth in 1602 with the help of Li Zhizao. The group had already completed a number of translations, such as Su's contributions to the 1607 Chinese version of the RST 6 chapters of Euclid's. 90. Elements of geometry. Ricci's writings on mathematics and astronomy generally relied on his teacher Clavius's Latin editions. Ricci's translation of Cosmology, printed posthumously in 1614, called The Structure of Heaven and Earth, was based on Clavius's commentary on the Tractatus de Sphera of Sacrobosco, an elementary textbook that defended the Ptolemaic system. Along with the elements, Sacrobosco's cosmography was taught at the Jesuit colleges in Portugal and elsewhere as an aid to navigation using applied mathematics. 84 Until the eclipse controversy of 1610, Su Guangqi had been more interested in the new mathematics, which he linked to traditional measurements based on the relational features for the sides of a right triangle, for reform of Ming agricultural practices and for water control measures. His translation and publication of the Western techniques of hydraulics was a case in point. Su Guangqi and Xiong Minjiao together worked with Sabatino de Ursus to translate the Western techniques and had it published in 1612 to introduce European principles of water management. The preface to the translation equated studies of numerical correspondences between the heavens and earth with studies of the investigation of things and exhaustively mastering principles, an indication of the accommodation between European and Chinese learning that the Jesuits and their converts were seeking in their translations. The Western techniques was later included in Su's magnum opus, published posthumously as the Complete Works on Agrarian Management, and reveals how early modern European learning was also applied to statecraft issues and traditional agrarian crafts, pharmacopoeia, and horticulture. 85 Although Su Guangqi and Li Hizao were interested in working on the translations for the calendrical reforms, the Wanli court again took no action. Up to 1619, the emperor tolerated calendrical reform proposals but did nothing about them. Rather than entrenched conservatism, it was his inaction that made such proposals moot. The Ministry of Rites, however, had clearly recognized the serious dimensions of the calendar problem. In 1613, Li Hizao was summoned to Beijing from mourning in Hangzhou to begin work on the reforms, while Zhou Ziyu as director of the bureau ordered revision of Chinese methods used to calculate the calendar and predict eclipses. 86 Zhou intended to use Western methods to correct the errors in the Grand Concordance astronomy system, but this was not yet done because the Jesuits only had Clavius's original works on astronomy and some minor instruments such as an astrolabe. They needed more technical treatises on mathematical astronomy before they could proceed. Ricci had written a letter on May 12, 1605, requesting that a mathematician, an astronomer, and calendrical tree. 91. Theses be sent to China. Ricci's successor as head of the China mission, Nicholas Longobardo, called on Rome several times to send specialized books and instruments, as well as Jesuits with mathematical training, to further the cause of Christianity in China. In 1612, the Belgian Jesuit Nicolas Trigault was sent to Rome to report the order's progress in China and to collect as many mathematical and astronomical works for the mission in Beijing as possible. To gain support from the Ming court and literati for the larger missionary enterprise, Ricci decided to present the Jesuits in China as specialists in mathematical astronomy. After Trigault's return, they mastered how these technical elds had changed and advanced since the Gregorian calendar reform in 1582. Until 1616, no papal act prevented them from transmitting more dangerous parts of the new learning, such as Copernicanism, although Copernicus's cosmology was generally neglected. For instance, Longobardo wrote to Rome, "If this plan is successful, 2 or 3 missionaries will professedly occupy themselves with these scientific studies, while the rest of the missionaries will calmly and safely attend the Christians in other parts of the kingdom." This plan was worked out in advance with Su Guangqi and Li Hizao, then high officials in the Ming government. What Longobardo did not say was that this would mean a significant portion of the Jesuit contingent in China would become subordinates of the Ming and Qing dynasties. 87 In 1613, Li Hizao memorialized the throne, itemizing 14 new features of Western learning when compared to Chinese calendrical procedures. Among these, Li included the mathematical device of deference and epicecles from Ptolemaic astronomy, the graduation of 360 degrees in a circle rather than the 365 degrees based on the tropical year of the Chinese, and the geometrical representation of celestial phenomena that provided a spatial theory of eclipses. Li also regarded the Western notion of the precession of the equinoxes as novel without seeing its parallel to the annual difference used since the UN to adjust for the displacement of the winter solstice. At the same time, Li recommended that the proposed translation project should move forward with the assistance of Pantoja de Ursus, Longobardo, and Manuel Diaz the Younger. Su Guangqi planned to use European astronomical tables as supplements to the existing ones, just as Arabic tables were used in the past. 88 After these early translations were authorized, however, the Vice Minister of the Ministry of Rites in Nanjing, Shen Ke, proscribed the Jesuits in 1616 for establishing illegal residences in China and staining the minds of the people. Shen urged that the Jesuits and converts be executed for clandestine meetings similar to the subversive White Lotus sect's religious groups. He was incensed by local literati who feared the Jesuit presence in 92. Nanjing. Shen also opposed any Jesuit role in calendrical reform. In Nanjing, Shen jailed Alfonso Vagnoni as the leader of the mission, along with other Jesuits and several of their converts. The Jesuit house in Nanjing was dismantled, and its building materials were used to restore a shrine honoring an early Ming martyr. Vagnoni and Alvaro Simadou were beaten and then transferred in cages to Guangzhou for expulsion. A sympathetic prefect there freed them, fortunately, and provided for their care before they were sent on to Macau. 89. In contrast, Yang Tingyun, a convert, and Li Zhizao, who again retired temporarily, provided the Jesuits from Beijing with a haven in Hangzhou. Some Jesuits had already arrived in Hangzhou in 1611 at the invitation of Li Zhizao while Li observed a period of mourning for his father. Yang Tingyun met the Jesuits at that time following his retirement to Hangzhou in 1609. Yang then collaborated in Hangzhou with Pantoja to produce the Seven Overcomings, a tract on the seven deadly sins. In 1615, the Explicatio Spherico Coelestis was translated by Diaz the Younger. It included an updated geocentric model of the Ptolemaic cosmos and also presented a description of the telescope and Galileo's discoveries using it. After 1616, most of the 14 Jesuits remaining in China studied Chinese texts and language in seclusion in Hangzhou. 90. Shen renewed the persecution of the Jesuits from 1621 to 1627 when he became a Grand Secretary in Beijing during the null-factional debacles of the Ming. After brief returns to office, Su Guangqi and Li Zhizao again resigned. This time of palace inkting between asymmetrical factions of eunuchs and officials, many sympathetic with the Donglin Academy partisans, coincided with wars against the Manchus in the northeast. Shen was able to take advantage of a calamity in Beijing in 1621 to continue his attacks on the Jesuits. By this time, however, they were presented in Beijing as military experts, which gained them permission to reside there. Su ordered a shipment of European cannon, procured through the Jesuits, to be used in the anti-Manchu campaigns, but 2 of them exploded, causing loss of life when they were read in Beijing. 91. Several years later, when the Chongzhen Emperor came to power, he recalled Su as a court diarist. In 1629, Su became a senior vice minister in the Ministry of Rights. In his new position, Su Guangqi reported on the competition for predicting the solar eclipse of June 21, 1629. Chinese and Muslim predictions were not as accurate as the Jesuit determination of the time and length of the eclipse. When calls for calendar reform continued and drew government support, Su then announced the need for immediate calendar reform. The Astrocalendric Bureau continued in its normal duties, but in 1629 Su Guangqi proposed establishing an independent agency in 93. Beijing. When approved, the agency resided at a separate venue in a former academy conveniently located next to the Catholic Church established by Ricci. Once in charge of calendrical reform, Su presented a plan to manufacture 10 new astronomical instruments. He also prioritized the key astronomical problems that required technical attention. The reforms for a Sino-Jesuit calendrical system were presented in stages between 1631 and 1635, but the null steps of implementation failed, in part due to Su's death in 1633, and definitively at the fall of the Ming dynasty due to internal revolts and external invasion in 1644. 92. Su could proceed with an ambitious translation project to solve these problems because Trigalt had returned in 1621 from his 1613 to 1614 assignment to Rome with some 7,000 new works, many scientific, published in Europe in the 1610s. Most were still Ptolemaic, i.e., geocentric, in orientation. By 1628, Li Zhizao, for instance, had used several of these works to compile the first collection of celestial studies, which included 19 of the books Trigalt brought back. The first collection included the translations of guidelines for practical arithmetic, which had been translated by Ricci and Li jointly, as well as Su's and Ricci's elements of geometry. Li's collection represented the last stage of Ptolemaic astronomy in China. It would be replaced there in the 1630s by the geoheliocentric system devised by Tycho Brahe at the end of the 16th century. 93. Many works of Aristotelian natural philosophy were also translated into classical Chinese by the Jesuits and their collaborators. A summary of Western learning, for example, was compiled by Elman to introduce the scholastic educational system to China. It was RST published in Hangzhou in 1622 and later was given eminence of place in Lise Hizao's first collection of celestial studies. It discussed the system of schools, curricula, examinations, and degrees in a Thomistic manner and was based on both the Jesuit Ratio Studiorum for Pedagogy at the Collegio Romano and the Coimbra texts known as the Commentarii Collegii Iconum Bricensis, which represented a new synthesis of the works of Aristotle. Elman presented the 6 divisions of scholasticism and scientia, i.e., specialized learning. 94 The Coimbra textbooks used to train Jesuit missionaries were famous in Catholic and Protestant countries, where they were also widely used. Li's first collection marked the initial group of European teaching materials made available in Chinese. To encompass Western learning, it was divided into 2 parts, principles or patterns and applications, literally, implements or utensils. The RST part included Elman's summary of Western European fields of knowledge and world geography, the second included geometry, astronomy, and hydraulics. Similarly, the Inquiry into the Universe by Lise Hizao and Francisco Furtado represented a translation of 94. Aristotle's De Silla et Mundo. Other Aristotelian materials that were translated included De Logica, again by Furtado and Lise Hizao, the treatise on the composition of the universe by Alfonso Vagnoni, from the Coimbra edition of Aristotle's Meteorologica in 1633, and Vagnoni's Creation of Heaven and Earth in 1637. Other works on medicine, mining, and mechanics were also translated, such as Agricola's De Re Metallica by Schall in 1640. 95 For the future calendrical reform, however, the most significant Jesuits who arrived in China with Trigault in 1621 were the German Johann Adam Schall von Bell and the Italian Giacomo Rò. Both brought with them a new orientation to the cosmos drawn from the work of Tycho Brahe, which replaced the Ptolemaic system with a geoheliocentric one in which the Sun and its planets revolved around the Earth. In the face of the Copernican challenge, this development represented a compromise position beyond Ptolemy's increasingly discredited geocentrism, but one not yet acknowledging Copernican heliocentrism. 96. The compilation of the mathematical astronomy of the Chongzhen reign. The inauguration of a formal astronomical reform system in 1629 by Su Guanqi, Lise Hizao, and their coterie of Jesuit translators led to the official production of an essential series of translations from the latest Western works, which was titled The Mathematical Astronomy of the Chongzhen reign. Although the work was never published as a collectanea, i.e., a collection of books published as a set, many works from it were. Some works included had been translated before 1629, such as Lise and Schall's On the Farseeing Optic Glasses completed in 1626 with help of Lise Yubo, later martyred in 1665. In the early 1630s, a telescope, the RST of many, was sent from Rome. Published in 1630, On the Farseeing Optic Glasses introduced some endings but no cosmology by Galileo. It also presented information on the manufacture and practical use of telescopes. It was arguably the earliest book that introduced the tectonic system to China. The Earth was immobile, i.e., non-orbiting and non-rotating, the planets rotated around the Sun, and all en masse rotated around the Earth. The choice of this system by Su Guanqi as a replacement for the spherical heavens cosmology preceded the inauguration of calendrical reform in 1629 and meant that a decision had already been made by the Jesuits not to adhere to the Ptolemaic system and by the Chinese not to adhere to spherical heavens cosmology. 97 Two ancient Chinese models of the cosmos were initially inuncial, since the account in the Gnomon of the Zhou dynasty and classic of computations. 95. Appeared in the early Han period. The vaulted heavens cosmology was usually interpreted as a hemispherical dome, an umbrella-like canopy, over at Earth. Its classical alternative, beginning in the transition from the early to later Han, was called the spherical heavens cosmology, which became inuncial in the period between AD 100 to 180, but was not further elaborated, and was seldom discussed afterward. The Chinese Compute was essentially numerical, like modern computer programs. Therefore, mathematicians in the Astrocalendric Bureau after the Han did not correlate their methods with an actual mapping of the cosmos. 98 As director in charge of the reform effort until his death in 1633, Su Guangqi organized a calendrical team to systematically adopt European astronomical knowledge. Moreover, as the official supervisor of Jesuit translators, he allowed them to implement the Taconic system as the theoretical and observational foundation of the calendar reform. In early 1631, Su presented the throne with the RST group of 8 works in 23 volumes translated by his team. To avoid the charge that European learning took precedence over Chinese learning, Su's memorial to the emperor stressed that the translations of Western methods were the RST step in preparing a comprehensive system of correspondences between European and Chinese measurements, melting the material and substance of Western knowledge. We will cast them into the mold of the Grand Concordance system. Such accommodative language diverted attention from what the translations actually signed, that is, a new cosmological system. Unlike Lise Hizao, who earlier in 1610 had stressed the newness of Jesuit calendrical methods, Su in 1631 minimized novelty and stressed accuracy instead. This emphasis on unifying European and Chinese knowledge was a tactic that would continue during the Qing dynasty. 99 Su noted that, for the 1,350 years between the Han and Yuan dynasties, calendrical methods had developed continuously. Because no major improvements in the Yuan-Ming calendar had been achieved in the 350 years since the Mongol system, it was now time for reform. Su added that the usual rule of thumb was that any calendrical system had to be reformed every 300 years, which was close to the slip of one day every 308 years that so concerned the Gregorian reformers. Stressing accuracy based on improved observation, Su contended that every calendar must be reformed to maintain accuracy. Islamic materials had been used for Yuan and early Ming reforms, and now Su would use Western methods to provide newer and more up-to-date source materials for contemporary reform. Measurement and mathematics were the key for Su. He regarded mathematics as the root of European expertise, which followed Ricci's view, derived from Clavius. To end a precedent, Su appealed to the ancient. 96. Rights of Zhou for technical corroboration of the importance of mathematics for early Chinese scholar officials. 100 In 1632 Su Guangqi presented a second set of 7 translated works to the emperor dealing mainly with XED stars, and a star atlas. Falling ill in September 1633, Su recommended Li Tianjing to succeed him as head of calendrical reform. Rou and Schall continued their work on the project, and they later made a third presentation of 7 more translations. In 1634, Li Tianjing presented the 4th group of translated calendrical works, which comprised 29 volumes and 1 star atlas. A last installment was presented in 1635. The VE sets of works were then combined into the mathematical astronomy of the Chongzhen reign, totaling 137 volumes and 2 star atlases. The traditional goals of reform, to determine seasonal divisions and verify eclipses by observation, were satisfied by 1642. 101 Unfortunately for the Jesuits, Li Tianjing allowed Muslim calendricists in the Astrocalendric Bureau to establish a 4th branch in 1634, which was known as the Eastern Office. The Reform Center was renamed the Western Office. In effect, the Ming Bureau now had competing Chinese, Islamic, and European branches. After 1634, Li negotiated a compromise to compare the results of all the systems, even though the European remained the most accurate. After various predictions for the 1642 solar eclipse were evaluated, the old calendrical system was replaced with the new system, but this decision came too late for the Ming dynasty. 102 The works included in the mathematical astronomy of the Chongzhen reign were quickly taken by Adam Schall to the conquering Manchu court in 1644. When the Shunzi emperor appointed Schall as the RST European head of the Qing Astrocalendric Bureau, Schall strategically changed the title to Mathematical Astronomy according to new Western methods and had it recopied in 1645 for the Manchu court in 103 volumes with minor rearrangements. The Qing dynasty's compute for the temporal model astronomy system accordingly was based on the European system adapted for the Ming dynasty. The Jesuits' change of loyalty to the conquering Qing did not please literati loyal to the fallen Ming, however. This episode confirmed their view of Schall and the Jesuits as opportunists, particularly since Schall was also eager to work with the anti-Ming rebel leader Li Zichun when he recaptured Beijing in 1644. Some later argued to the Shunzi court in 1660 that Schall subordinated the Chinese Empire to Europe. They accused Schall and the Jesuits of touting the superiority of Christianity through their calendar. After Schall became director of the Bureau, except for a successful attack on the Jesuits from 1664 to 1669, a Jesuit was in charge of the Bureau. 97. From 1645 until 1775, although the society was suppressed by the Pope in 1773. The Jesuits were unable to substitute a linear calendar based on Christian notions of time for the cyclical Ming and Qing calendars. 103 Schall also added a few new works to the new Western methods, such as Elman's essential methods for determining quantities, and the methods for using counting rods, which included Napier's device for quickly multiplying, dividing, and taking square and cubic roots of numbers by using multiplication tables on rods. Schall also included a translation introducing Galileo's proportional compass and a work by Su Guangqi answering his Chinese critics. 104 Elman's essential methods was read more widely in the late Ming and early Qing than the now more famous Ricci/Su translation of Euclid's Elements of Geometry. Measuring a quantity, literally, measuring magnitudes had initially referred in Elman's A Summary of Western Learning to the Aristotelian category of continuous quantity, that is, a theory of magnitudes. In the early Qing, Mei Wending, separating geometry from arithmetic, followed Ricci's translation of the term rather than Elman's. Elman's book collected applications of mathematical astronomy and was not a geometry for beginners. Just as in medieval and early modern Europe, Euclid's geometry was introduced to the Chinese in different forms, which were aimed at different audiences for different purposes. 105. From the spherical heavens to the tectonic world system. When Tycho Brahe obtained a higher degree of precision for his celestial observations by using new astronomical instruments, his observations opened a new era of precision in astronomy. Clavius had checked Copernican data to correct earlier positions because Brahe's endings had challenged the astronomical tradition. Clavius apparently also had his doubts about the Ptolemaic system, based on Galileo's observations. Building on such developments, Rowe and Schall as the chief astronomers in Jesuit circles introduced the tectonic system to Ming China. Because the Copernican system replaced the tectonic system in Protestant European astronomy, the continued use of the tectonic system in Ming and Qing China bequeathed disadvantages to the further development of astronomy in China. These limits were set by the Jesuits, whose intellectual stratagems in this regard have been described by Nathan Sivin. The development of Chinese mathematical astronomy would have been different if the Copernican system had been introduced in a timely fashion by the Jesuits in the Astrocalendric Bureau. A few of Galileo's discoveries, for example, were noted in Ming Jesuit translations, but not his support of heliocentricity. 106. 98. Nevertheless, the tectonic age in the Ming and Qing Astrocalendric Bureau meant that Chinese specialists by the 1630s had available to them a rich toolkit of new computational techniques, more accurate observations, a new view of the cosmos that molded the spherical heavens system, and the latest precision instruments that went beyond those available to the Gregorian reformers in Europe a generation earlier. Johannes Kepler and Christian Longomontanus, Brahe's assistant, became the European authorities on geoheliocentricity named in Chinese accounts. Longomontanus's Astronomia Danica, published in 1622, was crucial for the adoption of the tectonic system in China. Furtado, an Aristotelian, refused to accept the corruptibility of the heavens, a ending which had resulted after the discovery of sunspots by using the telescope. Schreck's brief description of the measurement of the heavens, presented to Throne in 1630, had already included a description of sunspots. Opposition by older Jesuits in China suggests that the newer Jesuits were able to introduce more recent astronomy so long as they observed the proscription against Copernicus. Furtado and others, for instance, also published objections to Longomontanus's claims about the rotation of the Earth in the moded version of geoheliocentricity. 107 Rowe's translation titled The Treatise on the Motion of the Five Planets was subsequently revised by Schall with help of Chinese scholars and presented to the throne in 1635. It presented Longomontanus's semi-taconic system and included illustrations of the old Ptolemaic and new taconic world systems, which were integrated into the mathematical astronomy of the Chongzhen reign. The planets, it was contended, moved freely by themselves through the clear ether of the atmosphere. Longomontanus had also denied the Aristotelian boundary between a changing sublunar world and an unchanging celestial world. Rowe gave no clear indication of what Copernicanism was when he presented its peripheral features by perhaps intentionally mixing it up with Brahe's general method. The motions of the Sun, Moon, and VE planets all relied on the Tycho Longomontanus interpretation. For the general model of lunar motion, however, the works in the mathematical astronomy of the Chongzhen reign presented both the Copernican and taconic mapping of that motion. Both remained, of course, geocentric. Rowe's mathematical explanations of the motions of the planets were presented in three categories: Ptolemaic, Copernican, and taconic. It marked the RST transcription of Epiclecles in Chinese. Similarly, Rowe worked out a sort of hybrid Tycho-Copernican system. 108 The geometric understanding of eclipses also came from Rowe's and Schall's reliance on Longomontanus. The influence of Kepler's optical astronomy on the geometrical theory of solar and lunar eclipses was also essential. For in 99. Stance, Schall's treatise and table on eclipses, prepared under Su Guangqi's supervision from 1632, included Kepler's chart of optical refraction. Kepler's optics had noted the important effect of atmospheric refraction. The aim of the translators was clear: to present a precise theory of eclipses, the prediction of which was so important to the Chinese. Interestingly, the materials included in the mathematical astronomy of the Chongzhen reign portrayed Kepler as a student of Brahe. He was also seen as contributor to the development of an unexplained theory of the motion of Mars, but Kepler's elliptical laws were not introduced for another century, although he was the RST to correctly explain planetary motion around the Sun in 1605. Numerical tables, star maps, and instrumentation. To enhance the accuracy of the Chinese computus, Su Guangqi recognized how important European astronomical tables, maps of the heavens, and instruments were for the reform. All of these accompanied the treatises presented to the throne from 1631 to 1635. For his astronomical tables, Rowe had used early 17th century calendars. Others used the 1551 Copernican Prutenic tables by Reinhold, which the Gregorian reformers had also employed. Kepler's Rudolphine tables of 1627 were not available in China until a full set was sent to Beijing in 1646. The Chinese created correspondence tables between European calculation tables and Chinese measurements through a synthesis. 109 In addition, the Jesuits introduced trigonometric tables in the mathematical astronomy of the Chongzhen reign and translated the Englishman Henry Briggs's Arithmetica Logarithmica, which was published in Chinese in 1624. Briggs was a professor of Gresham College, the original site of the British Royal Society until 1710, and later professor of geometry at Oxford. Nicolaus Smogulecki and his collaborator Xuefeng Zhuo introduced trigonometric logarithms in the early Qing. In an astronomical work, circa 1656, which pioneered spherical trigonometry and logarithms in China, Smogulecki introduced the latest European method for calculating eclipses. The use of both arithmetical and trigonometric logarithms enhanced the ease of astronomical calculations. For example, when Verbiest was asked by the Kangxi Emperor to prepare the groundwork for the eternal calendar, which was completed in 1678, he had to calculate its accuracy for 2,000 years in the future. To accomplish this task, the Astrocalendric Bureau had to go through an enormous number of calculations that were made easier using trigonometric logarithms. 110 In addition, the Jesuits provided the Ming court with up-to-date star maps, which culminated a classical tradition in China dating back to the CLAS. 100. Sick of stars around 70 BC. The catalogue and atlas of fixed stars in the late Ming improved on the mapping of XED stars earlier in China, but in this astronomical eld the Jesuits had to follow the Chinese system of constellations because they were unable to correlate all the stars known to them with the Chinese star maps. Hence Chinese constellations survived, and the Jesuits could only contribute further to the Chinese tradition of star catalogues. Su Guanqi and Adam Schall completed a remarkable star atlas in 1631 while also presenting the throne with a treatise on XED stars. The latter followed Bra's methods and other works on positional astronomy. Schall had to transform the two coordinate systems, equatorial in China and ecliptic in Europe, even though Bra, like late Europeans, chose equatorially mounted instruments and recorded in equatorial coordinates rather than ecliptic. Because trigonometric logarithms were not introduced until the early Qing by Smogulecki and Xuefengzhuo, the system of equatorial coordinates used in the Jesuit star atlas was classically Chinese and became universal in Europe only after Bra's time. 111 The 1631 atlas, although a sort of hybrid between Chinese and European star maps, gave the positions for 1,366 stars in the epoch 1628. The planisphere assimilated European knowledge into Chinese constellations. The 1634 General Atlas of fixed stars in the southern and northern hemispheres divided by the equator increased the number of stars mapped to 1,812. The outside was graduated into 360 Western degrees, while the inside used 365.25 Chinese degrees. Beside these, it employed the 12 houses of the zodiac and the 28 Chinese equatorial mansions in the graduated circumferential circle belt along the border. 112 Finally, Su was very enthusiastic about instrument making for the calendar reform. Ricci had noted the old instruments preserved since the early Ming in Nanjing and Beijing, but many new instruments were acquired by the Bureau after reforms began in earnest in 1629. These included the quadrant for measuring the altitude of celestial bodies, the parallactic ruler for measuring time, the celestial globe, the sextant, an equatorial astrolabe to observe the movement of the stars, an ecliptic equatorial armillary sphere to measure planetary motions, and gnomons to nd the declination of the sun through the year. 113 For example, until the Jesuits introduced the ecliptic armillary sphere, which worked from coordinates based on the sun's path through the XED stars, the Chinese had employed equatorial coordinates, i.e., the equator of the Earth extrapolated to the celestial sphere. These instruments were all illustrated and explained by Bra in his 1598 work titled Astronomia Instauratae Mechanica, which Ferdinand Verbiest duplicated in 105 woodcut illustrations prepared in Beijing circa 1674. They were discussed and printed in the Astronomia Europea and later included in the Sin. 101. Thesis of Books and Illustrations Past and Present Encyclopedia. The illustrations were based on instruments produced in 1669 and the early 1670s, when Verbiest succeeded Adam Schall in 1670 as the Jesuit co-director of the Astrocalendric Bureau and re-equipped the Imperial Observatory. 114 The telescope gave a special boost because it allowed study of the phases of Venus and the motions of the 4 Jovian moons around Jupiter in terms of the tectonic world system. In addition, Kepler's optical astronomy and Galileo's telescopic works were very important in China and became part of 102. Figure 2.1. Verbiest's instruments in the Beijing Observatory. Source, F. Verbiest, Xinzi Yuxiang 2. The New Astronomy. A telescope was used to observe a solar eclipse in China on October 25, 1631. Kepler also made a wooden pinhole device to measure the apparent diameters of the Sun and Moon and to observe solar eclipses in 1600, which was introduced into China circa 1632. 115 sighting devices were graduated, but now used Bras degree subdivisions. Later, when Adam Schall was appointed to the Qing Bureau in 1644, he replaced Chinese due with European degrees and time. Yang Guangxian and other literati attacked this change in units in 1667 when Yang objected to instruments for astronomical prediction calibrated according to European methods. In the end, however, the Astrocalendric Bureau adopted European measurements. 116. Just as timekeeping in Europe had provided a ritual regularity within society, so too furnishing standard time to the dual capitals of Beijing and Nanjing was the most routine function of the Astrocalendric Bureau. Official timekeeping in China's largest cities had depended on a water clock for quantitative astronomical observation. Timekeeping officials in the bell tower and drum tower in large cities marked public time. The Chinese reception of European mechanical clocks, which Ricci and the early Jesuits introduced in part to amaze the Chinese, should also be seen in light of the Ming and Qing dynasties' imperial horological needs, although the mechanical clock never replaced the three-chamber Inau-type clepsydra then in use. 117. The principles of mechanical clock making was part of the second-year curriculum at the Collegio Romano, for example, when Ricci studied under Clavius, along with studies of the astrolabe, planetary theory, perspective, and ecclesiastical computation. The Jesuits also became the Qing dynasty quartz clock makers, and a Jesuit, usually Swiss, was placed in charge of the emperor's clock collection. Later, under the Kangxi emperor, Chinese who worked under the Jesuits were expected to make native mechanical clocks. Imperial clockmaking workshops were also established in Suzhou and Hangzhou. By the 18th century, both telescopes and mechanical clocks became common playthings in the imperial palace. 118. The Ming calendrical crisis created an institution in the palace, where Chinese literati and Jesuit scholars interacted in translating European mathematical astronomy and instruments into Chinese texts and artifacts. Despite their taconic features, the instruments that Su Guangqi and Verbiest produced for the Imperial Observatory represented a cultural hybrid. Alan Chapman has noted that the European circles and technical parts were mounted upon stands contrived in the form of lions, dragons, Ming pearls, and other ori. 103. Antal motifs. The technology is wholly European, while the decorative features are characteristically Chinese. 119. On the other hand, Louis Le Conte, one of the French Jesuits who arrived in China in 1687, noted in his 1696 memoirs that while the Beijing instruments that Verbiest produced were the best in the world in terms of design and execution, the quality of the scale graduations was very poor by European standards. In other words, the accuracy of Chinese instruments remained deficient even after the late Ming calendar reforms. Yet, the late Ming and early Qing calendrical reforms had been successful in correcting the calendar and predicting eclipses to the minute. The implications of this paradox requires further elucidation before we turn in Chapter 3 to the further consequences of the Jesuit presence in 17th century China. 120. Chapman has described how Verbiest in his 1687 Astronomia Europaea illustrated a wide variety of taconic instruments in the fields of astronomy, ballistics, mechanics, meteorology, navigation, and optics as they were understood up to the 1650s. For instance, there were several illustrations of telescopes in the treatise, but Verbiest failed to discuss the telescope as a measuring device as well as a viewing instrument. Nor was there any awareness of astronomical instruments incorporating the telescopic sight or micrometer. In other words, Verbiest had not gone beyond Bras 1598 astronomical instruments. European positional astronomy, according to Chapman, still functioned in a taconic context for over half a century after Bras died in 1601. Consequently, When Verbiest left Europe for China in 1656, he sailed on the eve of a string of key advances in European instrument technology. In 1658, Huygens produced the Rst-efficient pendulum escapement, which transformed the clock into a precise measuring instrument. Horological developments were paralleled by the invention of the micrometer in the 1660s, which enabled astronomers to read celestial angles more precisely than by using taconic scale graduations. Simultaneously, the telescopic sight significantly improved the accuracy of the sextant and quadrant by overcoming the physiological limits, for even Tycho Brahe, of the naked eye. 121 These new inventions dramatically transformed the manner in which astronomical instruments in the observatories at Greenwich and Paris, for instance, were designed. Smaller, more delicate, and much more accurate than the large and unwieldy instruments in the Beijing Observatory, the new astronomical instrumentation and timepieces in Europe after 1658 left the late Ming and early Qing far behind. When Verbiest arrayed his huge taconic instruments at the Beijing Observatory in 1669 to 1670, he had outdid them with obsolete equipment. Moreover, the production of more accurate timepieces in Western Europe was increasingly tied to efforts to determine the 104 thorny problem of the longitude of ships in open seas. This level of immediate accuracy went well beyond the needs of a Gregorian or Qing calendar that calculated a solar year within several minutes of accuracy. At sea, an error of just a few minutes in plotting longitude could be fatal and lead to a shipwreck. 122 On the one hand, the Jesuits in China were certainly cut off from the latest developments in European science and technology, Schall in particular after 1656. On the other hand, just as the Jesuits made no effort to introduce the Chinese to the Copernican cosmology that eventually superseded Brahe's geoheliocentric system, so too they, especially Verbiest and his Jesuit successors in the Astrocalendric Bureau, failed to keep up with subsequent developments in astronomical instrumentation, precision timepieces, or, as we will see in Chapter 5, the revolutionary implications of analytical geometry and the differential and integral calculus for European engineers in the 18th century. Because Jesuit mathematicians stressed that mathematics could not explain motion, they never went beyond the focus on Euclidean geometry that Clavius had imprinted as a curriculum in the Jesuit colleges. 123 By 1660, the Jesuits were no longer on the cutting edge of the emerging scientific community in Europe. A century earlier, under the leadership of Clavius and others in Rome, the papacy had forged a Gregorian calendar that was revolutionary in impact if not in conception. After the Church's proscription of Copernicanism in 1616 and the condemnation of Galileo in 1633, however, the Catholic Church and its leading intellectual lights, the Jesuits, rarely forged ahead in scientia and its new instrumentation. Even when they had just arrived in China in the late 16th and early 17th centuries, Ricci and his colleagues, because they were not specialists, were at RST unable to provide the Ming court with the technical expertise needed to resolve the problems in the Ming calendar. After Ricci, the other Jesuits required a crash course based on the new materials Trigault brought back in 1621 dealing with the post-Gregorian changes in astronomy. 124 The Jesuits were not in China to further the boundaries of scientia or to improve European-style astronomical instruments. They sought to make China a Catholic country. Nevertheless, a few of the French Jesuits were sent by Louis XIV to the Kangxi court as royal mathematicians and as members of the Paris Academy of Sciences founded in 1666. In addition, Clavius and his contemporaries reddened Jesuit education at the Collegio Romano to include astronomy, mathematics, and clockmaking. Finally, Schall and Rowe in the late Ming, and Verbiest in the early Qing, could not have accomplished what they did in astronomy without the accruing astronomical literature in Latin that had made the Gregorian reforms possible. Chapman is right, however, when he concludes, the Jesuit observatory never produced any discoveries that were of significance to West. 105. Earn science. The technical work the Jesuits performed for Su Guangqi in the late Ming and for the Shunzi and Kangxi emperors in the early Qing gave them access They were willing minions of the state because, as their letters back to Europe indicated, this approach sanctioned their religious success in China. The Ming and Qing emperors required an accurate calendar and precise eclipse predictions. To give the Chinese what they wanted, the Jesuits provided the imperial government with a new cosmological system, mathematical tables, and instrumental techniques needed to satisfy the carefully itemized list of demands that Su Guangqi outlined in 1629. 125 More importantly, perhaps, a model translation laboratory was created in China from 1600 to 1635 that enabled Europeans, Chinese, and later after 1669, Manchus to work together for a common technical goal, even though many on each side had ulterior religious or political motives. This translation project far outweighed what the Jesuits achieved as individuals or the Church achieved in aggregate. The translations bequeathed an archive of books, manuscripts, maps, and instruments that would become part of the imperial library and the literati intellectual world. The intellectual impact of Jesuit works in natural studies and their assimilation by the literati, for example, belied how few Jesuits lived in China. Even the Japanese sought these works. Despite Su Guangqi's political and administrative success in reforming the Astrocalendric Bureau, Adam Schall's imprisonment in 1665 indicates that the Jesuit reform of the imperial calendar and Chinese time was not yet complete when the Ming dynasty buckled in 1644. Moreover, it was clear to Ricci that Ming literati were usually more interested in his knowledge of scientia than the teachings of Christianity he conveyed. With the help of Lise Hizeo, he tried to encompass both in his use of the term studies of heaven, which designated both astronomy and theology in the first collection of celestial studies. Qing literati, with some exceptions, would also welcome the former and elide the latter. Rather than the linear date since creation for Easter, they remained focused on the prediction of cyclical celestial events in a creationless cosmos. 126. 106. Sino-Jesuit accommodations. During the 17th century. 3. One of the ironies of the Jesuit-Chinese exchange is that Western scholars have often argued that the Chinese turned a blind eye to the European sciences introduced from Europe in the 17th century. To this view they usually add that the resistance of China's rulers and elites contributed to the Qing dynasty's backwardness when compared to the rise of the West. In fact, however, before 1800 Chinese literati had chosen that part of Renaissance scientia that they found interesting, namely studies of natural phenomena, astronomy, mathematics, and anomalies. What they usually rejected was Christian theology and the scholasticism that was even then declining in Europe. European scientia and natural studies in Ming-Qing China. In Ming China, when the Jesuits and their Chinese converts translated terms such as scientia from Latin into classical Chinese, the elite written language of literati, the translations reeked the personal views and intellectual frames for natural studies of both 16th century China and Europe. Such studies were not the sciences of more modern times. Literati converts chose scholarly learning as the classical Chinese equivalent to correlate native categories of specialized studies with scientia. One of the most influential of the early Jesuits in late Ming China, Matteo Ricci, for instance, equated scientia with knowledge. Following Clavius, his translations of mathematics stressed geometry with proofs in the Euclidean style. In the face of the Protestant Reformation, Catholicism reaffirmed scholasticism in the new Jesuit colleges of the 16th century, such as the Jesuit College of Arts at Coimbra in Lisbon and the Collegio Romano in Rome, which offered the best training in mathematics and natural studies then available in Europe. Many of the Jesuits who went to China studied at the Collegio Romano's Academy of Mathematics and at Coimbra RST. 2. 107. The logically precise mode of presentation that marked Ricci's translations of European mathematics into Chinese differed from the inductive approach in calculation problems associated with native manuals. Ricci's explanation of right triangles presented 15 solutions for right triangles proved in the Euclidean style. Ricci and Lise Hizeo compiled treatises on European arithmetical knowledge, such as the 1614 translations of Guidelines for Practical Arithmetic, which added problems and solutions they copied from Chinese mathematical texts. 3. Ricci and Li also introduced the European pen and paper approach to calculations, replacing counting rods and the abacus. Although more onerous, this method facilitated checking calculations, i.e., using subtraction to check addition, etc. The traditional counting board in Yang Hui's Practical Rules of Arithmetic for Surveying, for instance, provided a matrix notation to keep track of mathematical operations performed mentally. 4. In addition, the new method for recording fractions was introduced. Despite their logical rigor, these initial mathematical translations did not supersede the practical limits of traditional Chinese mathematics. Although arithmetic had been part of an elementary education in the ancient record of rites, the early Qing call by Yan Yuan and Li Gong to teach children more practical learning such as arithmetic likely reeked at an accommodation between European and Chinese reckoning. 5. Jesuit translations of Scientia in Classical Chinese. Unlike his Mappa Mundi discussed below, Ricci's Structure of Heaven and Earth, completed circa 1605 to 1608, was based on Clavius's work in Rome, as was his translation of the RST 6 books of Euclid's Elements, printed in 1607, which was drawn from Clavius's 1574 annotated Latin version. Refuting skeptics of the Ptolemaic astronomical system, which he included in his commentary on Sacrobosco's work, Clavius used the terms scientia and opinio in their traditional scholastic senses to show that Ptolemy's efforts to trace the positions and motions of heavenly bodies were consistent with the principles of physics and thus consistent with scientia. Because he believed that geometrical proofs were syllogistic, Clavius contended that geometry was also important for mathematics and philosophy as a window on God's divine plan for nature. 6. Between 1592 and 1606, the College of Coimbra produced a series of Latin textbooks and commentaries for the required works of Aristotle, which the missionaries trained there brought to China. In the 17th century, for example, the scholastic uses of experience were adjusted to t-novel ends. 108. When new experiences became legitimate in historical reports of events and in citing witnesses, reliable evidence became an empirical component of natural philosophy. For Jesuit Aristotelians, discrete experience was the focus rather than experiment as an arbiter of hypothesis. In those cases where miracles seemed an implausible explanation for an anomaly, the 16th century European intellectual community began to require reliable evidence of miracles. 7. In their translations, the Jesuits and their converts frequently stressed the syllogism as the tool to pursue scientia, which was a mark of specialized learning. The initial Latin translation of the Doctrine of the Mean, one of the 4 books, was included in the Synorum Scientia Politico-Moralis. The translation was published partially in Canton in 1667 and partially in Goa in 1669. It was rendered into French and published in Paris in 1673 as La Science de Chinois in a collection of travel literature. The Latin translation assimilated this part of the 4 books into Aristotelian moral inquiry. Use of scientia as a general term by the Jesuits also implied that studies of God and humanity were unid. 8. Likewise, the translation of the Great Learning, another of the 4 books, was initially titled the Magna Scientia as part of the Confucius-Synorum Philosophus, sub Scientia Sinensis Latin Exposita. The section in the Confucius-Synorum Philosophus that included the translations of the Great Learning, Doctrine of the Mean, and the Analects of Confucius was originally titled the Scientia Sinensi. The null version of the Confucius-Synorum Philosophus published in 1687 in Paris elevated Confucius's name to the main title while reducing Scientia Sinensis to a subtitle. These translations attempted to show that the Chinese possessed a natural religion based on a rational nature. 9. Giulio Alani's A Summary of Western Learning roughly corresponded to the curriculum based on the commentaries on Aristotle at Coimbra. The curriculum prioritized the study of philosophy and reasoning, which was the beginning point for astronomy and mathematical studies. Scientia as systematic learning in Latin contrasted with art. The content of scientia was generated by the demonstrative syllogism from Aristotle's posterior analytics. Art and opinion were generated by the probable syllogism based on dialectical reasoning, i.e., reasoning from authoritative opinions. 10. To communicate and overcome the difficulties of translation, the Jesuits talked about their knowledge systems in the classical Chinese terms that Ming literati chose. The translated terms and transcriptions that were adopted Sug. 109. Jest correspondences and parallels when Chinese terms were commensurable. Transcriptions were necessary for incommensurable differences in conceptions. To convey the meaning of philosophia in Western learning to literati, Elman RST presented a transcription, Philosophia. With the help of his Chinese adepts, he then linked this transcription to Chinese terminology for philosophy, associated since the Song dynasty with Chengzu teachings. Hence, in a summary, Elman equated philosophia with exhaustively mastering principles and the investigation of things. Elman and his Chinese informants presented physica as a subset of philosophia equivalent to the investigation of the principles of the nature of things, again drawing on terminology associated with Song classical learning. The choices Elman made were repeated in his account of countries not listed in the records office, a treatise on world geography, and later reproduced verbatim by Verbiest in his essential records about the West. Similarly, Furtado and Lise Hizeo compiled their De Logica in Hangzhou in 1631 from a text on Aristotle's dialectics prepared in 1606 at the Jesuit College in Coimbra. This view of Jesuit-Chinese collaboration challenges the standard view of the Chinese collaborator as the passive partner in the Catholic mission in China. 11. Elman's A Summary of Western Learning presented a classification of the sciences that corresponded to the general Western European standards of the 16th century, which attributed a more important place to mathematics and technology. Li and Furtado turned De Logica into a version of the Aristotelian categories for a potential Chinese literati audience that never materialized. In his treatise on the composition of the universe, Vagnoni distinguished between the ancient scientia of the Chinese and the new scientia of Europe in light of the investigation of things and extension of knowledge. The new learning fathomed the inner workings of things that the ancient learning found difficult. Similarly, Francisco Sambiase translated philosophy as the study of investigating things and extending knowledge, and the investigator as one who investigated things. Adam Schall later equated the inquirer of knowledge with one who investigates things. For physics, the Swiss Jesuit Johann Schreck's diagrams and explanations of the marvelous devices of the Far West, compiled with the help of Wang Zheng, complemented the mathematical astronomy of the Chongzhen reign as translations that introduced Renaissance mechanics, machine technology such as clocks, and topics such as optics and heat. 12. Between 1600 and 1773, Jesuit authors worldwide wrote more than 4,000 books, 600 journal articles, and 1,000 manuscripts dealing with scientia. The vast majority were by educators. They and their 110 converts in China translated or compiled 437 works between 1584 and 1790. 30% of that total were in the sciences, and 57% were on Christianity. Usually a Jesuit orally translated the Latin texts and dictated it to a Chinese, who turned it into passable literary Chinese, choosing terminology and concepts. This process was repeated after 1850 when Protestant missionaries and their collaborators translated many works of modern science primarily from English into classical Chinese. In the late Ming, Matteo Ricci translated Clavius 1607 Elementorum in this manner, as did de Ursus for the 1612 Western techniques of hydraulics. Smogulecki and his collaborators introduced European methods for calculating eclipses in an astronomical work circa 1656, which was also the RST to introduce spherical trigonometry and logarithms. Later in 1672, Ferdinand Verbiest furnished further information on world geography beyond Ricci's earlier Mappamundi. By way of contrast, most 18th-century European translations in China were theological works, and the Jesuits turned instead to translating Chinese works into European languages. 13. The late Ming Light Radus Fanyasi stressed concrete investigations in his magnum opus, titled Notes on the Principles of Things. His goal was to comprehend the seminal forces underlying the patterns of natural change. Presented as a collection of observations, endings, and other sources, the notes as a form of jottings resembled the late Ming encyclopedias and collectanea. Fang generally accepted European explanations of natural phenomena, such as a spherical Earth, tectonic cosmology, and human physiology, but he was critical of the Jesuits for leaving concrete investigations behind and ending in unvaried religious positions, such as Schall's claim that God's existence was revealed in the world's design. Fang favored, instead, descriptive knowledge of the natural world, and he infused the investigation of things with a new view of the accumulation of knowledge, which gainsaid both the moralist focus of Zhu Xi and the introspective focus of Wang Yangming, the two most influential voices of moral philosophy and knowledge theory in China since the Song dynasties. 14 Most Chinese literati labeled as perverse or heterodox those Jesuit works on the learning from heaven that made what they considered unacceptable claims about the world or the power of an otherworldly god. Acceptance of a portion of European scientia was possible in Ming and Qing China precisely because Chinese literati themselves had a long-standing and commensurable interest in natural phenomena, which had undergone a significant revival in the 16th century before the Jesuits, Augustinians, Dominicans, and Franciscans arrived in South China. 15. 111. The Accommodation Project. One of the most controversial aspects of the Jesuits' initial success in China was their monopoly, under the auspices of Portugal and Rome, over the transmission of Christianity to Asia. Until the 1630s, when with Spanish support the Dominican and Franciscan friars were nally able to overcome Jesuit opposition and join the China mission, Ricci and his followers had adopted an accommodation approach to the family rites practiced by the Chinese. The Jesuits' approach was not threatened until the middle of the 17th century, when the Spanish orders began preaching in South China. Rather than treating Chinese ancestor worship and veneration for Confucius as religious forms, and thus idolatries, Ricci despite some opposition treated such behavior as civil rights, which he considered commensurable with the Catholic faith. In contrast, the Dominicans and Franciscans demanded entry into China from the New World and the Philippines because they charged that the Jesuits permitted their converts to retain idolatrous observances. This brouhaha with the Jesuits simmered throughout the 17th century. In 1700, it burst its barriers, and the Jesuits were publicly chastised by the Jansenists in Paris for their role as Mandarin missionaries in preaching an impure form of Christianity in China. Domingo Fernandez Navarrete, in particular, led the Dominican opposition in China during his 12 years there from 1655. Nevertheless, the Jesuit accommodation policy remained in place until the early 18th century. 16. One aspect of the accommodation strategy, which characterized the Jesuit-Chinese interaction in the 17th century, was the joint use of Chinese terms such as the investigation of things, exhaustively mastering principles, and knowing heaven. Such expressions indicate some of the commensurable concepts that were at the core of the intellectual encounter between China as represented by Ming literati and early modern Europe as represented by the Jesuits. Mutually commensurable terms dealing with scientia and natural studies suggested to both Chinese literati and the Jesuits intellectual correspondences between Catholic Europe and Ming China. Classical Chinese terms were used by literati and Jesuits to accommodate both European and Chinese views of practical studies, which included the emerging sciences of mathematics and astronomy in Europe and China. We can also see an overlap between religious and scientific work on the part of the Jesuits and their Chinese converts and sympathizers. 17. It is significant that the term investigating things and extending knowledge was chosen by late Ming literati as one of the native categories. 112. Of appropriate learning, with the latter term equivalent for many Ming literati to European scientia. For example, a manuscript by Lu Zhengzi entitled The Essential Criteria for Specialized Learning, which dated from the late Yuan dynasty, was nally printed in 1700. It divided classical learning into 6 major elds: heaven and earth, studies of principles and patterns, statecraft, morals and regulations, antiquities, and miscellany. As a mid-14th century classification scheme, the essential criteria focused on elds that were still considered important for literati studies in the 17th century. 18 early Jesuit translations of Aristotle's theory of the four elements in the treatise on the composition of the universe and Agricola's De Re Metallica into classical Chinese had also used investigating things and extending knowledge in light of the Latin scientia in their titles. Such translations suggest that orthodox doctrine and natural studies, particularly medical and mathematical astronomy, were not mutually exclusive. 19. Commensurability was fraught with tensions that lurked just beneath the surface of well-intentioned accommodation agendas. Each side sought to efface the other by simple reduction of the other to themselves. Their actual common ground was a hybrid that assumed each side had the same agenda, but each aimed to achieve diametrically opposite results. Ricci and the Jesuits tried to efface the classical content of the investigation of things with Western European natural studies, which would then enable the Chinese to know heaven and accept the Church. Chinese effaced Western learning with native traditions of investigating things and extending knowledge, which would allow them to assert that European learning originated from China and thus was assimilable. The early Jesuits and their collaborators acquired a reputation for learning and thereby gained a role in Chinese society through mathematics and astronomy. However, furthering the Church in China remained their ultimate objective. Ming literati, on the other hand, used the debate between Zhu Xi and Wang Yangming over investigating things and exhaustively mastering principles to domesticate Western learning within native traditions of natural studies. Jesuits who came to Ming China, such as Alani, Furtado, and Ricci, focused on promoting good relations with literati to protect the conversions of commoners by other clerics in the Eld, as well as to augment their accommodation project for Christianity and literati learning. Thus they generally stayed out of Ming imperial politics and received support from local Chinese scholars and officials. Ricci and the Jesuits also had strong ties to the fundamentalist position in late Ming literati learning. The accommodation approach that Ricci and his generation of Jesuits adopted allowed them to take 113. Advantage of the late Ming return to antiquity currents of classical learning without political interference. 20. Ricci distinguished what he considered the original teachings of Confucius and the classics from the materialism he associated with the learning of the way orthodoxy of the officially prescribed Chengzu school, which he also considered atheistic. In the early Qing, such denunciations would become dangerous. Ricci favored the earlier interpretations of the classics over those given by Zhu Xi and his Ming followers. Ricci also tried to convince Chinese scholars that Zhu Xi's metaphysics were not an integral part of original classical doctrine. The Jesuits thereafter contended that the ancient classics were ultimately assimilable to Catholicism, but only when purged of Buddhist and Daoist corruption. Ricci wrote, "The doctrine most commonly held among the literati at present seems to me to have been taken from the sect of idols, as promulgated about VE centuries ago. This philosophy we endeavor to refute, not only from reason but also from the testimony of their own ancient philosophers to whom they are indebted for all the philosophy they have." 21. The language and allusions in Ricci's translations, for example, were in classical Chinese, but his humanist toolkit drew on the tactics and arguments of Western European Renaissance culture. For instance, Ricci used Epictetus's Manual of Stoic Moral Philosophy for his Chinese work titled 20 Sayings, what Goodman and Grafton aptly call rhetorical chinoiserie. Updating pagan and biblical texts had preoccupied Renaissance scholars, so Ricci's use of Stoicism followed in this tradition. Justus Lipsius's presentation of Seneca as a wise pagan was another example of how Catholics had massaged pre-Christian texts to serve official church doctrine, while meeting the needs of reform-minded Catholics in 1600. In the process, the Jesuits inscribed Greco-Roman culture with the precepts of Christian morality. 22. Ricci's efforts to end Chinese points of contact with Christianity paralleled humanist concerns with ending natural theology in the paganism of ancient antiquity in Greece and Rome. His use of allegorical forms for updating Stoicism to promote the European classics in China was guided by humanist tactics. Ricci's encounter with Zhou Yuan Biao is instructive when seen in this light. Zhou argued Ricci had realized that Christian teachings were contained in the ancient Chinese classics, an idea that later became the kernel for the Chinese notion that all Western learning was derived from China. Zhou, however, suggested that the Jesuits use the Change Classic to elaborate their ideas further, but this idea was not taken up until the French Jesuits arrived in China after 1689. 23. 114. Likewise, Ricci's belief in the transforming power of ancient Greek mathematics reeked the peculiar place of Euclid's geometry in Renaissance European thought, which saw it as a sourcebook for ancient wisdom. Geometry was regarded as the basis for astronomy because it was essential in the European astronomy informing the Gregorian calendar reform. As an important participant, Clavius regarded mathematics as the mediator between metaphysics and physics, and he studied the book of nature using an Aristotelian framework. Applying the views of his teacher to China, Ricci also thought mathematics would prepare the Chinese for the higher truths of Christianity. His use of logic was intended to convince Chinese of the necessary existence of God, as his collaborator Su Guangqi made clear in his introduction to the Chinese translation of Euclid's Elements of Geometry. A clear notion of geometry as a deductive system was not yet apparent, however. Earlier we saw that the Chinese initially regarded Euclid's geometry as a theory of magnitudes, i.e., mathematics. Moreover, Fang Yazi and Mei Wending successively suppressed the proofs in the Elements in favor of computational rules and theorems. Like many Europeans, they reduced Euclid to a set of fundamental, if preliminary, procedures and principles. 24. Ricci's true meaning of the Lord of Heaven did not focus on Christian scriptures of the Old and New Testament. Instead he emphasized a rational knowledge of God in a dialogue between a Chinese literatus and a literatus from the West. Rather than quoting Latin scriptures, Ricci reinterpreted the Chinese classics using Christian arguments. Ricci used the notions of investigating things and exhausting principles in his true meaning to propagate Western learning. In the same manner Zhang Xinjiao referred to the Jesuits as scholars from Western countries versus native scholars. 25. The Jesuits and some of their Chinese counterparts in the late Ming believed that Christianity and classical learning shared a common heritage. Hence a literatus such as Zhang Xinjiao could sympathize with Ricci when he claimed that ancient scholars had adhered to an ancient natural religion and that later scholars had departed from the original teachings in the ancient classics. Even in the late Ming, however, Ricci's repudiation of Song literati, primarily Zhu Xi, was not widely accepted by Chinese such as Zhang, primarily because Zhang focused on the more ancient five classics in his accommodations, unlike Ricci, who used the more recent four books. Although Ricci attacked Zhu Xi's Song commentaries for what he perceived as the philosophical materialism and atheism they contained, he showed no awareness of the Luwang tradition of classical learning, which earlier in the 16th century, 115, had been critical of the Chengzu school in favor of more ancient Chinese classical learning. Wang Yangming's heralded attack on Zhu Xi's interpretation of the Great Learning may have predisposed some late Ming literati to recognize that Ricci's critique of Chengzu learning was not unprecedented. Had Ricci been aware of Wang's critique, his own attack on Zhu Xi might have been strengthened. 26. Later in 1711, the French Jesuit François Noël produced the last fruits of the Jesuit translation project in Europe. His Sinensis Imperii Classici Sex, which added the Mencius, classic of filial piety and lesser learning to earlier Jesuit translations, was received unenthusiastically in Europe. Noël joined the early 18th century rights controversy to support the Kangxi Emperor, but his position was out of favor among Catholics in Paris, whose Sorbonne theologians were Jansenists. In 1700 they impeached VE propositions in Louis Le Conte's memoirs on China. Specifically they attacked the French Jesuit figurists, Noël and Le Conte included, for verging on heresy in their fascination with hieroglyphic symbols such as the trigrams of the Change Classic, which the figurists saw as repositories of ancient celestial knowledge and associated with a sublime philosophy concealed in Chinese texts. 27. The contributors to the Confucius-Sinarum Philosophus had initially translated the Great Learning as Magna Scientia, but Noël changed this to Adultorum Doctrina. Moreover, Noel's version did not disparage Zhu Xi and his followers as neoterics as Ricci and earlier Jesuits had done. In the Kangxi reign, the Jesuits could no longer afford to attack Zhu Xi and the Song scholars as idolaters or as corruptors of the ancient classics, although such a position in 1700 might have spared them the wrath of the Sorbonne's Jansenists. 28. Preliminary debates between Chinese literati and Jesuits. Chinese literati moderately transformed their own traditions of natural studies due to their interaction with European scientia. The Jesuits in late Ming and early Qing China saw the investigation of things and exhaustively mastering principles as a step in conveying the experience of God to the Chinese they hoped to convert. For late Ming Chinese such as Fang Yizi, their recovery of the concrete studies of antiquity predisposed some literati to accept Western learning in its Jesuit version as an alternate form of the investigation of things and a confirmation of Chinese ancient learning. 29. 116. Investigating things as an object of tension. According to Matteo Ricci, the Chinese entertained several absurdities concerning the nature of the world. The earth is at and the sky is a canopy, there is only one celestial sphere instead of 10, and the stars move in a vacuum. They do not know what air is and they only see a vacuum between the celestial spheres. They count VE elements instead of 4, for solar eclipses. The moon diminishes the sun's light when it approaches the sun, during the night the sun hides under a mountain near the earth. To gainsay such errors, half of which were misreadings, Ricci used ancient Chinese texts to confirm Christian readings and Aristotelian natural studies. He attributed the mistaken literati doctrine of man forming one body with heaven and earth to Buddhist Inyans in later times. Ricci's scholastic toolkit enabled him to assert that ancient China had a Christian religion but that it was lost after the despotic Qin Empire came to power and eliminated ancient religious traditions. Ricci's tactics facilitated Christian reinterpretations of ancient Chinese learning. Through accommodation, Ricci disqualified later Chinese learning, called learning of the way, by appealing to reason and logic as the basis for correct textual interpretations. The Jesuits also appropriated the Chinese stress on the innate goodness of human nature and appealed to a notion of a rational soul endowed spiritually by God to overcome the sinful material nature of humanity. 30. Although not a Jesuit convert, Xiong Minjiao accepted Ricci's attacks on Zhu Xi and Cheng Yi in favor of ancient Chinese learning. Ricci's toolkit focused on the Chinese phrase for the Lord on high, which he contended was the ancient Chinese name for God. Xiong paralleled Ricci's tactics by focusing on investigating things and arguing that the learning of the Jesuits corrected native traditions. For Xiong, the Jesuit conception of scientia corresponded to Chinese natural studies. Xiong's views carried over to Fang Yizi, whose father had discussed Jesuit learning with Xiong in his son's presence. Xiong Minjiao together with his own son, Renlin, published a 2-volume work on Jesuit scientia titled General Survey of Natural Studies and Geography. His own volume in the work was titled Draft for Investigating Things and Extending Knowledge and addressed natural studies, while Xiong Renlin prepared a volume on geography, which was indebted to Ricci and reproduced his Mappamundi. Father and son each had access to the late Ming translations included in the account of countries not listed in the Records Office and the first collection of celestial studies. 31. Xiong noted in the late Ming preface for his draft that literati took to heart the great learning and of course spoke of the necessity of RST investi. 117. Gating things and extending knowledge. Unfortunately, literati failed to capture the unity of knowledge that the doctrine of the mean and the Mencius had extolled. What was required, Xiong explained, was a detailed examination of the heavens, earth, stars, constellations, the transformations of qi, plants and animals. Fathoming each actual phenomenon one by one, one realized the reason why things are as they are, which illuminated the principle for why they could not be any other way. 32. 5 phases versus 4 elements. Both sides saw an order and purpose in the cosmos and on earth, which the Jesuits linked to a physico-theology encompassing theology and geography to unify God and nature. 33. Most Chinese literati also saw the earth and heavens as a harmonious whole, but they framed arguments for the design of the cosmos around an eternally evolving way rather than around a linear chronology of a divine providence. In place of a cosmos made up of 4 elements, the Chinese conceived of change in light of an undifferentiated supreme ultimate with no opposites. It spontaneously split into a completely differentiated stage of yin and yang. The interaction of yang and yin on the stuff of the universe then set in motion the VE phases of cosmic change and yielded the concomitant production and destruction cycles of the myriad things in the world. 34. The Jesuits' use of Aristotelian natural philosophy to refute Chinese notions of qi was another part of this Christianizing agenda. They regarded qi as air, one of 4 elements, within the category of matter. Neither spiritual beings nor the human soul were reducible to qi. Chengzu scholars had explained ghosts and spirits, for instance, through an appeal to rend but disintegrating qi, which was the spiritual cum material basis of both. Zhu Xi argued that although the essence of qi was spiritual, the soul eventually dispersed. Ricci, as a believer in the immortality of the soul, saw this position as heresy and sought to illuminate the true nature of spiritual beings by refuting what he perceived as Chengzu atheism. 35. Vagnoni's treatise on the composition of the universe was in part a refracted presentation of the theory of the 4 elements from the Conum Bricensis edition of Aristotle's works. In his translation, for example, Vagnoni vainly tried to convince the Chinese of the error of their ways for including wood and metal and excluding air as the building blocks of things in the world. His use of translation for the Jesuit encounter with Chinese literati built on Ricci's earlier efforts to expound a theory of the 4 elements in his summary of the 4 elements. 36. 118. Vagnoni coined the new term of a primary element to render Aristotle's concept of element into classical Chinese and to demarcate it from the Chinese notion of VE phases. An element is a pure substance in that when divided it does not form any other sort of thing. It can only form a composite thing made of several sorts. What is a pure substance? It is a substance of a single nature with no other composite elements. Accordingly, the myriad things in the world are distinguished by their being pure or composite. The pure elements are the 4 elements of earth, water, air, and re. Composite things take on VE forms such as the category of rain, dew, thunder, and lightning, the category of metals and stones, the category of plants, trees, and the VE grains, the category of birds and animals, and the category of humans. All VE of these forms are composites of the 4 elements. 37. The key concern for Vagnoni from the outset was to refute the Chinese inclusion of metal and wood in the elements. The latter were not pure substances like air, which the Chinese had not included. Replying to a query by a Ming Light Radus, Vagnoni gainsaid whether there were the VE phases at all. If one observes how the myriad things are formed, it is not from metal and wood. The many categories of humans, reptiles, birds, and animals are examples of this. Therefore, metal and wood cannot be the primary elements of the myriad things. Moreover, who does not know that metal and wood are in actuality themselves composites of water, re, and earth? As composites they cannot be primary elements. There are many additional composites that might be called primary elements, such as plants, stones, and other things, and which could be arrayed as primary elements. Consequently, they are not limited to just VE. Why only select metal and wood? 38. In the dialogue that Vagnoni imagined with the Light Radus, there was an assumed agreement, however, that at least 3 of the Chinese VE elements, namely, water, re, and earth, overlapped with the 4 elements of Aristotle. In other words, Vagnoni thought that what he meant by an element as a pure constituent of reality was the same as what the Chinese meant by the VE phases. The issue was, simply put, that the Chinese had miscategorized the elements by failing to ascertain that in addition to water, re, and earth only air was another pure substance that made up composite things such as wood and metal. Vagnoni and his Chinese informant Han Yun made no effort to conceptualize the VE phases in Chinese terms, namely that the VE phases were not substances but marked phases in every sequence of 119. Change, whose configurations in time were the key to the delineation of the myriad things in the world. Of particular importance to the Jesuits in their efforts to promote Aristotle's views of nature and principles was their belief that air was one of the four primary elements. This entailed an equation of the Chinese notion of qi as matter energy with the Aristotelian element of air. Aristotle had complemented the four elements with ether as a fth substance to account for celestial bodies that were not susceptible to change and remained in eternal, circular motion. The sublunar world was composed of the four elements and subject to night motions of all kinds in a world of constant change and transformation. On the other hand, the Chinese notion of qi worried Ricci and his colleagues because they saw it as a materialist continuum that encompassed all matter. In other words, qi verged on materialistic pantheism, leaving no place for the unlimited spiritual power of God. Consequently, Vagnoni tried in his dialogue to equate qi and air, thus demoting it to one of the four pure physical substances. The conversion of qi from an unlimited, physico-spiritual presence, undergirding all physical and spiritual things, into a single substance making up some but not all things was based in part on what Vagnoni perceived, incorrectly, as the physical notion of qi. To prove that air was a pure element, Vagnoni appealed to the physical presence of qi as a sort of etherling in the vacuum of space within the celestial spheres. Otherwise, without qi the space within the heavens would be empty, and there would be no natural motion possible up or down from the earth. Moreover, without air to breathe no thing could live. Without air, humans would perish. From this we can infer that the qualities of humans and things, whether they are wise or ignorant, beautiful or ugly, old or young, strong or weak, etc., all are wholly related to the air that one breathes. 39. The Jesuits were trying to delimit qi, rejecting both classical and popular notions of qi in China, favoring the equation of air and qi. By modern standards, this interpretive effort by the Jesuits seems a mistranslation and misrepresentation. In its time, however, the interpretation of texts and doctrines was a time-worn practice for both Jesuits and Ming literati. Christian efforts to rework ancient Greek and Latin texts, including Aristotle's writings, represented an earlier phase of this willful interpretive process. The Christianization of Galen, which eliminated his materialist conception of the soul and established instead the notion of pneuma as a physical instrument and agent of the immortal soul, is a clear precedent for what Vagnoni was trying to do in his treatise. Alani, for example, also adopted qi in this sense as both a physical and psychic spiritus. 40. 120. Rather than building blocks of the universe, Chinese literati perceived in the VE phases evidence for the successive changes in all things. Rather than the lifeless element air enunciated by Vagnoni, Chinese perceived in qi a more fundamental material, vital, and spiritual unity, which pervaded all things in the cosmos and undergirded all space-time change of yin and yang. While inconclusive in the 17th century, Vagnoni's fascinating opposition of the four elements and the VE phases was replayed in the late 19th century when Protestant missionaries presented the modern concept of a chemical element in their translations of chemistry. 41. Nor should we assume that the Jesuit refraction of the VE phases into the four elements was completely antithetical to Ming literati. In a discussion titled Views on the Four and Five Phases, Fang Yizi presented an ambiguous account in which he explained that even in Chinese classical learning there had not been unanimity on whether there were four or VE, or six, phases. Fang noted that Xiao Yang, for example, had spoken of water, Ri, earth, and stone as four phases, thus leaving out both metal and wood. Fang also pointed to the tradition that deemed qi as a single continuum, which was described in terms of two phases, namely yin and yang. Fang Yizi concluded from this survey that there was no set way to talk about reality. Four or VE phases were equally plausible conventions as were many other arrangements. Fang did not give ground to the Jesuits, however, in his insistence that even when given material form, the phases were describable in light of the duality of yin and yang and not as pure elements that composed reality. Fang maintained that water and Ri were the key transformative agents of qi that made it increase or decrease in amount. Movement was due to the action of Ri, and congealing was the result of water. 42 other literati in China had talked about the four greats of earth, water, and air, which were more comparable to the Jesuits' four elements. The Chinese had dealt with the idea of four elements this way in medieval times when Buddhism introduced to China the Mahabhuta as the substances of all material. In addition, Muslims had introduced the original Aristotelian four elements to China in Islamic texts translated into Chinese from the Arabic and Persian during the Mongol era. 43 On the other hand, there were late Ming literati who thought that qi, when it took physical shape through congealing, made up everything between heaven and earth. Qi could be explained as both organized activity or energy and the material structures that embodied it. In this view, the VE phases actually referred to qualities of qi that made up all substances, another side of their denotation as VE sorts of qi as fundamental processes. 121. For Song Ying-Xing, who was interested in traditional technology and agriculture, two of the VE phases instead become basic ingredients of matter but not elements. 44 Song's chief works were published in 1636 to 1637, and his magnum opus, Heavenly Crafts Revealing the Uses of Things, was compiled as a practical compendium in the 1630s, with a preface dated to 1637. It echoed the Ming daily use compendia, which we have discussed earlier. The Heavenly Crafts had one important difference with the Ming compendia by Li Shizhen and Hu Wenhuan, however, namely that it was compiled in an era when Jesuits were prominent in literati and Ming court circles in Beijing and the Yangtze Delta. Song's work made no mention of European agricultural and hydraulic techniques that were introduced in works by the Jesuits and their converts, such as the Western techniques of hydraulics and Su Guangqi's complete works on agrarian management, although he did make some mention of European weaponry. Song's delineation of 18 categories of traditional agrarian and craft production documented native success in all these areas. He excluded materials he had prepared on subjects that were often included in other daily use digests, such as celestial observations and mathematical harmonics, because they were not pertinent to techniques of production. 45. The Jesuits and Mappa Mundi in Ming China. Because of their travels, the Jesuits could also claim expertise in world geography. Their charts of the globe were based on the New World discoveries of the Portuguese and Spanish explorers they often accompanied. The Mappa Mundi that Ricci, his collaborators, and others produced for literati in the late 16th century caused an uproar because the Ming imperial system was based on a cosmological assertion of its geographical centrality in the world, which the Jesuit maps seemed at RST to challenge. Some literati, for example, resisted the Jesuit claim that the earth was spherical, because this suggested that the vaulted heavens was a sphere as well. Many literati considered the earth and the sky a night vault overhead. 46 Native attempts at serious cartography and descriptive geography provided Chinese with a foundation that cumulatively helped bridge the gap between the orthodox symbolic geography popular since the Song period and the Jesuit techniques that stimulated the emergence of more rigorous cartography in the 17th century. Chinese achievements in geography climaxed during the Yuan and late Ming dynasties with the production of schematic grid maps, sailing charts, and relief maps. Two extant maps that demonstrate the remarkable development of map-making in China were carved on stone in 122. The 12th century. Informed by Tang models, the maps were titled the Map of China and Foreign Areas and Map of the Tracts of Emperor Yu. The latter, carved in 1137 as a grid based on a scale of approximately 1.5 million, is described by Needham as the most remarkable cartographic work of its age in any culture. 47 The medieval cartographer Peixiu Rst used the method of indicating distances by a rectangular grid system. Since then, cartography in China was often based on the grid tradition, although many important maps still followed the Map of China and Foreign Areas model and were not Ren. 123. Map 3.1. Map of China and Foreign Areas source, reprinted from Science and Civilization in China, Volume 3, by Joseph Needham, with the permission of the publishers, Cambridge University Press. Dared using a grid. Jia Dan, the greatest Tang cartographer, constructed a map of Chinese and foreign regions for the emperor. The map, now lost, was 30 feet long, 33 feet high, and used a grid scale of 1 inch for 100 Chinese miles, i.e., equal to about 33 English miles, the same scale used in the map of the tracks of Emperor Yu. Jia Dan's map likely depicted all of known Asia because of its huge scale. 48 Zhu Siben inherited this grid format. Perhaps the best-known Chinese cartographer until the 20th century, Zhu used grid maps to summarize the large body of new geographical information that the Mongol conquests in Asia had added to the earlier fund possessed by Tang and Song geographers. Zhu's map, circa 1320, became known in Europe as the Mongol Atlas of China. An early Ming map of about 1390 replicated the imperial pretensions of Mongol maps, asserting the empire's sway from Central Asia and Japan to the Atlantic via Southeast Asia and the Indian Ocean world. 49 In the 16th century, Luo Hongxian discovered a manuscript copy of Zhu Siben's map of the known world, which had been prepared between 1311 and 1320 but never printed. Luo revised and enlarged Zhu's grid format in 1541. He also added new information, some derived from the early Ming naval explorations led by Admiral Zheng He. Luo's map, printed about 1555, included clear depictions of the Cape of Good Hope and southern Africa, suggesting that some of Zheng's ships had traversed from the Indian to the Atlantic Ocean and back some 70 years before Vasco da Gama did it in reverse. 50. Cartography and Ming military defense. As the early Ma Wangdui maps reveal, interest in cartography and geography in China frequently was tied to problems of border or maritime defense. Luo Hongxian became interested in geography because of Japanese pirate raids on the maritime provinces in the Yangtze Delta and along the southeast coast in the 16th century, which had been aided by Chinese accomplices. The Ming government urgently needed maps and geographical advisors to cope with the situation. Luo spent 3 years collecting geographical materials for military defense and in the process discovered the manuscript of Zhu Siben's grid map. Zheng Ruozheng, a native of Suzhou Prefecture, was also involved in coastal defense because of the Japanese pirate threat. In the 1540s, Zheng compiled a strategic atlas of China's coastal region extending north from the Liaodong Peninsula to southern Guangdong. Maps and strategic information were included. More importantly, Zheng Ruozheng compiled a work on coastal geography under the auspices of Zhejiang governor Hu Zongxian. First published in 1562, Zheng's A Maritime Survey, a compilation of plans, was modeled on Luo Hongxian's earlier work. The Maritime Survey was an ambitious presentation of geographical minutiae about the China coast, containing accurate accounts of China's neighbors, Japan and Korea. Hence, it was not simply an atlas. A major contribution to Chinese historical geography, the Maritime Survey marked a major turning. 125. Point in Chinese geographic studies. Its completion arguably provided the impetus for later literati to incorporate Jesuit information into the Chinese tradition of geography and cartography. 51. In the past, threats to China's security had mainly come from the north and northwest, example the Mongols. Hence, earlier geographers focused attention on northern frontier areas in their geographical accounts. In the 16th century, however, the primary military threat was along the South China Sea coastline. Zheng Ruozheng's research on the menace posed by Japanese pirates and their Chinese collaborators in the southeast thus stimulated a shift in geographically inspired research. A number of 16th-century geographical treatises on maritime defense were either inspired by or followed the pattern of the Maritime Survey. 52. Ming knowledge of foreign countries. Geographers and cartographers in Ming China were fairly knowledgeable about the southern regions and countries in the Indian Ocean and Arabian Peninsula. Information of this type peaked in China after the early 15th century voyages of the Ming Eat. Zheng He, the eunuch commander of 7 Ming expeditionary eats launched between 1405-1433, reached at one time or another Sumatra, Java, Ceylon, Hormuz, Aden, and Eastern Africa. The expeditions overlapped with the extent of the Ming maritime tributary system around which trade and diplomatic relations were organized. Moreover, Ma Huan left a descriptive account of Zheng's Eats in 1433, which was based on his service as Muslim translator for 3 of the 7 expeditions. Ma's captivating views of the ocean's shores described the countries the Eat had visited and portrayed the customs, religions, and lifestyle in each place. He also depicted topography, geology, and wildlife. 53 Subsequently, other members of Zheng He's expeditions described their adventures. For example, Fei Xian's captivating views from a star-guided vessel and Gong Zhen's Gazetteer of the western tributary states were based on first-hand visits and help the gap in Indian Ocean accounts between Marco Polo's The Travels and Portuguese reports in the late 15th century. References to the expeditions and the exotic gifts brought back to China were added by 1462 to Cao Zhao's circa 1387-1388 inventory of artifacts discussed in Chapter 1. 54 In the early 18th century, imperial compilers of the synthesis of books and illustrations past and present, the largest encyclopedia in Chinese His 126. Tory, subsequently included excerpts and extracts from such Ming accounts. The Qianlong Imperial Library also included a 1520 annotation of Ma Huan's account by Zhang Sheng. In addition, the Imperial Library summarized the content of Gong Zhen's work and mentioned Huang Shenzhen's 1520 records of western tributaries, although neither was copied into the collection. Wang's work drew on and cited earlier sources. 55 Within China, Ming explorers such as Wang Shixing, Xie Zai, and Su Hongzhi traveled to the most remote borders of the empire. In their travels, they prepared notebooks outlining in descriptive terms the river systems, topography, and cultural aspects of the places they visited. Su Hongzhi, for example, discovered the main source of the West River in his travels through much of southwest China and was able to determine that the Mekong and Salween were different river systems. 56. Matteo Ricci's Mappamundi. Jesuits added to the geographical knowledge that Ming literati already had in the late 16th century. Produced with the help of Chinese converts, the RST edition of Matteo Ricci's Mappamundi, titled Complete Map of the Earth's Mountains and Seas, for instance, was printed in 1584. A sphere projection with parallel latitudes and curving longitudes, Ricci's world map went through 8 editions between 1584 and 1608. The 3rd edition was titled The Complete Map of the Myriad Countries on the Earth and printed in 1602 with the help of Li's Hizeo. Li studied European mathematics and astronomy, in addition to geography, after meeting Ricci in Peking in 1601. 57 Ricci's description of the form and size of the Earth obliged many 17th-century Chinese literati to revise their views of the world. For the RST time, Chinese became aware of the exact location of Europe in relation to their own country. In addition, Ricci's maps contain technical lessons for Chinese geographers. Ricci taught Chinese cartographers to localize places by means of circles of latitude and longitude. He invented many geographical terms and names, including Chinese terms for Europe, Asia, America, and Africa. His maps transmitted to China the most recent discoveries made by European explorers. He described the existence of terrestrial continents surrounded by large oceans. The maps introduced the sphericity of the Earth. Nally, he spoke of geographical zones and their location on the Earth, i.e., the Arctic and Antarctic circles, and the temperate and tropical zones. 58. 127. An indication of the initial impact of Ricci's maps, especially the 1608 edition printed in Beijing, was its inclusion in geographical works produced by late Ming literati scholars. For example, Zhang Huang, who had met Ricci in Jiangxi in 1595, added Ricci's complete map to his own massive illustrated collection, which Zhang called the Compendium of Maps and Writings. In addition to Ricci's 1584 map of the world, Zhang also included European depictions of the northern and southern hemispheres along with traditional maps of the four seas. 59. The only known copy of the RST Chinese map of the world produced in 1593 was titled The Comprehensive Map of Heaven and Earth and the Myriad Countries and Ancient and Modern Persons and Artifacts, which included geographical information from the Jesuits. It was based on Ricci's RST World Map of 1584, which is now lost. The map offered a traditional representation of China with foreign lands arranged around the periphery. It served Qi as an administrative map for officials and thus included statistical information such as population and locally produced commodities. Topological rather than topographical, the 1593 Chinese version T European lands in along its edges without affecting traditional cartography. The New World was shown as a series of small islands surrounding China. Methodologically, however, the compiler stressed the achievements of investigating things and extending knowledge, which by now served as a native trope for the accumulation of knowledge. The linkage of the world map of 1593 to such studies heralded the application of native terminology to European scientia. 60. The 1602 complete map of the myriad countries on the Earth corresponded to one of the RST issues of Ricci's Third World Map and is the year 129. Liest version that survives. This 1602 edition followed the Typus Orbis Terrarum by Abraham Ortelius, a Flemish scholar and geographer, which was RST published in a 1570 European atlas called the Theatrum Orbis Terrarum, which was itself based on Gerardus Mercator's prominent 1569 world map. The chief alteration for the Chinese version was that Ming China was placed at the center of the map to appeal to Chinese dynastic sensibilities. The New World was located on the eastern borders. A fourth edition of the map was prepared in 1604. 61. Longobardo and Manuel Diaz the Elder continued Ricci's map-making, in 1623 producing a lacquered wooden globe, which updated Ricci's map and also stressed the sphericity of the Earth. Alani and Yang Tingyuan quickly followed with their account of countries not listed in the Records Office, which was later included in the 1628 first collection of celestial studies compiled by Lise Hizeo. Alani's account grew out of notes on Ricci's 1601 Mappamundi that Pantoja and Ursus had prepared for the Ming court. 62. Alani's translation represented the RST detailed exposition in Chinese of a world geography that drew on Renaissance traditions of local lore and Ptolemaic cosmography to describe Asia, Europe, Africa, and the Americas. Another section focused on the oceans. In addition to the first collection of celestial studies, other Chinese collectanea reproduced Alani's treatise in the 18th century, thus making it more influential during the Qing dynasty than Ricci's maps, which were quickly forgotten by literati. In the 19th century, Alani's work was reprinted 3 times in 60 years after world geography became de rigueur for literati trying to understand the military consequences of the Opium War. 63. A world map composed by the Neapolitan Jesuit Father Francesco Sambiase in 1648 was designed as simplified version of the large maps by Ricci. It was drawn as an oval projection with China at the center. Later, Michael Piotr Boym, a Polish Jesuit who had served the embattled southern Ming in the 1650s, produced the map of the Middle Kingdom, circa 1652, which he took back to Rome in 1656. The original manuscript conveyed Jesuit knowledge of China to Europe. This version was superseded by Martinus Martini's Novus Atlas Sinensis published in an Amsterdam Atlas series in 1655. 64. Although Matteo Ricci introduced the system of longitude and latitude to Ming China, the grid system employed by Luo Hongxian and his predecessors still exercised a dominant influence on Chinese cartography throughout the late Ming and Qing periods. The Chinese grid still conceived maps and texts as integral rather than independent. For example, an admired genre known as complete maps of all under heaven was INI. 130. Tiated by the Ming loyalist Huang Zongzi in 1673 and continued by a number of talented literati scholars interested in map-making. Cao Junyi's ambitious complete map of 1644, for instance, mixed inaccurate classical geographical lore with precise recognition of Europe, Africa, India, and Central Asia, providing longitudes and latitudes for estimating their distances from Nanjing, the Ming southern capital. 65 In the early Qing, Verbiest, with the help of others, produced two works that dealt with world geography. His 1674 World Atlas included a comprehensive map in two hemispheres with gazetted information about each part of the globe. It was based largely on Elman's account of countries not listed in the records office. Similarly, Verbiest's essential records about the West drew on the topical organization in Elman's 1637 Answers about the West, which compared China to Europe in light of geographical lore. The compilers of the Imperial Library Catalogue during the Qianlong reign considered these works important enough to copy them into the collection in the 1780s. 66 The null stage in the development of traditional Chinese mapmaking came between 1708 and 1718 when French Jesuits on behalf of the Kangxi Emperor systematically surveyed the entire Manchu realm. They drew up a series of maps of the Qing Empire and its border areas, which became known as the 1718 Kangxi Atlas. Along with succeeding maps in the Yongzheng and Qianlong periods, the Kangxi Atlas surpassed Jesuit surveys completed earlier. The Manchu court restricted access to and local reproduction of these surveys and maps. Nevertheless, when brought to Europe, the atlas remained the West's chief source of China's geography until the 20th century. 67 Rather than switching to Jesuit cartography, late literati such as Ma Junliang sometimes presented both a traditional picture of a China-centered world and global maps that loosely duplicated Ricci's Mappamundi. Ma's capital edition of a complete map based on astronomy circulated widely in the 1790s. It included two smaller global maps of the Euro-Asian, African and Pacific hemispheres above his detailed map of the Qing Empire, which roughly corresponded to Ricci's map of the myriad countries on the Earth rendered in a late Ming encyclopedia. 68 Despite displaying substantial variations, a prominent feature of the complete maps was the mingling of traditional and newer techniques, such as the hybrid overlap between the grid and latitude-longitudinal approach for large-scale land maps. Indeed, Li Zheoluo's famous 1832 Atlas of the Qing Empire showed grid as well as latitude and longitude lines on the same map, indicating the reluctance of native geographers to give up the traditional system long after the Jesuit Mappamundi were introduced. This 131 map 3.4 Capital edition of a complete map based on astronomy. Source, the Woodson Research Center of the Fondren Library, Rice University. Nativist pattern for domesticating European learning was repeated in mathematical astronomy during the late 18th century. 69. Literati attacks on calendar reform in the early Qing. Scholarly debates between literati and Jesuits intensified during the early Qing dynasty, particularly after 1660 when the issues of Christian creationism and biblical chronology challenged Chinese assertions of their cosmic centrality. In addition, the fundamental differences between the orthodox study of principles among literati and Jesuit views of how God had created the world and endowed humans with an eternal soul became political ashpoints. In the 1660s, the Manchu court's brief tolerance of Jesuit religious beliefs was severely tested when Chinese, Muslims, and Manchus attacked Adam Schall and his staff in the Astrocalendric Bureau as enemies of the dynasty and classical civilization. Although the Jesuit mission survived the 1664–1667 purges, from then on the court carefully scrutinized its missionary impulses. As long as the Jesuits provided the court with needed expertise in mathematical astronomy and geographical matters, the emperor kept them on, but increasingly the needs of the Qing government, rather than the goals of the church, deemed their activities. The Jesuits could no longer protect the conversion projects of their local priests. As minions of the Qing dynasty, the Jesuits would pay dearly after 1700 when Jansenists, Dominicans, and Franciscans in Rome and Paris and the Kangxi Emperor in Beijing challenged their accommodation policy. In 1704, for example, Pope Clement XI issued an ordinance prohibiting the use of the Chinese terms for heaven and the Lord on high to designate God. 70 Late Ming concerns about the accuracy of the official calendar forced literati to evaluate and apply specific European techniques to reform the Ming calendar. Given the interest early Manchu emperors exhibited in astronomy, we might expect that topics dealing with the calendar, as in the Ming, to carry over to the civil examinations. Because the Jesuits had penetrated the astrocalendric bureau, however, the throne preferred to limit this potentially volatile area of expertise to Manchu bannermen, princes, and select Chinese literati. The contemporary calendrical debates between Jesuits and officials, which challenged the Yuan Ming calendrical system during the Ming-Qing transition, gave the court pause about adding possibly divisive calendrical questions to civil examinations. We have seen in Chapter 2 that Ming emperors had permitted such debate after 1525. In contrast, the Manchu throne proclaimed its legitimacy by resolving the Ming calendar crisis. For self-legitimation, the Qing court presented a new calendar that, like its Mongol predecessor, would link empire and time far into the future. 71. 133. Unlike Ricci and his late Ming Italian and Portuguese cohorts, German, Belgian, and French Jesuits who came to China during the rise of the Manchus to power, such as Adam Schall, Ferdinand Verbiest, and Joachim Bouvet, focused on the imperial courts of the Shunzi and Kangxi emperors in Beijing to promote Catholic interests. They were there at a time when Chengzu Orthodox learning, which Ricci and his cohort had vigorously criticized as atheistic, again nourished as orthodox under imperial ideologists such as Li Guangdi. Many early Qing literati now blamed Wang Yangming and his late Ming followers, not Chengzu learning, for promoting empty scholarship that had helped bring the Ming to its knees. 72. From Wu Mingxian to Yang Guangxian, the Chinese Muslim Computus. Beginning in 1657, Adam Schall, director of the reconstituted Qing Astrocalendric Bureau since 1644, eliminated the Muslim section of the Bureau, although he maintained the other three sections for astrological interpretations, timekeeping, and calendrical matters. His appointment meant the Jesuits and their converts would take charge of the calendar, but it also meant that they would deal with the astrological applications of the calendar to determine auspicious days and choose propitious burial sites for the imperial family. Their technical prowess now extended into thornier aspects of Chinese culture and Manchu imperial politics, which drew on the calendar as a marker of dynastic legitimacy. 73 functionaries in the Muslim section had long been jealous of their Jesuit counterparts, but they were doubly upset when Schall was installed as bureau director and they lost their political inions in 1645. Because their eclipse predictions appeared in some cases to be less accurate than those of Schall using recently improved Ptolemaic methods, the inions of Muslims in the bureau now waned. The elimination of the Muslim bureau, LLED with hereditary astronomers since the Yuan dynasty, was intolerable to Muslims. Wu Mingxian, one of the Muslim hereditary functionaries, attacked Schall for allegedly making faulty predictions. When the charges proved wrong, Wu was jailed for false accusations. Upon his release from prison, Wu Mingxian and a Han Chinese collaborator, Yang Guangxian, together pursued an anti-Jesuit campaign. In the late Ming, Yang had submitted 2 memorials accusing officials of corruption and incompetence. One official had called for abolition of the civil service examinations, and the other was a grand secretary and an imperial favorite. Yang ambivalently took his coffin with him to Beijing in case his charges were not sustained. Yang's life was spared even though the charges 134 against the grand secretary proved unfounded, but the Ming court had Yang ogged and banished to the northeast. When the Ming fell in 1644, Yang was freed. By 1659 he was again in Beijing, when he joined Wu Mingxian to dislodge the Jesuits from their position of power and influence. 74 Beginning in 1659, Yang wrote several works attacking the Christians for their beliefs and assailing Schall for serious mistakes in the Western-inspired Qing calendar. Like many literati since Zhu Xi, Yang distrusted astronomical officials because their computational expertise was not tied to an understanding of the metaphysical workings of the cosmos. Unschooled in either European computational techniques or traditional mathematical astronomy, Yang colluded with the Muslim astronomer Wu Mingxian to craft his charges. Yang appropriated methods he gleaned from the classics and early dynastic histories, to which he added Muslim computations, to counter Ming techniques for intercalations and fortnightly periods that the Jesuits in the Astrocalendric Bureau continued. Jesuit methods for computing intercalations and fortnightly periods were not new. The Jesuits had not been very attentive to the day-to-day positions of these luminaries. Nor had their taconic cosmology fundamentally changed the Ming Bureau's computational procedures. They had only imposed revised Ptolemaic techniques for certain solar, lunar, and planetary phenomena. 75 Yang Guangxian's RST accusation against the Jesuits came in a 1660 memorial, which included his treatise on choosing an auspicious date. In it, he exposed an alleged error in the Jesuit calendar because the latter contained 3 fortnightly periods in the 12th month of 1661, which was impossible by traditional Chinese methods. Yang's charges were based on the different methods of calculation employed by each side to order the calendar. The antiquarian astronomy that literati such as Yang Guangxian learned divided the tropical year into 24 equal periods of a little over 15 days each. Since calendar months were either 29 or 30 days long, none could wholly contain 2 of these so-called solar fortnights. Usually parts of 3 overlapped, a point about which Yang was very confused. The Jesuits used instead the Yuan Ming system of 24 equal divisions of the sun's apparent path on the ecliptic. Because the sun's speed varied through the seasons, these apparent fortnights differed noticeably in length from the average. It was possible for 2 complete fortnights, and parts of 1 or even 2 more, to tea within a month. This any point did not matter, however. The receiving clerk rejected Yang's memorials outright because as a commoner he did have the privilege to submit them. 76 Yang's second attack began in early 1661. He also accused the Jesuits of a serious error in adding an intercalary month to that year. Without access to the official computational system they had used, Yang relied on Wu Mingxian's 135 Muslim technique to charge peremptorily that the Jesuits had selected the wrong month. The point was not purely technical. Like Yang's other charges, this one bore on many issues that gird in court debates such as the correct performance of ritual, siting of buildings and tombs, and astrology. Not only the technical work of the Jesuit-controlled Astrocalendrical Bureau, but the cultural and political value of its products, was at stake. 77. Overturning the Jesuit calendar in 1664. In spite of Yang Guangxian's and Wu Mingxian's efforts, Shaol and the Jesuits continued to enjoy the support of the Qing court until 1664. Moreover, the Jesuits successfully accused Yang of intrigues against the dynasty related to the just-started Ming history project. The charge was that a preface to Yang's anti-Christian essays by a relative referred to the Ming dynasty by a phrase that betrayed loyalty to it. Yang made a confession of error before the Ministry of Punishments. Yang Guangxian quickly struck back. Oboy and the other Manchu regents in charge of the government while the Kangxi emperor was too young to rule received Yang Guangxian's third memorial. The court nally called for an investigation of Yang's charges that the Jesuits were plotting rebellion and spreading heterodox doctrines among the people. Yang was aware of the success the Jesuits in the Eld were having converting among the common folk. Because Yang tied some recent inauspicious deaths in the imperial family to Shaol's divination to determine burial sites, the charges now caused a sensation in the imperial court. 78 Yang began by challenging the date chosen for the burial of an infant prince in 1658. The Shunzi emperor's concubine, who became the imperial honored consort in 1656, gave birth to a son on November 12, 1657, but he died unexpectedly after 3 months. Shaol, in charge of the Astrocalendric Bureau, was ordered to select an auspicious date for burial and to report it to the Bureau of Sacristies in the Ministry of Rites. The Chinese supervisor of the timekeeping section of the Astrocalendric Bureau determined a date based on the Great Plan's 5 phases tradition, which emphasized the sighting of the tomb rather than the date of birth of the prince. The Ministry of Rites then translated the time into Manchu and reported it to the emperor, but a Manchu clerk apparently mistranslated the correct time of the FTH double hour as the 7th double hour. 79 The timekeeping section protested this error, but the date had already been forwarded to the emperor, and the prince was buried at the wrong time. Because the imperial house considered it inauspicious, the supervisor of the 136 timekeeping section attacked the Ministry of Rites. In 1658, those officials responsible for the error were tried and dismissed from office, barely escaping the death penalty. Others were beaten. Scholl and the Jesuits were not implicated. When the Shunzi emperor and his empress died of smallpox in quick succession in 1661, however, his mother concocted a series of complaints alleging that the dead emperor had been critical of Han Chinese involvement in the government. Under the succeeding Kangxi emperor, his Manchu regents gradually diminished Scholl's influence. 80 Using his own treatise on choosing an auspicious date as a guide for deliberations on hemerology, Yang Guangxian's renewed attack on Scholl in 1664 charged that the year, month, day, and time had all been inauspicious for the burial of the young prince. Yang contended that the date should have been chosen on the basis of the prince's birth date by following the orthodox 5 phases method. He attacked as heterodox the Great Plan's 5 phases routine for sighting the tomb that the Bureau had used. In effect, Yang was accusing Scholl of purposely selecting an inauspicious day in 1658 for the burial of the prince so as to cast a deadly spell on the emperor and empress as the parents of the deceased child. 81 The political background for Yang Guangxian's use of hemerology and other esoteric techniques in his anti-Christian attacks makes it clear that the responsibility of the Astrocalendric Bureau for determining auspicious days was not lifted under the Jesuits, much to the dissatisfaction of those Jesuits in China who were opposed to astrology and hoped to Christianize imperial time. Longobardo, for example, had explained earthquakes in his 1626 interpretation of earthquakes as a warning from God when evil people outnumbered the good. Although Scholl claimed ignorance of Chinese prognostication methods, as the bureau director he had no choice about supervising their use. When other missionaries attacked him for allowing their practice, Scholl claimed that he was unifying the methods so that everyone would adhere to the same hemerological signs. 82 In 1645, for instance, Scholl had gone through the motions of submitting a report about the waiting for the qi procedures used by the Bureau to determine the onset of spring fortnightly period, whose precise timing was one of its charges. Waiting for the qi was a technique for measuring the Earth's qi emanations. By using a standard set of musical pitch pipes of graded lengths, whose ratios were used for weights and measures, the onset of the fortnightly periods could be measured. The procedures involved burying the set of pipes in a sealed chamber after laying them with light ashes. The ancients had believed that when the sun entered the second fortnightly period of any month, the Earth's qi, a seminal force, would rise and expel the ashes from the appropriate pipe. 83. 137. Ancient debates had discussed the correct location for the experiment, the quality of the soil, the selection of materials, and the placement of the pitch pipes. By the mid-Ming, the repeated experimental failures of this technique had led to skepticism. At the end of the Ming, Zhu Zaiyu, who had also made recommendations for calendar reform, published his Essentials of Musical Harmonics, in which he rejected the method as an incorrect elaboration of the methodology for investigating things and exhaustively mastering principles to extend knowledge. 84 Since the ritual of waiting for the qi was a bureau responsibility, Scholl could not prevent its becoming one of the principal issues in his confrontation with Yang Guangxian over its efficacy. When Yang brought his 1664 suit against the Jesuits, for example, the Jesuit attitude toward waiting for the qi became a focus of Yang's attacks. Yang accused Scholl of relying on his own calculations and ignoring the old system to determine the onset of spring. When Scholl replied that his predecessors in the Ming Astrocalendric Bureau had abandoned it, however, the court noted that he had earlier used it to ascertain the onset of spring. The Oboy regents were unhappy with Shaw's dissimulation, which made it uncertain that the timing of the onset of spring had really been varied with the old system. 85 Similarly, Shaw was in charge of the bureau when the Dalai Lama planned to visit Beijing in 1652. Prince Dorgan, one of the Manchu court ministers, initially had wanted the Shunzi emperor to meet the Dalai Lama at the border of the capital region and escort him to Beijing. Seeking to supplant the political and religious alliance between the Mongols and the Tibetans, Han metropolitan officials, however, were opposed to this arrangement. When the emperor announced he would go, some of the grand secretaries appealed to two astrological portents from the Astrocalendric Bureau to dissuade him. The planet Venus rivaled the brightness of the sun on the day before. A threatening meteor was sighted in the region of the pole star, which corresponded to the imperial court. Because of these signs, they argued, the emperor should send a high official to escort the Dalai Lama. This astrological intervention was successful, and the emperor cancelled his journey. Qing-Tibetan relations were not cemented until the 1690s when Kangxi Emperor personally led military campaigns against the Zhonghars, challenging their unions in Tibet. 86 Because portents had political implications, Shaw's bureau had obligingly supplied the grand secretaries with omens. Neither the daytime apparitions of Venus nor the meteor were rare phenomena. The rarer combination of the two within a day of each other was suspicious. Shaw's goal seems to have been to lower public esteem for Lamaism in order to promote Christianity. 138. Before the Dalai Lama arrived, for example, Shaw sent a memorial that sunspots had appeared as an alert to the court that the Dalai Lama was obscuring the emperor's radiance. Shaw had allied with the literati in the court who shared his reservations about the Dalai Lama's visit. 87 Shaw did not foresee that the intertwining of astronomy, waiting for the Qi tradition, and yin-yang numerology in telling fortunes and determining auspicious days might ensnare the Jesuit mission in a battle where astronomical competence would not be the key issue. Nor did he anticipate that the previously supportive Manchu court would respond to charges that the Jesuits and their converts were teaching that the Chinese and other Asian peoples were lineal descendants of the Hebrews after the Great Deluge. These claims suggested that the Jesuits were plotting against the dynasty. Noah and the Chinese. When Yang sent his 1664 memorial to the Ministry of Rites, he also attacked Shaw's Chinese disciples in the Astrocalendric Bureau, such as Li Xiubo, who had helped Shaw translate a work on the telescope in 1626. Yang alleged that Li's short history of Christianity in China, titled Overview of the Transmission of Heavenly Studies, was part of a missionary plot to foment revolt. The preface by the censor Su Zhejian, a 1655 Palace graduate, also implicated Su in the charges against Li. 88 Yang thus tied his accusations against Li Xiubo and Su Zhejian to Shaw's zing of an inauspicious day in 1658 for the burial of the infant prince to cast spells on the emperor and empress. Yang argued against a notion of an anthropomorphic god by appealing to heaven as the origin of all things and cited heaven's hexagram in the Change Classic as proof. There was no need for another ruler over heaven, Yang maintained, and he accused Christianity of being a byproduct of Buddhism. Because Li had also linked Fu Shi, the reputed ancient founder of Chinese writing and the RST sage king of Chinese history early in the 3rd millennium BC, to the history of Judea in the Bible, Yang concluded that Li's 1664 pamphlet on Christianity was heretical. Yang also attacked the absurdity of Christian beliefs in the virgin birth. 89 Jesuit-Chinese cooperation in mathematical astronomy was an exceptional accommodation project, which had obscured a larger clash between European universal time and history and the likewise universal cyclical chronology of Chinese ancient texts and historical accounts that might have preceded the Great Deluge associated with Noah. The chronologies based on the Hebrew Masoretic texts, for instance, dated the Ood to a time later than the dates of the early Chinese sage kings. Arch. 139. Bishop James Usher's famous chronology published in 1650-1654 gave 4004 BC as date of creation. By this reckoning the deluge occurred in 2348 BC, or 1656 years later, and thus far later than the reigns of Fuxi and other early Chinese sage kings for whom the Chinese had continuous records. The Latin Vulgate version of the Bible prepared in the 4th century had been based on Masoretic texts that were no longer extant. The Septuagint version, which was prior to the Latin Vulgate, had been based on a Greek version of the Old Testament from Alexandria. It dated the creation to 5200 BC, with the Ud in 2957 BC. This earlier date for creation allowed Christians in China and Europe to reconcile Noah's universal patriarchy after the deluge with Chinese records. Nevertheless, the Catholic Church refused to entertain an infinite, eternal, and possibly uncreated universe, a heterodox position that had cost Giordano Bruno his life. Yang Guangxian, like most Chinese literati, believed in a creationless universe. Because the chronology based on the Latin Vulgate caused problems for the Jesuits in China, they conveniently received papal permission to use the Greek Septuagint chronology instead, which allowed Chinese historical accounts to date after the universal Uds. The need to accommodate Chinese history with the Bible also entailed that the Christians identify the Chinese sage kings with Old Testament patriarchs. Once the chronologies were rected, the Jesuits could then correlate ancient Chinese history with the Old Testament. The Europeans thus had to make room for China in their universal histories, but they did so on their own universalist terms of time. 90 Michael Ryan has noted that the Europeans tended to understand other peoples and cultures in terms of biblical genealogies and timelines, thereby making new worlds into old worlds by reducing their uniqueness. Philippe Couplet's chronological tables, for example, dated the origins of Chinese history to the Yellow Emperor in 2697 BC. Curiously, the Chinese, with their own universalist pretensions, developed a similar strategy with no dates at all by asserting that the origins of Western learning were originally in China. Martinus Martini's 1654 History of China challenged European chronologies by accepting the Fuxi reign. Hence, Martini also preferred using the Septuagint chronology to place the Great Deluge in China before 3000 BC, although he was skeptical that the Chinese Ud in Yao's reign was the same as Noah's Ud. John Webb, on the other hand, drew from Martini's account to argue that Emperor Yao was in fact Noah. Others chose Noah's son Sem as the RST to get to China, while Athanasius Kircher chose Cham. 140. Kircher had already read into the Egyptian hieroglyphs esoteric truths about the world and God. In his 1667 magnum opus on China, Kircher accepted Fuxi as the originator of all writing and contended that the origins of Chinese pictographic writing were the same as Egyptian hieroglyphs. Webb in his heralded an historical essay endeavoring a probability that the language of the Empire of China is the primitive language maintained that the Chinese written language was fundamentally continuous with the Adamic language before the ancient languages diverged from an ancient purity. 91 Based on his studies under Adam Schall, Li Xiubo also linked early Chinese history with biblical time in his overview. The work, a collaborative effort involving several Jesuits working with Li, claimed, the RST Chinese really descended from the men of Judea who had come to the east from the west, and the teaching of heaven is therefore what they recalled. When they reproduced and reared their children and grandchildren, they taught their households the traditions of the family, and this is the time when this teaching came to China. 92 Li and others thus implied that the Chinese classics embodied the same primitive revelations as the Christian Bible. The biblical creation was described with traditional Chinese terminology, and heavenly learning was equated with biblical learning, which had been carried to China by the RST descendants of Adam and Eve. According to the overview, the founding Chinese sage, Fuxi, was one of these descendants. Because of the Qin dynasty book-burning policy, these teachings had been lost. The impetus for publishing Li's overview in 1664 came from Yang Guangxian's 1660 an exposure of heresy, which had attacked Schall as head of the Astrocalendric Bureau. Consequently, Li Xiubo's translation was a defense of Schall, as well as a restatement of early Qing Jesuit accommodation tactics on time and the calendar. Such claims infuriated Yang, who immediately wrote his anti-Christian diatribe, titled "I Cannot Do Otherwise." Yang argued at the outset, formerly Li Madao used the sacred Chinese classics and commentaries of the sages as texts to adorn his heterodox teachings. Today's Yuebo cites the sacred Chinese classics and commentaries of the sages as if they were passages from the scriptures of the heterodox teaching itself. Yuebo's crime deserves the greater punishment. Louis Bulieu wrote a rebuttal published in 1665, which led to his implication in Yang's charges against the Jesuits and their converts. Although the Jesuits eventually emerged victorious in 1667, the costs of this confrontation proved so high to the mission that they refrained from presenting this sort of biblical argument in favor of Christian time publicly in China thereafter. 93. 141. Yang Guangxian in charge. As a result of Yang Guangxian's third memorial and its litany of charges, Schall, Verbiest, and their Chinese colleagues were imprisoned and condemned to death. All Jesuits in the provinces were to be arrested and forwarded to Beijing. Despite an amnesty for the Jesuits following an earthquake on April 16, 1665, a day after their sentencing, VE of the Chinese Christian astronomers, including Li Zuobo, were executed. The Kangxi Emperor's Grand Empress Dowager had favored the amnesty because of Schall's past services and his poor health after a stroke while in prison. Jesuit errors were pardoned but not those of Li Zuobo and their Chinese collaborators. After 1664, the Sino-Western calendar was still used, but it was again complemented by the Ming Grand Concordance calendar. Moreover, the Muslim section of the Astrocalendric Bureau was restored, with Wu Mingxian back in charge. Although Western methods usually remain superior in predicting solar eclipses by from 15 to 30 minutes, this accuracy was not enough to rescue Schall, Verbiest, and Bulieu from Yang's cultural and political charges. In 1665, the Kangxi regents appointed Yang Guangxian director of the Astrocalendric Bureau despite his efforts to decline the position. 5 times he pleaded lack of knowledge of mathematical astronomy, though he was, he claimed, knowledgeable about calendrical principles. The court, however, held him to this task, and Yang was forced to put his ideas, such as they were, into practice. 94. With Wu Mingxian as associate director, Yang had the bureau set up a traditional calendar based on the onset of spring using calculations to be varied by waiting for the qi. They built a special chamber in front of Yang Guangxian's residence, but the waiting rituals failed. When the Kangxi Emperor took power from his regents in 1667, he remained concerned about astronomical irregularities and increasingly became involved in mathematical matters himself. In 1668, he asked Verbiest, who after Schall's death in 1666 became the Jesuits' chief spokesman, to review the calendar that Yang and Wu had prepared. In late 1668, Verbiest made a case that using reed pipes and yin ashes was no way to measure the 24 fortnightly periods of the year. Verbiest argued that the spring equinox was determined not by qi but the sun crossing the intersection of its orbit with the equator. According to Chinese convention, the equinox was not the beginning of spring but its midpoint. Astronomers deemed the fortnight onset of spring, which began the season, by its distance in space and time from the same intersection. Verbiest further asserted that the Earth's qi varied according to the sun's location so that rituals based on it could not yield consistent results. 95. 142. From December 27 to 29, 1668, the emperor demanded a prediction of the sun's position on the next day, which tested Yang Guangxian and the Muslim astronomers in the bureau who were allied with Yang against the Jesuits led by Verbiest. Given the methods that Yang Guangxian and Wu Mingxian used, Verbiest was able to itemize a series of errors in the Muslim approach, varied before the emperor by observations. Additional tests were called for, however, when Yang and Wu denied the accuracy of Verbiest's endings. Moving carefully as a young monarch in treacherous political waters, the Kangxi Emperor began to study mathematics and astronomy under Verbiest because he realized that the cultural legitimacy of the new dynasty was tied to a successful ephemerides. He also authorized the Jesuits to review the 1669 calendar prepared by Wu Mingxian. Yang Guangxian and Wu continued to appeal to the cultural conventions of the Chinese calendrical tradition, while Verbiest and the Jesuits asserted that what the emperor needed was an accurate calendar, best provided by the new Western methods. Verbiest again demonstrated many errors in Wu's calendar, due to misplacing the intercalary month and the fortnightly periods. 96 The emperor then convened a council of deliberative officials to measure 2 fortnightly periods, onset of spring and the onset of the rains. During these deliberations, the Jesuits also had to adjust their calculations. Verbiest, for example, changed his calculation of an intercalary month from the RST to the second month of 1670, prompting the Kangxi Emperor to correct the position of the intercalary month on Wu's 1669 calendar. In effect, the emperor endorsed Verbiest's calculations, expecting Jesuits to follow traditions associated with the cosmological and ritual aspects of the calendar. These court tests to measure the shadow of the sun relied on instruments calibrated to European methods. Although Jesuit predictions were slightly more accurate than Wu Mingxian's, they were based on obsolete methods, and far from exact either. To conclude that the tests were settled by imperial endorsement rather than accuracy, however, overdetermines the battle between Yang Guangxian and Shal as simply a struggle over the rules of the game. It was certainly in part an ideological skew, but in the end, when compared to their opponents, the Jesuits, despite some errors, were able to predict eclipses within minutes rather than within a quarter or half an hour of the Muslim methods. 97 When the deliberative council reported the Jesuits' endings were more accurate and proposed that the 1670 calendar should be prepared by them, the emperor accepted their recommendation. He was critical of the council, however, for not explaining why Yang Guangxian and Wu Mingxian had been declared right and Shal wrong in 1664 but not now. The Kangxi Emperor also demanded to know why Shal's methods were now acceptable. 143. When they were not before. To satisfy the emperor, Yang was thus found guilty by the council of making false accusations and was banished, but the emperor pardoned him because of his age. Yang apparently died on his way home. 98. Ferdinand Verbiest and the Kangxi Emperor. Verbiest's appointment as administrator of the calendar of the Bureau in 1670 restored the Jesuits to preeminence in the astrocalendric bureau. Wu Mingxian initially saved his position by switching sides and endorsing Verbiest's calculations, but in August 1670 Wu was ogged 40 strokes for his continued calendrical errors. Later, Verbiest presented the Kangxi Emperor with a 2,000-year calendar in 1678, which was called the Eternal Calendar to symbolize the longevity of the Qing dynasty. Earlier, Yang Guangxian had accused the Jesuits of preparing a 200-year calendar to symbolize a short reign. Verbiest also explained the difference between the Chinese lunar solar calendar's intercalary month and the Gregorian solar calendar's leap years. He also defended the Shunzi Emperor's use of Western methods to subtitle the new Qing calendar in 1645 by arguing that the Emperor not Shal was simply referring to the unique character of the new dynasty. Nevertheless, the Qing court retained the 3 main divisions of Chinese, Western, and Muslim sections in the bureau based on the Ming model. Only in 1725 were Jesuits again appointed as directors of the bureau, and only then with a Manchu counterpart. 99 Although the Kangxi Emperor allowed the missionaries to return from exile in Guangzhou in 1671, he refused their request to spread Christianity. He also ordered that Shal's phrase in accordance with new Western methods on the title page of the Qing calendar should be replaced by temporal model calendar. The late Ming collection of Jesuit mathematics and astronomy, titled Mathematical Astronomy of the Chongzhen Reign, which had been renamed by Shal in 1645, was reissued in 1669 as Mathematical Astronomy following new methods. The Qing government published the temporal model calendar with imperial authorization. It was distributed annually empire-wide and improved when French Jesuits helped the court in the 1720s update its translations of mathematical and astronomical works. 100. Failure of the Studies to Fathom Principles project. While director of the Astrocalendric Bureau, Ferdinand Verbiest collected all preceding Chinese translations of the commentaries on Aristotle by the J.E. 144. Suit University of Coimbra and called the result Studies to Exhaustively Master Principles. Verbiest started this project in 1678, perhaps to accompany his eternal calendar of 1678, which he presented on request to the Kangxi Emperor. The emperor seemed to show some interest in such a collection during his personal studies with Verbiest, when Verbiest presented the Studies to Fathom Principles as a complete repository of Western, that is, Catholic, scholastic philosophy, which he contended was the beginning point for astronomy and mathematical studies. 101 Tactically, Verbiest like Schall saw the calendar and astronomy as a means to imply the ultimate superiority of European philosophy. The sources of the Coimbra collection are unclear. About half seem to have come from De Logica, although Verbiest reworked this part without mentioning Alani or Les Hiseo, the original compilers. Verbiest added translations related to medicine, philosophy, and natural theology, that is, logic, the soul, the mind and brain, creation, etc., before submitting the book to the emperor. For example, Verbiest appropriated Schreck's translation of the Galenic account of the body, which elevated the importance of the brain for human memory and the perception of things. Because Chinese physicians believed that the heart was the center of cognition, this new medical claim embroiled the Studies to Fathom Principles in a major brouhaha that nipped Verbiest's clever plan in the bud. 102 The compendium was intended to explain European philosophy to the court as an ordered collectanea in Chinese of Aristotelian moral and natural studies. Verbiest's ambitious goal was to receive imperial permission to require such learning for the prestigious civil examinations. This, he dreamed, would lead the throne and literati to the Church and its divine law. It was a daring line of attack for the Catholic enterprise in Qing China, where millions of male candidates aimed their educations at the official examinations, the gateway to officialdom. Perhaps Verbiest had in mind complementing the 5 classics, 4 books, and orthodox Chengzu studies. Later, in 1767 the French Jesuit Alexandre de la Charme prepared his true and complete explanation of nature and principle to present a Catholic gloss on the official canon. The title mimicked the official Chengzu compendium titled Great Collection of Nature and Principle, orthodox since the early Ming. Verbiest's collectanea was intended to enrich the Chinese classical tradition with supplementary interpretations that would recreate the religious character of ancient China as a blend of Christianity and the Chinese classics. 103 In his October 1683 memorial that accompanied the presentation of the Studies to Fathom Principles collection to the Qing throne, Verbiest Con. 145. Tended that the study of European philosophy was the correct framework for the study of the calendar and astronomy. He stressed that the essential method of inference as taught by Aristotle to forecast principles was the foundation for all practical knowledge. In reply, the Kangxi Emperor strategically followed the advice of the Hanlin Academy and the Ministry of Rites, declining to publish the collection under imperial auspices. 104 The reason the Kangxi Emperor gave for his rejection was that his Chinese advisors considered it an inappropriate view of learning. His disapproval, dated December 1683, addressed Verbiest's work as Western Studies for Exhaustively Mastering Principles, thus pointing to its peripheral origins and its intellectual differences from native studies for mastering principles. Specifically, the Kangxi Emperor complained, "The style of the book is very perverse, erroneous, and illogical." The Manchu Grand Secretary Mingzu and others noted, saying that man's knowledge and memory belong to his brain completely contradicts the reality of principle. Because Chinese literati believed that the heart-mind is the ruler of intelligence, they rejected Verbiest's notion that all knowledge and memory is located not in the heart but in the brain. 105 This imperial position accurately rected the priority of the heart-mind over the brain in Chinese classical thought and medicine. Mencius, for example, had given priority to the heart-mind in thinking. The organs of hearing and sight are unable to think and can be misled by external things. When one thing acts on another, all it does is to attract it. The organ of the heart can think. But it will nd the answer only if it does think, otherwise, it will not nd the answer. In the 16th century, however, the physician Li Shizhen had already argued that the brain was an important organ for conscious life, as had other late Ming physicians. 106 According to Idunanspot, S.J., the Lithuanian compiler of the history of Jesuit mission circa 1700, ministers in the Hanlin Academy and Ministry of Rites, some likely recalling the Yang Guangxian era, had recognized Verbiest's strategy of disguising Christianity in the dress of dialectics and philosophy. The Kangxi Emperor could not act against the advice of his Chinese officials despite his personal friendship with Verbiest. Nor could the emperor unilaterally change the core classical curriculum of civil examinations. The Studies to Fathom Principles collection that Verbiest had labored on was returned to him and never published. Much of it was later lost. 107 Moreover, at the time the Studies to Fathom Principles was provoking such an interesting response about the brain from the Ministry of Rites, a Muslim scholar Lu Ji was working on a treatise that when published in 1704 was titled The Arabic Discourse on Nature and Principle. In it Lu indicated that the brain integrated various perceptions. Lu. 146. One of the Islamic scholars involved in the Su-inspired Han Kitab project used to revive Muslim high culture in the Yangtze Delta, held that the brain coordinated all the sense organs. Lu, like Verbiest, was likely building on Galen's refutation of Aristotle's view that the heart was the ruling organ, which also contributed to the eclectic Muslim view of the brain's centrality. Lu added that Chinese literati had wrongly maintained the heart-mind as the venue for intelligence. This fascinating difference of medical views among Chinese, Jesuits, and Muslim Chinese over the role of the brain may have paralleled their interactions concerning the calendar and astronomy. 108 This medical difference between Qing officials and the Jesuit missionaries over the location of human agency in humans revealed deep political waters. In a February 1685 letter, Verbiest did not appeal to East-West incommensurability as the cause of his failure. Instead he bitterly pointed to a breakdown in the accommodation process. Our philosophy cannot be published, because the rabbis had convinced the emperor that the fundamentals of the Christian learning were embedded in it. The emperor, however, still sent an aide to study Aristotelian philosophy with Verbiest in private, perhaps to assuage the latter. In addition, Verbiest was widely cited and read by Qing literati, some of whom were interested in his Christian teachings, such as Wang Honghan, and others who were interested in his sciences such as Li Guangdi and Mei Wending. The latter assimilated Verbiest's contributions in mathematics and astronomy into Chinese traditions for investigating things and fathoming principles. Verbiest's astronomical corpus in China was also influential in Europe. 109 We will see that the Kangxi Emperor also relied on Verbiest and the Jesuits to mediate between the Qing and Russian empires when their geographic borders expanded in the 1670s and 1680s. There were other signs, however, that Verbiest's power on the whole was limited to the Astrocalendric Bureau. In 1673 another attack on the Jesuits' methods had come from Yang Jingnan, a commoner from Suzhou, who had assisted Yang Guangxian earlier. Yang Jingnan also accused the Jesuits of errors in their official calculations. The Kangxi Emperor realized that the charges were still predicated on the unpromising waiting for the Qi procedures, which he considered unreliable. In 1681, when the divination for a tomb was disputed, the Kangxi Emperor again intervened. He charged that in this eld of learning there were no denotive endings, just fabrications by officials to suit their purposes. Similarly, Zhang Yangjing's efforts to discredit European astronomy by petitioning for a restoration of native methods for computing calendars based on ancient cosmology fell on deaf ears in the late 17th century. NEV 147. Nevertheless, in 1685 the emperor authorized compilation of an imperial manual of hemorrhagy as the single standard. In 1741, the Qianlong emperor ordered the bureau to produce a new guide for hemorrhagy that approved the approach that both Yang Guangxian and Wu Mingxian had used to assail Shaw and his staff in 1664. 110 After 1670, the Jesuits depended almost exclusively on Manchu imperial patronage and not on the support of Chinese literati. The opposite had been the case in the late Ming, when Su Guangqi and Li Zhizhao had been the order's stalwarts and sanctioned the quest for converts. Literati leaders turned toward evidential studies in the 18th century recognized the importance of European studies, particularly mathematics and astronomy, but they remained suspicious of the Jesuits' motives in coming to China. While the Jesuits immortalized Yang Guangxian as a bigot and xenophobe in their accounts of the China mission, Yang's works were highly praised by tier-8 critical scholars such as Qian Daxin and Dai Zhen for attacking Christian teachings in the name of China's imperial honor. Jesuit historians have claimed that Dai even accused Christians of paying high prices for Yang's works in order to burn them. 111 Moreover, Yang's belief that the Jesuits were part of a European plan to invade and conquer China resonated in the 19th century when Protestants rather than Catholics looked to China to spread a Christian agenda via science and medicine. These fears had been voiced in a late Ming collection compiled by Su Chenzi called the Collection Exposing Heterodoxy, printed in 1639, which included literati and Buddhist monks' attacks on Christianity dating from the 1616 to 1617 persecutions initiated by Shenke. Indeed, the Polish Jesuit Michael Piotr-Boym had called for a European invasion of China after the fall of the Ming. Later several anti-Christian sequels were prepared in the late 19th century to attack the Protestants in China. 112 When, after the rites controversy, the Jesuits lost the support of their last major patron, the Kangxi Emperor, their chief operational venue remained the Astrocalendric Bureau, where Indian and Persian astronomers in the Tang and Muslim calendricists in the Yuan and Ming had also been successfully sealed off from the rest of Chinese state and society. Because German and French Jesuits were increasingly tied to the emperor, his court, or the bureaucracy, rather than to provincial literati, they were now directly subject to dynastic power. The imperial politics of high risk and high gain, such as the 1667 calendar controversy, almost wrecked the Catholic mission in China. Besides controlling the Astrocalendric Bureau, Jesuits also served the throne as cartographers, clockmakers, architects, glassmakers, and optical lens mak. 148. ERS. The last European to serve in the Bureau, the Lazarist Montero de Sira, resigned in 1826, and the post reserved for a foreigner was then eliminated. 113. Li Guangdi's part in supporting Chinese specialists in mathematical astronomy in the Kangxi court was particularly significant. Literati scholars who were part of this group served the Kangxi emperor in his private quarters, where they helped compile in the 1720s the mathematical and astronomy treatises that superseded the late Ming translations prepared under the auspices of Su Guangqi. Mei Wending had helped to train many of them. By the time Li Guangdi introduced him to the Kangxi emperor in 1705, Mei already had the reputation of a polymath who had mastered both traditional Chinese mathematical astronomy and the new learning introduced by the Jesuits. 114 Mei Wending and his successors contended that study of natural phenomena gave classical scholars access to the principles undergirding reality. In essence, Mei saw Jesuit learning as a way to boost the numerical aspects of Chengzu moral and metaphysical principles. At the same time, however, the imperial court and Mei Wending prepared preliminary accounts stressing the native Chinese origins of European natural studies. 115 Mei's view of the history of mathematics combined aspects of both song learning and evidential studies. In many ways, his own research represented a transition from Chengzu learning to ancient learning. Such native origins made it imperative for Mei to rehabilitate and restore to their former glory the native traditions in the mathematical sciences. 116. 149. The limits of Western learning in the early 18th century. 4. When Michel Benoist belatedly introduced a brief but accurate account of Copernican cosmology in China after the Church's ban ended in 1757, the Jesuit Society was still defending obsolete counter-Reformation scientific orthodoxy. Anti-Jesuit polemics generated by the Jansenists led to suppression of the order, RST in Portugal in 1759 and then by France, Spain, Naples, and Parma, before the Pope dissolved the order worldwide in 1773. China's window on continental Europe and Europe's window on China were shattered by forces internal to both European and Chinese history. Benoist apparently died of a stroke or grief upon hearing in 1774 that the order had been suppressed. As Jesuit Indians in the court faltered, Manchu emperors increasingly patronized their own imperial mathematicians, whom they relied on to lessen the dynasty's dependence on foreign experts for astronomical precision. The lowly social status of the native mathematicians who emerged during the Ming-Qing transition changed dramatically after 1700 when they were increasingly patronized by Han Chinese literati officials close to the Kangxi Emperor. Mei Wending in particular emerged as a native mathematician who could challenge the credibility of the Jesuits in the Astrocalendric Bureau and at court. In turn, the emperor enhanced Mei's astronomical credibility empire-wide by according him unprecedented honor as a model for court mathematicians. The social standing of literati mathematicians during the 18th century rose dramatically. 2. The Kangxi Emperor and Mei Wending. After dealing with his regents in the 1660s, the Kangxi Emperor recognized the need for astronomical and mathematical expertise in court and in the bureaucracy. Although the Ming had banned public knowledge of Computa 150-tional astronomy and astrology in order to monopolize it in the Astrocalendric Bureau, the Kangxi Emperor initially opened them for official study by appropriate Han officials and trustworthy Manchu bannermen. His goal in part was to lessen the hold of the Bureau's hereditary Han and Muslim families on the transmission of mathematical astronomy by encouraging learning among official students from the 8 Manchu military banners. He also faced the monopoly of entrenched Catholic converts in the Bureau. 3. The court increasingly patronized mathematics to counter the Jesuit monopoly of European studies. Manchu openness to Western learning when compared to the late Ming should not be overstated, but the early Qing emperors prioritized such studies more than late Ming rulers. Court patronage meant that official mathematics was no longer under the sole purview of the Astrocalendric Bureau or its hereditary officials. 4. The Qing Bureau also had more students than the Ming Bureau, although the same eldes of study remained in place. In 1644 the Bureau had 66 Chinese students. By 1666, the number increased to 94 studying astrology and mathematics. Banner students of mathematics had 3 choices for careers: they could be added to the Bureau's students, they could participate in the provincial examinations and become generalist officials, and they could become instructors. Because the Bureau employed more students in astrology than in mathematics, the annual quotas were 6 astrology students from the Qing banners and 4 from the Han banners. Nevertheless, 66 such places for Han students of astrology remained, which the emperor increased to 160 in 1666. In 1675 the quotas for banner students of astrology decreased to 24, while the Han quota of 80 also decreased. Students of mathematics were given a better chance than astrologists for careers outside the Bureau, especially those the emperor chose as his court mathematicians. Because the bannermen regarded civil examinations and mathematical training as secondary and complementary to their primary military skills, however, their mathematical achievements were limited. The Qianlong Emperor stopped bannermen from training in mathematics in 1738. 5. The Yang-Guangxian affair had interrupted the Kangxi Emperor's youthful studies under Ferdinand Verbiest. When several French Jesuits arrived in Beijing in 1689, the emperor began a second period of learning European mathematics and astronomy. The French used the Manchu language to instruct the emperor in the newer Western learning they brought. They also assisted the Qing dynasty in its 1689 negotiations with the Russians that would culminate with the Treaty of Kiektá, delimiting the border between the Manchu and Russian empires. Enjoying the favor of the emperor, the French Jesuits prospered when the Kangxi Emperor lifted the ban on proselytization in 151. 1692 in 1693, after the French Jesuits cured the emperor's bout with malaria by administering Jesuit bark, he asked Bouvet to invite other Jesuits to come from Europe to China to serve him. 6. The interactions with the French Jesuits in court produced several outstanding native mathematicians, such as Minggetu, a Mongol bannerman, who had remained a lowly licentiate in the examination hierarchy. In his quick trigonometric methods for obtaining the precise ratio for divisions of the circle, Minggetu elaborated on Peter Jartua's work on the geometric power series expansion of trigonometric functions. Minggetu used the method of ending the chord to know the arc and added 6 procedures to Jartua's original 3. Such studies, which reformulated the traditional algebraic craft of dividing a circle, were carried on by his son and disciples. One of the latter, Chen Jixin, worked in the Astrocalendric Bureau and continued Minggetu's work on trigonometric methods, as did Zhang Gong. 7. The manner in which the Jesuits introduced European mathematics determined how Chinese literati would assimilate it. In contrast to Euclidean geometry, which the Jesuits and their literati informants adapted more or less in its entirety, Minggetu and others reinterpreted the power series in light of the Chinese system of calculations. Jartu, who arrived in China in 1701, failed to present the roots of the series giving, the power series expansions of the sine, or the verse sine functions in the contemporary calculus of Newton and Leibniz. Although developed in the late 17th century and expanded in the 18th, these were not introduced to China until the 19th century. 8. The Kangxi Emperor's private sessions with the French Jesuits included training in surveying, mensuration, calculating, astronomy, geometry, and logical argument. The source for their lectures on Euclid's Elements, for example, was a French edition of I.G. Pardi's Elements de Géométrie, which the Jesuits and their Manchu aides translated into Manchu. Later, using Jean-François Gerbillin's lectures at the Kangxi court, they translated Pardi's version of the Elements into Chinese. The emperor's court mathematicians included this version in the new official mathematical collection, which effectively replaced the incomplete version of the Elements by Ricci and Su Guangqi at court and among literati. The French geometry gave different proofs from the Ricci-Su translation. 9. Besides Li Guangdi and Mei Wending, Wang Zikin and Xue Fengzhuo were also Kangxi-era students of mathematics and computational astronomy. Xue worked as an obscure Christian disciple of Smogulecki to better predict lunar and solar eclipses. Du Zhijian, like Fang Zhongtong, a Ming loyalist and the polymath Fang Yazi's II. 152. Sun, tried to integrate Chinese and European mathematics. Du tried to create a unit system based on the computational methods in 9 chapters, one of the 10 mathematical classics. Du also wrote the abridgment of the Elements in 1700, which left the basic structure intact. Aware of those literati who shared his passion for mathematics, Mei Wending admired Du's mathematics and Yuan Shilong's work on equations. He was also familiar with Wang Zikin's work, although they never met. 10. Fang Zhongtong compiled a summary of mathematics early in the dynasty, but because of his father's Ming loyalist sentiments the work was not published until 1721. It presented a preliminary discussion of musical harmonics and numbers and a treatise on Euclid based on Ricci's and Su Guangqi's partial translation of the Elements. Fang also discussed written calculations, using the abacus for computation, and Napier's rods for mechanically multiplying, dividing, and taking square and cubic roots of numbers. Like Du Zhijian, Fang believed that European mathematics derived from ancient Chinese mathematical classics, particularly procedures for measurement based on the relational features for the sides of a right-angled triangle, that is, a kind of trigonometry. 11. Mei Wending was so honored by the emperor that later accounts have tended to overlook the above-mentioned Qing students of Chinese and European mathematical astronomy with whom he interacted. Wang Zikin's work remained in manuscript form, for example, and never had the impact of Mei's publications. Like the others, however, Mei Wending's mathematical career might have gone unheralded. His father and grandfather had been book collectors interested in the change classic and numerology. Ming loyalists, they kept their distance from the Manchu regime. In addition, although Mei recognized the value of Jesuit learning, he was leery of Christian Indians in the Astrocalendric Bureau. 12 As a youth, May studied astrology and mathematical astronomy along with the classics and histories. When he came to Beijing for the 1666 Capital Region examination at the age of 33 Sui, which he failed, he acquired several books on European mathematical astronomy. From 1669 to 1678, May met Fang Zhongtong 4 times in Nanjing when May and Fang took the provincial examinations. May used the time to collect books on astronomy and mathematics. While in Nanjing in 1675, for instance, May located works on logarithms of trigonometric functions and celestial motions by Smogulecki and Xuefengzhuo. By 1675, he had also seen works from the mathematical astronomy of the Chongzhen. 153. Reigned Collectania and thus had access to much of the mathematical toolkit introduced by the Jesuit mission. In 1678, May met the famous book collector Huang Yuji and obtained a copy of the seminal Computational Methods in 9 chapters, which although a mathematical classic was by then hard to come by in its complete form. 13 As a result, a friend recommended May to work on the calendrical treatise for the official Ming history project initiated in 1679. May corrected the chapter on the calendar in the Ming history and prepared a draft of the calendrical treatise. May also met with Prospero Intercetta in Hangzhou in 1688 to discuss mathematical astronomy before proceeding on to Beijing a second time in 1689, perhaps to meet with Verbiest, whose death in 1688 had dashed that hope. While there, May met Li Guangdi and received the latter's patronage for the 4 years May remained in the capital. When Li Guangdi printed 9 of May's works on mathematics in 1701, May became an acknowledged expert on European and classical mathematical astronomy, whom the Jesuits regarded with suspicion. 14 During the emperor's southern tour in 1702, Li Guangdi presented the Kangxi emperor with a copy of May Wending's Queries on Mathematical Astronomy, which was written in the 1690s when May stayed in Li's Beijing residence. Li hoped that the emperor would be pleased with May's talents at a time when the rights controversy was beginning to force the court to recognize the limitations in relying on the Jesuits for astronomical and mathematical expertise. After reading the work, the emperor was impressed, although he noted, perhaps after consulting his French Jesuit minions, that it had too few problems to solve. 15 Later in 1705, when the Kangxi emperor again traveled south, he asked to meet with May Wending. For 3 days, the emperor and May apparently discussed mathematical astronomy on the imperial barge, and the emperor was impressed that he had a native scholar who was as knowledgeable as the Jesuits, which might enable his court to rely less on the latter. May presented the emperor with a copy of his new work on trigonometry, which Li Guangdi had published. When the Jesuits proved to be unreliable intermediaries with the Catholic Pope, the Kangxi Emperor's discovery of May Wending and other Chinese mathematicians was timely. Moreover, May's efforts to reconcile Chinese and European mathematical astronomy appealed to the emperor because it legitimated both traditions. In a preface for a work titled Mastering Chinese and Western Mathematical Calculations Comprehensively, May wrote, "During the Wanli period, Master Li entered China, and began promoting the study of determining quantities. 154. Which took points, lines, surfaces, and solids as the basis for measurement. He constructed instruments and prepared maps that were all the epitome of accuracy. However, his books were limited by the precision of the translations. Because they contained many sections, it was difficult to navigate through them. The style was rambling and LLED with tries, making it difficult for the reader to complete the work. Moreover, they made Jesus into a religion, which was odd for literati. Those who studied their teachings tended to overly praise them. They never took time to inquire deeply into the origins and vicissitudes of Chinese calculation. They precipitously passed on the shallow techniques of their day and referred to them as the culmination of the ancient 9 chapters. Consequently, they slighted ancient methods as not worth taking seriously. Moreover, others who clung vacuously to ancient gleanings attacked Westerners for their heterodoxy. Both schools of thought are separated by a wide chasm because of the extremes of scholars. In my seeking the way to scholarly learning, I have sought to master them comprehensively, and no more. If others are more comprehensive than I, then they have successfully closed the distance between the ancients and moderns. What distance then remains between China and the West? 16. May's unstated contrast between Su Guangqi's over-enthusiastic support of European learning in the 1630s and Yang Guangxian's foolhardy anti-foreign xenophobia in the 1660s were presented as false choices for the emperor and literati to eschew in mastering mathematical astronomy. After meeting with the emperor, May prepared his supplement to the queries on mathematical astronomy, in which he appealed to the Chinese origins of Western computational astronomy to mediate between those who championed European methods and those who defended traditional approaches. For instance, in his discussion of the vaulted heavens cosmology mentioned in the Gnomon of the Zhou dynasty and Classic of Computations, May traced this ancient model back to its classical alternative, the spherical heavens cosmology. In this way, he affirmed the celestial sphere in terms of classical mathematical astronomy. In May's view, although the vaulted heavens cosmology had not confirmed the sphericity of the Earth, the celestial phenomena in the southern hemisphere could be derived from the same computational procedures used to demarcate the northern hemisphere. 17. Despite such ecumenism, the Kangxi Emperor began in 1689 to enunciate an official view that suggested European studies were derived from ancient China, a traditionalistic view that unexpectedly was reinforced by the M155 Paris studies of European mathematics under Bouvet and Gerbilin. The latter used ancient precedents in China to justify such learning. Later, May uttered the emperor by attributing this view to His Majesty. Further rend, the new approach would yield in the late 17th century the second stage of a claim that Western learning had its origins in China. 18. Thereafter, the prominence of the May family in Qing mathematics was widely recognized. May Wending's two brothers were also well versed. Although May's son died early, he was also trained in mathematics, which May's grandson, May Zhuoxian, continued. The latter became a prominent member of the Kangxi, Yongzheng, and Qianlong courts in the 18th century. May Zhuoxian's sons also mastered mathematics. The Kangxi Emperor confirmed the May family's eminence by declaring Zhuoxian an imperial school student in 1712, granting him a provincial degree in 1713, and the highest degree as a palace graduate in mathematics in 1715. May was allowed to take the palace examination without taking the preliminary metropolitan examination. 19. The mathematical and astronomical content of May Wending's works. May Wending's RST work, The Superfluous Observations on Mathematical Astronomy, was about the strengths and weaknesses of Yuan and Ming calendars. On simultaneous linear equations rehabilitated ancient Chinese techniques for solving linear equations, which were later incorporated into the imperially instituted Treasury of Mathematics. In May's view, the algebraic techniques the Jesuits introduced were foreshadowed in earlier Chinese works. 20. May's impression was plausible because the Jesuits had devised a simplified algebraic system for the Chinese that permitted only polynomials using one unknown with numerical coefficients, which was called borrowing of roots and powers. In practical terms, Jesuit algebra was not superior to Songyuan techniques, which could solve polynomials of higher degrees and with multiple variables. The latter had remained a craft stressing the results more than the formal process. The French Jesuit Antoine Thomas later prepared Qing translations of more advanced arithmetic and algebra for the Kangxi Emperor. 21. May's goal was to synthesize calculating techniques and methods of measurement into a unit mathematics. Unlike Fang Zhongtong, who reduced European 156 mathematics to the ancient Chinese mathematical classics, May sought to rehabilitate traditional mathematics. In addition, he never denigrated what the Jesuits introduced because he recognized the limitations of traditional methods for solving problems in mathematical astronomy. He sought to use European achievements to advance traditional techniques, now reinvigorated with logarithms and trigonometry. In the late 18th century, This approach climaxed with the rehabilitation of the 10 mathematical classics. 22 In mathematical astronomy, May sought a synthesis between traditional approaches and European methods that would make them commensurable. He built on Wangzuocan's studies, which had criticized the division since the Song dynasty between scholarly and specialized calendrics. For both Wang and May, this split had prevented interaction between literati scholars and bureau specialists. Literati did not understand calculations, and specialists lacked knowledge of principles. The result was poor understanding of mathematical astronomy and little innovation. 23 Wangzuocan had earlier criticized some aspects of Western methods but took its practical applications as improvements on Chinese methods. Wang's reaction to late Ming calendar reform was also critical, but in general he followed Jesuit writings on the movement of the VE planets. In addition, Wang prepared a critical overhaul of the tectonic system, which Mei Wending saw as an effort to ameliorate the European and Chinese systems. To work out the calendar, Wang and Mei had shifted from the numerical procedures of the Chinese computers to geometric models of successive locations of celestial bodies in space. Each realized that, unlike traditional numerical procedures, the mathematical models associated with the tectonic world system enabled them to explain as well as predict celestial phenomena. 24 Wang was also critical of the separation between classical studies and mathematical learning. He regarded Su Guangqi's late Ming calendrical reform as too practical-minded. Through the selective reception of European methods, Wang sought to rescue the traditional system. He challenged the newness of foreign methods by suggesting Chinese precedents. In a 1693 work, Mei Wending emphasized the cumulative development of astronomy and its improved precision, which encompassed both European and Chinese methods. Hence, he agreed with Su Guangqi's efforts to amalgamate European methods within the traditional system. Mei's work influenced Li Guangdi and through Li the Kangxi emperor, who sought to ensure there would be an emerging pool of native talent in mathematical astronomy during his reign. 25 Moreover, Wang's and Mei's accommodative approaches to the new computational astronomy encouraged the court to avoid the fatal choice of either returning to outdated Chinese or Muslim computational methods, an approach that was bankrupt after the Yang Guangxian ASCO, or replacing Qi 157. Nessa astronomy with that of Catholic Europe as the Jesuits wished. Mei Wending, for example, demarcated the cultural versus technical aspects of calendar making. For the latter, he commended European methods for dividing the celestial sphere into 360 degrees rather than the more cumbersome 365.2425 do. He also defended a spherical Earth in the face of a classical tradition that assumed the Earth was square. Mei stripped European techniques of their Jesuit cultural and religious accoutrements and harvested them for their skeletal efficacy. 26 With regard to Chinese cultural features, however, Mei acknowledged that the Chinese method for dividing up the year into 24 fortnights and inserting an intercalary month best suited the imperial calendar. Adopting purely European methods would require doing without the cultural import of Chinese festivals, auspicious and inauspicious days, and the lunisolar calendar on which all rituals were based. If it was a matter of cultural rather than technical proficiency, Mei came down on the side of maintaining Chinese ways. The Jesuit computers could be assimilated to the imperial calendrical tradition, just as the Indian and Muslim computers were. 27 Mei Wending's stress on the accumulated authority of astronomy had a long pedigree in China, although he based his views on the accrual of observational data in both China and Europe, and maintained that European input to Chinese developments was justified. For instance, Mei outlined the development of astronomy from Ptolemy to Brahe and stressed the role of the telescope in improving on Brahe's observations. New information, such as Kepler's laws and Newton's improved methods for predicting eclipses, were later adopted in the supplement to the Compendium of Observational and Computational Astronomy by Ignatius Kogler and André Pereira, with the help of Mei Juetian and He Song. The new computers stabilized eclipse prediction until the end of the dynasty. 28 Mei favored a quantitative approach to dealing with astronomical principles. Computations for grasping heavenly phenomena permitted numbers and principles to be linked. Someone might ask Master May, is mathematical astronomy a matter of concern for the classical scholar? I reply, of course. I have heard that it is the classical scholar who masters the comprehensiveness of heaven, earth, and humans. Is it permissible to be enveloped by but not know the height of the heavens? He might ask, the scholar in knowing heaven knows only its principles. What use does he have of astronomy? I reply, mathematical astronomy requires numbers. Outside of the numbers there are no principles. 158. And outside of the principles there are no numbers. Numbers are the orderly demarcation of principles. Numbers cannot be spoken of arbitrarily, but principles at times can be talked about via vague images. Hence, arbitrary views have been associated, which have deluded the people and brought chaos to heaven's regularity. All this results from not obtaining the true principles and numbers and instead maliciously overturning reality. 29. For May it was permissible to ban private astrology as long as scholars mastered mathematical astronomy, which would allow increased precision in the calendar. May Wending appreciated the link between computational astronomy and the new instruments Verbiest had built. Problems in measurement that had remained unresolved despite earlier progress, if properly conceptualized, could be solved. 30. In May's view, the cumulative development of European methods was analogous to those in China. Because the two were parallel, they could be united. European learning demonstrated that the prediction of eclipses required knowledge of the time and position of objects in space, which it had developed beyond the limits of traditional calculation. Equivalent developments in Europe and China demonstrated that the two traditions were commensurable. For example, May noted that Guo Xiaojing during the Yuan dynasty had preceded Tycho Brahe in recording regularly the positions of planets. 31. May regarded geometry as the most systematic aspect of European studies and the root of its mathematics. He was upset, however, that Ricci and Su had only translated the RST 6 of 15 chapters of Euclid. May prepared his Essentials of Geometry as a commentary on Euclid's chapters. In a second work, May prepared the appended sections on determining quantities, which he regarded as a supplement to the Su-Ricci translation of the elements. There May attempted to reconstruct the parts of Euclid that Ricci and Su had not translated by looking for possible hints in translations from the late Ming. Although he perceived geometry as an outgrowth of traditional mathematics, May Wending acknowledged that European spherical geometry provided new universals that even the ancient sages did not anticipate. May explained geometry by using traditional solutions for the sides of a right triangle. His interest in geometry was selective, but his approach to computational astronomy was thoroughly geometrical. He seems to have thought that Euclid could be reduced to traditional mathematics. May Wending was the RST to explicitly use the traditional term for determining quantities to mean geometry. In addition, May used trigonometry to apply the equivalent of spherical geometry, which he regarded as a 159. Simplification of traditional methods for transforming equatorial to ecliptic coordinates, etc. His writings on Napier's bones and the proportional compass argued that the new calculating devices developed by Napier and Galileo were essential aids for computational astronomy. May tied them to traditional counting rods and the late Ming use of logarithms. 32. When his grandson compiled May's collected works in 1761, 40 years after his death, May Wending was recognized as the leading Litteratus who had mastered all the eldes of European mathematics introduced to China. Moreover, his complete works on mathematical astronomy, actually not a complete collection, became the starting point for subsequent efforts until 1850 to reinvigorate traditional methods with the sophistication of new European approaches. Robert Morrison of the London Missionary Society, for example, had May Wending's complete collection on mathematical astronomy in his library. 33. Although he had rehabilitated ancient Chinese techniques, May was unable to locate all of the works included in the 10 mathematical classics because many were not widely available. While mid-Qing evidential research scholars included mathematics in their classical eldes of interest as a result of May Wending's ignorance, none of them followed up on later European mathematics. That was inevitable, for new developments such as the kinematic solutions and moving models of Newton's axial calculus and Leibniz's infinitesimal calculus, which directly linked time and motion, were not transmitted to China in the 18th century. May and his successors had only the static, essentialist geometry of Euclid and the qualitative motions of Aristotle to work from. 34 May's and the Jesuits' mathematical astronomy survived in 18th century classical studies through Zhang Yang, Dai Zhen, and Qian Daxin, who wrote on computational astronomy. When evidential research scholars after Mei Juetian rediscovered the Song single unknown craft of algebra, they had no reasons for preferring the more formulaic Renaissance science of algebra and ignored it on nativist grounds in favor of Chinese techniques. Nevertheless, May's canonization by the Kangxi Emperor was responsible for the change in status of mathematical studies during the Qianlong era. 35. The rights controversy and its legacy. The celebrity Mei Wending achieved in 1704 via promotion of his mathematical studies by the Kangxi Emperor occurred when the political situation of the Jesuits in the Qing court decisively changed. The French Jesuit John 160. Baptiste de Fontenay noted at the time, for instance, that the emperor was no longer as interested in European mathematics as before. Several months after the emperor and May met during the emperor's southern tour, the Chinese rights and term controversy challenged Jesuit claims that Qing subjects who adopted Christianity did not have to reject cultural practices such as ancestor worship. 36 The Jesuits believed that Chinese names for God and the rituals converts used to honor their ancestors were acceptable. Ricci and his followers, with misgivings from some such as Longobardo in 1615, thought Chinese rites for ancestors were of social and moral significance, but that they did not compromise an individual's belief in the Christian God. Because of the rites controversy, the theological battles among the Jesuit, Franciscan, Dominican, and Augustinian orders in Rome exceeded its papal guidelines. A chill ensued in imperial and literati attitudes toward the Jesuits and their missionary work in China. 37 A papal legate sent to Beijing by 1705 announced that the Church had ended the Jesuit policy of accommodating Chinese rituals and their names for God. This action began the decline of the Catholic mission in Qing China and echoed ominously Yang Guangxian's view of the Jesuits in the 1660s as treacherous foreign agents. As a result, the Kangxi Emperor overturned his Edict of Toleration for Christianity issued in 1692. In the late 18th century, classical scholars rehabilitated and praised Yang Guangxian for his cultural astuteness while they, like Mei Wending, dismissed his ignorant views of astronomy and the calendar. Qian Daxin, for example, praised Yang for his attack on Christianity in his colophon for the 1799 reissuing of Yang's I Cannot Do Otherwise. Mr. Yang was not an expert of calculation, nor did he have adequate help. Therefore, in the end he had to give up. However, he denounced Jesus's heterodox religion and prevented its diffusion, and this cannot be anything but meritorious for renowned doctrines. In the judgment of posterity, then, Yang's merit lay more in his opposition to Christianity than in his opposition to Western studies. 38. The breakdown of Jesuit consensus in China. Conics among Catholic missions worldwide were exacerbated by long-standing competition between Spain, which sponsored the Dominicans, Franciscans, and Augustinians, and Portugal, which trained and sent the Jesuits abroad. Later, French Jesuits would be justly accused by the German Jesuit Kilian Stumpf and the Portuguese in the Astrocalendric. 161. Bureau of trying to glorify French science. Each denomination had followed different strategies to convert the peoples of the world and please their patrons. Initially, the better educated and more urbane Jesuits were able to put in place an accommodation policy to facilitate their dealings with knowledgeable Chinese literati and the sophisticated courts of the Ming and Qing empires. This policy was not accommodation at any cost, however. Ricci refused to baptize converts who clung to their concubines or approved homosexuality. He also attacked Song metaphysics as atheism. 39 From the beginning, Franciscan, Dominican, and Augustinian orders, as well as the secular priests of the missions étrangeries de Paris, voiced opposition to the Jesuit mission. They all contended that the accommodation policy of Ricci, Schall, and Verbiest violated Christian teachings. The Dominican and Franciscan missionaries believed their orders in China had greater legitimacy because the Jesuits through accommodation had slipped into heterodoxy. Although later demonized in pro-Jesuit accounts, Domingo Navarrete published an account of politics, ethics, and religion in China in 1676 in which he exposed the dangers of the Jesuit conversion of the Chinese and excoriated the order's monopoly of Indians in the Manchu court. Navarrete had been the superior of the Dominican mission in Fujian when the 1664–1667 anti-Christian policies were promulgated. He resided in Guangzhou with several Jesuits while the Yang Guangxian affair took its course. Later Navarrete's report of his Jesuit colleagues and their tolerance of superstitious practices in China influenced the Pope to limit Jesuit Indians on the court, but to no avail. 40 Navarrete was taking a position in the dispute between the Jesuits based in China and the friars based in China and the Philippines. Although Jesuits' opinions differed, such as Longobardo's late Ming criticism of Ricci, the rights controversy at RST was a conflict between the religious orders, not a conflict of Chinese versus Christian culture. Like the Jesuits, the RST Dominicans in China were also well versed in at least one Chinese language after working among the Fujianese living in Manila. 41 In March 1693, however, the conflicts among the Catholic orders became public when the apostolic vicar of Fujian, Carolus Maigret, issued the Mandatum Seu Edictum. A Parisian prelate who served in the missions Étrangères de Paris, Maigret represented a congregation of secular priests authorized by the Sacred Congregation established by Pope Gregory XV in 1622 to promote the foreign missions. Its clerics, like Navarrete and the Dominicans, challenged the Jesuits by establishing a clerical hierarchy in China independent of Portugal. 42 Maigret declared 7 prohibitions effective immediately for all missionaries in Fujian. They pointedly disallowed use of heaven or Lord. 162. On high as appellations of God, denied that Christians could engage in sacristies for Confucius and their ancestors, rejected the supreme ultimate as an alternate term for God, and discarded the Change Classic as a repository of acceptable moral teachings. Maigret also sent an envoy to Rome to obtain the Pope's endorsement. 43 Although not effective outside Fujian, Maigret's unilateral action communicated only to Rome frightened the Jesuits when they learned of it in 1698. They called on the Kangxi Emperor to resolve the conflict in their favor. This act brought the internal battle among the Catholic orders into the court. In 1700, the emperor declared that ancestor worship and the veneration of Confucius were secular rites, as his Jesuit favorites maintained. The latter triumphantly forwarded the emperor's decision to Rome, seeking a papal intervention to counter Maigret's edict. Philippus Maria Grimaldi, the leader of the Jesuits in Beijing, called upon officials in the Astrocalendric Bureau and Chinese converts to weigh in by communicating their views to Rome. 44 Pope Clement XI, however, faced a powerful anti-Jesuit clergy in Europe, particularly among the Jansenists in the missions Étrangères at the Sorbonne. Between 1696 and 1700, the latter initiated a series of public debates to humiliate the Jesuits for their advocacy of probabilism and for the misguided policy of accommodation toward the Kangxi court. They were incensed by the claim that Chinese classical texts and basic Christian doctrine agreed. Le Comte's memoirs, published in 1696, later provoked a letter to the Pope by opponents and denunciations of the Jesuits for 2 months by the Sorbonne Faculty of Theology in 1700. The Jansenists also opposed excessive papal power and Jesuit complicity in that authority. 45 Pope Clement, unlike his predecessor, sympathized with the purists in the Catholic Church, although before 1702 he did not side with the Jansenists. To do so Clement had to overturn a papal decree issued by his predecessor that condoned Jesuit policy in China. In 1701, however, he appointed an opponent of the Jesuits, Charles Thomas Maillard de Tournon, as his legate to China to ensure that the prohibition of Chinese rituals among Chinese converts was enforced. De Tournon set out in 1702 and arrived in China at the end of 1705. The Pope also issued an unpublished decree, which approved Maigrat's mandate as church policy. When de Tournon arrived in China, the Kangxi Emperor treated him cordially. The Emperor summoned the legate for several audiences in 1706, and de Tournon brought Maigrat with him each time. The naive legate's meetings with the Emperor touched off a new phase in the rites controversy, resulting in the decline of all Catholic missions in China. In accord with the French Jesuits at court, the Emperor instructed de Tournon that Christianity 163 had to be compatible with Confucius's teachings, as Ricci had shown it was. If not, he would not allow the Europeans to remain in China. 46 Maigrat was asked at the audiences to demonstrate what passages in the Chinese classics were incompatible with Christianity. When Margot's reply indicated that his abilities in classical Chinese were dubious, the Emperor accused him of illiteracy and further charged him with inability to distinguish between the original writings of Confucius and Song Literati writings, as Ricci and his Jesuit followers had done. Disenchanted with Maigrat's comportment, the Emperor decided to deport all missionary troublemakers. To the dismay of the Jesuits, the new policy rolled back the Emperor's 1692 Edict of Toleration. After 1706, he required all missionaries to have an imperial certificate to maintain residence in Qing China. Even though the court supported their policy of accommodation, the Jesuits feared that the required certificates would give provincial governors discretion to deport all missionaries. Indeed, the Jesuits in Beijing were forced to pledge loyalty to the Qing throne to acquire such certificates. Because members of the missions étrangères de Paris refused to follow suit, they were refused certificates and deported. Maigrat was ordered out of the country when de Tournon left the capital in 1706. A Jesuit who had served on de Tournon's staff was imprisoned for his role in the ASCO. Suspicious of Jesuit complicity with the Qing Emperor, Maigrat left for Europe in 1707 and arrived in Rome in 1709. The Pope appointed him as assistant to the papal throne. This selection was followed by a 1710 papal decree that reconfirmed Pope Clement's anti-accommodation decree of 1704. Starting as an internecine squabble among the Catholic orders, the rites controversy reopened the Christianity controversy of 1660s in China and Rome, which had ended with the demise of Yang Guangxian in China and a 1669 papal decree granting relative freedom to the different orders for missionary work. 47 Despite the furor, Maigrat's 1693 mandate and Rome's condemnation of 1704 remained unpublished until 1707 when, as a result of his imperial audiences, de Tournon decided to include them in his Nanjing decree. As the Pope's legate, de Tournon supported Maigrat in China. When the Kangxi Emperor censored Maigrat in 1706, he also demanded that de Tournon present his credentials of appointment. Upon de Tournon's refusal, the emperor ordered him deported and retrieved all imperial gifts given to the legate to transmit to Pope Clement. De Tournon, in a letter from Macau dated July 27, 1707, instructed the superiors of the Dominican, Franciscan, and Augustinian orders to honor his excommunication of the Bishop of Macau for refusing to recognize his authority. 48 The Jesuits responded by sending a second mission to Rome in 1707, AF 164. THIRD-1 that left in 1706. The RST trip had met with shipwreck and drowning off Portugal. Not knowing this, it thus seemed to the Jesuits that de Tournon's 1707 decree ignored the emperor's legitimate request of clarification from the Pope in the 1706 mission. For his part, de Tournon felt that the Jesuits were manipulating the emperor, as Dominicans and Franciscans had long claimed. 49 The legation of 1705 to 1710 and the audiences with Maigrat and de Tournon turned the emperor against the missionaries, who he now understood were agents of the papal authorities in Rome. The eldest prince thought the missionaries were simply spies for the Spanish or Portuguese, who were preparing an invasion of China. In 1717, The emperor prohibited all missionary work in China. On the papal side, de Tournon's regula became the RST condemnation of the Chinese rites that publicly affirmed Rome's authority on the issue. The decree of the Inquisition signed by Clement in 1710 imposed an absolute ban on writing on the rites issue. Those who failed to heed the injunction, particularly the Jesuits, would face excommunication. Later papal bulls of 1715 and 1742 silenced all discussion of the controversy in Europe and cemented the triumph of the anti-Jesuit clergy. 50. The emperor's anger on receiving the 1715 papal bull led directly to the Red Manifesto of 1716, which was printed in vermilion in Latin, Chinese, and Manchu and sent to Europe. The emperor declared he would recognize only documents from Rome that were delivered by his own envoy on his own terms to Europe, Father Joseph Anthony Provena. Fan Shaoyi, a Jesuit priest, was influential in the Kangxi emperor's decision to limit Jesuit activities in the empire. Fan returned to China from Rome in mid-1720 and explained papal politics to the emperor, namely that Europe was militarily very powerful but that the authority of the Pope was relatively weak. The papacy in the 16th century had been a precursor of the modern state with a standing army, direct taxation, sale of offices, and the RST permanent diplomatic corps. By the 17th century, however, the nation-states of France and Spain eclipsed the papal states in political power and were competing to use the papacy. In the late 1720s, the Kangxi emperor understood that the Pope could not command the English or Dutch and that the Jesuit claim that their order represented the strongest ruler in Europe was false. Louis XIV had occupied papal territories in Avignon and Venaissin. To reconcile him, Clement IX granted the French monarch control of all church appointments in his realm. A century of Jesuit portraits of the Pope as Emperor of the Church had unraveled. The legation to China led by Carlo Ambrogio Metzebarba in December 1720 sought to mollify the emperor by proposing 8 permissions for certain Chinese ceremonies. 165. The emperor's distrust was confirmed, however, when Metzebarba also tried to gain the unconditional obedience of the Jesuits to the Pope. 51. When the Kangxi emperor died on December 20, 1722, he was succeeded by the Yongzheng emperor, whom the Jesuits in the Manchu court had opposed in the late Kangxi succession struggle. The emperor's eldest son had earlier interrogated the missionaries during the de Tournon mission. The younger son, who succeeded to the throne, hated the missionaries and compared them to the White Lotus sect, whom he suspected of plotting to overturn the dynasty. In June 1723, just after the new emperor took the throne, a Christian light Radus in Fujian apostatized and wrote to the local magistrate denouncing the missionaries. Most of them were exiled to Macau. Several Jesuit astronomers, artisans, and artists who professed their loyalty to the Qing stayed in Beijing. 52. In the Qianlong period, Jesuits could not preach Christian doctrines, but some were involved in clandestine Christian activities outside the capital. Compromise between the Church and the Qing court was impossible. In a decree of July 1742, for instance, Pope Benedict XIV demanded oaths of loyalty from all missionary orders in Asia to enforce his prohibition of Chinese and Indian rites. The Legations of 1705 to 1710, 1720 to 1721, and 1724 to 1725 to the Manchu court were sent to establish permanent diplomatic relations between the Qing and Rome, but they only widened the gap. 53. The rights controversy also backed on the Jesuits in Europe. As the Jesuits lost influence in China after 1705, their society also lost its legitimacy in Catholic Europe. In 1749 there were 22,600 members of the society and some 669 Jesuit colleges and 176 seminaries worldwide. After 1773, the Pope sequestered the Society's property, and its rich library collection in the Jesuit College of Clermont was sold en bloc in 1764. According to the 1773 decree, in which Pope Clement XIV dissolved the Society of Jesuits, the key issue was the Jesuit accommodation policy because it placed China and its rituals on equal footing with Europe and Christianity. 54. We will discuss below Jesuit opposition to Newtonianism in their colleges during the 18th century, which lost them the esteem of French philosophers such as Condorcet, who championed the new sciences. Although the Jesuits were the schoolmasters of France and Europe, Condorcet, from personal experience, saw Jesuit education as a disaster. In the 1740s, the curriculum of nearly 400 French colleges slowly shifted from Cartesianism to theoretical and applied Newtonianism. Despite the strong emphasis on mathematics in French colleges, if Newton nearly triumphed in France, it was probably over the corpses of the Jesuit order. French Jesuits were expelled in 1762. 55. 166. The elimination of natural studies in late Kangxi civil examinations. The collapse of the Ming dynasty initially created opportunities for Jesuit experts in mathematical astronomy to break out of their subordinate positions in the Astrocalendric Bureau and to challenge a discredited officialdom for power under the new Qing dynasty. The increased cultural importance of astronomical expertise, when the new dynasty had to reformulate in expert terms its raison d'être, challenged for a time the preeminence of literati who had mastered Songming classical studies. The Kangxi emperor, in particular, relished learning mathematics and surveying techniques and encouraged his sons and bannermen to master them. After the 1680s, when the Manchu dynasty expunged its enemies by putting down the revolt of the three feudatories, the political avidity of the early Qing waned, leaving Han Chinese literati and Manchu elites in a precarious balance at the top of the political and social hierarchies. This delicate balance was strengthened by the rights controversy and the Jesuit debacle. One of the ironic consequences of the rights controversy was the slow but steady encapsulation of European studies within the palace. French Jesuits continued to wield inions in the Astrocalendric Bureau and court generally in the early 18th century, but Chinese literati domesticated the new learning by transforming its study into the recovery of ancient learning. Literati who followed Mei Wending's pioneering mathematical studies now aimed to retrieve the classical mathematical and astronomical traditions in which the Jesuits had piqued their interest. For example, around 1711 the Kangxi emperor already knew about the Paris Academy of Sciences, which the French Jesuit Fouquet translated into Chinese as the Academy for the Investigation of Things and Exhaustively Mastering Principles. The emperor also modeled the court's Academy of Mathematics after it, but this was a temporary organization to meet the emperor's immediate needs. Its inience was con to the court. French Jesuits worked mainly on calendar reform and the empire-wide land survey commissioned between 1708 and 1717. The emperor preferred to send Manchu bannermen rather than Chinese literati to study astronomy with the Jesuits, with a quota of 10 students per banner. He did not encourage a broader focus on natural studies, as was increasingly the case in early modern France. Although literati mastered the new European learning in the 18th century, the end of the Jesuit mission in China precluded knowledge of the Newtonian century in Europe. 56. Simultaneously, policy questions on the triennial Qing provincial and metropolitan examinations, which drew civil candidates from every corner of 167. China's 1,300 counties, virtually ceased to include topics in natural studies, as did the 1,525 policy question on mathematical astronomy discussed earlier. In the Ming, questions on the calendar crisis, for instance, were not uncommon. In the eyes of the astute Kangxi emperor, the rights controversy confirmed the dangers of making imperial accommodations with European mathematical astronomy part of the civil examination curriculum. 57. The French Jesuits sent by Louis XIV to the Kangxi court as royal mathematicians and as members of the Paris Academy of Sciences soon stagnated. Their combination of scientific and religious objectives proved as problematical for the Jesuits and their church critics as for the Kangxi court. Although a Jesuit or ex-Jesuit remained director of the Astrocalendric Bureau until 1805, once the calendar and mathematics translation projects of the late Kangxi era were completed, the emperor felt that enough Manchus and Chinese were trained in the new astronomy, mathematics, and surveying techniques. 58 In 1713, the Kangxi emperor proscribed questions in the civil examinations on astronomical portents and the calendar because they pertained to Qing dynastic legitimacy. The emperor decreed that examiners assigned to serve in provincial and metropolitan examinations were forbidden to prepare policy questions on astronomical portents, musical harmonics, or calculation methods. The latest works in Qing natural studies and court translation projects on mathematical harmonics and astronomy, which had employed Jesuit experts, were off limits to examiners and examination candidates. The court tolerated some access for literati outside the civil examination bureaucracy, however. The ban on examination questions dealing with natural studies occurred within an effort by all dynasties to keep divination and portents out of public discussion. The Ming dynasty shared this concern, and the Qing reinstated imperial control over the public uses of European learning. The court's translation projects were designed to shift control of this technical learning from a foreign religious order to native literati and scholars in court without making them public. 59 In place of the banned natural studies and map-making, historical geography in particular prospered as an acceptable examination eld of Qing scholarship. The court and literati agreed that the dynasty must not depend on a religious group whose technical prowess was inseparable from their ties to the papacy and European expansion. 60 The Kangxi emperor's meetings with Mei Wending had been fortuitous because they signaled that the emperor could rely on literati mathematicians to assimilate any new mathematical astronomy the dynasty would need to maintain the calendar. The Yongzheng era began a closed-door policy that lasted until the Opium War. Nevertheless, scholarly work on 168. European mathematics continued, particularly geometry and algebra, which made it to China before 1723. Relative openness toward needed astronomical reforms continued even under the Yongzheng emperor. For example, Ming Gaitu was allowed to revise the Compendium of Observational and Computational Astronomy, which when published included Newton's improved methods for predicting eclipses. 61 The Yongzheng emperor and his court could not roll back the impact of European studies in the 18th century. Qing scholars built on the European learning translated into Chinese in the late Kangxi era. Those brought by the French Jesuit mission provided an important transition in Chinese classical learning from the Kangxi to the Qianlong reigns. We will address the full magnitude of the direct and indirect Jesuit impacts on literati in the 18th century below. 62. French Jesuits in the Kangxi court. The members of the French mission left Europe from La Rochelle for China in 1685. The declining political fortunes of the Jesuits in the early 18th century had led to decisions in Rome and at the Sorbonne, as we have seen, to reject the Jesuit accommodation strategy. Such policies in Europe produced through the rights controversy an increasingly hostile environment within China itself. By 1706, the Kangxi emperor was ambiguous about the new learning. 63 Fontenay's return to France in 1703 ended French Jesuit scientific work for the mission in China. By 1716 members of religious orders were no longer nominated for honorary status in the Paris Academy or otherwise affiliated. Nevertheless, in 1717, 28 of the 120 Jesuits in China belonged to the French mission. Moreover, Chinese Jesuits constituted the largest non-European group in the entire Society of Jesus in the middle of the 18th century, comprising about one-third of the total. 64 Fontenay, who was the only well-trained mathematician in the 1685 group, had been responsible for astronomical observations in China. Bouvet initially studied natural history and medicine, and L. Comte focused on history and the mechanical arts. Unlike their Italian and German predecessors, the French Jesuits shifted from collaborative work to individual study and authorship. Because of the Kangxi emperor's focus on mathematics for translations, natural history took a backseat to astronomical work. When Fontenay returned to Paris in 1703, Bouvet and L. Comte in China rarely interacted, while the rights controversy took up much of the French Jesuits' time in Paris. Fontenay had no immediate successor for astronomical work, and Bouvet increasingly worked on recovering ancient Chinese wisdom. Although in 169, Toan-Gobel tried to revive the mission's scientific work after arriving in China in 1722, his proposals to the Society of Jesus in Paris to fund an observatory in Beijing fell on deaf ears. Discouraged by the lack of response, Gobel watched as the Jesuit astronomers associated with the Portuguese mission in Beijing took over the leadership role in European astronomy. He turned his attention to the history of Chinese astronomy, producing the best reports before the 20th century. 65. Bouvet and figurism in Europe. Bouvet's accommodation policy and his studies of the change classic, for example, generally followed Ricci's precedent of mastering the classics as a tactic to convince literati of Christian doctrines. Unlike Ricci, however, Bouvet regarded the change classic as the oldest written text in China and the source of all her natural studies and customs. He also viewed it as a prophetic book that concealed the mysteries of Christianity, a position that contributed to the early 18th century figurist controversy in Europe and intensified European Catholic opposition to the Jesuit accommodation policy in China. 66. For Bouvet, written Chinese characters were hieroglyphs or pictorial writing that should be interpreted guratively and allegorically rather than as literal historical records. In Bouvet's study of the change classic, sponsored by the Kangxi Emperor, he explained the line changes in the hexagrams in terms of mathematics and Leibniz's binary numbers. This view diametrically opposed Ricci's earlier critique of the change classic as a fount of song atheism and materialism, a charge that Maigret later also made. Leibniz, following Bouvet, was willing to concede that, once recovered, ancient Chinese learning based on the change classic would prove to be the precursor of his binary mathematics. 67. For example, Bouvet cited the systematic treatise on computational methods by Cheng Dai, which had explained the mathematics of the magic squares in 1593. The Kangxi Emperor and his court then became interested in Cheng's work and had it reprinted. Bouvet argued that one of diagrams in Cheng's work was equivalent to European algebra and explained the 3, 4, 5 right triangle. The emperor mediated between Bouvet and Li Guangdi, who read Bouvet's studies of the change classic, although Li confessed to the emperor that he couldn't understand what Bouvet was doing. Neither the emperor nor Li Guangdi ever saw the figurists' claims in French and Latin, in which Bouvet and others argued that if one went back far enough in Chinese history one could end the point at which China diverged from God's teachings. 68. 170. The later French Jesuits privately identified Chinese history with biblical history and thus came into conflict with biblical claims of the high antiquity of the Jews. Thus, the French Jesuits reintroduced Charles and Lisieux's earlier volatile efforts to link the Chinese to Noah and his sons in new ways. Bouvet, for instance, questioned Chinese claims that Fuxi was the ancestral founder of China. For Bouvet, Fuxi represented the universal lawgiver, while the sage kings Yao, Shun, and Yu represented the RST rulers of the Chinese people some 6 centuries later. In contrast to his Italian, German, and Flemish Jesuit predecessors, who had stressed Confucius and the 4 books, Bouvet emphasized the 5 classics of antiquity and the change classic as the oldest surviving relic of a primitive universal language before the Great Deluge. Consequently, for Bouvet, the hexagrams attributed by the Chinese to Fuxi had been obscured by Confucius and his followers. When stripped of their later perversions, the hexagrams in the change classic revealed a binary mathematical order that allowed access to God's mathematical vision of all things in the world in light of numbers, weights, and measures. 69. Bouvet also agreed with the Chinese view of the change classic as a record of the regularities of heaven and earth, but he regarded the trigrams that made up the hexagrams as abstract principles in a philosophy of numbers identical to those of Pythagoras and Plato. Bouvet's efforts to restore the original and lost meanings of the change classic also stressed the Pythagorean link between numbers and music. Because of their fascination with symbols such as the trigrams, Bouvet and other French Jesuits in the early 18th century were figurists. They read into the change a proto-language and proto-mathematics of all mankind. 70. Similarly, Bouvet believed in Hermetism, which was based on the Corpus Hermeticum that Neoplatonic scholars claimed was written by Hermes Trismegistus, an Egyptian priest who lived after Moses. This curious blending of pagan philosophy with Christianity had turned Hermes Trismegistus into a quasi-Christian sage. Isaac Casaubon disproved the authenticity of the Corpus Hermeticum in 1614, claiming it was a forgery that reeked at Greek teachings of the early Christian era drawn from a blend of Platonism and Christianity. Bouvet added to the Hermetic tradition by focusing on the Change Classic and developing correspondences between Hermes Trismegistus and the sage King Fuxi, situating the father of writing within ancient divine wisdom from which all cultures had drawn. The figurists thought the hexagrams and cosmic diagrams in the Change Classic contained the key to reducing all phenomena to quantitative elements. According to Bouvet, just as Hermes Trismegistus had preceded Jesus' revelation, the Change Classic contained later Christian mysteries in a prophetic manner. 71. 171. Others such as Gogol remained more sober-minded, but Joseph de Primar, like Bouvet, believed that the sacred content of Chinese characters would reveal Christian doctrines that the Chinese had lost. The figurist approach to the classics reached a climax when Bouvet linked ancient Chinese writings to the Paschal eclipse associated with the resurrection of Christ. According to Bouvet, the Paschal eclipse was a supernatural event allegedly recorded in Chinese records and tied to Jesus' death. Gogol refuted this position by citing Chinese textual evidence that the Chinese record of the alleged Paschal eclipse was of AD 31, too late for the Crucixion. 72. Jean-Alexis de Gaulet believed that pagans such as the Chinese had been recipients of ancient revelation. He equated the sage King Yao with Jekten, a descendant of Shem, and systematically identified biblical and Chinese personages. In this view, Chinese observational records came from the Jewish patriarchs before the deluge. Gaulet, although a figurist, made biblical correlations in line with those of the 1660s in China, which we have seen cost Chinese Christian collaborators who published such views their lives. Bouvet and the other French Jesuits in China had the savoir-faire not to translate such aspects of figurism into Chinese. 73. They were not sufficiently careful about publishing their views in Europe, however, where anti-Jesuit feelings reached a peak after 1700. The Jesuits lost their credibility and their inions for expressing their figurist views in 18th century Europe. Fouquet presented figurism as an alternative to the two opposing European camps in the controversy. Instead of profane literature led with atheism and idolatry's rites or classics containing the principles of natural theology, Fouquet interpreted the classics as sacred writings containing the mysteries of Christianity in prophetic form. Because he re-examined the rites and terms question from a figurist point of view, Fouquet was recalled from China for disobedience. The papal ban on further discussion of issues relating to the rites controversy went into effect in Europe in 1710. Hence, the full appreciation of Bouvet's and the figurists' comprehension of Chinese classical literature, suppressed by the rites controversy, has only come about quite recently. 74. The second stage of the claim for the Chinese origins of Western learning. Most 18th century Catholic Europeans found the Jesuit claim that the ancient Chinese had received the Christian revelation blasphemous. Others such as Gogol dismissed it as historiographic bluster. For the most part, however, Europeans discussed the transmission of culture, science, and religion to 172. China, pros and cons, in terms of the priority of biblical events. On the Chinese side, however, the accommodation project provided an unforeseen ally for the Chinese observation that if the classics were indeed repositories of ancient wisdom Chinese and European, then all European learning, including the mathematical and natural history eldes of Scientia, originated in China and was later transmitted to the West. The Chinese could agree with the Jesuits about cultural transmission in theory, but they were free to change the direction of that transmission in practice and make themselves central. Although he was more favorably disposed to Western works, Mei Wending enunciated an early version of this narrative. According to Sima Qi, some ancient Chinese practical mathematicians had dispersed toward the western regions during the chaotic transition in the 8th century BC from the western to eastern Zhou dynasty. may use this passage to explain how astronomy in Europe had its origins in China. In the official account of the Ming history, prepared in the mid-18th century, for example, the Catholic centrality of the Great Deluge and the Levant was turned inside out. Those who have come to the Chinese land from the West, all call themselves Europeans. Their mathematical astronomy is the same as the Muslims, but they are more precise. In reviewing past eras, we see that many of those who came from far-off countries and are conversant with mathematical astronomy reside in the western regions. We have heard nothing from the southeast or north. It is likely that when Yao ordered the brothers Shi and the brothers He to reside separately in the four cardinal directions, Shizhong, Shishu, and Hoshu were restricted to Yi, Nanjiao, and the northern area. Only Hezhong was said to reside in the west and was not restricted to a particular area. At that time the fame and teachings of the west were far off indeed. At the end of the Zhou dynasty, the sons and disciples of the practical mathematicians had dispersed. In the western region, the Islamic countries were all linked continuously to the west, unlike the southeast where the Great Sea was a barrier. In addition, there was no like the fearsomeness of the north's extreme cold. Hence, it was convenient to transmit books and implements in expeditions to the west. The Europeans are to the west of the Muslims. Their customs are similar, but the Europeans surpass them in their quest for novelty, and in their desire to excel over others. Their mathematical astronomy has the same origins as the Muslims, but they have improved on them. Genera 173. Shin after generation. The Muslims could not keep pace. Their custom of wishing to surpass others led to their superiority. The brothers Shi and He of course lost their transmission. Of the ancient books we can only see the Gnomon of the Zhou dynasty and Classic of Computations. But the Western instruments such as the equatorial armillary spheres, the theory of the VE temperate and tropical zones, the principle of a round Earth, and the rectangular methods are all contained within the scope of the Zhou dynasty canon. In this way we can know their ultimate origins. 75. We see in this counter to the Jesuit narrative about the origins of China from the West an exactly parallel storyline in which European astronomy was derived from ancient China. Ming literati such as Su Guangqi had enunciated an earlier form of the Chinese origins narrative in light of a comprehensive synthesis. Su, for instance, presented in his 1607 preface to Euclid's Elements of Geometry an historical narrative that claimed that Chinese ancient learning in mathematics had been lost for 2 millennia since the Qin dynasty's burning of the books policy. Now with the arrival of Western learning, Su contended, these old lacunae could be led and repaired. Euclid served Su Guangqi as an antidote to the empty speculations of Ming literati, which would restore focus on practical expertise. In addition, Su Guangqi's research on traditional Chinese mathematics, although odd in its overemphasis on Euclidean geometry, also stimulated the rediscovery of ancient mathematics. 76. The notion that Chinese astronomical knowledge had spread to the western regions was suggested by Xiong Minjiao in his draft for investigating things and extending knowledge. Xiong's preface outlined the historical evolution of computational astronomy in ancient China, which paralleled the later account in the Ming history. He traced the decline of such learning to the most ancient of the 3 dynasties when, as it died out, it was transmitted in all directions but particularly to the west, where it had been mastered and improved upon. The Kangxi Emperor later embellished this version of the Chinese origins argument. 77. The accommodation policy of the Jesuits, particularly that of Bouvet and the French Jesuits, strongly influenced the Kangxi Emperor to accept and spread the theory that Western learning originated in China. The Emperor enunciated an early form of the Chinese origins theory in 1689–1690 when he personally studied Jesuit science and mathematics with Bouvet, Gerbilin, and others. Bouvet also explained to the Emperor how Leibniz's views on the binary system of mathematics were related to his own work on the 64 hexa. 174. Grams. Bouvet's studies of the change classic and Leibniz's binary system were roughly contemporaneous. Leibniz corresponded with Bouvet about the binary sequence of line changes in the 64 hexagrams. The emperor was intrigued by such equivalences. He encouraged the Chinese origins of Western learning to emerge as a historical trope. The Kangxi emperor also accepted the Jesuit claim that algebra had come from the East, which he and his court thought confirmed the Chinese origins theory. The court and 18th century literati did not know the Jesuits had meant that algebra had come to Europe from the Arabs in the East. 175. Figure 4.1. The order of the 64 hexagrams in Bouvet's Studies of the Change Classic. Source: Leibniz Archive, Niedersächsische Landesbibliothek Hanover. Copyright by D. E. Mungello, with his permission. This view later influenced Mei Juexian, who accepted the emperor's interpretation, and the claim became a cliché among a generation of evidential scholars. Mei Juexian affirmed the origins of algebra in the Zhou dynasty canon, and he regarded the heavenly unknown notations craft for expressing and solving quadratic and higher algebraic equations of several unknowns as equivalent to Jesuit algebra. This view was later expanded with a new term for algebra by Protestants in the 19th century. Succeeding evidential research scholars explored the mathematical sciences, but in the absence of the calculus and mechanics they strictly adhered to traditional mathematical astronomy. 78. In the 1690s the emperor used the Chinese origins claim to mediate disputes among literati in his court over the priority of European versus Chinese learning. This approach allowed the emperor and the Jesuits to justify study of European scientia as a native product returning to China after development abroad. Mei Wending advocated the Chinese origins theory at about the same time, but since he was employed by the court, it is likely that he honored the emperor with credit for the claim. 79. A good example of how court scholars deployed the claim of Chinese origins occurred with the 1723 publication of the imperially instituted Treasury of Mathematics. The claim was included in the Collectanea of Mathematics and Astronomy compiled by Wang Lanzheng and Mei Juexian in the Studio for the Cultivation of Youth since 1712. They had worked with or been influenced by French Jesuits such as Antoine Thomas. The Treasury, for instance, opened with discussion of the river chart, Luo writing, and the gnomon of the Zhou dynasty and classic of computations. This was followed by the RST 6 chapters of a Chinese translation drawn from the French edition of Euclid's Elements of Geometry by Pardies, which was thought to be simpler and easier to understand than Ricci's and Su Guangqi's version. The RST part of the Treasury opened with a brief discussion of the origins of the principles of mathematics. 80. The Luo writing was a three-order magic square in which three numbers along any diagonal line or column added up to 15, while the river chart was arranged in such a way that the outside odd and even numbers all added up to 20. Each received prominence of place in Zhu Shi's commentary on the Change Classic, which was still the orthodox interpretation when the Treasury was compiled. In particular, the magic squares were regarded since Song times as the primal world ordering instruments used by the sage kings and were also thought to be linked with the 8 trigrams. In addition, as magic squares, they were considered the veritable origins of writing and 176. Mathematics. By tradition, the sage King Yu had been presented these two magic charts by fabulous animals after he had tamed raging Uds, which the Jesuits dated to the biblical deluge. 81. In the Origins of the Principles of Mathematics, the compilers affirmed the mystical origins of the cosmograms, by which the sages illuminated mathematics and exhaustively fathomed the principles of all things. The sages composed the early mathematical classics, and the Duke of Zhou had made mathematics one of the 6 arts: rites, music, archery, charioteering, calligraphy, and mathematics. They added, "We know that the study of numbers and calculations had in reality been an important task for investigating things and extending knowledge." Wang Lanzheng and Mei Juexian, among others, contended the shapes, sizes, distances, and heights in Euclid's Elements were rooted in the ancient magic squares, which Verbiest had earlier in 1668 and 1671 tried to work out as a series of geometrical diagrams. Verbiest tied the Change Classic to geometric forms of circles inscribed in triangles, circles inscribed in squares, and multi-sided polygons inscribed in circles. In the Treasury of Mathematics, the compilers bemoaned the fact that mathematics had not been transmitted for a long time. Only the Zhou dynasty classic had survived from antiquity. They added that fortunately Ricci and other Europeans had helped restore mathematics and calendrics to a higher level of expertise, while insisting on Chinese origins. Still, in inquiring into their achievements, we can say that originally they were transmitted from China. The Kangxi Emperor and his court mathematicians believed that their Jesuit colleagues were helping them restore the ancient learning of the sages, which had been transmitted to the rest of the world. European learning was based on Chinese. Presented in this strategically orchestrated order after the Cosmograms and the Zhou dynasty canon mathematical classic, the second Chinese version of Euclid's Elements was successfully domesticated in the 18th century as an outgrowth of native learning, unlike Ricci's and Su Guangqi's version in the 17th century, which had in the preface championed a new Western learning and an unprecedented way of reasoning. 82. The Academy of Mathematics in Beijing. In the 1670s, Verbiest emphasized his role in China as an astronomical official serving in the Qing imperial bureaucracy. Bouvet, on the other hand, found a place for himself in the direct service of the ruler. The French mission's RST superior, Jean de Fontenay, equated the Kangxi Emperor with Louis XIV and hoped to introduce the institutional framework of Contempo 177. 178. Figure 4.2. The river chart on the right side and the logo writing on the left. The lashu is a magic square in which numbers along any diagonal, line, or column add up to 15. The hichu is arranged so that when the central VE and 10 are disregarded, both odd and even number sets add up to 20. Source: Zhu Shi, Zhuyi Benai. Rary French Science in China. He had held the mathematics chair at the Paris Jesuit College Louis Le Grand between 1676 and 1685 before leaving for China. Bouvet similarly expected, for instance, that the Kangxi Emperor would establish his own Academy of Science, which would emulate the Academy in Paris. 83. The Studio for the Cultivation of Youth was established in the suburban lofty pavilion garden palace in 1712 to 1713 for astronomical and mathematical work by the emperor's mathematicians. Earlier in 1711 Kangxi had noted mistakes in the summer solstice based on Western computations, and he wanted to employ French Jesuits to improve the calendar despite his dissatisfaction with Rome's papal policies toward China after the rites controversy. He invited the French Jesuits to work for him in the same way as they worked for the French Academy. 84. The Kangxi Emperor also formed his own Academy of Mathematics loosely on the model of the Parisian Academy of Sciences. But it was named after the Tang School for Mathematics and was not autonomous. The Academy was established in 1713 as part of the Studio for the Cultivation of Youth for Mathematical Astronomy, but only Qing literati and bannermen were appointed to it. No Jesuits were allowed in this inner coterie of imperial scholars, which included the third prince, Yinzi. This post-rights controversy policy ensured that the Jesuits would not unduly influence court mathematics. The emperor wanted his own men in charge of such technical knowledge. 85. Li Guangdi, supporting a coterie of native specialists on mathematical astronomy in the Kangxi court, also sought to avoid relying on the Jesuits. Li's group included Wang Lanzheng, who was granted the highest civil service degree in 1721 by the emperor because of his mathematical abilities and called a palace graduate in mathematical astronomy. Wang then entered the Studio for the Cultivation of Youths and helped the French Jesuits compile newly translated works on mathematical astronomy, which Mei Zhuoxian and Chen Haoyao also worked on starting in 1712. In 1712, Chen proposed a new compendium of European mathematics to replace the Ming mathematical astronomy of the Chongzhen reign. The result was the Sources of Musical Harmonics and Mathematical Astronomy Collectanea, which included the Treasury of Mathematics. In 1713, the Kangxi Emperor charged Mei Zhuoxian and Chen Haoyao with supervising Hiqiu Asang, Ming Geitu, and others to complete the project. The Sources was printed in 1723. This special group of mathematical and astronomical specialists included Wei Tingzhen and those Mei Wending had helped train before he died in 1721. All had benefited from Li Guangdi's court patronage. 86 altogether. The emperor recruited more than 100 scholars regardless of their civil examination status to join the Academy of Mathematics. Mei Jueshan was chief and Ming Geitu assistant editor for preparation of the treasury. In addition to those in the Academy of Mathematics who studied mathematics, astronomy, and music, a large number of instrument makers were hired for the technical needs of the new academy. A team of 15 calculators varied the computations based on the theoretical notions, mathematical techniques, and applications, and numerical tables in the RST part of the treasury. Patterned after mathematical textbooks used in Jesuit colleges, the treasury introduced European algebra. The last part had a section on logarithms to the base 10 and drew on the methods used in Briggs's 1624 Arithmetica Logarithmica to compute decimal logarithms. Although Briggs's work had been introduced in 1653, the Treasury explained the use of logarithms in greater detail, and it also included tables for sines, cosines, tangents, cotan 179. Gents, secants, and cosecants for every 10 seconds up to 90 degrees, as well as a list of prime numbers and a log table of integers from 1 to 100,000 calculated to 10 decimal places. The emperor had the treasury distributed empire-wide. It was reprinted in 1875, 1882, 1888, 1896, and 1911, which suggests a more limited audience until the 19th century. 87 The Chinese mathematics that informed the treasury included traditional equations for mensuration and techniques for computing the sides of a right triangle, which were based on Mei Wending's reinterpretation of traditional techniques to solve simultaneous linear equations. The French Jesuits in the court significantly enhanced the compilation of the sources of musical harmonics and mathematical astronomy, and its staff of over 100 working under Wang Lanzheng and Mei Jueshan. The new and influential sources collectanea included the Compendium of Observational and Computational Astronomy, the Treasury of Mathematics, and the Orthodox Meaning of the Pitch Pipes, which were all compiled in the Studio for the Cultivation of Youth starting in 1712. The collection was intended to be a series of textbooks for the studio and for students in the Imperial College's own Academy of Mathematics. The Compendium of Observational and Computational Astronomy in particular was compiled for fear that the Jesuits had not divulged all their astronomical techniques in the earlier Ming version of the mathematical astronomy. Mei Wending had been critical of the Jesuits, particularly Ricci, for not translating all 15 books of Euclid's Elements, and charged them with deliberately keeping the last 9 books secret from the Chinese. In the aftermath of the rights controversy, such charges seemed credible. After the treasury was printed in 1723, no further European mathematics was introduced into China until after the Opium War. Notably missing in China was the European discovery of the dynamic calculus. Moreover, the version of Euclid's Elements in the treasury remained the official version until 1865, when Alexander Wiley and Li Shanlin translated the remaining 9 books of Euclid and added them to the Ricci-Su translation of the RST6. This lack of innovation was due in part to the way the Jesuits introduced the new mathematical currents of the early 18th century. Fouquet, for example, unsuccessfully introduced algebraic symbols using Descartes' new notational forms in a treatise prepared for the emperor. The Kangxi emperor could not grasp the bonnet of general symbols that described the algebraic process. He preferred the calculating craft of algebra, which led to the precise solution. By 1730, moreover, astronomical books of the Kangxi era were out of date by European standards. 88. 180. The Kangxi era Compendium of Observational and Computational Astronomy. The French Jesuit role in calendrical reform during the Kangxi reign paralleled their predecessors' role in late Ming improvements of the Astrocalendric Bureau detailed in Chapter 2. Kangxi era efforts at reform culminated in the 1724 promulgation of the Compendium of Observational and Computational Astronomy and a sequel. The European astronomy in the compendium was mostly a century old, but the 1742 supplement adapted more recent European discoveries, such as Kepler's elliptic orbits, for traditional calendar reform. 89 Hashimoto Keizo has noted the use of astronomical modeling by the group that compiled the Compendium of Observational and Computational Astronomy. Such new techniques were wedded to calendar reform and not developed further, however. The compendium did lead to Chinese observations and computations during the Yongzheng reign that no longer depended on Jesuit help. There was no turning of the clock backward, as Yang Guangxian had attempted in 1664, since mastery of Western methods by Chinese and Manchu specialists had demonstrated to them the observational and theoretical shortcomings of Chinese methods. 90 Overall, the Kangxi Emperor's experts followed Mei Wending's lead in rejecting Jesuit efforts to insinuate Christianity into their astronomy. Mei's mathematical work tied in with the court's efforts to have a calendar that would fuse European and Chinese techniques into a comprehensive system and end wrangling on both sides. When the compendium was drafted in 1722 and promulgated in 1724, for instance, it followed European models but was prepared by Chinese in the court with only indirect Jesuit input. The key gur was Mei Jueshan, who had served on the staff since 1713 and had links to his grandfather's patron, Li Guangdi. Along with Mei Jueshan, He Kuosong and Chen Haoyao were also instrumental. 91 The RST part of the compendium dealt with general mathematical astronomy. Through its use of physical and mathematical models, the work was not simply a continuation of Schall's mathematical astronomy according to new Western methods, which had been based on the late Ming calendar reforms. Mei Wending's study of the moon's motions allowed Mei Jueshan and his group to make improvements in lunar eclipse prediction. The results enabled the Qing court, following Jean-Dominique Cassini's correctives, to adjust Verbiest's earlier eclipse prediction in 1676 that had been slightly in error due to atmospheric refraction. As the head of the Paris Observatory, Cassini had enlisted Fontenay's help in China to provide him data. 181. For the French project to remap the world, and had provided in return his corrected tables for Jupiter's moons. 92 The early Qing calendars produced by Schall and Verbiest were based exclusively on European models, but the new system cobbled together in the compendium fused European with Chinese methods. Mei Jueshan and his group of native specialists affirmed Mei Wending's efforts to reach a synthesis that would supersede past European and Chinese systems. During the 1720s, the court specialists mastered Jesuit astronomical methods and made them part of the imperial repertoire for computational astronomy. However, Qing specialists had no domestic incentive to go beyond the immediate needs of the Qing calendar, now successfully reformed. Nor did the Jesuits press them to do so. By 1725, the latter were themselves no longer on the cutting edge of the early modern sciences, and their mathematics, no more than simple algebra, trigonometry, and logarithms, had been domesticated by late Ming and early Qing specialists. In the 18th century, a larger community of Qing classical scholars associated with evidential studies would restore traditional Chinese mathematics to a level of intellectual prestige commensurate with the Jesuit version of European studies. 93 Despite the Yongzheng rejection of Jesuit learning in court, the Kangxi-era advisors under Mei Jueshan were influential in the succeeding Qianlong court. Although the studio for the cultivation of youth was discontinued, the Yongzheng emperor expanded official studies of mathematics by selected bannermen in 1734. This act allowed mathematical studies to grow outside the astrocalendric bureau. In 1738, however, the Qianlong emperor ended this program of official studies in mathematics because the students were poorly trained. Instead, he established mathematics as a course of study for the bureau. In 1739, the emperor placed mathematics under the purview of the official school system. Han Chinese students outside the astrocalendric bureau could now officially study mathematics. 94 When compared to 18th century developments in Europe, however, the fate of the Qing dynasty Academy of Mathematics is instructive. In France, the Paris Academy of Sciences became a building block for an increase in men of science and the institutions that supported them. Such institutional changes encouraged the eclipse of the more general learned societies and favored the rise of more technical institutions. The establishment of strictly scientific disciplines by the late 18th century was accompanied by the expansion of universities and research institutes where professionalized science slowly incubated in institutions of higher learning, and specialized laboratories eventually replaced gentlemanly academies. Not until the 19th century would such developments commence in China. 95. 182. The Newtonian century and the limits of scientific transmission to China. Initially, the French Jesuits played a significant role in the scientific developments associated with the French Academy of Science. Similarly, the Jesuits introduced Isaac Newton in China in the 1742 edition of the supplement to the Compendium of Observational and Computational Astronomy, which mentioned Newton by name but gave no systematic presentation of his theories. By the late 18th century, however, the Jesuit order had been abolished and ridiculed by the likes of Lagrange, d'Alembert, Condorcet, and Delambre. The latter were the leaders in the integration of mathematics and science and the practical application of the differential and integral calculus to mechanics and probability theory. The calculus of probability, for instance, provided a mathematical model for evaluating the validity of individual opinions and determining the probable outcomes of individual actions. 96. An analytic style of mathematical reasoning in Europe. The rise of the analytic style in European mathematics and probability, which stressed a formal examination of the steps used in algebraic reasoning, facilitated the application of mathematics to late 18th century public policy. The triumph of analysis also provided a foundation for the growth of statistics during the Enlightenment, when the mathematization of the social, economic, and political world in the name of political economy became de rigueur. Similar to the calculus, these social science trends did not penetrate Qing China until a century later. The widespread attempt to apply scientific thinking to all aspects of public affairs deemed the Enlightenment. Educated at a time when French science confirmed and elaborated Newton's mathematical principles, Condorcet, for instance, sought to extend that mathematical vision into a universal social mathematics. A nobleman who refused a military career, Condorcet turned instead to pure science and mathematics. 97. Newton did not use science in his 1687 Principia, which relied on formal geometric proofs that his readers would accept. Flux ions represented a notational form for a calculus of owing numbers. Newton's geometric proofs were passable for presentation, but useless for research. Descartes' analytic geometry had translated and extended the classical art into a more exable algebraic form that became part of the new approach. His equations did away with the special status of celestial circular motion, sublunar natural motion, and many other stures of the Greek tradition. Hence continental European scholars checked, varied, and extended Newtonian. 183. Natural philosophy using the more effective calculus notations of Leibniz based on an innate series of small differences. Continental specialists explored the mathematical physics of the Principia, while British scholars focused on the experimental physics in Newton's optics. Laplace insisted in his Celestial Mechanics that the perfection of Newtonian mechanics was mainly due to French scholars and the essay supported by the French Academy's prizes. In French hands, the sciences of algebra and calculus provided analytical tools that no longer needed classical geometric presentation. The task was to translate mechanics into a quantifiable algebraic language that explained movements in space over time. 98. In the middle of the 18th century, for instance, Leonard Euler RST expressed Newton's three laws of motion through the calculus to defend universal gravitation as a physical theory. Mathematically inclined astronomers LLED in the details of the Newtonian solar system. Adapting the calculus required differentiation and integration, and the summing of divergent series. Euler's success created a sense of progress in explaining physical operations of the solar system, and the equations that Laplace, Lagrange, and others devised augmented the engineering toolkit of Newtonian mechanics. 99 The application of Newtonian science created laws of mechanics that superseded Renaissance mechanics, which had existed as a body of principles explaining the use of levers, wedges, and pulleys through rules of practice. Artisans had understood the workings of machines but never considered an ordering theory or a set of principles to give their mechanics coherence. Classical mechanics had included the parallelogram of forces, the laws of the lever, principles of virtual work, and other diverse principles, but the Newtonian theory of force united them into a new system in which mechanical devices were models for processes in nature. After the Principia was published, continental mathematicians regularized and systematized mechanics, pneumatics, hydrostatics, and hydrodynamics. 100 Artisans played an important role in mechanical expertise by recognizing the transformations in the mechanical philosophy, particularly in England. Similarly, engineers and mechanical artisans popularized and actually implemented the reform of natural philosophy in 18th century England. By 1750, textbooks made the application of mechanical principles accessible to anyone literate in English and French, and artisans and engineers applied them. 101 The Jesuits never made the jump to the mathematical analysis of changes in practical mechanics because they upheld the Aristotelian notion of movement based on an object's elemental makeup. Typical accounts of the intro. 184. Duction of geometry to China by the Jesuits overlooked the fact that by the late 18th century geometry had been superseded in Europe by experimental physics and mechanics. Moreover, traditional Chinese mathematical crafts, once the mathematical sophistication in the 10 mathematical classics was reconstructed using Jesuit models for algebra, provided a convenient toolkit of numerical methods that facilitated mastery of the calculus in the 19th century by Chinese mathematicians such as Li Shanlin, Hua Hongfang, and others. 102. Newtonian science in England. As Newton's Principia was extended, entrepreneurs and engineers employed mechanics to link natural philosophy with the practical arts, science, and technology. The engineer's toolkit that emerged mathematized the laws of nature via the elaboration of the calculus by Newton's British and French champions in the 18th century. The new science was integrated differently in the British social and cultural landscape than on the continent. From the 1720s, British schools taught basic mathematics, including algebra, geometry, surveying, mechanics, and astronomy. Arithmetical and mathematical texts doubled in number during the first half of the 18th century. Young artisans in the 1720s already knew rudimentary mathematics and mechanics. At the same time, Oxford and Cambridge in their somnolence included only classical geometry in the curriculum. 103 Rather than contrasting the pure French sciences of Laplace and D'Alembert with practical engineers such as James Watt in England, Margaret Jacob has focused on the multiple cultural values that fostered disciplined curiosity among natural philosophers, capitalists, entrepreneurs, educators, engineers, and industrialists in both countries. British and French missionaries subsequently introduced their own regime for science to China in the 19th century. The Jiangnan Arsenal in Shanghai, for instance, was organized largely on the English model, while the Fuzhou shipyard followed a French approach to technological development. The popular assimilation of science through schools, lecture halls, textbooks, and newspapers represented the educational beginnings of the Industrial Revolution in Britain. By 1750 England had many male entrepreneurs who approached the production process mechanically. Production could be mastered by machines and conceptualized in terms of weight, motion, and the principles of force and inertia, which was then translated and practiced in light of work and workers in factories. Watt, for example, knew that the practical applications of mechanics allowed engineers using the calculus to quantify the motion of fluids and solids, measure the weight and pressure of 185 different substances, and create mechanical devices such as pumps, pulleys, levers, weights, as well as utilize electricity and light. 104 In contrast with the doctrinal inexhaustibility of the French Catholic Church, Jesuit colleges, and fundamentalist Calvinism, Newtonian physics quickly became the scientific core of natural religion. Mechanical knowledge was at center of the curriculum of dissenting academies in Britain. By the 1720s, Newtonianism became the body of natural learning for laymen in Britain to master, practice, and apply. One of them, James Watt, molded and improved the simpler steam engines of the 18th century and made them into most advanced technology of the age. The steam engine linked Newtonian mechanics and engineers in a cycle of manufacturing and industrial changes that made efficient use of natural deposits of fossil fuels to provide an unprecedented amount of new energy for practical work in factories, arsenals, and on ships. 105 Watt's engine became a model for industrial change, and his own intellectual life recreated the cultural origins of the RST Industrial Revolution. Watt came from a family of mathematical practitioners who were well informed about instruments and machines. He understood the latest mechanical science and turned to mechanized industry as an engineer and entrepreneur. Jacob contends that a new cultural paradigm emerged in 18th century Britain, which was marked by a set of recognizable values, experiences, and learning patterns among engineers and industrialists that formed an industrial mentality. The autonomy of the press in England and its independent public favored the interests of practical-minded scientists and merchants with industrial interests. After 1750, laymen and civil engineers communicated through a common scientific heritage that fashioned the mental world of the Industrial Revolution. 106. The French century in science and engineering. By the 1790s, the French emulated the British educational system, but earlier in mid-century they had already become leaders in applied mechanics requiring mathematical training and basic geometry. The Ministry of Turgot drew upon science and systematic knowledge to revitalize the French monarchy in 1774. According to Charles Gillespie, the Paris Academy of Science in the 18th century attained a higher standing in science when compared to the London Royal Society. Science in France had evolved further toward the formation of a profession whose expertise presupposed mastery of a technical body of knowledge that granted social prestige. As the profession of science gained its own jurisdiction over the education, qualifications, and conduct of 186. Its members, its disciplines approached the levels already reached by the divinity, law, and medical faculties in French universities. 107 Loyal Aristotelians, Jesuits fought Newtonianism in their colleges into the 1740s and beyond. After that the curriculum of nearly 400 French colleges shifted from Cartesianism to theoretical and applied Newtonianism. If French Cartesianism was used by its clerical supporters to glorify Louis XIV as the Sun King, the negative associations of Cartesianism for its links to absolutism and atheism were overcome in France when Voltaire and the philosophes offered Newtonian science and English society as models of enlightenment. In addition, they attacked Cartesian science as insufficiently experimental. Willem Jacob Escravizanda in Holland was noteworthy in popularizing Newtonian science among the scientifically literate by presenting a mathematical exposition of Newtonian science in textbook form. After Escravizanda secured a professorship in astronomy at Leiden University, with Newton's intervention, he educated a generation of students in an applied version of Newtonian mechanics through his collection of mechanical instruments and illustrative devices. His mathematical elements of natural philosophy replaced the Principia in the transmission of Newtonian mechanics for basic scientific education. 108 Unlike Britain, major industrialization did not occur in France until the 19th century, despite Newton's impact on the emerging French scientific community. Abbé Jean-Antoine Nollet was one of chief French promoters of the new science and its mechanical applications. He learned the techniques of demonstration from Escravizanda and the Dutch Newtonians and then established a course of physics as a series of lectures while traveling in France. Such French popularizers of mechanics provided an alternative to the Cartesianism dominant in colleges and the University of Paris since the 1690s. While England evolved toward a more balanced polity, the French philosophes justified the linkage between the absolutist state and support for scientific inquiry. Condorcet saw science academies as beneficial for the monarchy. French applied mechanics popularized by Nollet and others adhered into Diderot's encyclopedia in its 1750s volumes. Although the inspiration was Baconian, the volumes were LLED with drawings and descriptions of mechanical devices. Some 20,000 copies circulated before 1789. Diderot and D'Alembert, for example, urged that mechanics be the RST science studied for its utility, but this was realized only after the revolution overturned the aristocratic domination of science academies and military engineering schools. 109. 187. In the 1750s the French monarchy focused on steam-powered boats for military use. In the 1770s and 1780s, the state encouraged mechanical devices for controlled farming. In the French pattern, engineers and men of science served the state. In Britain science had a greater affinity with public entrepreneurs. An emphasis on mechanics in French education began in French colleges in the 1770s and 1780s, but French military engineers were the only cluster with sufficient mechanical knowledge. Their military values prioritized military needs over commerce. Laplace, for example, arrived in Paris in 1769 to take up RST teaching post at the École Royale Militaire. 110 Civil and military engineering were introduced as fields of study in schools for the State's Corps of Civil Engineers, which was given royal patronage in 1775. The Corps of Engineers consisted of 230 commissioned engineers in the 1780s, whose work focused on designing, drafting, and verifying structures. The École de Ponts et Chaussées became a professional school with a technical curriculum, which was introduced via French engineers to China at the Fuzhou shipyard in the 1860s and 1870s. Subjects, arranged in descending order of importance and difficulty, included 1. Mathematics, mechanics, hydraulics, differential and integral calculus, algebra and conic sections, elements of geometry. 2. Architecture, bridges, docks, jetties, locks, dikes, canals, civil building, stone cutting. 3. Style and method, drafting, leveling and volumetric calculations applied to earthworks, estimating work tasks. 4. Drawing, maps, GURs, landscapes. 5. Writing, block lettering, penmanship. 111 In 1793 at the height of the French Revolution, all scientific academies were abolished. The Paris Academy, founded by Jean-Baptiste Colbert, was revitalized in 1795 with largely new personnel. It had lost half of its members. New populist versions of science LLED the void left by the disestablishment of Enlightenment science. Laplace was appointed in 1795 to give mathematical lectures at the École Normale, where he ridiculed Leibniz's proof for the existence of God. The triumph of engineering as the quintessential practical science was evident in the fanfare surrounding the founding of the L'École Polytechnique in 1794. It became an incarnation of revolutionary ideals and a new vision of science to change the world. The leaders of the Revolution and Napoleon all embraced an industrial vision for France that drew on the power of science to change society and nature. French civil engineers were prized a generation after their English counterparts in the 1760s and 1770s. In the 19th, 188th century the Napoleonic success in science and technology was studied and transferred to Germany. 112. The typical historian's view of Chinese intransigence and imperial arrogance has relied on a narrative dating from the 1793 Macartney mission, which we will reassess in the next chapter. When Lord George Macartney led his diplomatic mission to China, he commented in his journal on the failure of the Jesuits to grasp the Newtonian sciences. As Zhou Antong has noted, he pointed out the deterioration in scientific understanding from the leadingers of the RST generation of Jesuits in China, such as Ricci, Schall, and Verbiest, to those of his own time. The truth indeed is, that the present missionaries are very little conversant in algebra, or science, and but poor proficients in any other branches of science. 113 When Su Xiao had his RST intellectual contact with modern science as it appeared in Benjamin Hobson's Treatise of Natural Philosophy, it awakened him to how far beyond the Jesuits' natural studies in Europe had gone. His 18th-century predecessors in China, however, never knew what had transpired in Europe after the demise of the Jesuit order. They were content to domesticate the Western learning that the Jesuits had introduced and note its similarity to ancient astronomy and Songyuan mathematical innovations. 114. 189. The Jesuit role as experts in Hai Qing cartography and technology. 5. This chapter explains why the Manchu court still valued its Jesuit minions during the 18th century despite the anti-Western policies of the Yongzheng reign. We will see that the Jesuit supervised imperial factories in China before 1800 survived principally as venues for luxury arts and crafts. Meanwhile, China's immense porcelain industry produced millions of pieces for sale in the 18th century, which suggests an interesting parallel to the rise of Wedgwood porcelain in England in the early 19th century during the Industrial Revolution. When Manchu forces captured a Ming artillery division using cannon based on Jesuit prototypes, their repower proved decisive in the siege warfare that enabled the Manchus and their Han Chinese allies to subdue forted Ming cities. During later Qing campaigns to subdue the southwestern revolt of the three feudatories, the emperor ordered Verbiest in 1674 to cast 132 heavy cannon. The court also ordered 320 light cannon for the military. Verbiest alone supervised the casting of more than half of the 905 cannons produced during the Kangxi reign, for which he also provided detailed translations on the theory and method for their ring. Manchu military banners were reformed to include artillerymen. Despite setbacks during the rights controversy, the Jesuits remained not only as important participants in the Astrocalendric Bureau and the Academy of Mathematics in Beijing but as supervisors in Qing imperial workshops. They also introduced precision instruments that made accuracy a realistic goal for mathematical astronomy in China. This linkage of precision and accuracy was then extended to cannon making, surveying, and map making along the Manchu-Russian frontier. After Ricci, Adam Schall, and Ferdinand Verbiest championed the role of mathematics to Christianize literati elites. They also produce astronomical instruments and military weapons whenever the court needed them. 2. 190. In addition, Jesuits participated in building new imperial palaces and gardens at a time when the Manchu court introduced the innovative garden palace complex in picturesque suburban surroundings. Before 1700, the Ministry of Public Works and the imperial household created temporary palace-building agencies of craftsmen, supervisors, and planners whenever needed. In the late Kangxi era, the court introduced what Carey Lu has described as the architect as holistic designer, planner, and builder to develop what eventually became the lofty pavilion garden palace in the northwestern suburbs of Beijing. Their Chinese imperial designers, particularly the Lei family, and the Jesuits helped develop and build bucolic complexes of whimsical mountains and lakeside villas that reiterated regal authority when the rulers resided outside the Forbidden City. 3. While in Beijing, for example, the French Jesuits Michel Benoist and Jean-Joseph Marie Amiot interested themselves in electricity. In 1755 they sent a report of their tests to St. Petersburg. Such experiments were kept secret allegedly so as not to upset the Chinese. In 1773, Benoist demonstrated an air pump to the Qianlong Emperor, who decided that the proper name for the device would be a pipe to wait for the Qi, a reference to the TEFL efforts by the Astrocalendric Bureau to determine the onset of spring by timing the Qi emanating from the earth. The Kangxi Emperor had ridiculed this ritual early in his reign, but the Qianlong Emperor was less critical about such matters. Other Europeans and Americans in China compared native technologies in China with their own, which continued the traditions of Jesuits such as Terence Schreck's 1627 diagrams and explanations of the marvelous devices of the Far West. 4. Mensuration and cartography in the 18th century. The late Kangxi and Yongzheng bans on propagating European natural studies did not sink literati learning, where a decisive sea change in classical learning was occurring. Imperial policies lost much of their intellectual inerence. 18th century evidential research scholars stressed painstaking research, rigorous analysis, and impartial evidence drawn from ancient artifacts and historical documents and texts. They made verification a central concern for the emerging empirical theory of knowledge they advocated. Their slogan revived the Han Dynasty expression to seek truth from actualities. 5. In geography, moreover, evidential scholars during the late 17th and 18th centuries reacted to what they knew of world geography by domesticating new knowledge in the midst of Qing Empire building, as the court used Jesuit surveying techniques to measure its domains. At the same 191 time that the Manchu dynasty took advantage of international changes in Central Asia, Chinese literati in their new geographic works took an inward turn intellectually by focusing on native topics. 6. The 17th century turn inward. Chinese naval power had revived when the Ming defended the South China coast from Japanese pirates in the mid-16th century. Led by their naval commander Qi Jiguang in the 1560s, hundreds of Ming coastal ships equipped with large European-style cannon destroyed the pirate ships used to maraud on land. Later, the Ming Qi had trained joint forces with the Korean Navy to resist Japanese invasions of the Korean Peninsula in 1592 and 1597. 7. Modeled on their Ming allies' large warships, Korean turtle boats under Admiral Yi Sun-sin helped gain control of the sea war. Their combined forces of some 100 ships and 15,000 men were decisively superior in tactics and technology and continually threatened Japan's land-based supply lines. Despite mobilizing a Japanese fleet of 12,000 men on 100 ships for the climatic battle at the Noryang Straits in December 1598, Hideyoshi failed in his grandiose plans to use Korea as a stepping stone to conquer China. Some 300 Japanese ships with 10,000 sailors were lost. 8. Despite the increased awareness of foreign nations as a result of the Korean Wars, contact with Jesuits, or border treaties between the Qing and Russian imperial governments in 1689 and 1727, Han Chinese scholarly interest in the maritime world waned in part due to Japan entering a period of relative seclusion. During this time, there was wide travel in North and South China by many eminent scholars in the 17th century, particularly as a response to the Manchu military conquest in the 1640s to 1660s. Research on geography in the early Qing returned to traditional questions of regional military strategy and local, coastal defense. Meanwhile, the Dutch colonized Taiwan from 1623 when the Dutch East India Company increasingly contracted Chinese traders and farmers from southeast China to settle the island. 9. Subsequently Southern Ming loyalists led by Zheng Chenggong resisted the Manchus in major naval and land battles along the Fujian coast in the 1640s and 1650s. Zheng's land and sea forces took heavy losses, however, when they moved up the Yangtze River to Nanjing in 1659, and were forced to retreat to Xiamen. Southern Ming naval forces then challenged the Dutch garrison in northern Taiwan at Castle Zeelandia in April 1661 with a force of 600 ships and 20,000 sailors. The Dutch capitulated after a bitter 9-month siege. Zheng unsuccessfully demanded via a Dominican missionary that the Spanish in Manila recognize his suzerainty. 10. For its part, the Qing government in 1662 ordered coastal inhabitants from Shandong in the north to Guangdong in the south to move inland to cut Zheng's supply lines and to negate the value of the coast as a battleground. Earlier, Manchu military forces had captured Ming cannon, which they used to pound walled Chinese cities into submission. They also turned to a naval fleet to defend the coastline, after Shi Lang, one of the southern Ming's most capable admirals, joined the Manchus in 1646 because of a dispute with Zheng. She commanded Qing naval forces in the 1650s and 1660s along the Fujian coast. In July 1683, he led the Qing fleet of some 300 warships and 20,000 sailors, which subdued the pescadores. Taiwan fell to the Qing navy in October, and for the rest time the island became part of China. 11. The Qing navy no longer remained on a war footing after Taiwan was annexed, and the Manchu emperors became increasingly preoccupied with the land-based expansion of the Russians from Siberia into the Manchu homelands and the renewed dangers posed by the Dzungars in Central Asia. In addition, the Qing expanded its empire in Tibet and Turkestan. By the end of the 18th century, it had more than doubled the size of China. When the Opium War with England broke out in 1839, therefore, the Qing was again mainly a coastal navy used principally for defense against pirates and local marauders. 12. Furthermore, even before the conquest of Taiwan, maritime considerations evoked less interest among Chinese literati. Because the Manchu conquest emanated from the northern steppe, Guyanwu, a leading voice of the early Qing, turned toward precise studies, emphasized China's strategic positions in relation to her traditional foreign neighbors to the north and northwest in his influential geographical treatise titled The Strategic Advantages and Weaknesses of Each Province in the Empire, compiled between 1639 to 1662. Ironically, such foreigners, particularly the Manchus, Mongols, Tibetans, and Uyghurs, would become part of the political-cultural unit called China by Europeans in the 19th century. Concerned with texts as much as he was with maps, Guyanwu did not even mention Ricci's Mappamundi. He was concerned with the effects of topography on political and economic development within China. His endings, however, were based on his wide travels, careful first-hand observations, and the study of written materials. Likewise, Guziwiu's Essentials of Geography for Reading History, written 1630 1660. 193. Was a study of native historical, administrative, and natural geography, with an emphasis on the importance of topography for military strategy. Literati disregarded Ricci's world map, and late Ming interest in the maritime nations waned. 13. Zhou Zongtang read Guyanwu's and Guziwiu's geographical treatises in 1829. They inspired in him a lifelong interest in Chinese topography and military strategy. His interest in Chinese Turkestan underscored his insistence in the 1870s that troops be sent to northwest China to prevent that area from falling permanently into Russian hands. Zhou's campaigns provoked the opposition of Li Hongzhang and other Beijing officials who regarded naval power for coastal defense and protection of Korea from Japan as more pressing needs than the recovery of territory in the distant interior. The compilers of both the Ming history and the comprehensive geography of the Great Qing realm had access to Ricci's and other Jesuit geographical works, but they dismissed as titious many of the Jesuits' claims and much information on their Mappamundi. Nevertheless, Su Qianxiu, who chose scholars to work on the comprehensive geography project when he was appointed director in 1687, had high regard for the emerging evidential scholarship of his times, which we can see in his choice of leading textual scholars as editors of topographical material for the geography project. Su's appointment of Guziwiu, perhaps the most qualified student of historical geography in his time, indicates the caliber of experts who carried out the comprehensive geography project. 14. Similarly, the late Qianlong compilers of the 1787 edition of the Comprehensive Analysis of Archival Sources during the August Dynasty, which included documents and materials covering the period 1644 to 1785, demoted the mention of Europe to a minor section on Italy within the category of the four frontiers. 24 chapters in the traditional category of geography and lands dealt with imperial domains, while only 8 covered the borderlands. The compilers of the four frontiers focused on Korea, the Ryukyu Islands, Vietnam, and other neighboring tributary countries. The section on Italy mentioned that what the Italians had said about the division of the world into VE continents followed from Zhou Yan's Warring States theory of the Sacred Ocean, although the Italians dared to add that the land of China was but one of the VE continents. Such claims infuriated the compilers, who dismissed the Italians as too grandiose, so much so that they failed to mention Zhou's 9 continents, in which China was central. The Italians could not be taken seriously because they were simply trying to impress the Chinese with European customs. 194. Goods, governance, and education. Still, the comprehensive analysis included detailed geographic discussions of Europe and Russia. 15. Moreover, the dramatic political impact that European surveying methods had in China early in the 18th century piqued the interest of the Qianlong Emperor and his court when the Kangxi map of the empire was updated using European surveying methods. European geographical content may have been overlooked, but European methods were still admired and copied in official geography as well as astronomy. 16. We saw in Chapter 3 that Xue Fengzhuo studied astronomy and mathematics under the Jesuit Jean-Nicolas Smogulecki. Xue then applied the techniques of spherical trigonometry and logarithms to surveying, which was appreciated by the Qianlong Imperial Library editors in their review of Xue's compendium on the Yellow River and Grand Canal. The editors noted that Xue's mathematical expertise was an invaluable aid in analyzing problems related to wood control and canal upkeep. His use of European trigonometry was recognized as a clear improvement over the native forms of trigonometry known as double application of proportions, which dominated traditional Chinese surveying techniques. 17. By comparison, the Imperial Library editors writing in the late 18th century singled out a 1557 study of West Lake in the Hangzhou area by Tian Rushan to make a methodological point. Because of the lack of corroborating evidence, no one can evaluate the accuracy of its claims. This is a blunder that Ming scholars all shared. Since Song times, increases in precision informed greater accuracy in mathematical astronomy, an expectation that the Jesuits used to enter and control the Astrocalendric Bureau. Qing literati expected similar levels of accuracy in evidential learning due to overlaps between classicism, geography, and mathematical astronomy. 18. On their own terms. Science in China, 1550 to 1900. Benjamin A. Elman. For Susan Naquin and Nathan Sivan and in memory of my mother, Rachel Elman. Contents. List of maps, illustrations, and tables 11. Chinese dynasties 15. Abbreviations 19xxi. I1. 3. Finding the correct conceptual grid 4. What should be the literati theory of knowledge? 5. Late Ming classicism in the context of commercial expansion 9. Printing technology and publishing 16. Naturalization of anomalies in Ming China and early modern Europe 20. 1. Ming classification on the eve of Jesuit contact 24. Ordering things through names 24. Collecting the collectors 34. Late Ming statecraft, mathematics, and Christianity 53. Collecting things in texts 57. 261-2. The Late Ming Calendar Crisis and Gregorian Reform 63. Development of the Ming Astrocalendric Bureau 65. Evolution of the Late Ming Calendar Crisis 73. Gregorian Reform 80. Jesuits and Late Ming Calendar Reform 84. 3. Sino-Jesuit accommodations during the 17th century 107. European Scientia and Natural Studies in Ming-Qing China 107. Literati attacks on calendar reform in the early Qing 133. Ferdinand Verbiest and the Kangxi Emperor 144. 4. The limits of Western learning in the early 18th century 150. The Kangxi Emperor and Mei Wending 150. The rights controversy and its legacy 160. French Jesuits in the Kangxi court 169. The Newtonian century and the limits of scientific transmission to China 183. 5. The Jesuit role as experts in High Qing cartography and technology 190. Mensuration and cartography in the 18th century 191. Cartography, Sino-Russian relations, and Qing imperial interests 200. The Jesuit role in Qing arts, instruments, and technology 205. 3. 223-6. Evidential Research and the Restoration of Ancient Learning 225. Early Qing Critiques of Zhu Xi and Wang Yangming 226. Medical Works and the Recovery of Antiquity 227. Chen Yuanlong and the Mirror of Origins Encyclopedia 236. Revival of Ancient Chinese Mathematics 244. 7. Seeking the Truth and High Qing Mathematics 255. High Qing Views of the Investigation of Things 255. Mathematics in an Age of Evidential Research 262. Nativism and Early 19th Century Mathematics 270. 4. 281-8. Protestants, Education, and Modern Science to 1880. 283 Protestant missionaries in China. 283 Protestants and Modern Science in Shanghai. 296 303 The Shanghai Polytechnic and Reading Room. 308 9. The construction of modern science in late Qing China. 320 Early science primers. 321 Atkins's Primers for Science and the Problem of Darwin in China. 323 From the Scientific Book Depot to the China Prize Essay Contest. 332 Prize Essay Topics and their Scientific Content. 340 Medical Missionaries since 1872 and Medical Questions as Prize Essay Topics. 342 Natural Theology, Darwin, and Evolution. 345 V35310 Government Arsenals, Science, and Technology in China after 1860. 355 From Chinese working for missionaries to missionaries working for the dynasty. 356 Post-typing reformers and late Qing science. 357 The Jiangnan Arsenal in Shanghai. 359 Technical learning in the Jiangnan Arsenal and Fuzhou Navy Yard. 368 Naval warfare and the refraction of Qing reforms into failure. 376 Reconsidering the Foreign Affairs Movement. 386 11 Displacement of traditional Chinese science and medicine in the 20th century. 396 Western learning mediated through Japan. 396 Science and the 1898 Reformers. 398 From traditional to modern mathematics. 403 Modern medicine in China. 405 Indians of Meiji Japan on modern science in China. 408 Appendixes 1 Tang Mathematical Classics. 423 2 Some Translations of Chemistry, 1855 to 1873. 425 3 Science Outline Series, 1882 to 1898. 426 4 Partial Chronological List of Arsenals, etc., in China, 1861 to 1892. 427 5 Table of Contents for the 1886 Primers for Science Studies. 428 6 23 Fields of the Sciences in the 1886 Primers for Science Studies. 429 7 Science Compendia published in China from 1877 to 1903. 430 8 Some officially selected Chinese prize essay topics from the Shanghai Polytechnic. 433 9 Scientific societies formed between 1912 and 1927. 434 Notes. 437 Bibliography of Chinese and Japanese sources. 527 Acknowledgements. 541 Credits. 543 Index. 545 Conventions. This work is not a straightforward historical survey of the Chinese sciences that approaches that history topically. Fortunately, Joseph Needham's Science and Civilization in China series provides the best sourcebook for that. Instead, I focus principally on Chinese natural studies and the literati mastery of European natural learning from 1550 to 1900. In particular, I show how Manchu rulers and Chinese scholars broadened late imperial studies of astronomy, geography, mathematics, and medicine through court and literati contacts with Jesuits and Protestants, who presented European natural philosophy as part of their religious inheritance. Other areas such as physics, chemistry, and technology are covered when pertinent. In this volume, the term literati refers to select members of the land-holding gentry who maintain their status as cultural elites primarily through classical scholarship, knowledge of lineage ritual, and literary publications. The term gentry refers to those before 1900 who wielded local power as landlords or provincial and empire-wide power as government officials. The cultural status of both the gentry at large and the literati in their midst correlated with their rank on the civil service examinations. In addition, during the late empire, gentry and merchants intermingled, with the latter becoming part of the gentry elite. Chinese characters have not been included for Chinese historical gers. Most are readily available in biographical collections such as Dictionary of Ming Biography, Eminent Chinese of the Qing period, and Howard Borman and Richard Howard, Biographical Dictionary of Republican China. A romanized bibliography of Chinese and Japanese sources cited in the text is presented at the end. Terminology such as the West refers to early modern Europe in parts I, 3 and grows to include the United States and modern Europe in parts 4, v. Chinese sources typically refer to the West or Western. When appropriate, I narrow the focus to Western Europe in chapters 1 to 7, when Europe is the focus rather than the West. Normally, I present the West as a cultural construct used by Jesuits, Protestants, and Chinese to refer to themselves or to the other. European and Euro-American will designate a regionalized view with more historical and chronological precision. The term learning of the way will refer to the schools of literati thought that developed in the Song, Yuan, and Ming dynasties. Unfortunately, there has been a tendency to use Neo-Confucianism to cover all classical intellectual currents from the Tang dynasty until the fall of the last dynasty in 1911. Readers should guard against this tendency to assimilate Neo-Confucianism to the broader amorphous designations that have been attached to it. The definition and content of learning of the way were as debatable during the 11th and 12th centuries as they were in the 17th and 18th. The term Chengzu orthodoxy will refer specifically to the imperially sanctioned Chengyi and Zushi school of interpretations for the official canon. These were officially accepted in civil examinations beginning in 1313 and remained the basis of the imperial examinations until 1905. Historiographical issues. During the Sino-Japanese War from 1894 to 1895, the Japanese Army and Navy decisively defeated the armed forces of the Manchu Qing dynasty. Since then, Chinese and Japanese patriots and scholars have assumed that Meiji Japan was vastly superior to Qing China in modern science prior to 1894. Actually, prior to the war many contemporary observers thought the Qing Army and Navy were superior, even if only in sheer numbers. After 1895, each side rewrote their histories to validate triumphant Japan or lament the defeated Qing. For Chinese and Manchus, the Sino-Japanese War turned the Qing era of self-strengthening reforms from 1865 to 1895 into an alleged scientific and technological catastrophe. 1. Naval wars in Chinese history. One of the ironies of the Qing misfortune in 1895 was that since the Song dynasty China had at times supported a substantial navy, which the Mongols used to invade Japan in 1274 and 1281 and attack Java in 1293. XXII. Subsequently, the Ming dynasty navy carried out several enormous excursions into Southeast Asia and the Indian Ocean from 1403 to 1434, which ended when the court scrapped the navy in the 1460s to prepare for possible land wars in the northwest against the Waray Mongols. A coastal navy equipped with cannon and rearms had defended the China coast from Japanese pirates in the mid-16th century, initially in vain but with eventual success. Chinese naval power further revived when the Ming helped Korea to halt Toyotomi Hideyoshi's invasions of 1592 and 1598. Ming loyalists early on defeated the Qing dynasty in major naval and land battles along the Fujian coast. The naval revival lasted only until the 1680s when Qing naval forces annexed Taiwan. Thereafter, the Chinese still developed new types of sailing vessels, such as the Zhejiang Junks RST built in 1699. Chinese merchants used them in northern waters for the Ningbo-Nagasaki trade between Japan and China, which lasted into the 18th century despite Japan's alleged closed-door policies. 2. The Qing court in the 1860s and we today might have heralded the revival of the Qing Navy after the Opium Wars as a return to the brighter days of the early 15th, mid-16th, and 17th centuries. Instead, the late Qing Navy was ridiculed after 1895. Anti-Manchu patriots appealed to the Zhengheites as sign of China's past greatness and current Manchu weakness. Moreover, the superiority of Japan in modern technology and science was assumed after the Sino-Japanese War. The Japanese Navy dominated Pacific waters until 1945. 3. After 1895 each side read their fates differently, back to the early Meiji period, in the case of triumphant Japan, or back to the failures of the self-strengthening movement after 1865, in the case of the defeated Qing. The possible continuity between the military strength of the Ming and early Qing naval elites and the late Qing navy became inconceivable. 4 scholars revisited the RST Western impact in East Asia that began in the 16th century and concluded that, unlike the more open-minded Japanese who absorbed Dutch scientific learning, the Ming Chinese, like their Qing successors, had also rejected the new world of scientific learning the Jesuits offered them. This perspective, for instance, still informs the discussion in the recently revised edition of Sources of Chinese Tradition, Volume 2, which uncritically describes the general disinterest of the Chinese in Western science, which had been tendered at the hands of gentle missionaries. 5. No amount of sophistry can turn the Qing debacle in 1895 into a victory, even a hollow or moral one. Past accounts of China's failures in science and dynastic losses on modern military battlefields are instructive, but their rhetoric XXIII about that violence has usurped the actual destructive events long since past which placed China at the mercy of the West and Meiji Japan from the 1890s onward. Beneath the cultural narrative of scientific, technological, and military failure, which many Euro-Americans, Japanese, and Chinese still attach to Chinese history after 1895, lies another story. It will never replace the triumphal story of the march of Western and Japanese imperialism via science, technology, and empire building, nor should it. Nevertheless, this book tells a quieter story of long-standing Chinese interests in the natural world, medicine, the arts and crafts, and commerce that set the stage for the interaction with European science, technology, and medicine from 1600 to 1900. The impatient perspectives of China's efforts to westernize after 1865, which are still prominent among historians today, have unfortunately predisposed us to underestimate the crucial role the missionary translations of science, the industrialization and technoscience in the Qing arsenals, and the new government schools played in the emergence of modern science and technology. We should deal with the late 19th century arsenals, factories, and translation schools by also considering them as a harbinger of things to come and not simply as a prelude to the end of the Qing dynasty and imperial China. China's defeat in 1895 was not due to a lack of science or technology. Late Qing Manchu and Chinese leaders inherited a legacy of regionalism and decentralization from the Taiping Rebellion, which appreciably contributed to corruption and the mismanagement of the war effort. Pamela Crossley has noted that the military reforms were overwhelmed by the inability to integrate development in such a way that innovative institutions might reinforce each other rather than impede each other. 6. Pre-modern and modern science. When Europeans reached China during the Age of Exploration, the highest learning of their men of culture did not connote natural science. For Thomas Aquinas, natural philosophy, not natural science, was a eld of higher learning. Science was a medieval French term, which was synonymous with accurate and systematized knowledge. When Latinized, the word became scientia and represented among scholastics and early modern elites the specialized branches of Aristotelian moral and natural philosophy. 7. Philip Melanchthon's On the Soul upheld the scholastic distinction between scientia and opinia. The former represented certain knowledge, while the latter referred to plausible or commonly accepted beliefs. Included in the scholastic regime for learning were the 7 sciences of medieval learning: grammar, logic, rhetoric, arithmetic, music, geometry, and astronomy. Comparable to the classical ideal of the 6 arts. XXIV. In ancient China, these 7 liberal arts served in Roman education as preparation for more specialized training in philosophy, medicine, or law. 8. In medieval times, Boethius's pioneering translations of Aristotle into Latin had prioritized 4 mathematical disciplines for elementary education: arithmetic, geometry, music, and astronomy. They represented the 4 roads to wisdom, which balanced the 3 disciplines of logic, namely, grammar, dialectics, and rhetoric. After Thomas Aquinas in Paris and others elsewhere reconciled the Muslim harvest of classical learning with Christian theology, the preferred order of Aristotelian learning for the Renaissance scholars and bookmen became logic, mathematics, natural science, moral philosophy, and metaphysics. This regime was reproduced in the Ratio Studiorum at Jesuit colleges in Western Europe. The Jesuits transmitted Aristotelian cosmology, physics, and meteorology through their scholastic theory of knowledge. 9. Like contemporary Europeans and Islamic scholars, late imperial Chinese also prioritized mathematical studies for their pre-modern exact sciences, which informed Chinese astronomy, geography, cartography, and alchemy in different ways. Literati also applied the naturalistic concepts of yin and yang and the VE evolutive phases to elucidate the spontaneous changes in the stuff of the world. Rational and abstract explanations of natural things and phenomena characterized the pre-modern sciences worldwide, particularly Chinese elite traditions of natural studies. 10. I will discuss popular understandings of natural events and the popularization of the exact sciences in late imperial China, but readers interested in the popular conceptions of natural phenomena among non-lights should refer to the forthcoming work of Nathan Sivin on the relationship between science, medicine, and popular culture in light of gods, ghosts, and spirits as intermediaries between humans and the cosmos. Works on Chinese Buddhism and Daoism by scholars who address popular religion rather than esoteric religion with a hereditary priesthood also advance our understanding of the history of medicine. 11. If pre-modern science in China, Europe, and Islam often denoted a rational and abstract understanding of the natural world, the rise of modern science in the 18th and 19th centuries melded the exact sciences with machine-driven technologies that surpassed the rich artisanal traditions of the early modern world. In addition, historians of modern science have stressed the application of mathematical hypotheses to nature, the use of the experimental method, the geometricization of space, and the mechanical model of reality to explain the scientific revolution in the West. My study will be agnostic about these latter claims, which philosophers of science frequently use. XXV. To explain why China or the Islamic world failed to develop the rigorous mental mindset of modern science. 12. Instead, I will explore Chinese interests in natural studies as they articulated and practiced them on their own terms rather than speculate about why they did not accomplish what the Europeans did. Whenever appropriate, I will contextualize Chinese natural studies by comparing the lingering vitality of the pre-modern exact sciences in China with the decisive turn toward Newtonian mechanics and industrial revolution in 18th century France and England. I will also compare the rapid industrialization of Europe in the 19th century to the slower but equally extraordinary rise of modern Chinese machine-driven industry. Traductory, Traditor, Christianity, Science, and Translation in China. I should note at the outset the surplus of studies on the Jesuits and science in late imperial China and the relative surfeit of such studies for the Protestants and science. As a result, until recently most accounts have underestimated the religious activities of the former and overestimated them for the latter. I will add another layer of materials and interpretation to earlier accounts of science and the Jesuits in China. I will also emphasize the relationship between Protestants and modern science in China, which was repressed by both Chinese and Christians after China's debacle in the Sino-Japanese War in 1895. Scholars and churchmen since 1600 have lauded and damned the role of the Jesuits in China. I will describe their many sides, but my focus on science will highlight their anti-Copernican and anti-Newtonian positions in the 17th and 18th centuries. The Jesuits should not be black-boxed, however, as a religious enemy of science. Many were closet Copernicans or Newtonians at a time when they could not publicly disown the ecclesiastical positions the Pope and the Jesuit order took against Copernicus and Galileo. In the end, as Nathan Sivin has explained, European cosmology had been discredited by its own unexpected lack of internal coherence. In the 17th century, Jesuits presented Copernicus as a follower of Ptolemy and then of Tycho Brahe. When Michel Benoist Nally presented Copernican heliocentrism in the mid-18th century, Chinese literati thought the presentations too incoherent to take seriously. 13. Similarly, my account of the Protestants will highlight their opposition to Darwin's theory of evolution, particularly the notion of the survival of the fittest through natural selection. Lacking a unit church such as Catholicism under the Pope, the Methodists, Presbyterians, and other Protestants who came to China after the Opium War nevertheless were XXVI. Surprisingly even more unanimous in opposing Darwin than the Jesuits had been contra Copernicus. Few Protestants in China were closet Darwinians, almost all favored Christianized versions of evolution. Still, the Protestants were not unrelenting enemies of science either, even though they delayed the translation of modern biology in China by 3 decades. What united the Jesuit and Protestant eras in Chinese history was the religious agenda they brought as foreigners to China. Their primary project of religious conversion required that they translate Christianity into Chinese, orally and textually, as well as in ritual practice. Hence, Christians worked with Chinese literati converts to present Catholic and Protestant beliefs orally and in readable classical Chinese, the lingua franca of educated Chinese until the 20th century. The majority of works produced by this workmanlike partnership were religious works. A significant minority dealt with the sciences, early modern for the Jesuits, and modern for the Protestants. 14. How the Jesuits and Protestants worked with their native Chinese informants to legitimate the West after 1600 is one of the keys to understanding the translation enterprise, which packaged Christianity and European science together. Jesuits and Protestants tainted their translation project with their own conscious and unconscious predispositions by massaging the literal meaning of original European texts. They often chose to capture the spirit of the original through a wide-ranging engagement with the classical resources of the target language and audience. At other times the missionaries and their Chinese partners created new terminology to present Christian religious and scientific views. Usually, however, both sides could end acceptable terms in the vernacular and classical lexicon of Chinese to accommodate the meaning of the Western source. Accommodation was as difficult for the Jesuits during the rites controversy as for the Protestants. By 1850, the new disciplines of chemistry and the calculus, for example, increasingly required new concepts, not only new words. Such concepts shaped new realities, which empowered many Chinese to grasp new scientific discourses. 15. In this volume, I bracket the religious texts that the Catholics and Protestants spent most of their time translating into Chinese. In addition, I spotlight the early modern and modern scientific texts translated jointly by Christian missionaries and Chinese literati. These science translations were not simply innocent byproducts of the missionary enterprise, however. The science texts the missionaries successfully translated into classical Chinese were encoded with Christian messages and religiously induced silences. Hence, I do not focus on translation as a futile exercise in philosophical incommensurability. Instead, I demonstrate the willful inultration of Christian beliefs in the scientific textbooks translated into Chinese. 16. My analysis of scientific translations by missionaries and their converts will XXVII. Reveal the unspoken ideological predispositions that Catholics, Protestants, and Chinese all encoded. This lack of transparency has been underestimated in previous accounts of translation in China and Japan as high-minded efforts at achieving verisimilitude. Jesuit and Protestant translators did not just fail to achieve a seamless word-by-word correspondence from Latin or English to Chinese. Nor were they simply idealistic failures because they unsuccessfully sought to transmit the spirit of the source through more adventuresome literary tactics. The translation enterprise in Japan, for example, followed a different cultural trajectory altogether because the Japanese barred the Jesuits early on and stressed their own translations of science in the 19th century, rather than relying on Protestant middlemen. 17. The Jesuits and Protestants in China rejected the European original when the native source betrayed their religious sensibilities. The result was not a failure to communicate. Competent in vernacular Chinese, the Jesuits and Protestants communicated well enough to their Chinese partners who produced the classical translations. Rather, the enterprise of translation became a mindful, Christian effort not to translate Copernican heliocentricity or Darwinian evolution in the original to the target audience. We see in this act of dissembling about the sciences a sense of religious commitment that we should not underestimate. Jesuit and Protestant dissembling tells us that we must further problematize the act of translation ideologically and recognize that the Chinese were not privy to the untranslated passages that we are today. What they did not know mattered. Science, medicine, and social status in late imperial China. Modern scholars have stressed the social distance between those in imperial China who represented the classically trained scholar gentry elite and those who worked as physicians or professed mathematical astronomy. I have tried to account for all by presenting men such as the physician herbalist Li Shizhen and the mathematical astronomer Mei Wending as part of the community of literati scholars. Many physicians and mathematicians were proficient in the triad of astronomy, non-judicial astrology, and divination. Not until 1900 would a scientific community emerge in China that would fully encompass the doctor and the mathematician, but both were rooted in the same elite social formations since 1100 that undergirded pre-modern study of natural studies. 18 specialists will readily understand why I select Li Shizhen and his systematic Materia Medica to represent in part late Ming Chinese views of natural phenomena, but they will wonder why I also choose the relatively unknown Hu Wenhuan and his XXVIII. Much maligned Collectania for investigating things and extending knowledge. Although it contained many rogue editions printed in Hu's Hangzhou and Nanjing print shops, the wide dissemination of the Collectania in Mingqing China and Japan marks it as a popular work. Like Li's systematic Materia Medica, it was influential among elites, although many belittled its populist audience. Who also incorporated orthodox classical lexicons and natural histories that were representative overall of literati learning on the eve of the Jesuits in China. Although lacking the scholarly pedigree of the more famous genre of jotted notes, the lower brow status of Hu's collection of natural studies grants us a unique window onto the quotidian world of learning, which existed beyond the reach of Wang Yangming's revival of ancient classical values, his influential schoolmen, and other late Ming higher-brow literati intellectual currents. As Mai makes clear, most local literati were reading popular novels and encyclopedias whether or not they appreciated Wang Yangming's classical discourses. Hu's Collectania is also uncontaminated by later accretions that mark many materials reproduced after the Jesuit presence. 19. The subsequent rise in social status of literati who mastered mathematics, astronomy, and Western studies was appreciable after 1700. Just as mathematics enhanced the Jesuit view of themselves in Europe and China as urbane masters of scientia, so too when Ming and Qing literati mastered mathematical astronomy, they enhanced their social status and political value when the calendar crisis loomed over the Ming and Manchu courts. While the cognitive framework of science in the making was certainly seminal in late imperial China, as in modern Europe, its institutionalization also depended on the heightened social prestige and political patronage that experts in the exact sciences increasingly displayed in the 18th century. Things as phenomena, affairs, and events. Chinese interest in the natural world focused on things. In the Chinese context, however, things meant more than simply material objects. The Chinese term referred to objects, events, mental and physical phenomena, the unknown, and the anomalous often simultaneously but frequently delimited depending on context. Ming literati and artisans applied other terms, such as tool or implement, controlling mechanism, and device, contrivance, or weapon to utensils and cannon. Johann Schreck's diagrams and explanations of the marvelous devices of the Far West, for instance, presented traditional European crafts. XXIX. Manship in light of Chinese artisanship. Later, Chinese and Manchus assimilated the terms to industrial machinery in the 19th century. 20. Some leading classical scholars such as Zhu Xi tried to subdue the range of things to limits more to their liking. Particularly since 1000, literati who favored rational explanations of moral principles in the perceptible world sometimes distanced the unknown or the anomalous from their discourses about the investigation of things. They were never successful in eliminating such alleged excesses, but their efforts were influential in creating a highbrow image of a typically agnostic Confucian stereotype that modern historians have reproduced uncritically. In this work, things serve as shorthand for a broader and more amorphous understanding of objects, phenomena, and events that could usually be named. In encyclopedias and popular compendia, for instance in Hu Wenhuan's lower brow editions, the rational commingled with the ineffable, the fantastic, and the magical. Late imperial references to things were multivalent and fluid, and the reader should avoid the more objective notions of things that might at rst seem relevant. Taboos. I should speak to my efforts in this book to prioritize the history of Chinese science for a fuller understanding of pre-modern Chinese intellectual history. The average reader will not have heard of the awesome taboo that overcomes specialists who study Chinese art, literature, history, humanities, and social science. Nathan Sivin describes the taboo as follows: this stupendous prohibition rules out, under penalties so hideous that no one has even imagined them, reading, under any circumstances whatever, any primary source devoted to science, technology, or medicine. 21. The cultural history of the calculus in China has not mattered to humanists yet in Chinese, who tend to fall all over themselves in the presence of traditional Chinese philosophy and religion. Nor have a generation of sinologically trained social scientists or institutional specialists included the history of science and technology in their discussions of the political, social, and economic transformation of China in the 19th and 20th centuries. Unfortunately, a lesser science taboo is also common among those who speak for the sciences. While overtly welcoming studies of the sciences by humanists, they frequently assume the superior white robes of the scientist when they dismiss or refuse to read accounts by those whose careers are not primarily in the sciences. While training in science is a marvelous benefit for the historian of science, it is not a substitute for historical precision. Nor does XXX scientific training provide the full relief of historical context. We will supersede Thomas Kuhn's analytically still useful division of the internal versus the external histories of science only when our humanistic and scientific taboos are identified and rendered psychologically benevolent. Late imperial rulers and literati were frequently more interested in the sciences than contemporary humanists like myself. Those affected by the awesome taboo or the science taboo will perhaps remain so. Hopefully, younger scholars less vulnerable to such taboos will quickly supersede my book, since it is just the intensive effort to link the Jesuit and Protestant eras to explain the rise of science in China. I especially want to thank those who have helped me cross the divide between the sciences and the humanities to produce this book. An overview of the argument. This study is premised on the need for a unit narrative to describe the Chinese development of modern science, medicine, and technology since 1550. It ties together the Jesuit impact on late imperial China, circa 1600 to 1800, and the Protestant era in early modern China from the 1840s to 1900. Without such a synthesis, which is currently unavailable, a coherent account of the emergence of modern science in China lacks a wider historical significance for both specialists of China and students of modern science. Arguably, by 1600 Europe was ahead of Asia in producing basic machines such as clocks, screws, levers, and pulleys that would be applied increasingly to the mechanization of agricultural and industrial production. In the 17th and 18th centuries, however, Europeans still sought the technological secrets for silk production, textile weaving, porcelain making, and large-scale tea production from the Chinese. Chinese literati in turn, before 1800, borrowed from Europe new algebraic notations, Taconic cosmology, Euclidean geometry, spherical trigonometry, and arithmetic and trigonometric logarithms. If there has been one constant in China since the middle of the 19th century, it is that imperial reformers, early republicans, Kuomintang party cadres, and Chinese communists have all prioritized science and technology. Yet, we have undervalued the place of science in modern Chinese history. Indeed, our understanding of Chinese natural studies before 1900 has remained muddled, despite the important contributions made by Nathan Sivin and Joseph Needham and his collaborators. This volume surveys the evolution of the native Chinese sciences from the 16th to the early 20th century under the influence of the Jesuits and Protestant missionaries. In the end, however, we will discover that the Chinese produced their own science. Parts I and II of this volume will challenge allegations that Chinese literati XXXI. Were not curious about European science in the 17th and 18th centuries. 22. We will describe how the Jesuits in China devised an accommodation approach focusing on mathematics and astronomy, which they generally did not employ in Japan, India, Persia, or Southeast Asia, not to mention the New World. To gain the trust of the secretive Dragon Throne and its literati elites, Matteo Ricci and his followers prioritized natural studies and mathematical astronomy during the late Ming and early Qing dynasties precisely because they recognized that literati and emperors were interested in such fields. They realized that such interest would improve the cultural environment for converting Chinese to Christianity. 23. The inverse of modern claims about Chinese obduracy toward modern science is the assertion that Christianity and science only had marginal influence on mainstream Chinese thought before the 19th century. Many historians cannot see past the key internal issues in the classical debates of Ming-Qing scholars. In the round, this claim has many merits. We will see in Part 3, however, that literati interests in natural studies and Western learning continued after the rights controversy and actually peaked in the late 18th century. The failure of the Jesuit mission and other Europeans to transmit scientific and mathematical knowledge during and after the Kangxi reign was not due to Chinese disinterest. We will contextualize the Chinese absence of knowledge about 18th century scientific developments in Europe by describing the break in scientific transmission that the demise of the Jesuits and their schools in Europe during the 18th century caused, which deprived the Chinese of information about new trends there. The Jesuit demise delayed information from Europe about the role of the calculus as the engineer's toolkit and mechanics as the physicist's building blocks for almost a century. 24. Earlier historical accounts have generally overvalued or undervalued the role of the Jesuits in Ming-Qing intellectual life. In many cases the Jesuits were less relevant in the ongoing changes in literati learning. In the medical field, for example, few Qing dynasty physicians before the 19th century took early modern European Galenic medicine seriously as a threat or complement to native remedies. On the other hand, the Kangxi revival of interest in mathematics was closely tied to the introduction of Jesuit algebra, trigonometry, and logarithms. The technical competence of the Jesuits in the China mission during the 18th century ranged from surveying methods to cannon making. They also introduced pulley systems, sundials, telescopes, water pumps, musical instruments, clocks, and other mechanical devices. Their European enemies accused the Jesuits of making themselves useful to local rulers for their personal advantage rather than in the name of Christianity. In addition, emperors XXXII, their courts, and literati families welcomed Western goods and manufactures, which reverberated in the material culture of Qing novels such as Dream of the Red Chamber. 25. Initially, the Chinese required a higher degree of astronomical expertise than Ricci could provide, because Ming needs focused on eclipse prediction based on cyclical time, not the determination of the linear date for Easter. Gregorian reformers in the 1570s had not worried about eclipses. Because of their preference for better cosmology, the Jesuits in China went beyond the Ptolemaic world after Ricci's death and mastered the new Decanic world system. Once this was accomplished, however, the work of Jesuits in the Astrocalendric Bureau became regulatory rather than explorative. Armed with the intellectual and instrumental tools provided by Bra and his followers, the Jesuits solved the problems they were hired to undertake. They did not keep up with newer scientific developments in Europe, which more and more were products of Northern European Protestants outside the Church. Consequently, the Decanic system was still used to train astronomers in Qing China during the late 19th century. The Kangxi Emperor reproduced the institutional models for translation that Su Guangqi had created with the help of Matteo Ricci and Lise Hizeo. Later, on an even larger scale, the Protestant missionaries collaborated with Chinese to translate post-industrial revolution science and technology into Chinese after 1850. 26. Parts 3 and 4 assess the growing interest among elites in classical medicine, mathematics, and astronomy during the 18th century. When Pope Pius VII in 1814, after the defeat of Napoleon, restored the Jesuits as a religious order, it was in the context of the Congress of Vienna and its efforts to reinstate the ancient regime across Europe. In this climate, the Jesuits became even more conservative, and its members generally opposed the progressive liberal ideologies of the Protestant missionary organizations sent to China after 1840. Whether due to an unnecessary controversy, or because of a Jansenist conspiracy, the breakdown of the Jesuit consensus in the 18th century coincided with an increasing Chinese self-reliance in mathematical training and acceptance of European learning as rooted in China's ancient classics. Under imperial patronage, literati upgraded mathematical studies from an insignificant skill in 1700 to an important domain of knowledge that complemented classical learning by 1800. One irony of the failure of the French Jesuits to keep up in mathematics and science was that although French Jesuits had corresponded with Leibniz, the inventor of the notational forms for the calculus that engineers employed during the 18th century in Europe, the Jesuits, not the Chinese, failed to see beyond the figurist mysteries they read. XXXIII. Into the binary mathematics in the order of the 64 hexagrams of the Change Classic, a divination text of possible imminent transformations that took its null form as one of the 5 classics during the Han Dynasty. The chapters in Part 4 recount how Protestant missionaries and their Chinese assistants nally translated Newton's laws of physics in the 1687 Principia and modern mathematical analysis into Chinese when the missionaries arrived in China's newly opened treaty ports after the Opium War. The leaders of the 1793 Macartney mission had deemed their historical role in relation to their Jesuit predecessors by presenting Great Britain, and thus themselves, to the Manchu court and Chinese literati as the manufacturing leaders of Europe and as enthusiastic teachers of their new scientific knowledge. Lord Macartney believed that the gifts that he had brought, chief among them a solar planetarium synchronized by the most ingenious mechanism that had ever been constructed in Europe, were more sophisticated than the geocentric armillary spheres, mechanical clocks, and telescopes previously introduced by the Jesuits. He also thought that such gifts would convince the Qianlong Emperor of Britain's dominance in science and technology. 27 Neither Macartney nor his ship's mechanic and mathematician cum astronomer James Dinwiddie thought much about the fact that the British East India Company had purchased the German-made planetarium at an auction and coded it in Oriental style for the Chinese market. Only when he visited the lavish Qing Imperial Gardens LLED with spheres, orreries, clocks, and musical automatons of such exquisite workmanship did Macartney stop to consider the limits of his scientific apparatus. Savants in London had already ridiculed the intended gifts for China as a banal effort to redress Britain's large deficits in the China trade. When someone suggested that the Chinese might be more interested in British machinery, that was set aside out of fear that the clever Chinese would quickly learn how to copy export machinery, as American machinists mischievously had. 28 Indeed, Macartney never presented the pulleys, air pump, chemical and electrical contrivances, or steam engine models that he had on board. Nor did the mission present the chronometer Macartney also brought as a possible gift. As a new means to determine longitude, the chronometer would have been more efficient than the Jesuit method for surveying that the Manchus used to appraise their domains. Instead, the apparatuses were returned to the British East India Company or given to Dinwiddie, who lectured on them and presented some experiments in Guangzhou to the English factory, which was attended by Chinese merchants. Macartney remarkably noted, had Dinwiddie remained at Canton and continued his courses, I dare say he might have soon realized a very considerable sum of money from his Chinese pupils alone. 29. Third. Qing China did not yet require the specific ingenious objects or manufactures from England that Macartney actually presented, any more than India before the Manchester textile factories exploited the prodigious Indian cottage clothing industry. Such material needs in China followed on the heels of an illegal opium trade that created a commodity that millions of Chinese could not do without. Nevertheless, Chinese merchant interests in Dinwiddie's experiments and contrivances in 1793 suggests that we should not be surprised that many Chinese quickly took notice of the engineering fruits of the Industrial Revolution after the Opium War. 30 Because of Britain's role in defeating Catholic France, her Protestant missionaries increasingly traveled to India, Singapore, and China. In the late 18th century, Protestant churches became influential arbiters of public attitudes toward the social issues of the day. Evangelism, the belief in salvation by faith alone, was formed through the auspices of Protestant churches, particularly the Methodists and Low Church Anglicans, and informed Victorian public values. Great Britain's scientific ethos based on Newtonian mechanics and machine-driven industry was transmitted worldwide by enlightened missionaries and church evangelicals. 31 Resurgence of emigration in the mid-18th century paralleled growth of the British Empire. The middle classes joined in the nation's civilizing mission at home and abroad. The 1780s and 1790s were a time when missionary philanthropy for spiritual conversion found widespread support. 18th century missions abroad focused on keeping European settlers in the church and were supported by a small circle of wealthy aristocratic sponsors associated with English monopolies. In contrast, the modern missionary movement in the Second British Empire, like its free traders, depended on the financial support of large numbers of small contributors. The missionary enterprise turned from saving lives through aid of the poor at home to reforming manners and saving souls abroad. Protestant initiatives to introduce European and American political and cultural institutions to China in the 1830s built on and surpassed earlier Jesuit geographies of the world and descriptions of European countries. Chinese scholars based in Guangzhou soon gained a more precise understanding of the new missionaries and the various countries they came from. The Qing dynasty's collection of strategic information to deal with the opium menace was prioritized by those most closely involved in the maritime crisis. Both Lin Zexu and Wei Yuan realized that China's knowledge of the West gained during interactions with the Jesuits in the 17th and 18th centuries was obsolete. Indeed, Wei hoped that the Russians on land and the newly established United States at sea might become allies of China in future wars with the British. 32. XXXV. Stress on science for dynastic self-strengthening attracted Chinese literati interest, particularly after the debacle of the Taiping Rebellion. The Chinese terminology for modern science in the 19th century was less and less compatible with the Ming-Qing traditions of natural studies. The Jesuit use of this traditional terminology had not implied that European countries were economically and politically superior to the Ming or Qing Empire. The linking of state power to science had not occurred to the Jesuits because Christianity still took precedence. They linked science to the church and its religious mission. 33 From 1850 to 1870, a core group of missionaries and Chinese co-workers in Guangzhou, Ningbo, Beijing, and Shanghai translated many works on astronomy, mathematics, medicine and related fields of botany, geography, geology, mechanics, and navigation. Parallel to the arsenals and official schools, private initiatives also popularized modern science in the treaty ports and among Qing officials and literati. The second half of the 19th century began China's modernization, which was initially perceived as westernization. 34 In Part V, we reconsider the new arsenals, shipyards, technical schools, and translation bureaus, which are usually undervalued in earlier failure narratives about China's early industrialization. In light of the increased training in military technology and education in Western science that was available in Qing China after 1865, we will see that a decade before similar efforts in Meiji Japan, Qing reformers forged a union of scientific knowledge and experimental practice among literati and artisans, RST, and most notably in Shanghai at the Jiangnan Arsenal and at the Fuzhou Navy Yard. Japan's Iwakura Embassy noted both industrial sites when it visited Shanghai on the way home during its worldwide fact-tending mission from 1871 to 1873. 35 We also scrutinize long-standing claims made by contemporaries of the Sino-Japanese War that China's defeat demonstrated the failure of the foreign affairs movement to introduce Western science and technology successfully. Readers will be surprised to learn that, based on their comparable levels of science and technology in the 1890s, Qing China might have defeated Meiji Japan in their Great War over Korea, just as the late Ming had helped Koreans defeat Hideyoshi's invading forces in the 1590s. When we look more carefully at the total picture of the self-strengthening period from 1865 to 1895, the view that Qing China was irrevocably weak and backward, in contrast to a powerful Europe and a rapidly industrializing Japan, is a relic of the impact of the 1894 to 1895 war on international and domestic opinion. 36 changes in elite and popular opinion after 1895 forced literati to reconsider the suitability of the Manchu-Chinese domestication of Euro-American science and technology using the interpretive lens of the investigation of 30 things. Westernizing radicals such as Yan Fu concluded that the accommodation between Chinese ways and Western institutions, which had informed the self-strengthening movement since the 1860s, had failed. The Sino-Japanese War altered the frame of reference for the post-1895 period for both the New Chinese and the New Japanese intelligentsia that was emerging from Qing and Tokugawa's scholarly elites. For late Qing overseas Chinese students of modern science and medicine, Japan replaced the Jesuits and Protestants as the messenger of science. In Part V, we also trace the beginnings of the failure narrative for Chinese science, which paralleled the story of political decline and economic deterioration. After 1900, Chinese elites, particularly reformers and revolutionaries, increasingly demeaned their traditional sciences as incompatible with the universal endings of modern science. They disparaged Chinese natural studies and medicine. This negative rationale allowed them to transfer support to a positive set of revolutionary institutional changes that required modern science and medicine based on Western models as mediated by Meiji Japan. 37 The elimination of traditional terms for science empowered reformers and radicals to elide the scientific texts that had been translated since 1850. After 1895, reformers no longer considered the arsenals, navy yards, and factories, where the manufacture of armaments and ships had begun, as Western-style enterprises. Instead, they dismissed them as backward Qing dynasty military factories. Single-minded promotion of Western learning caused a cultural rupture in attitudes. Radicals separated modern science from the preservation of the Qing China. 38 Because civil examination credentials no longer confirmed elite status after 1905, everyone not just civil examination failures as before turned to other avenues of learning and careers outside officialdom. They traveled to treaty ports such as Shanghai or abroad to seek their fortunes as members of a new gentry-based Chinese intelligentsia that would be the seeds for modern Chinese intellectuals, scientists, doctors, and engineers. The failure of the 1898 reforms enhanced the mediation of science in China via Japan. The new texts translated from Japanese made modern science available to a wider audience and raised the level of knowledge among students and teachers. Chinese students educated abroad at Western universities such as Cornell or sponsored by the Rockefeller Foundation after 1914 for medical study in the United States, as well as those trained in the sciences locally at higher-level missionary schools and the new universities, regarded modern science in light of the Japanese version of Western science, rather than traditional frameworks. They believed terms from the latter, derived from the language XXXVII of the discredited Chinese past, were inappropriate for universal, modern science. After 1915, the teleology of a universal and progressive science RST invented in Europe replaced the Chinese notion that Western natural studies had their origins in ancient China. The dismantling of the traditions of Chinese natural studies and natural history, among many other categories, which had linked the pre-modern sciences and medicine to classical learning from 1370 to 1905, climaxed during the New Culture movement from 1915 to 1919. When their opposition to classical learning and its traditions of natural studies peaked, New Culture advocates helped replace the imperial tradition of natural studies and classical medicine with modern science and medicine. 39 If we now have seen through the pretensions of an earlier narrative in the 20th century that adored the technological superiority of Western Europe over the non-West, then we will not welcome replacing that smug narrative with a self-satisfied story about the rise of modern science in China that a Chinese patriot might write in the 20th century. I prepare the narrative of science in China in this volume as a qualified success story, but I would not subscribe to any nationalistic claim that the march of science in contemporary China should appropriate imperial and technological pretensions vis-a-vis others. Hopefully, the fateful accommodation between technoscience and Chinese cultural history in modern times will be more measured, more hybrid, and less exuberant than the European measure of man was circa 1914, when English, French, and German politicians and generals authorized an unprecedented technological catastrophe during the Great War until 1918. 40. 38. In a famous 1966, Michel Foucault recounted his laughter while reading a passage by Jorge Luis Borges that revealed to him the exotic charm of another system of thought. Borges quoted from a certain Chinese encyclopedia titled Celestial Emporium of Benevolent Knowledge, in which the Chinese had classified animals into a series of bizarre divisions whose order was impossible to fathom, such as those that have broken a or vase or those that resemble eyes from a distance. Borges attributed the title and content of the encyclopedia to Dr. Franz Kuhn, a German translator of Chinese novels. Foucault drew the lesson that Chinese exoticisms revealed the limitations in our system of thought. Foucault noted, for instance, that Western use of an alphabetical series separated all entries from their natural affinities, linking them instead arbitrarily. One Borges's fable about enumerations from China challenges our efforts to establish an unproblematic order among things. Borges's caricature enabled Foucault to reframe fruitfully the early modern European act of classifying new curiosities in the 18th century, which, arguably, gave the sciences of life a new precision and scope. By comparison, the Chinese versions of natural history, more accurately, an historical array of entries about things, still resembled natural history in the classical period in the West, when a dividing line between living and non-living things was not decisive. Like their classicist counterparts in 16th century Europe, the Chinese authors of natural histories sought to identify and classify natural phenomena through a correct language of words. For them, all phenomena originated from the stuff of the world formed through the spontaneous shaping of all things by some sort of ultimate shaping force or internal power. They mediated efforts to make sense of the world of things through their prevailing social, political, and cultural hierarchies. 2. 3. 4. Finding the correct conceptual grid. Before the arrival of the Jesuits, the classical method of investigating things and extending knowledge was a key feature of Chinese literati efforts to set the limits of the natural and establish the boundaries for the known and unknown. Finding the correct conceptual grid had also required investigating meanings, conceptions, and ideas when foreigners introduced new religions such as Buddhism to China after AD 200. To this end, Chinese scholars compared foreign terms in light of native doctrines to determine any systematic correspondences between them. 3. After 1600, the Jesuits linked the Chinese investigation of things to European higher learning. Natural studies in pre-modern China had long implied that things included visible objects, physical or mental phenomena, and historical events. Since the Song dynasty, literati contended that things and affairs were synonymous. Each revealed universal principles. Chinese classifications thereafter reflected the cultural priorities of literati elites who saw principles in all things. 4. Things also extended to the unnamed or unknown, that is, the supernormal and otherworldly realms of human experience that were never completely elided by literati uncomfortable with the unseen and unfathomable. Natural wonders were also considered natural objects, such as luminescent amber, which gave off yellow light, magnetic lodestones with marvelous qualities, and exotic plants and animals. Discovery of magnetism, for instance, led to the invention of the magnetic compass circa 1080, which was used for both navigation at sea and geomantic sighting on land. As in Renaissance Europe, the Chinese believed the lodestone possessed healing properties. Things that had medicinal uses, such as herbal medicines, or valued as mirabilia, were also commodities to be bartered locally, purchased in the marketplace, sold to traders, collected at home, or more literally consumed. Since the Ming, Chinese cooks, for example, sometimes laced exotic foods with imported opium. Writers textually deployed things chronologically or topically in pre-modern Chinese encyclopedias with accompanying glosses so their significance could be widely fathomed. As a result, natural studies became a field for Chinese scholars who were fascinated with the etymologies of the words for natural and marvelous things, phenomena, and events. Accordingly, Chinese classical scholars normally presented the social lives of things textually. 5. Unlike early modern European scientific culture, where natural history was increasingly encompassed in a museum, the historical array of entries about things, phenomena, events, and affairs represented a nuanced account of natural phenomena as words in a text that needed to be decoded primarily through the analysis of language by connoisseurs. Each historical or natural event, natural object, or man-made implement, and mental or physical phenomena could be described chronologically in terms of a teleology of its usefulness or value to humans. In this chapter we will emphasize the textual lives of things as a clue to the cultural framework within which late imperial Chinese scholars classified them. We will also describe the monetarization of the late Ming Dynasty economy, which unleashed the commoditization of all things and turned things into objects of wealth rather than moral cultivation. 6. How literati presented things in this volatile time will enable us to understand better why the investigation of things became the Chinese window on Jesuit natural philosophy and the Jesuit window on Chinese learning after 1600. Late Ming efforts to naturalize anomalies and supernormal events by appealing to the operation of yin and yang polarities through the VE evolutive phases of Qi present us with an interesting parallel to the early modern European transformation of prodigies, such as supernatural miracles and monsters, into natural phenomena. 7. What should be the literati theory of knowledge? During the Ming Dynasty, literati increasingly relied on the annotations of Chen Yi and Zhu Xi to interpret the core philosophical interpretations of the classical canon. Gainsaying the then influential Mahayana Buddhist claim that all things were ephemeral and thus empty of abiding reality, they argued that investigating things and extending knowledge presupposed that there was a principle for all things in a real, not illusory, world. They also denigrated the petty belles lettres of their time as vacuous classical learning and thereby prioritized for literati the search in the classics for universal principles of all things, events, and phenomena, which they labeled learning of the way. Zhu Xi also discarded Xiao Yang's cosmological speculations, which Xiao had forcefully enunciated in his influential Northern Song treatise on the ultimate axis for managing the world. In the latter, Xiao contended that human beings should not pick out things, phenomena, and affairs from a human standpoint. A sage, Xiao argued, could internalize perception so that things were perceived as things. In this way, one could exhaustively fathom the principles of all things. Xiao favored a naturalistic epistemology that prioritized apprehending unmediated principles directly in things. 8. 5. Chen Yi and Zhu Xi feared that without the classical unity provided by investigating things for moral cultivation, Xiao's misplaced stress on perceiving things would succumb to triviality. Thereafter, the investigation of things rather than broad learning, literary error, or alleged Buddhist nihilism became the key to wisdom for literati versed in the classics, dynastic histories, and natural studies. By mastering orthodox classical learning, Ming literati hoped to pass the rigorous civil service examinations and gain a prestigious office in the dynastic bureaucracy. 9. Zhu Xi concluded, one must in 3 or 4 cases out of 10 seek principles outside oneself. In 6 to 7 cases out of 10, however, moral principles should be sought as part of one's moral cultivation. Although the document's classic, one of the 5 classics, warned against overly delighting in things, Zhu Xi still sought to accommodate human feelings to them. 10. Zhu Xi proposed a uniform methodology to accumulate knowledge and wisdom in both the cultural, moral, and natural political realms. He did not, however, delineate a precise classificatory system within which the investigation of things represented a particular kind of knowledge, i.e., astronomical or mathematical, social or political, cultural or religious. 11. Since the Southern Song, leading literati who disagreed with Zhu Xi's prioritizing the investigation of things attacked Zhu's use of the Great Learning as one of the 4 books to establish the epistemological boundaries for literati learning. 12. A learning of the way master, Zhu had elevated his own commentary on the investigation of things by reading it into the great learning from antiquity as if Zhu's words were the authentic commentarial voice of one of Confucius's direct disciples, Master Zheng. Zhu Shi's classical conation of his own commentary with the allegedly original 10 commentarial chapters was controversial and widely disputed by his contemporaries. During the Ming, however, Zhu's commentary became the orthodox standard in the civil examination curriculum. 16th century debates surrounding other versions of the Great Learning, however, increasingly challenged Zhu Shi and reopened literati efforts to reconsider the appropriate meaning of the investigation of things as the literati theory of knowledge. 13. The mid-Ming scholar official and statesman General Wang Yangming, for instance, preferred the old text version of the Great Learning that had survived in the record of rights over the redacted version that Zhu Shi and his followers championed. This scholarly tactic enabled Wang to contradict Zhu Shi's externalist views of the investigation of things in the 4 books and claim his own classical views as orthodox. In particular, Wang Yangming gainsaid Zhu Shi's emphasis on the investigation of things and extension of knowledge ahead of morality. For Wang 6. And his late Ming followers, the investigation of things and the extension of knowledge took a backseat to making one's will sincere. Literati morality should take precedence over classical erudition. Moreover, Wang equated Zhu's approach with an amusement in things that ruins one's aims, which the Hounds of Lu chapter in the Documents Classic had condemned. 14. One of the stories associated with Wang Yangming related that in 1492, when he was in Beijing to take the spring 1493 metropolitan examination, he discussed with a colleague Zhu Shi's version of the investigation of all things as the means to attain sagehood. Wang suggested that his friend should begin investigating for principles by looking at the bamboo in front of their pavilion. Chen Yi earlier had contended that every blade of grass and every tree possesses a principle that should be examined. When his friend grew exhausted, Wang took up the task, but he also failed to fathom the principles of bamboo. 15. Because he had concentrated so hard and had become ill, Wang Yangming now considered Chen Yi's views on the investigation of things naive. He also pointed to the elusiveness in Zhu Shi's investigating things to fathom principles. The official account in Wang's instructions for practical living, recorded by students between 1521 and 1527 while Yangming was in retirement after a roller coaster military career, described the episode. From morning till night I was unable to undo the principles of the bamboo. On the 7th day I also became sick because I thought too hard. In consequence sighed to each other and said it was impossible to be a sage or a worthy, for we do not have the tremendous energy to investigate things that they have. After I had lived among peoples for 3 years, I understood what all this meant and realized that there is really nothing in the things in the world to investigate, that the effort to investigate things is only to be carried out in and with reference to one's body and mind, and that if one RMLY believes that everyone can become a sage, one will naturally be able to take up the task. 16. Wang's alternate agenda for investigating things, which he clarified in later years, dismissed the tedious search for principles in things out there, such as bamboo, in favor of an innate knowledge of the moral consciousness. The latter was essential for moral cultivation and the inner repository of universal principles. Wang demonstrated to his followers that the moral principles of things were not easily grasped by following Zhu Shi's methods because such principles were in the mind, not in things themselves. In fact, searching for such principles outside the self was enervating, Wang contended, because 7. Piecemeal knowledge never yielded a singular moral vision unifying knowledge and action. One of Wang's students noted that things were the same as events, which Song scholars such as Chen Yi had already claimed, but the student extended the point to clarify that both referred to the mind, where their principles resided. Wang concluded from the exchange that investigating things meant preserving the clear character of the mind. The principles of things were not in the world out there, which were only things in themselves, but rather in human consciousness. Such views also wreaked the Yangming schoolman's interest in the Buddhist stress on the emptiness of things in the world and the centrality of the mind's consciousness as a reservoir of innate knowledge. 17. Subsequently, the late Ming appearance of an ancient stone-inscribed version of the Great Learning, which was later determined to be a forgery, reopened for many literati Wang Yangming's initial claim that Zhu Xi had in Song times manipulated the original text of the key passage on the investigation of things to make his personal interpretation canonical. Others sympathized with Wang's ideas but went beyond his position on the priority of the old text version of the Great Learning from the Record of Rites. To get back to the most ancient meaning of the Great Learning, they uncritically accepted a stone version allegedly rediscovered among manuscripts and recently made public. 18. That an object such as a rubbing from a spurious stone inscription of the Great Learning could set off a classical brouhaha during the late Ming was not unprecedented when compared to earlier examples of charges of classical forgery. In the past, however, forgeries and fakes had not threatened the aura of the original. Indeed, through reproductions Song, Yuan, and early Ming literati had approximated and appreciated originals of calligraphy and painting long since lost. Northern Song antiquarians, for instance, also appreciated antiquities such as bronzes and revived the classical canon such as the Great Learning as an omen of cultural and political legitimacy. Wang Yangming continued this high-minded trend even though he pointedly gainsaid Zhu Xi. 19. Because the Southern Song government valued bronze currency, officials criminalized making new vessels and confiscated ancient bronze vessels to melt down for currency. The substantial challenge an archaic literary fake posed for literati classical learning tells us that, even more so than the Song and Yuan, the late Ming intellectual marketplace was increasingly concerned with texts not just antiquities as cultural commodities. In an age when printed versions of the classics were no longer the restricted prerogative of learned elites, literati increasingly demonstrated 8. Their exclusive mastery of the canon by appealing to the authenticity of their unique editions and manuscripts. Such textual trends also allowed Ming commentators in the South to repossess the northern drama scripts from the Yuan, which they later competed over bitterly to edit and reprint. These exclusive claims were in turn challenged by many other connoisseurs and experts who possessed or claimed to possess the requisite cultural resources. 20. Late Ming classicism in the context of commercial expansion. Both officials and literati concerned themselves with the technical facets of maintaining the late Ming agrarian economy. The latter drew its strength from the productivity of an integrated river-canal lake system and land commodity labor taxes collected from private farms in over 1,300 counties where about 90% of China's population of approximately 150 million people lived in 1600. Since 1381, the government had classified the entire population into social and economic categories to determine taxes and measure access to the civil and military examinations. Revised in 1391, this massive undertaking aimed at measuring the economic resources under Ming control, equalizing the distribution of the land tax, and obtaining fair labor services from all households. Echoing the ancient classical models in the Rituals of Zhou, a text that imperial reformers since antiquity appealed to for contemporary guidance, these classifications, such as households of farmers, commoners, military men, artisans, and merchants, recorded the initial status of each family in early Ming society and how much labor service they had to provide. The government assigned each household category with a specific labor service it had to perform for the bureaucracy, and these tasks were organized according to village family units of 110 households in each community. 21. A merchant household was expected to supply merchandise or goods on demand, a military family had to provide at least 2 soldiers for service, an artisan household provided 1 worker for imperial workshops. The land registers were supposed to be revised every 10 years, and each family was required to perform its labor service in perpetuity. The wide gap between the theory and practice of Ming tax collection, however, greatly diminished government control of the economy by the 16th century. When regional markets gradually turned to a silver currency for large transactions out of the direct control of the government and for payment of land and labor taxes, this confirmed the dynasty's weakened hold over its agrarian tax resources. 22. Geared to a village commodity economy circa 1400, the Ming tax system became increasingly obsolete as population rose from 65 to 150 million and the economy became more commercialized. The Ming economy was further 9. Transformed by an agrarian revolution in which cotton displaced rice production in southern coastal provinces and the influx of Japanese and New World silver monetarized the 16th century economy in unprecedented ways. Ming Chinese unwittingly faced a global marketplace in contrast to Song regional concerns. By the 1570s, the Ming government had bowed to the inevitable and through the single whip reforms commuted the land tax and service labor systems into a single monetary payment in silver. 23 Wang Yangming's claim that the principles of things existed only in the mind, accordingly occurred at a time when literati views of the economy, commodities, and objects and their significance were changing. As China's population grew between 1450 and 1600, the reach of the relatively static imperial bureaucracy declined. Similarly, anxious Ming literati wondered if the Chengzu classical orthodoxy could still represent universal principles of knowledge at a time when domestic goods were nationally converted into objects of wealth paid for with imported silver. Ming literati such as Yuan Huang worked out the tensions between morality and affiance when he created a new moral calculus for measuring private wealth by keeping track of good and bad deeds in ledgers of merit and demerit. 24 Although literati after Wang Yangming still placed human understanding within a classical theory of knowledge, the quantity and exchange velocity of goods in the marketplace had multiplied exponentially. Ming elites were living through a decisive shift away from the traditional ideals of sagehood, morality, and frugality. Within an interregional market economy of exceptional scope and magnitude, gentry and merchant elites transmuted the impartial investigation of things for moral cultivation into the consumption of objects for emotional health and satisfaction. Ming painters presented the contemporary fondness for and connoisseurship of antiquities, for example, as a genre known as broadly examining antiquities. The paintings valorized the light ratus as a collector of exquisite things. 25 Late Ming antiquarianism in particular drew its strength from the economic prosperity that pervaded the Yangtze Delta. There and elsewhere merchants and literati used their increased natural resources to compete for status through conspicuous consumption. Merchants and literati on their travels searched for ancient works of art, early manuscripts, rare editions, and magnificent ceramics. They paid extravagant sums when they found what they wanted. The rise in value of ancient arts and crafts also touched off increased production of imitations, fakes, and forgeries of ancient bronzes, jades, and ceramics. Late Ming antiquarians with their zation on possessing things challenged the principled ideals of both Chengzu learning and Yangming revisionism. For the latter, the former had focused on things too much. 26 Wang Yangming rejected the Song Chengzu theory of knowledge because he thought its epistemology that all things were knowable in light of principles was naive. He rerouted the Chengzu agenda and reduced all things in the perceptible world to the unit eld of the mind's awareness, where all principles ultimately resided. Wang noted, seeking principles in myriad affairs and things is like saying that one should seek the principle of leal piety in one's parents. 27 Things in themselves were banal for Wang and his followers, who demoted the value of things out there, precisely when man-made commodities of value proliferated in the marketplace. Wang Yangming's turn from things to the mind in part refuted the inroads made by connoisseurship and commoditization among Ming literati. Purists like Wang still sought enlightenment, but they no longer located true principles in the vulgar connoisseur's world of objects and wealth. 28 Late Ming commercial expansion built on the dramatic monetarization of the Chinese economy during the Silver Age of 1550 to 1650 and unleashed the commoditization of things into objects of desire and affection. After the Ming state commutated village and town labor tax services into cash levies, for example, the imperial court and its bureaucracy lost control of its land and labor resources. In effect, during Wang Yangming's time a decisive shift from a predominantly subsistence livelihood based on a huge agrarian economy to a steadily expanding market economy occurred, which was linked to internal and external networks of provincial, regional, and international trade. 29 The increase in internal and external trading links stimulated an escalation in commerce, especially merchant travels and resources. Since late medieval times, the imperial state had provided a shipping infrastructure via the Grand Canal, bridges, and roads for grain tax purposes, which had linked North China and the Yellow River to the Yangtze Delta, the granary of the empire since medieval times. The delta was then linked via the Yangtze to its vast middle and upper reaches. 30. This infrastructure fueled a revolution in domestic cotton production and clothing after 1400, whereby almost all commoners in China by 1600 wore winter garments made from cotton rather than the hemp or axe linens of Song times. Diversification of crops and stress on sericulture and cotton paralleled sophisticated rice transplantation techniques in the middle Yangtze, which increasingly replaced the lower Yangtze region, Wang Yangming's home region, as the rice granary of the empire. Sugar and other cash crops, which traded as commodities in exchange for rice from new areas that now had rice surpluses, made up for the rice deficits in the more handicraft-oriented Yangtze Delta. 31 Specialized towns emerged in which the cultivation of commercial crops such as cotton and silk replaced rice land. In Shandong and Henan, hired northern laborers also grew cotton that was shipped to the Yangtze Delta for 12. Weaving. Dual cropping of summer rice and winter wheat had long been common in the south. In this commercialized environment, the cultivation and manufacture of cotton and silk using multiple spindle spinning machines tended to become separate operations with an accompanying division of labor. Local commodity production in the Yangtze Delta, for instance, shifted from traditional household handicrafts in the early Ming to merchant-oriented production in family workshops. 32 Silk, cotton, and rice markets furthered the commercialization of the rural village economy and spurred trading links with towns and cities. Improved seeds, changing crop rotations, and new cash crops such as maize, peanuts, and sweet potatoes from the New World produced a doubling of grain yields as a complement to the extension of cultivated acreage from 1500 to 1800. Commercialized handicraft production meant that changes in the rural economy produced corresponding changes in the social order for both men and women. Differentiation between urban centers and rural production in village households made peasant producers dependent on market forces and merchant middlemen. 33 Until the Ming dynasty, it was generally true that men till while women weave. Silk production, that is, spinning, weaving, and raising silkworms, was handled by women, who used family looms. By the 16th century, however, when taxes were increasingly monetarized, men and women began contributing equally to rural labor in South China. The shift in sericulture from a local, household industry to a new interregional product changed the long-standing gender division of labor. Men now worked at the loom in urban or suburban family workshops, while rural women still produced the cocoons for thread. 34 For elite consumers, Ming cotton and silk production translated into commoditized fashion, which Tim Brooke perceptively notes traveled through the social structure just as it did through the marketing structure. Fashionable women, whether wives or courtesans, preferred Suzhou cotton embroideries or Huzhu silk brocades, which simultaneously affirmed their modesty but also enhanced their stylishness. Maids and concubines quickly emulated their masters' tastes. Rather than affirm the occasional warning about luxurious living or Wang Yangming's renewed call for moral cultivation, most Ming elites became agents for the transmission of extravagance through style. Purists criticized the affinity they perceived between literati collectors of antiquities and the predilection of their wives and families for silks and furs. 35 Retreat of the dynasty from direct involvement in village affairs also magnified the role of gentried elites as landlords in late imperial politics and society. Under the umbrella of the central government, gentry and merchants. 13. In the Yangtze Delta and elsewhere diversified their hold on local power via proteering based on land rent and commercial enterprises. As state unions lessened, local public health matters evolved under the umbrella of gentry philanthropy and local literati physicians. Such elites also monopolized positions in the imperial bureaucracy by translating their economic and social power into cultural and educational advantages that enabled mainly the sons of gentry and merchants to pass the empire-wide civil examinations. 36 Expansion of the internal economy matched growth in foreign trade. The spice trade with Southeast Asia, for instance, doubled in the 16th century, and Ming China increasingly imported hardwoods from Southeast Asia for furniture, palaces, and temples. The Ming and Qing dynasties exported teas to Central Asia in exchange for horses until the 18th century. In addition to large profits from cotton goods in the domestic market, the Chinese became the world's largest exporter of manufactured goods, tea, silks, and ceramics. Production costs were kept low as a result of low overhead and a surplus of labor. Efficient agriculture also kept food prices low. 37 Early Ming porcelain was manufactured primarily for the domestic market, principally at kilns in Zhejiang, Jiangsu, Fujian, and Jiangxi provinces. Merchants linked the pottery kilns to their imperial and literati consumers. Traders translated the external demands of the market to the local producers. Later in the dynasty, the Ming exported porcelain to Japan and Southeast and South Asia. The Dutch East India Company handled some 6 million pieces in the 17th century, but this number represented only about 16% of Ming ceramic exports. Yuxing's and Jingdezhen's landlocked factories were linked via lakes and rivers in the lower and middle Yangtze region to southeastern ports such as Xiamen, Fuzhou, and Guangzhou, and from there to the Indian Ocean trade and Islamic markets. The Blanc de Chine styles developed at Dihua were for a time extremely popular in 17th century Europe and were exported in large quantities at the nearby port of Quanzhou. 38 The largest pottery factories at Jingdezhen, for example, followed the usual imperial pattern for operating such enterprises, which involved state supervision of merchant activities. The enterprises were based on the labor of hundreds of artisans, who produced the Mohammedan blue and polychrome ware in the VE colors for which the Ming became famous. Imperial taste and literati connoisseurship dictated the technical discourses of the producers into a sublime discussion of porcelain aesthetics for consumers. With the fall of the Ming, imperial purchases declined, but Jingdezhen revived and remained the major domestic and international producer of porcelain in China until 1800. 39 After 1750, Europe gained access to the technical secrets that had made China the leader in pottery making and ceramic ware for centuries. Many as 14 pecks of Ming technologies, including ceramic ware, were included by Song Yingxing in his late Ming Heavenly Crafts, revealing the uses of things, for example. Because Song described processes that were government monopolies, however, his work was not widely available during the Qing dynasty, even though it now constitutes our major source for Ming and Qing technologies and handicrafts. 40. Printing technology and publishing. Woodblock printing developed during the Song and Ming periods into a sophisticated art that by the late Ming included multicolor printing, woodblock illustration, the use of copper movable type, and woodcut facsimiles of earlier editions. Government printing during the Song dynasty had encouraged paper production, and an explosive expansion of printing in the mid-Ming yielded a wider circulation of erudite and practical knowledge empire-wide. By 1800, scholarship, book production, and libraries were at the heart of China's cultural fabric. Highbrow printing of classical works for literati elites in the Yangtze Delta was paralleled by printing of popular literature, vernacular novels, almanacs, encyclopedias, and literacy primers for a wider audience of commoners in the Yangtze Delta, Fujian in the southeast, and Sichuan in the southwest. 41 Classical learning revived during the Song dynasties in part due to the increased circulation of books and the diffusion of classical texts brought on by the spread of printing, and this development was surpassed in the late Ming. Widespread woodblock printing of classical texts created repositories for books used by scholars and students. Such publishing enterprises in turn increased interest in scholarship and education. Editions were now more readily available, and prices were low enough to make book collecting a possibility for most scholars. Printing in the early Ming capital at Nanjing surpassed Hangzhou, which had been a publishing center since the southern Song. Merchants from Huizhou, who could access the cheaper wood in their home area for woodblocks, and book traders from elsewhere congregated in Nanjing. Color editions of books became a prominent feature of Nanjing editions. Woodblock printing reached its peak in technical sophistication in the mid-16th century with the rise of scholar printers in Suzhou, Nanjing, Hangzhou, Huizhou, and Yangzhou in the Yangtze Delta, and more commercially oriented printers in Jianyang, Fujian. During the late Ming period, Suzhou became the center for quality printing, and outstanding xylographers staffed the printing shops. Fujian, the center for commercial publishing, produced a larger quantity of novels, dramas, and popular manuals than elsewhere. 16. Family businesses predominated in Fujian publishing, for example, particularly in the western mountains, where the local lineages established successful low-cost enterprises through an intricate network of bookstores and traveling merchants. The kinship links among local publishers, distributors, and sellers instantiated a nested geographical hierarchy for producing and selling books for elite and popular audiences locally and regionally. As family businesses, the local print shops fooled their lineage's cultural aspirations by catering to the local civil examination market for books on the classics and classical primers. In this manner, merchant families that proed from the book trade also invested in education for their kin in the hope that their social status would improve through an association with books and the classical scholarship of elites. 42. When successful, this strategy allowed the more prominent family print businesses to become highly cultured literati enterprises. We will see this change more clearly when we look closely at the Hu family print shop in Hangzhou in Chapter 1. By the late Ming, Hangzhou printers such as Hu Wenhuan operated shops in several cities in the Yangtze Delta to disseminate their publications. Encyclopedias such as Hu's Collectania for investigating things and extending knowledge, because they were printed in so many different combinations, were widely available in China and Japan. Although Chinese printers experimented with movable type, xylography was generally more economical when publishing many copies of a particular work. Woodblocks were easily stored and, with reasonable care, preserved for frequent reuse. In fact, printers often used the same woodblocks for collectania of different titles and compilers. Books set with movable type accommodated misprints and errors more easily, whereas a woodblock, once proofread, was more permanent. Moreover, breaking down type matrices after a printing rendered later editions very expensive. A previous woodblock, on the other hand, could be used for cheap later printings. When relatively few copies were needed, then it was feasible to employ movable type. Woodblocks were especially economical for books and manuals produced by lowbrow print shops in Fujian and Sichuan. 43. The proliferation of books and manuals during the late Ming led to the printing of numerous encyclopedias. Encyclopedias functioned as repositories and manuals of popular knowledge during the late Ming, in addition to serving as scholarly compendiums for students preparing for the imperial examinations. From this environment of readily available reference books, practical manuals, and popular compendiums of knowledge emerged a book-oriented atmosphere conducive to the development of scholarship and the practical arts. 44. For instance, the Street of the Glazed Tile and Glass Factory, located in the southern, Han Chinese city inside Beijing, originally a factory site, by the 18th century was the major book emporium and center for antiques in Qing, China. The street factory reached its height as a book market during the Qianlong era, 1736 to 1795. Because it was located close to the Hanlin Academy, the emporium was a gathering spot for intellectuals, scholars, and degree candidates who came to Beijing. Its cultural atmosphere stressed the value of rare works and ancient artifacts, promoted the exchange of books, and stimulated scholarship during the 18th century. Books and manuscripts of all kinds moved freely between Beijing and the main book markets in the Yangtze Delta and southeast China. In addition, the printing of daily use encyclopedias in the 1590s was emblematic of a widening publishing world that appealed to the lesser lights of late Ming society, namely, merchants, artisans, and licentiates. Presented as repositories of useful information for daily life, popular encyclopedias provided non-lights with a wide choice of subjects dealing with medical prescriptions, divination formulas, ancient lore, astrology, geomantic almanacs, calligraphy, etc. Unlike reference books for elites that focused primarily on the civil examinations, elite family ritual, and classical learning, many late Ming encyclopedias included information on travel and lodging useful to merchants. Such attention to the practical needs of nunlights in provinces such as Fujian meant that compilers and printers were no longer limited to orthodox topics. They could present the material aspects of normal life in rich detail for a broad audience of new readers. 45. Building on a new realism that also informed late Mingtian, ribald novels such as The Plum in the Golden Vase presented protagonists who owned drugstores, for example. Composed by an author who was writing as daily use encyclopedias proliferated, the book, circulating as a manuscript in the late 1590s, presented an inventory of goods, money, objects, collectibles, events, and skills from medical potions for enhancing sexual prowess to elaborating food at banquets, drinking games, and popular jokes. The fictional contents of the novel enlivened but also mirrored the categories and contents of the narrative-free encyclopedias. The latter was the source where authors obtained their detailed information about popular songs and daily life experiences, which they imploded in the new realism of the time. In this publishing environment, novels and encyclopedias represented different aspects of a burgeoning commercial environment that was reaching non-traditional audiences. 46. While the late Ming novel often made officials the villains, the more mundane practical encyclopedia leveled the eld to include lowbrow interests. 19. Alongside elite tastes and conventions. Such trends challenge our image of Ming learning. Was Huangyangming learning really representative of late Ming literati? In Chapter 1 we address the appearance of many practical compendia on things, affairs, and phenomena, which owered into a profusion of daily use encyclopedias in the 1590s and which contrast sharply with the high-minded claims of the Yangming schoolmen that the principles of all things were already in the mind. Yangming idealism was more a reaction to than an obstacle to the collection and investigation of things of cultural cum-natural value. Wang's highbrow idealism represented a classical rejoinder to the widespread lowbrow commodification of things during the late Ming. Many other works predated, led up to, or paralleled the late Ming encyclopedias. They also enunciated the problem of knowledge in light of the investigation of things as a textual inventory of objects. 47. The increasing market for published works during the late Ming represented a time of expanding classical and popular literacy. Late Ming followers of Chengzu learning in turn superficially blamed the crisis of knowledge on Huangyangming's misplaced idealism rather than rampant connoisseurship. They reacted by stressing even more the concrete aspects of Zhu Xi's search for informing principles in the stuff of the world. Literati authors also embodied the realm of qi in late Ming literature and poetry by instantiating it in human emotions. At the same time, Huangyangming radically prioritized the principles of things in the mind at the expense of the emotions. 48. Naturalization of anomalies in Ming China and early modern Europe. Changing attitudes towards anomalies can serve as a barometer for different outlooks concerning natural, otherworldly, and supernatural causes. The description of monsters and attitudes toward them in Europe, for example, evolved in the 16th and 17th centuries while their religious significance gradually diminished. In contrast to the monism of qi that most Chinese affirmed as the psychophysical stuff of the world, the Jesuits presented to the Chinese a numinous world of a personal God, angels, and the eternal souls of the dead. 49. Initially perceiving monsters as divine prodigies contrary to nature, early modern European elites transformed them into natural wonders. Subsequently, in the 17th century Francis Bacon included them in natural history in his Novum Organon. Prodigies when treated as natural anomalies allowed Bacon to explain the secrets of nature. Such phenomena 20. Eventually lost their autonomy as prodigies, and French specialists in the Parisian Academy of Science integrated them into the medical disciplines of comparative anatomy and embryology. Monsters thereby became counterexamples to normal development, and thus examples of medical pathology, in which nature's uniformity contrasted with the exceptionalism of monsters. 50. Similarly, with regard to the treatment of miracles in Europe, Lorraine Daston describes how the debate over the evidence of miracles became a debate over the evidence for miracles. In moving from signs to facts, miracles as preternatural or supernatural eventually lost much of their religious meaning. By focusing on the natural causes for deviating instances, Bacon and others made the anomaly and the miraculous pertinent to scientific discourse. The goal in 17th-century naturalism was to explain the causes of marvels and prodigies in light of natural philosophy and not as pure miracles. 51 Ming Chinese literati were also setting limits in official circles to the use of anomalies as political or religious signs. In Europe among learned and powerful elites, however, the evidentiary requirements there implied less confidence in the authenticity of supernatural events. Both Ming and European elites saw any emotionally charged enthusiasm for the marvelous as a possible act of deception or ignorance. For both, the dangers of false prodigies among the intellectually heterodox or politicized rabble-rousers were very real. Among late imperial Chinese elites, and the Jesuits in China, however, the otherworldly as a counterpart to the natural world never diminished as much as among secular Protestant elites in Northern Europe. Late Ming civil examinations also demonstrate that the naturalization of unusual phenomena among Ming literati, as for the Catholic Jesuit missionaries who were tied to a new counter-Reformation vision of the natural world, remained incomplete. By way of contrast, among Protestant men of science the boundary between the natural and the artificial dissolved into the notion of God as a great artisan, who could be mimicked by the great artist or man of science. The mechanization of nature was the result. Nevertheless, even in Protestant Europe the non-natural persisted as a legal category governing abnormal familial and sexual relationships. 52 Moreover, early modern European mechanical philosophy quickly became in the hands of the Protestant faithful a significant means to head off the development of an agnostic or atheistic naturalism. This goal paralleled the Jesuit concern with pagan atheism and materialism, which they perceived in the Song dynasty cosmology still prominent in the late Ming. The new mechanistic view in Europe infused dead matter with the supernatural activity of God. Jesuits would similarly contend in Ming China that the psychophysical states of Qi could not produce a world infused with spiritual vision and human. 21. Intelligence. Heaven and earth were inanimate things and could not produce all things in the world. For the Jesuits, entities could reproduce themselves, but only God created ex nihilo. 53 In early modern Europe, unlike Ming China, the distinction between natural and supernatural events was effectively obliterated by the role of divine activity in mechanical philosophy. The heretic Isaac Newton, for example, thought the observed stability of the solar system was maintained by divine intervention and that gravity could not be accounted for by the laws of mechanics alone. For Newton, as for the Jesuits, mere matter and motion could not explain cohesion or gravity. Ming literati never saw gravity, but they explained motion in terms of dense versus light Qi informed by the supreme ultimate's patterning of principles through the efficacy of yin-yang and the VE phases. 54 Theological considerations remained an integral part of early Newtonianism, which represented, surprisingly, Protestant cultural echoes of the role of divine activity in scholastic philosophy. Hence, both Thomism and Newtonianism represented a mitigated naturalism, which unlike Aristotelianism did not exclude divine providence from natural explanations. The French theologian and reformer John Calvin had rejected occultism, for instance, because for him inert matter required the spiritual excitation of natural impulses to move and change. Later, the Cambridge Platonists who opposed Calvinism still affirmed the principle of immanent divine causation. Because inert matter could not be accounted for by mechanics alone, Protestants preferred Newton's theory of gravity, as it brought God into the continuous activity of creation. For many, the natural required divine intervention. Similarly, Cartesianism affirmed but did not depend upon God's role as the guarantor of truth. We cannot assess the scientific revolution in early modern Europe as a purely naturalistic movement. The new divine right of kingship was likewise enmeshed in a similar question of God's immanent participation in running the mundane human world. 55 The reinterpretation of nature, that is, the naturalization of anomalies and miracles, still required divine props of physico-theology for its authority in Europe. Until nature was universalized as neutral and amoral, or gravity could be explained by the laws of mechanics alone, portents and prodigies could not be reduced to non-issues. As long as Ming-Qing literati believed that a rational and orderly cosmos informed the microcosmic patterns of differentiation and organization in the creation and evolution of all things in the world, the naturalization of anomalies in Ming and Qing times still required the cultivation of moral perfection of learned scholars and officials. Only the sage could truly investigate things and extend knowledge. In England only gentlemanly enthusiasts, such as the 22 early Fellows of the Royal Society, possessed the circumstances, education, cultural heritage, and moral equipment to rightfully engage in the new practice of empirical and experimental science. 56 Later in 1699, even the Jesuits were excluded from the French Academy of Science because they were no longer regarded as contributing members of the emerging scientific community in Paris. Jesuits in France had successfully moved out of their traditional classroom milieu into fields of scientific activity earlier in the 17th century. Many typed how early modern Catholics became members of the European scientific community. After Academy membership in Paris became more exclusive, however, the lack of Jesuit scientific work in China, for example, was clear. In the 18th century, French Jesuits had no official affiliation with the Parisian Academy, unlike their late 17th century predecessors. The Jesuit decline in leadership in European science and mathematics after 1700 delayed the transmission of modern mathematics, such as the calculus, and modern mechanics to China until the middle of the 19th century. 57. Ming China in 1600 was not awaiting the Jesuits' arrival. It was a dynamic if troubled dynasty of puzzling but powerful rulers, who had sent armies and navies to roll back a major Japanese invasion of Korea. Concerned literati, free-spending elites, and a vast peasantry tried to understand the present and future in light of past ideals. Scholar printers during the late Ming produced encyclopedias and collectanea that presented the natural world in light of past and present knowledge, both classical and popular, and added new layers of concern for daily existence, fascination with material life, and spiritual concern for bodily health. In 1579, on the eve of the Jesuit arrival, for instance, the Henan provincial examiners prepared a policy question asking several thousand civil service candidates to discuss astrology, mathematical astronomy, and the calendar, which was then in crisis. In particular, they asked candidates to discuss the issues in detail so that the examiners could ascertain their learning based on the investigation of things. The best essay obliged by emphasizing the natural regularities of the heavens and the fundamental principles underlying them. In Chapter 1, we will explore how mid and late Ming compendia recycled popular lore while simultaneously reorganizing classical knowledge and natural learning into more accessible repositories of ancient wisdom. 58. 23. Ming classification on the eve of Jesuit contact. 1. By the time the Jesuits arrived in Ming China, many Han Chinese literati were debating an appropriate theory of knowledge. The debate often took the form of claims that morality took precedence over formal knowledge or vice versa. The focus of the debate in Ming China was on the investigation of things and the extension of knowledge. Ming literati invoked a sense of urgency in their encyclopedic efforts to reconstruct the textual lives of things at a time when the meaning and human significance of natural and man-made objects as commodities for the many betrayed the ideals of moral cultivation for the few. 1. The Jesuits tried to reshape this research agenda by mediating between what they thought was China and their West. They would add precision to the Chinese notion of investigating things and extending knowledge by exposing Ming literati to European classification schemes, forms of argument, and the organizational principles for all specialized knowledge, i.e., scientia. They never grasped, however, that what was happening in Ming China, namely the commoditization of things into objects of material value, was also sweeping through Western Europe. Mexican silver dollars coming to China were the RST steps of disenchantment about the moral investigation of things for the Chinese. 2. Ordering things through names. Under Mongol rule during the Yuan dynasty, medicine as a profession became increasingly attractive when physician families were exempted from taxes and corvée labor as an occupational group. Some literati physicians also linked investigating things and extending knowledge to medicine as a classical term to denote the technical learning of the latter. As the only eminent Yuan physician initiated in the direct line of Chengzu teachings, Zhu Zhenhong, for example, associated medical learning with classical studies. In his most famous work, titled Discussions Based on Investigating Things and Extending Knowledge, Zhu also opposed Song's standardized government medical prescriptions that had been drawn from an empire-wide collection of Northern Song medical texts for the imperial pharmacy. 3. In the discussions, Zhu asked Yuan literati to acknowledge medical learning as one of the key fields of study that complemented moral and theoretical teachings by demonstrating the practical uses of the latter. Zhu's work had drawn on Lu Wansu's direct investigations of cold damage illness, which had also appealed to the ideal of investigating things. Cold damage disorders included influenza, common colds, and typhus or typhoid fever. In the late 18th century, the editors of the Qianlong Emperor's Imperial Library favorably cited Zhu Zhenheng's claim that medicine was one of the concrete fields that informed the investigation of things and extension of knowledge. 4. Overlap between medicine and the investigation of things was often mentioned in late Ming writings. For example, the literati physician Yu Chang, a secondary provincial graduate of 1630, prepared a medical case book. In his 1643 preface, Yu presented the methodology of the Great Learning as the epistemological basis for his efforts to gain an impartial understanding of the root causes of a particular medical problem. The achievement of sincerity resides in the investigation of things and the advancement of knowledge. Drawing distinctions requires more rigor than the dichotomy of fraud versus honesty. According to Yu, investigating a case of illness was like investigating things. The key was to advance one's knowledge one item at a time until the proper diagnosis became clear. 5. When the Catholic convert Wang Honghan learned about the Western anatomy introduced by the Jesuits in the late Ming, he equated Catholicism with ancient literati classical learning. In addition, Wang likened the great physician with the great literatus, and stressed that study of the two traditions necessitated exhaustively fathoming principles and investigating things. To classify studies and clarify principles was the way of the physician and the literatus. Although Wang accepted the Galenic tradition of anatomy as part of the Songming investigation of things, he also turned to the Chinese therapeutic tradition for lessons in how to cure illnesses. 6. Ordering antiquities and new findings. The investigation of things was conceptually also applied to the collection, study, and classification of antiquities, as in Cao Zhao's Qi. 25. Issues in the Investigation of Antiquities, which was published in the early Ming and enlarged several times. The work originally appeared circa 1387 to 1388 with important accounts of ceramics and lacquer, as well as traditional subjects such as calligraphy, painting, zithers, stones, bronzes, and ink slabs. It became an exemplar for late Ming antiquarians. 7. The 1462 edition prepared by Wangzhou was considerably enlarged and included endings prepared by several members of the Official Ming dynasty naval expeditions led by Admiral Zheng He taken to Southeast Asia and the Indian Ocean from 1405 to 1433. Ma Huan's captivating views of the ocean's shores, for example, had described the 20 countries the Eat visited and included detailed accounts of Yemenite towns such as Dhufar and Aden in southern Arabia. 8. In addition to such descriptions, Wangzhou was particularly interested in ancient bronzes, calligraphic specimens, and native curiosities. He also added native imperial seals, iron tallies, official costumes, and palace architecture to the collection. In his preface, Wang added, "Whenever you see an object, you must read all about it in the repertories, study its provenance, classify its quality, and judge its authenticity." Archaic-looking fakes produced by clever craftsmen for the Ming market of cultural commodities posed significant dangers for literati. 9. Unlike the impact 16th-century oceanic discoveries allegedly had in early modern Europe, the new information the Zhenhe brought back to Ming China from Southeast and South Asia in the 15th century did not challenge the existing frameworks of orthodox knowledge. Donald Latch has argued, for instance, that the early modern European world underwent a transformation in the 16th century which produced in observers a sense of mild shock, wary fascination, or deep wonderment. Latch acknowledges, however, that many scholars remained oblivious to the rents in the curtain obscuring the East. Those who were alert to the new endings realized that neither classical nor Christian learning in Europe could encompass the latest information, unusual artifacts, and geographical discoveries or duplicate the more advanced technical arts of India and China in textile manufacture and porcelain production. 10. More recently, however, Michael Ryan, following Lucien Febvre, has argued that the newly discovered lands and new peoples registered little impact on the values, beliefs, and traditions of 16th and 17th century Europeans. We might add that the overwhelming intellectual influence in 16th century Europe came from classical Greek manuscripts sent to Europe from Constantinople in 1453, and not from oceanic voyages. Similarly, Ryan rejects Latch's view that new forms of cultural relativism emerged in Europe. Instead, 26. Ryan has examined how these new worlds were incorporated into a European lexicon by asking how European contemporaries interpreted their world. Their use of categories, such as ancient paganism as a trans-historical framework to classify the cultures of the new worlds, enabled them to domesticate exotic peoples within the frame of Greco-Roman pagan antiquity. 11. Europeans understood other peoples in light of familiar genealogies, which minimized the impact of new worlds by conceptualizing new worlds within the terms of the old one. In 1669, John Webb contended that after the biblical deluge Noah's son Sem and his people had entered China. Athanasius Kircher, a Jesuit scholar who thought China a derivative of Egypt, thought that Cham was the better choice. The Jesuits maintained that all people in the world descended from Noah's 3 sons. Europeans usually regarded Sem as the ancestor of Asian peoples. When Chinese converts translated the Jesuit argument that the earliest Chinese were of foreign origin, however, this provoked an attack by critics of the Jesuit in Qing court circles in 1664 and led to the martyrdom of the converts. 12. Ryan has contended that the new worlds were discovered by the Europeans, which implies some sort of ownership of their discovery. Later, however, literati in Ming China also discovered and incorporated the world of Europe introduced by the Jesuits. If the discovery of the new worlds in early modern Europe coincided with the recovery of the ancient pagan world, then an alternative, a parallel, and a contemporary assimilative process occurred that we can call the Chinese discovery of the West, not to mention the European discovery of China. Moreover, after the Jesuit arrival in Ming China, literati who welcomed them prepared parallel but opposite narratives to place Western learning within the boundaries of China's classical antiquity. A century prior to the Jesuit arrival, Ming literati had widely applied their paradigm for investigating things and extending knowledge. The approach had enough authority to allow the compilers of the key issues in the investigation of antiquities, for instance, to domesticate the new materials brought by the Ming Navy from the Indian Ocean within a traditional focus on encyclopedias and their already established range of classifications. The 15th and 16th centuries in China were certainly not centuries of wonder. Leaving out the discovered and their reception of their discoverers, however, produces only a one-sided historical narrative. Moreover, the Chinese had been learning about the Old World via Islam in Central Asia and Persia all along and had never experienced isolation as the Europeans had. Any claim that most Ming literati, when compared to their European contemporaries, engaged in a subjectivist and idealist discourse about things is off the mark. Indeed, Mark Elvin has misread his sources to contend that. 27. Wang Yangming and his 16th-century followers led most Ming literati away from the precocious intellectual promise of objectivist science and natural studies in Song times. In Elvin's view, the pervasive influence of Wang Yangming was one of the three key factors that had doomed Ming China to failure in its global competition with early modern Europe. 13. Moreover, the popular encyclopedias outlined below make it clear that Ming compilers of encyclopedias never took literally Wang Yangming's efforts to ND the principles of bamboo through meditative techniques. We need to address the roots of these practical compendia of things, affairs, and phenomena, which were printed as a wide variety of daily use compendia of the 1590s. They contrast sharply with the high-minded claims of the Yangming schoolmen that the principles of all things were innate in the mind. 14. Natural studies in Yuan Ming encyclopedias. During the Yuan and Ming dynasties, compilers constantly added material to Southern Song compilations, but the military dislocations of the period from 1350 to 1450 yielded a dramatic downturn in the numbers of such publications at the same time that the Chinese population declined significantly. The expanded records of a forest of matters, for example, was a Southern Song compilation that scholar printers added to during the Yuan dynasty. By 1330 to 1332, the edition had 43 divisions, which included heavenly correspondences, the calendar and time, topography, plants and fruits, bamboo and trees, musical harmonics, Daoism, Chan Buddhism, mathematics, tea, wines, liquors, etc. In contrast, the original expanded records had only 17 divisions, which generally focused on government and essay questions from the civil examinations. 15. The Yuan Encyclopedia, complete collection of classic affairs essential for those living at home, was a precursor to late Ming encyclopedias that focused on customs, practical learning, home rituals, sericulture, health, etc. The 1301 preface to the complete collection, for instance, called it a guide to local clerks' learning, and like Ming daily use compendia it focused more on the audience of lower clerks who served in yamens in cities and the countryside. 16. The production of such daily use compendia spread more widely from the coast to the hinterlands. Late Ming publications for a popular audience centered in Fujian province, especially in the interior county of Jianyang. A noticeable increase occurred in printed works on agriculture, health, medicine, and mathematics for social groups in traditional Chinese society who were 28. Classically or functionally literate, that is, literati, artisans, and merchants. This publishing upsurge in the 16th century should be understood in light of a similar expansion during the Southern Song. In other words, the publishing of popular encyclopedias from the Song to late Ming increased, although there was a significant dip in the early Ming. 17 Jianyang editions were criticized during the Wanli reign period for their poor paper and for their use of softwood to carve wood blocks in order to sell editions quickly. They remained widely popular, however, as part of an expanding print culture, which took advantage of a decline in printing costs and book publication expenses. Such savings were due in part to a more efficient division of labor in the production of wood blocks for printed books and because the sea route for Jianyang editions from Fujian in the southeast to other regions, particularly the prosperous Yangtze Delta, proved cheaper. 18. The classification system for daily use compendia published in the late Ming typically ranged in content from 20 to over 40 major categories. Those that appeared most frequently in late Ming practical handbooks were astrology, topography, medicine, mathematics, dream interpretation, nourishing life, sericulture, writing skills, legal matters, and plants. The encyclopedias published in Jianyang encompassed a wide variety of books, including household manuals, quotation dictionaries, and collections of anecdotes, but their common feature was their topical arrangement as household handbooks and manuals for everyday life. We can identify 7 types of late Ming daily use compendia: general works, works oriented to the civil service, reference use, literary collections, sources for looking up names and people, collections of stories and anecdotes, and primers for children. 19. Based on this synopsis of the classifications and bibliographic locations for natural studies used since medieval times in the dynastic histories, imperial library, and in official and private encyclopedias, we cannot identify a single, Unit Eld of traditional natural studies before the Jesuits arrived in China. Although the four classifications were usually in effect, they were often superseded by Songyuan and Ming popular compendia. Nonetheless, we will see that among late Ming and early Qing elites both the wide learning of things and investigating things and extending knowledge were becoming a common epistemological frame for the accumulation of classical and practical knowledge. 20. Ordering pharmacology through names. Biographies of Li Shizhen have noted that the pharmacologist-physician had at the age of 14 Sui passed the preliminary county civil examinations held at his home province of Hubei. Assuming approximately 1,000 candidates per county for local qualifying examinations, Li was one of some 1.2 million literate local candidates. After he failed 3 times in the provincial examinations, like 95% of the candidates empire-wide, Li never advanced further. As he came from a family whose patriarchs had been medical practitioners and studied pharmacognosy for several generations, Li Shizhen turned to medicine for a livelihood. His father served in the Imperial Medical Academy and had written treatises on diagnosis, smallpox, the pulse, ginseng, and the local mugwort. 21. In terms of classical literacy, i.e., mastery of the orthodox canon, dynastic histories, and encyclopedias, Li was by 1535 one out of some 35,820 licentiates within an approximate population of 100 million. Beginning in the 15th century, each stage of the Ming civil service selection process eliminated the vast majority of candidates, most likely, at the local and provincial competitions. A vast constituency of failures, like Li Shizhen, sought alternative careers in teaching, medicine, preparing legal plaints for others, etc., where they could use their classical skills as scholars and writers. 22. An unexpected consequence of the empire-wide civil examinations was the large number of classically literate men who as a writing elite also formed a significant reading public. In addition, literate women in elite lineages were by the late Ming exchanging poetry and educating their male and female children with equal facility. Such large numbers of classically literate men and women created an audience of some 5 million readers and their families, that an author of a popular Ming work, such as a practical digest, pharmacopoeia, or novel, could potentially reach. 23. Li Shizhen was not directly influenced by the 1590s daily use compendia discussed above, but he was aware of the dubious quality of such earlier works. His magnum opus, the Systematic Materia Medica, and the effusion of encyclopedias and classide pharmacopoeia in the late Ming represented improvements. An ample number of classically literate men and women, and a large audience for practical manuals, compendia, and population, created the market that late Ming printers in South China sought to prod from by selling a wide assortment of works by men such as Li Shizhen in the late Ming. Choson Korea, Tokugawa Japan, Le Vietnam, and the overseas Chinese communities in Southeast Asia were additional markets for Ming and Qing editions of such compendia. 24. Li Shizhen completed the null version of his Systematic Materia Medica in 1587. By 1590 he lined up a printer in Nanjing for the complete project. The RST printed version appeared posthumously in 1596. Subsequently, the huge work sold out rapidly enough that 8 reprints were issued in the 17th century alone, 3 of them by 1602. The Systematic Materia Medica was quickly transmitted to Tokugawa Japan via European traders. The RST Japanese edition came out in 1637. Scholars in Europe began to take notice of Li Shizhen's work in the middle of the 17th century, and the French Jesuit academic Jean-Baptiste du Halde cited it extensively in his 1735 geographical and historical account of the Manchu Empire. In the late 18th century, the 1655 edition of the Systematic Materia Medica was included in the Qing Imperial Library. 25. If we place Li Shizhen's Systematic Materia Medica in its medical and pharmaceutical context, we nd that Li worked tirelessly on a revised Materia Medica that would correct the errors of identification, classification, and evaluation that had accrued in the standard Song Dynasty series. In particular, Li's generation of physicians, like their Jin and Yuan predecessors, were dissatisfied with northern song materia medica. 26. Unlike the Ming, the Song Bureau of Medicine, for example, had collected thousands of medical formulas that led it to publish and distribute formularies beginning in 1107 to 1110. The latter were based on compound medicines packaged for sale in the government dispensaries. Revised many times, these formularies were reprinted for wide use. Lu Wansu and Zhu Zhenheng, among others, had been critical of these recommendations because they found the system rigid and not effective in treating illnesses in the 13th and 14th centuries. 27. From 1556, Li traveled widely in major drug-producing provinces, gathering comprehensive information on mineralogy, metallurgy, botany, zoology, and drug formulas. Over the span of 3 decades from 1552 to 1578, Li took into account some 40 pharmacopoeias by various authors, 361 medical works, and 591 classical, historical, literary, and encyclopedic works. The medical works were further divided into some 84 cited in earlier pharmacopoeia and the 277 Li cited for the RST time. The non-medical works were from historical, canonical, technical, and literary sources, as well as from dictionaries and encyclopedias. Of these, 151 texts had been used in earlier accounts, 440 were cited by Li for the RST time. Among the 932 titles, including the 792 described above, which Li cited as sources in his detailed bibliography, 36% were medical and pharmacological works, while 76% were quoted for the RST time in the materia medica literature. Hence, the RST innovative aspect of Li's work was his addition to the materia medica literature of much data about drugs and diseases new since the Song dynasties. He incorporated, for example, the medicinal uses of maize and the sweet potato, New World crops introduced from the Spanish Philippines in the middle of the 16th century. He also reported on the Emmer 31 gens of a new disease, syphilis, which he traced back to the late 15th century in Guangdong province, but which may have had a New World origin. Li Shizhen argued in his conventions to the systematic materia medica that the ancient headings in earlier canonical works on materia medica had been mixed up and that their true meanings were lost. Because Li saw his efforts in terms of a revisionist, tripartite research agenda that included RST research and correction, then analytic procedures, and Nally synthesizing procedures, recent historical accounts have described Li Shizhen as not merely a pharmacist doctor but also a botanist naturalist. 28. The structure of previous works on materia medica had been based on the ancient classifications in the canonical materia medica of Emperor Shenan, which became a classic after it was compiled circa the RST century BC or AD. Although the work was subsequently lost, its three-part distinction between minerals, plants, and animals was appropriated in later pharmacopoeias because of its canonical status. Drugs, for example, were classified from a therapeutic point of view into 3 grades. The canonical pharmacopoeia of Emperor Shenan with collected commentaries by Tao Hongjing introduced a second partition in the materia medica literature. Based on the 3 natural grades of minerals, plants, and animals, Tao distinguished each of these categories by subdividing them into several subgroups with no attempt at rigorous taxonomy. Completed in 1496, a century before Li Shizhen's work was published, Wang Lun's Essentials of Materia Medica distinguished between 10 different subgroups: herbs, trees, vegetables, fruits, grains, minerals, quadrupeds, birds, insects, and and humans. Chen Jiamo's Enlightenment on the Materia Medica, which was published in Li Shizhen's youth, had followed Wang Lun's model with a few modifications in the order of Wang's 10 subgroups. For example, Chen made plants RST and humans second in the order. 29. By the time Li Shizhen turned to materia medica issues, there was a clear sense that past classifications, like Song official prescriptions, had become problematic, both because of accumulated confusions in the historical record and because of a good deal of new information that had to be added based on experiences with illnesses more common in South China. In addition, Li Shizhen's organic pharmacology continued the Songyuan Ming condemnation of ingesting poisonous substances, which had been associated with the traditions of external alchemy in medieval times, favoring natural herbs and less harmful minerals. 30. In his conventions, Li further declared the need to reorganize the existing knowledge of drug products. He did this by hierarchically ordering the material into 16 sections, 60 categories, and 1,895 kinds. Li's use of Kate. 32. Goris as an independent structuring device was somewhat less innovative, but he did improve on earlier efforts to develop a classificatory scheme. Li Shizhen paid attention to the ecology of living things from which drugs were derived. His taxonomic order combined rubrics that were indifferent as to habitat, physical characteristics, and use. Items were organized by their morphology and their qualitatively deemed physical configurations of qi. To the latter, Li applied the VE evolutive phases as divisions for dynamic processes or static configurations. The Re phase, in particular, was reconceptualized in Li's systematic materia medica as an independent medical category, which represented one of the configurations of qi affecting the body. In this regard, Li was building on Song and Jing conceptual developments that prioritized the focus on Re within and without the body as an important heat factor in the maintenance of health and the prolonging of life. 31. Li's sorting of plants was sometimes determined by the following categories: the habitat of plants, their morphological aspects, whether they were wild or cultivated plants, their therapeutic aspects, culinary and medicinal aspects, and the agricultural categories for grains. His taxonomy was, however, often still based on subjective judgments, medically overdetermined, and not on botany. Hence, the criteria for his categories were not exclusively naturalistic. 32. Moreover, Li Shizhen reclassified the entire materia medica record, which revealed Li's concern with the investigation of things. His approach also stressed the problem of nomenclature, as the main entry in his classifications. Another sub-entry explained the names of things themselves. The structure of Li's entries in the systematic materia medica were presented as explanations, corrections, and clarifications in the conventions. They provided late Ming physicians and scholars with a broad reservoir of practical medical knowledge. 33. Accordingly, Li Shizhen's materia medica enterprise was also a scholarly project, although this is what doctors have called medicine. In examining and explicating their principles, I have actually practiced what we literati scholars call the study of the investigation of things. This can LL the gaps in the progress toward elegance and those in the commentaries on the poetry classic. Appealing to the Ming tradition of investigating things, Li contradicted in practice Wang Yangming's claims about what constituted careful research concerning the external world. Li Shizhen had little patience with any effort to employ meditative techniques to fathom the principles of a plant such as bamboo. He was too busy concerning himself with its natural history, nomenclature, and medicinal aspects. 34. Li's materia medica and the many daily use compendia of the late Ming are a better guide than the work of Yang Ming schoolmen to the evolution of the investigation of things as an epistemological principle for precise scholarship. 33. Before the index of Western learning via the Jesuits in the 17th century. Earlier accounts that have paid attention primarily to the moral philosophy of Wang Yangming have misrepresented the intellectual complexity of pre-Jesuit natural studies in Ming China. Like Li Shizhen's systematic materia medica, late Ming digests cited a wide variety of books, manuals, dictionaries, and literary collections, although they did not strive for Li's standards of scholarly rigor. Their common feature was their increasingly complex topical arrangements, which were accompanied by new knowledge and more information about things. Such works were widely printed in South China by printers when lower printing costs made cheaper editions accessible beyond the classically literate elite. Collecting the collectors. The Ming scholar merchant and Hangzhou bookseller Hu Wenhuan, like Li Shizhen, pregeared the Sino-Jesuit dialogue concerning the investigation of things and European scientia in the early 17th century when he compiled and published his widely circulated Collectania for investigating things and extending knowledge in the 1590s. This collection of books, published as a set, embodied a repository of classical, historical, institutional, medical, and technical works from antiquity to the present in China. The Collectanea also contributed to the growing late Ming literature of material culture. Its wide dissemination in Mingqing China and Japan, in many editions from Hu Wenhuan's Hangzhou and Nanjing print shops, marks it as a very unusual and thus representative work. It did not have the scholarly pedigree of the systematic Materia Medica, but whose Collectanea affords us a unique window onto more common divisions of knowledge. Who had successfully commoditized classical learning in an age of Ming connoisseurship. 35 Although provincial informants mention 200 sets of the Collectanea in the 1780s, the compilers of the Qianlong Imperial Library Catalogue criticized its unevenness, looked down on Hu's prot-oriented marketing of several editions, and only summarized its content in the official catalogue. It was not included in the library. Nevertheless, its extensive circulation in many published forms allows us to access a representative world of pre-Jesuit natural knowledge and lore. Analyzing its subject matter allows us to go beyond Borges's and Foucault's ahistorical musings about quaint Chinese encyclopedias. The Collectanea for investigating things and extending knowledge presented a cumulative account via a collection of books of all areas of knowledge important to a literati and nouveau riche audience before the Jesuits made their presence felt in Ming literati circles in South China after 1611. 36. 34. Because Hu Wenhuan also had wide-ranging interests in medicine and popular religion, some versions of the Collectanea contained a broad scope of illumination texts and esoteric writings, which I will discuss. In addition to addressing the Collectanea in light of its many variant editions, I will also analyze its initial, pre-Jesuit focus on early lexicons and natural histories, which overlapped with classical learning and natural studies during the late Ming. The smaller, more orthodox version of the Collectanea thus parallels the distancing of the queer and supernormal in some song encyclopedias of the 10th century. 37 For example, the northern song materials of the Taiping Xinguo era for the emperor to read did not include unusual phenomena or paranormal novelties from medieval times. Moreover, the compilers declined to present grotesques, strange plants, animals, and minerals, and odd countries that appeared in the expanded records of the Taiping Xinguo era, which focused on popular religion. The taxonomy informing the materials of the Taiping era was more representative of highbrow literati tastes, which were reproduced in the song genre of jottings. The latter were generally aboutional, historical, or textual material that were preserved by their authors as odd notes. Earlier interests encompassing natural phenomena and supernormal topics in jottings had waned. Thereafter, most jottings were about recollections of court events, celebrated fellow officials, and experiences in the civil service. 38 On the other hand, even though the expanded records was less consonant with orthodox encyclopedias, its contents were representative of lower-brow literati and echoed the nourishing of life traditions that permeated popular religion and medical discussions on prolonging life and achieving immortality. This dual track of song encyclopedias was never mutually exclusive, however, and the creative tension between them continued in later Ming collections of books published as a set, such as Hu Wenhuan's Collectanea. 39. The life of a late Ming scholar-printer-collector. We glean from Hu's many prefaces to the works he collated a sense of his life and work as a scholar-printer. His grandfather and father were both Hangzhou collectors and printers, and many of Hu Wenhuan's reprints came from his family's cultural traditions. Between 1592 and 1597, Hu wrote some 49 prefaces for works he compiled and published. Hu and his staff assembled some 100 works in his Hangzhou and Nanjing print shops, which made their way, selectively, into the enlarged versions of the Collectanea for investigating things and extending knowledge and other Collectanea that Hu printed. 35. Hu Wenhuan had several colleagues who shared his bookman's interests and helped compile his works. In addition to collation, they provided prefaces and encomia in Hu Wenhuan's series. One of them, Zhang Lun, was also the teacher in the Hu family school, which indicates that he was well versed in classical learning and that like Hu he was a licentiate who had not advanced further on the examination ladder. Another colleague, Chen Bangtai, helped in printing the books. Hu's family printing shop in Hangzhou became known as the Hu Chen Great Print Shop, which suggests Chen's importance to the enterprise. 40 Hu himself was a Nanjing Imperial School student, who had likely purchased his licentiate status to enable him to compete in local qualifying examinations. Like Li Shizhen, then, Hu Wenhuan had attained a high level of classical literacy and literary ability, but also never attained a higher provincial or metropolitan degree. By the late Ming, of the 50,000 candidates empire-wide competing triennially for some 1,200 provincial degrees, fewer than 3% would succeed. Because most like Hu Wenhuan, never became provincial graduates, the Ming dynasty required licentiates to keep taking biennial renewal examinations to maintain their special legal status. Like most such students, Hu did not attend his assigned school. The roles of local official schools were increasingly LLED with candidates who had repeatedly failed higher examinations and had nowhere else to go. 41 Hu used two studio names, one known as the Hall of Writings brought together in Hangzhou and the other called the Office of Thoughts of Retirement in Nanjing. His other sobriquets, such as penetrating the arcane, also suggest his sympathies with the esotericism associated with popular religion. As the southern capital of the Ming, Nanjing was an important publishing center in the Yangtze Delta, along with Hangzhou and Suzhou. Consequently, Hu also relied on the Nanjing book market for many of his editions, although they were mainly published in Hangzhou. Hu's range of focus, from orthodox classical texts to esoteric medical writings on nourishing life, were tied to his examination studies and his weak health as a youth. 42 In addition to books and texts, Hu Wenhuan also collected antiques and musical instruments. He was interested in tea as a cultural phenomenon, as well as wines and perfumes. The Nanchal Bonnets from his printing enterprise, based on selling many different series of his printed works or individual volumes from the collection, enabled Hu to maintain the lifestyle of a literati scholar with wide cultural interests, even though he had failed to gain an official appointment. By the late Ming, merchant and literati collectors like the Hu family grew and diversified. Hu Wenhuan Nali received an appointment in 1613 and served as a low-level county official in Hunan province, RST as a 36. Magistrate's aide and then as an administrative clerk. While Wenhuan was away, the Hu publishing enterprise diminished. 43 In sum, Hu was a merchant scholar of wide-ranging literati interests, and the large-scale collectania that he compiled, collated, and printed before 1613 preserved many rare texts for his Ming contemporaries, though his editions were later criticized for their poor quality. 44. A highbrow version of the collectania. The contents of the more classical versions of the collectania for investigating things and extending knowledge ranged from aspects of heaven and earth to classifications of birds, animals, insects, grasses, foodstuffs, architecture, and tools. A classicist frame of reference informed Hu's systematic collection of data from native sources concerning China's natural resources, the arts, and manufactures. The portions dealing with these high-minded themes reveal Hu's efforts to republish and cumulatively build on previous works that focused on natural phenomena, names and their referents, and affairs and things. The earliest printing of Hu's more orthodox versions included 46 works that we will focus on RST. Later, enlarged editions of 180 to 200 or more works were compiled by Hu in order to sell more sets of the collectania for prod. These editions somewhat resembled the Northern Song expanded records of the Taiping era as a repository of popular and religious lore, although the latter was not just a collection of texts available for purchase. Starting with annotations of the Progress Toward Elegance Dictionary and the explication of names, the initial edition of 46 works emphasized a comprehensive account of etymologies and word definitions that would shed light on the Golden Age of Antiquity, a period of enlightened governance. The rectification of names, a perennial literati concern, was a passionate aim. Overall, the collectania emphasized a broad learning of phenomena, one of whose main classification categories, which encompassed natural and textual studies within a humanist, esoteric, and institutional agenda. Missing, however, was the sense of methodological unity to the investigation of things and the extension of knowledge that Zhu Xi and his Songming followers had prioritized. Who was content to introduce the lexicographers together in one place without any guidelines for synthesis or analysis. 45 whose collectanea represented one of a large number of late Ming collections of books published as a set that were aimed at elite and popular audiences. Their contents incorporated information on natural history and lexicography to LL the gaps in meaning that had opened between visual things and written. 37. Words in classical learning. Scholars working on pharmacopoeia and medicine, such as Li Shizhen, were also concerned that the language used to designate things, phenomena, affairs had by the 16th century become increasingly muddled. Historical accounts of phenomena were presented as a genealogy of glosses, a sort of textualized natural history, but the order had accrued chaotically. Names for plants, animals, etc., in terms of kind, species, attributes, and uses needed reordering, i.e., rectification. Although it did not pursue the methodological rigor that informed the Li Shizhen systematic materia medica, whose collectanea, nonetheless, contained a repository of works from ancient to contemporary times, which in its initial printing presented the classical ordering of knowledge and its later recapitulations. The collection embodied the problems rather than the solutions. Overall, late Ming collectanea and encyclopedias sought to restore all the words that had been lost or muddled since antiquity through a meticulous re-examination of things. Composed in the classical language of elites but accessible to low-level licentiates and clerks, whose collection of the collectors allowed him to describe and order things, phenomena, and affairs. The extant genealogy of classical glosses was the RST step in capturing the common affinity of things through the language in which they were historically represented. The late Ming collectanea became a textual site for refashioning and reproducing the endings of past sages, worthies, scholars, seekers of immortality, monks, masters, and commoners. It served as a genre for collecting the collectors through texts and diagrams, which drew on the intellectual lineage of things, phenomena, affairs, and esoterica dating from the ancients. 46 Just as Li Shizhen engaged in a reformative agenda of observing, analyzing, recognizing, and naming plants for medicinal purposes, others reviewed the classical search for why things were the way they were. By delimiting and altering the visible structure of things drawn from a wide variety of sources, whose collectanea derived its classical respectability from the traditions of orthodox classical learning. When the Jesuits presented an alternative natural history in an Aristotelian conceptual language for the structure of the world, their description of the visible world was translated by their Chinese collaborators in the language of the late Ming theory of knowledge, namely investigating things and exhaustively mastering principles. Lexicons in the collectanea for investigating things and extending knowledge. Available since the Han Dynasty, the Progress Toward Elegance dictionary contained glosses for the names of things in early classical texts. The compiler. 38. Was not the observer, but the second-hand entries of cryptic glosses identified anything from grammatical terms in language, labels for kinship relations, technical language for palace architecture, and names of utensils and tools to the names of musical instruments. Since antiquity, elegance in language had corresponded to elegance in material life. In addition, the Progress Toward Elegance extended its classifying vision to the natural world. One of its 19 subjects explicated astronomical, calendrical, and climatic terms. 4 sections included glosses for geographical, topographical, and geological items. Finally, 2 sections covered the names of plants, and VE sections presented words for insects, sh, fowl, and wild, domestic, and legendary animals. 47 As a classical dictionary, the Progress Toward Elegance was not written by a botanist or paleontologist. Yet its search for orderliness through understanding ancient names was a serious effort to know about things through an assessment of words. When the medieval commentator Guo Pu annotated the dictionary, for instance, he noted in his that it was a comprehensive compilation of theses. He added that it was the unconfused basis for a broad learning of things. The progress toward elegance, Guo concluded, was the handiest contemporary source for names of birds, animals, and plants. It was also a valuable source for names of curiosities and words in different dialects, based on reliable and varied sources. The compilers of commentaries and follow ups to the progress, which Wen Huan also included in his Collectanea, addressed the discourse of names, things, phenomena, and affairs. Mediated through the classical language, an amorphous natural history emerged. The allegedly well-constructed classical language for reality gave the reader access to the verbal structure of the visible world. 48 The stature of the progress toward elegance was enhanced during the Wei dynasty when it was attributed to the sagely Duke of Zhou by the expanded elegance, which was the third work included in the initial printing of Hu's Collectanea. Later classicists often accepted this attribution and contended that Confucius had said the progress toward elegance was a window on ancient Zhou governance. Because of such attributions, the progress toward elegance rose in the 9th century to the status of a classic. Consequently, from the late Tang to the end of the Song, scholars treated it as a canonical text even though few accepted the claim that the Duke of Zhou was its author. Nevertheless, when the Qing Imperial Library was completed in the late 18th century, the progress toward elegance was classified under the classics and given eminence of place as the paradigmatic work in etymology. 49 Other Song classical works such as Lu Dian's Adding to Elegance. 39. Linked the progress toward elegance as a classical collection of glosses to the poetry classic. Lu noted in his that the civil examination essay was not used before 1056 and that prior to that candidates for public office had relied on poetry questions in the civil examinations to gain a name for themselves. As a byproduct of such preparation, candidates had a greater knowledge of the aura and fauna enumerated in the poetry classic. 50 Lu Dian was paraphrasing Confucius' famous injunction to his students in the Analects that through study of the poetry classic they could become more acquainted with the names of birds, beasts, and plants. Lu described how after 1077, when the examination essay took precedence over poetry, everyone mastered classical techniques while traditions of belles lettres declined. As a result, knowledge of the names of natural things diminished. Lu Dian clearly pointed to the importance of the poetry classic for natural knowledge. 51 In his observations added to the heavens section of the progress toward elegance, Lu Dian included sections on thunder and lightning. Citing ancient and medieval sources on how rain produced thunder, Lu Dian explained thunder in terms of the concatenation of yin and yang. Thunder is the yang part of yin. He then cited the medieval work by Yang Quan on the principles of things to the effect that an accretion of wind produced thunder. From this perspective, the fundamental cause of lightning was thunder and not vice versa as in modern accounts. Hence for lightning, Lu Dian noted that when yin and yang intercept each other and dazzle, this is the same qi as thunder, which when released produced bright light. 52 Based on traditions that thunder emanated from heavenly qi, while lightning came from earth's qi, Lu noted that thunder belonged to the Re phase, and that the bright light was the lightning while the sound was thunder. In conclusion, Lu cautioned that although related in terms of yin-yang and the Re phases, one should still see thunder and lightning as separate phenomena. Lu added that when the ruler decided court cases, such cases were seen as counterparts of heaven and that if there were occurrences of lightning and thunder, these were taken into account. 53 Wen Huan included his own work on the poetry classic, in which he repeated that knowledge of the names of birds, animals, herbs, and trees was important for understanding the poetry classic. Hu's views reeked at what was in late Ming commonplace in civil examination policy questions on broad learning. In a 1597 provincial examination, for instance, the Shuntian examiners asked several thousand candidates for civil office to address why Confucius had focused students on names and things and not just principles and nature. 54. 40. In a 1593 preface to one of his works, Hu replied to critiques that his research was redundant or too nitpicking, "If one says that Master Zhu brought together and that I have split it all up, then what good is erudition? In effect, who revived focus on the things phenomena affairs mentioned in the poetry classic, which displaced Zhuxi's efforts to Baudelarize the more sensuous love poems in the classic. The charge that Hu was splitting up knowledge, however, was an indication that his printing of works dealing with things, affairs, and phenomena no longer sustained an overarching methodological unity, which had informed the song appeal to universal knowledge. In his scholarship on the poetry, Hu collected items of information. He was not searching for universal principles. 55 Perhaps because it was already widely available, Hu Wenhuan did not include the 2nd century analysis of simple graphs as an explanation of complex characters in the many printings of his Collectanea. A paleographic dictionary of ancient writing forms, the analysis of simple graphs frequently informed the lexicographical content of Hu's Collectanea, however. Nor did Hu's RST collection of books published as a set embrace important Tang and Song works on phonology, although he included Ming works on poetic rhymes, including 2 by himself. Overall, the lexicographical focus in this version of the collection stressed etymology over both phonology or paleography as the means to recover ancient glosses. This endeavor wreaked at late Ming trends in classical studies that stressed etymology and paleography, which were later superseded by Qing dynasty phonology. 56. Early natural histories in Hu Wenhuan's Collectanea. Chinese naturalists represented the physical world through an historical array of entries about things, phenomena, and affairs. Several works were included in Hu Wenhuan's Collectanea that resembled natural history in the classical period in the West, when a dividing line between animate and non-animate objects was not yet decisive. A biology did not yet exist among the Chinese or the Jesuits, although we can identify aspects of a vitalism linked to qi and nurturing life in Ming-Qing medical discourse, which was bounded by a classical concern with the structure of the visible world expressed as a theory of words about things. 57 Like their classicist counterparts in Europe, the authors of Chinese natural histories, whose works were included in the RST printing of Hu's Collectanea, sought to identify and classify natural phenomena through language. The RST such natural history that Hu Wenhuan included was the Hori Classic of Mountains and Streams, annotated by Guo Pu. Guo was 41. A master of esoterica who had annotated several archaic texts included in Hu's Collectanea that dealt with anomalies and natural phenomena. Guo's official biography in the history of the Jin dynasty noted that he was a student of classical techniques, whose broad studies included the VE phases, astrology, techniques for prognostication, warding off calamities, and turning back misfortunes. The Classic of Mountains and Streams was a composite compiled over several centuries, which can be described as a Descriptio Mundi. Ascribed by some to the sage King Yu the Great, it described the earth in terms of concentric rectangles with a central territory, 4 seas encompassing the central lands, and a great wilderness. Because it also contained valuable information about mountain spirits, popular medicine, divination, and other mantic arts, often incorporated in later texts, it was at times classified simply as a handbook of anomalies and prodigies, in addition to a historical geography. Han Dynasty scholars regarded it as a window on ancient portents and foreign customs. The Ming bibliophile Hu Yinglin, a Zhejiang contemporary of Hu Wenhuan, described it as the ancestor of oddities in Chinese literature. This view foreshadowed its derisive inclusion under the idle chatter and gossip subcategory in the late 18th century Imperial Library Catalogue. 58 Guo Pu's preface to the work opened by noting that most scholars before him had seen the text as a strange and unconventional collection, that everyone had doubts about. For Guo the key issue in interpreting the work was RST to be clear about what an anomaly was, with respect to a correspondence phenomenon. When people called it an anomaly, they did not know why it is anomalous. When they did not call it an anomaly, they did not know why it is not. Why? Something is not anomalous of itself. It must await R before it can be anomalous. Anomaly ultimately resides in us, not the thing. Because an anomaly was apparently odd to us but not in and of itself, an assessment of a thing, phenomenon, or affair, according to Guo was based on our prejudiced judgments drawn from our unbalanced experience. We observe based on what we habitually see, and we regard as strange what we have rarely heard about. This is the usual screen for human feelings. Moreover, because oddities reeked at our assessment of them more than anything inherent in phenomena, any strange things recorded in the text of the classic of mountains and streams were difficult to explain away simply as anomalies. Guo concluded that such records probably reeked at ancient, everyday references that no longer corresponded to today's habitual designations for 42 things. In effect, Guo was protecting the phenomena in the classic of mountains and streams from thoughtless derision. However odd such records appeared to us today, they had to be taken seriously as ancient accounts of actual things, phenomena, and affairs. Guo later prepared a work containing over 250 appraisals of the famous illustrations that by the 3rd century AD were included in the work but later lost. 59 Next in the Collectanea, Hu Wenhuan included 2 works on birds and beasts. First came Zhanghua's annotation of Shi Kuang's broad classic of aviary. The work allegedly dated from the Zhou dynasty and opened with 360 categories of birds. Priority was given to the male phoenix as the chief example of feathered types of animals. Like Guo, Zhanghua was a medieval master of esoterica, famous for his knowledge of underground and remote realms, skilled as a diviner, and informed about spirits and exorcism. The classic of quadrapes, which followed, included mention of auspicious animals. Neither work was a zoology per se, though each contained descriptive accounts. Rather, they were repositories of curiosities, prodigies, and wonders, and thus outside the realm of normal explanation. 62 later works in the initial printing of the Collectanea were records of anomalies that dated from the Han through the Song. The classic of spirit marvels of the later Han dynasty was completed circa the late 2nd century, and a later Jing commentary attributed to Zhanghua was added. The religious tenor of the work, including the veneration of sacred texts, linked it to the increasingly porous cultural and religious boundaries of orthodoxy and esoterica, which Chinese literati could comfortably straddle up to the Song dynasty. The record of accounts of strange things was allegedly prepared during the Liang dynasty, although the compilers of the Qing Imperial Library Catalogue saw it as a Tang forgery because it contained anachronisms. 61 A preface to the record of accounts of strange things dating from circa AD 503 indicated that the author had accessed a library of 30,000 chapters when he prepared his work, which allowed him to include a great deal of stories about anomalies. In addition, his work was informed by an interest in a broad learning about things. The afterword composed in 1044 by Yefang defended the record and deemed oddities as matters that were unheard of. It linked the focus in the work to the broad learning of the scholar, thus making writings about anomalies perfectly respectable, a claim that was contentious among Song literati, who distanced themselves from the records of anomalies genre. 62 Perhaps the most representative texts of early natural history included in Hu's Collectanea were those that focused on broad learning of things. 43. Zhanghua's treatise on broad learning of things and Li Shi's Song dynasty continuation were included. Other such Song dynasty works in Hu's Collectanea were Record of the Origins of Things and Affairs, compiled by Gao Cheng circa 1078 to 1085. Discussions on the formation of heaven and earth and the myriad things by Wang Bo. Several works from the early and middle Ming were also printed. Origins of Things. Origins of Things Old and New Examination of Ancient and Contemporary Things and Affairs. Zhanghua had prepared a table of contents with 39 topical headings for his treatise. Of particular note in this classification list are the highlighted items number 17, Nature of Things, number 18, Principles of Things, and number 19, Categories of Things, which used terminology that would later be refracted RST by Jesuit and then by Protestant missionaries with the help of their Chinese collaborators to refer to late medieval and early modern scientific elds. 63 The Jesuit translation for physics into Chinese was used in Giulio Alani's A Summary of Western Learning. Physica or Physiologia appeared in the De Logica, which was compiled by Francisco Furtado and Luis Hizeo. Similarly, the modern translation for physics, despite its late 19th century Meiji Japan lineage, could also trace its genealogy as a technical term back to Zhanghua's treatise. 64. In general, these works stressed each human event, object, implement, or natural phenomenon in terms of a teleology of their usefulness to humans and presented a genealogy of discovery that traced each item back to the appropriate sage, ruler, or scholar in antiquity. In his preface to the Record of the Origins of Things and Affairs, dated 1448, Yanjing linked all myriad things and affairs to their principles, which could be investigated by studying their origins. The myriad things, which heaven and earth and extend from antiquity to the present, always have matters changing within them. Things 1. Geography 14. Unusual insects 27. Debates on Fangxi 2. Earth 15. Unusual sh 28. Corrections of names 3. Mountain 16. Unusual plants 29. Corrections of texts 4. Waters 17. Nature of things 30. Corrections of geography 5. General topography 18. Principles of things 31. Corrections of ceremonial rites 6. Peoples in VE 19. Categories of things 32. Corrections of directions music 7. Product 20. Medicines 33. Corrections of sumptuary display 8. Foreign countries 21. Medical discussions 34. Correcting names of utensils 9. Strange peoples 22. Food taboos 35. Correcting names of things 10. Unusual customs 23. Pharmaceutical arts 36. Information about anomalies 11. Unusual products 24. Stagecraft 37. Historical supplements 12. Unusual beasts 25. Fangxi 38. Miscellaneous words, Part 113. Unusual birds 26. Medicinal foods 39. Miscellaneous words, Part 2a. A. Baoji, 1-4-5, in GZCS. See also Company, Strange Writing, pages 49-52, Roger Griotrex, trans, Baoji, an annotated translation, and Hervu ed. A Sung Bibliography, p. 343. Have myriad variations, affairs have myriad transformations. No matter or thing is without a principle and an origin. If one does not fathom the principle, then there is no way to complete the knowledge in our minds. If we do not research the origins, then how can we unravel and fathom its principle? Therefore, sagely studies give priority to investigating things and extending knowledge. Literary scholars value broad inquiry and wide learning. But a scholar would be embarrassed by failing to know even one thing. 65. The meaning of the title for the Record of the Origins of Things and Affairs assumed an overlap of natural things, phenomena, and human affairs with a stress on the investigation of things and exhaustively mastering principles. Its scope ranged from large to small, to subtle, and to the manifest. This spectrum moved from natural to social phenomena. The sources for each item were cited in chronological sequence to elaborate a particular item and set its origins in human terms. Further discussion was Oshios. 66. Luoqi's 1474 preface for his Origins of Things opened with discussion of the sages as the creators of implements. He was critical of earlier works for not excluding patently absurd items. Within his arrangement of 18 categories, Luo included 239 total items. The afterword explained that the aim of the Origins was to explain the things of heaven and earth in relation to changes in human matters. 67. The examination of affairs and things from antiquity to the present by Wang Sanpin included an institutional account of historical geography, as well as general information required for classical literacy and civil examination preparation. In addition, Wang's brief history of numerical correspondences, later a term for mathematics in the 19th century, was linked to the change classic and the naturalistic process of the formation of things based on yin-yang and qi. In his 1538 preface, Wang Sanpin noted that he had added material to song accounts. Wang presented naturalistic explanations for the phenomena of wind and lightning based on yin-yang and qi that added some precision to Lu Dian's earlier analysis in the adding to elegance. Lu Dian had cited on the principles of things to the effect that an accumulation of wind formed lightning. Wang Sanpin, on the other hand, explained this by contending that the yang that is within cannot escape, and its resounding blows produce lightning. When yang is outside, Wang continued, and cannot get inside, then it swirls around without stopping, forming wind. Similarly, Wang cited Song dynasty accounts on rain. When earthly qi rise and heavenly qi fall, they form the vapors of steam and form rain. 68. A theory of cosmology and natural change. Although Wang Bo's work was presented before the origins of things and other such compendia on things and origins, we can conclude this discussion of early natural histories with a work that dealt with the theoretical issues inherent in this genre of entries about things, phenomena, and affairs, namely, Wang's ambitiously titled Discussions on the Formation of Heaven and Earth and the Myriad Things. Wang Bo had opposed Zhu Xi's interpretation of the passage in the Great Learning on the investigation of things and extension of knowledge. Nevertheless, he was in substantial agreement with the spirit of Zhu Xi's investi. 46. Gashing of things to fathom principles. Wang, like Zhu, articulated a holistic, structural account of natural processes, which enabled literati to explain in theory the production of all things. In his preface to Wang's discussions, Zhou Yang summarized this all-encompassing view of the cosmos and its naturalistic evolution. The great ultimate is principle. Yin-yang is qi. Heaven and earth are forms. Talking about them in aggregate, when a form is endowed with a certain qi, principle is complete within that qi. Talking about them disaggregated, then what is above form and what is below form are bound to differ. The great ultimate originally contains yin-yang. What moves becomes yang, what remains quiescent becomes yin. If something is alive, then all of it is alive at once. One cannot speak as something occurring before and something else after. 69. Zhou placed Wang Bo's account of the shaping of all things within the theoretical framework of what in Song times was referred to as studies of principles associated with Zhu Xi and his followers. Wang Bo, according to Zhou, had pushed back to the origins of all things and illuminated the mysteries of the shaping of things, and was truly adequate to elaborate studies of principles and provided wings for this culture. In Zhou's view, Zhu Xi's learning of the way was not simply a moral vision of philosophical principles. It was also a theory of the principles of natural change. 70. Wang Bo's work represented an extended essay on the cosmology of phenomenal beginnings that created all things in the world through the interaction of qi, form, and materiality. The shaping of all things presupposed, however, the more paramount status of humans in the cosmos. Wang was not unusual in this claim that humans were the rulers of birds and beasts, and that, therefore, things in the world were classified, encyclopedically and otherwise, as secondary to humans and subject to their vital needs. 71. Wang Bo's own account in the discussion stated the pre-Jesuit theoretical vision informing natural history in late imperial China, which Europeans would challenge in the late Ming. Originally, before the beginnings of distinctions, there was the great change, the great origin, the great beginning, and the great simplicity. The great change occurred before qi was manifest. The great origin was the beginning of qi. The great beginning was the beginning of forms. The great simplicity was the beginning of material. When qi, 47, forms, and materiality were not yet mutually separated, then we call this chaos. Chaos refers to the myriad changes, chaotic without a beginning of separation. When chaos was already separated out, then heaven and earth opened out. When heaven and earth were distinguished, then they produced two models. The light and clear opened up and became heaven, the heavy and turbid congealed and became earth. 72. Without citing his source, perhaps to disguise its unorthodox status, Wang Bo was paraphrasing classical Daoist cosmology in the Book of Master Li, a work that he thought was written much earlier but today would be dated circa 3rd century AD. The Book of Master Li included the following passage under the heading of Heaven's Fortune. In the past, the sages conformed to yin-yang to unify heaven and earth. If what took form grew out of the formless, then from what did heaven and earth grow? Therefore it is said, there was the great change, the great origin, the great beginning, and the great simplicity. The great change occurred before Qi was manifest. The great origin was the beginning of Qi. The great beginning was the beginning of forms. The great simplicity was the beginning of material. When Qi, forms, and material were not yet mutually separated, therefore we call this chaos. Chaos refers to the myriad things when there was mutual chaos without a beginning of separation. It was invisible, inaudible, and unobtainable. Therefore it was called the change. 73. Borrowing from a classical Daoist text was still acceptable during the declining years of the Southern Song, even when appeals to orthodoxy became more strident. Moreover, the overlap between the orthodox cosmology of the learning of the Way and that of Master Li indicates how closely tied classical learning and natural speculations had become. Wang Bo used this classical if unorthodox theory of the shaping of things to explain, precisely, natural phenomena. At times, Wang correlated phenomena based on numerological regularities, but more often his cosmological concepts were used to explain natural events. 74. We have noted that the medieval adding to elegance and Ming examination of ancient and contemporary things and affairs explained lightning and thunder by the concatenations of yin and yang. Zhu Xi had explained lightning in conversations with his students by criticizing the popular notion of a thunder spirit. Like Lu Dian and Wang Bo, Zhu also stressed the mutual rubbing and grinding of yang versus yin qi that produced lightning and thunder when qi was condensed and exploded. Nevertheless, Zhu also considered the 48 anomalistic aspects of qi in light of thunder as auspicious or ominous. For Zhu, during a thunder and lightning strike the qi condensed into a sort of thunder axe that possessed spiritual powers. Zhu tied that thunder and lightning to the appearance of spirits and the manifestation of devils. 75. For the same phenomena, Wang Bo explained that when yin and yang rubbed and ground against each other, their interaction exploded into sparks of lightning. Wang Bo's Southern Song account added more materiality to the swirling winds than earlier accounts and left out the popular understanding of the thunder axe. Nevertheless, the common denominator of these explanations, whose dates range across almost a millennium, was that rain, clouds, thunder, and lightning resulted from interactions between yin qi and yang qi. 76. From orthodoxy to esoterica. In addition to his interests in classical lexicography and natural history, Wen Huan also compiled and printed a wide range of works based on his broader interests in Chinese religion, which extended to popular Daoism, Buddhism, and medicine. Nourishing life was an important theme in Chinese classical medicine and internal alchemy. The goal was to achieve the ancient ideal of bodily regeneration and longevity through internal moral discipline. Likewise, the focus in Ming publications emphasized multiplying descendants and nurturing life. By linking meditative exercises, sexual discretion, and ingestion guidelines, Ming scholar printers found a rich vein of readers when they tapped into teachings that historically were concerned with the sexual arts of the bedroom and stressed love, fertility, and health in light of the body's potential for producing offspring. 77. This aspect of Chinese interest in the natural world grew out of the need to maintain the harmonious functioning of the human body, avoiding both excesses and wasting of the body's natural vitality. The Basic Questions, one of the two best-known works in the medical corpus known as the Inner Canon of the Yellow Emperor, for example, had emphasized the goal of human longevity. There the ruler was advised to cultivate serenity, detachment, and non-striving in order to guard one's essence and spirit within. Such medical regimes were paralleled by early claims in the classical literature that an imperishable metal could serve as an elixir and that the attainment of earthly immortality was also possible using herbs of immortality. Such recipes for nourishing life became a major focus in late Ming collectanea and encyclopedias. 78 The goal of various techniques of breath control was physical immortality in an imperishable body, which was nurtured like an embryo through yogic disciplines. As an inner alchemy, such bodily transformation was 49. Comparable to how an alchemist brought an elixir to maturity in a matrix of lead. Older alchemical writings were later reinterpreted in light of the physiologic procedures associated with popular breath control and the meditation techniques introduced by Buddhists in medieval China. 79 Alchemy from the start had medical overtones because the art of making elixirs of immortality represented a natural process for creating perfected substances that could be ingested or internalized. Alchemical treatises accordingly presented chemical operations as metaphors for cosmic and spiritual processes. The extraction of silver from lead, for example, wreaked the emergence of a perfected self. Internal and external alchemy were complementary and regularly practiced together until the 11th century, when adepts largely abandoned external alchemy. Events, like things, tee into a cyclical pattern of natural processes. The life cycle of birth, growth, maturity, decay, and death paralleled the cycles of day and night, the seasonal changes, and the calendrical cycles of cosmic change. Yin and yang as dualistic, dynamic concepts were applied to spatial relations that were changing or in equilibrium. The VE evolutive phases provided a parallel division of cycles or configurations of change for organizing natural phenomena. The 8 trigrams and hexagrams from the Change Classic were also associated with the production of elixirs. 80 In Hu Wenhuan's time, the unconventional light Ratus Yuan Huang drew on 2 chief views of fate in Ming public and private life, a system of merit and demerit that human agents could enhance, a framework of meaning beyond human enhance. Ming literati such as Yuan increasingly regarded merit accumulation in the moral realm as homologous with cultural prestige and worldly material benet. Later a Chengzu follower, Lu Xi, initially used Yuan's personal ledger of merit and demerit and titled his own work as Chapters on Investigating Things and Extending Knowledge. The late Ming debate between moral purists, who thought fate was beyond human enhance, and those like Yuan Huang, who favored merit accumulation among elites for success in civil examinations and among commoners for personal self-improvement in daily life, had become important enough to contest in official circles such as the civil examinations. Elaboration of a moral vision for those in late Ming society such as Hu Wenhuan, who aspired to social mobility and material success, was not so easily controlled in an era of social and moral exhibility, however. 81 Yuan Huang also reinvigorated the traditions of inner alchemy by drawing on the psychophysical model of the body, which informed traditions of outer alchemy. In such representations, the body became the crucible where 50. The gross material of physical life could be rend and poured through human discipline. Yuan recommended the know-how to ensure that a fertile body was properly disciplined by sexual and spiritual exercises and by diet and pharmacy. This Allah's body manifested the powers and pleasures of sexual function and the possibility of sagely transcendence and bodily immortality achieved through the procedures of inner alchemy. By mastering the techniques of sexual hygiene, meditation, breath control, and bodily visualization, an adept could produce an elixir out of his or her own body. Yuan Huang emphasized the moral management of the seminal essence and breath through the 3 primary psycho-spiritual material vitalities of the body, qi, and psyche. An adept could link the refinement of the body's essence, purification of one's qi, and the self-transcendence of the psyche to the inner cultivation of an immortal embryo. In a perfect state of emptiness, the circulated vitalities of the body would assume an increasingly concentrated and ethereal form. This life-affirming overlap of sex, cultivation, and male fertility for nourishing life appealed to elite and popular audiences of men and women. Charlotte Firth has described how the Ming ideal of inner alchemy required moral cultivation and enlisted the sexual drive for the inward goals of classical sagehood, a short step, we might add, from a concept of the sublimation of the affects into spiritual ideals. Male sexual powers in particular were associated with the reproductive function. Consequently, Late Ming versions of Nourishing Life that appeared in popular daily use compendia published separately or in collections focused more on human health and longevity than on the utopian quest for immortality. Inner alchemy was popularized as the moralization of health in Ming cultural life, and the goal of individual fertility displaced human longevity as the goal. 82. Other editions of natural lore, expanded versions of Hu Wenhuan's Collectania. The 1609 version of the Collectania for investigating things and extending knowledge was likely the most authoritative edition because it contained the only datable preface by Hu Wenhuan and a general table of contents of 140 works in the collection. Hu's preface presented 14 categories of works that he and his staff had collated from the early and later masters and the 100 lineages of classical learning. 1. Etymology. 2. Philology. 51. 3. Poetic ability. 4. Literary criticism. 5. Astrology. 6. Geography/topography. 7. Astronomy/harmonics. 8. Penal laws. 9. Low-ranking officials. 10. Medicine and prognostication. 11. Buddhism/Daoism. 12. Border people/foreigners. 13. Fauna. 14. Aura. Except for the lexicons and natural histories, which had appeared as a separate edition, whose division of categories for the 1609 edition of his Collectania generally reeked of those that we have previously described in the daily use encyclopedias of the 1590s. 83. Like many Ming scholar printers, who mixed and matched the contents of his editions to sell more copies of his printed works. He also changed several original works to conform with his own printing needs. The Qianlong editors of the Imperial Library Project found this aspect of Hu's editions especially egregious as they castigated him for his blatant prot-seeking. The editors made clear in their 1780s critique of Hu's massive Collectania that they also disapproved of his inclusion of works on natural history because such accounts represented writings previously classified as fictional accounts. In addition, the editors noted that the version of Hu's Collectania that they reviewed contained 181 works divided into 12 classifications. At least 4 of these dealt with natural events. 1. Classics/commentaries, 15 works. 2. Unofficial histories, 21 works. 3. Officialdom, 12 works. 4. Legalists, 12 works. 5. Lessons/admonishments, 14 works. 6. Masters and others, 8 works. 7. Respect for life, 18 works. 8. Seasons/agriculture, 8 works. 9. Crafts, 10 works. 10. Virtuous/praiseworthy, 17 works. 11. Channel works, 11 works. 12. Arts collections, 30 works 84. 52. What is interesting here is that Hu Wenhuan's publications on poetry, literature, the arts, nourishing life, etc., were added to the earlier, smaller versions of the Collectania, such as the version with 46 classical works summarized above. Later, many were also included in Hu Wenhuan's other major Collectania known as the famous works of all the scholastic lineages, which can be dated to 1603. The preface by the Hanlin academician Zhu Haifan made it clear that Hu's famous works was also a comprehensive library of works stressing poetry, astrology, astronomy, aura and fauna, medicine, and the arts of longevity, in addition to the more classical themes of philology and technical glosses on things and affairs. In his preface, Zhu Haifan used the term for investigating things and extending knowledge to suggest the overarching unity Hu Wenhuan applied to such works, which linked the famous works collection to the Collectania for investigating things and extending knowledge. 85. Each Collectania contained many of the same works that Hu Wenhuan compiled or wrote himself. In the late 16th and early 17th century, Hu Wenhuan compiled and published more than 100 works in Hangzhou and Nanjing. Moreover, the various editions of the Collectania for investigating things and extending knowledge and famous works of all the scholastic lineages that have circulated over time are almost all different in content. 86. Using works from earlier editions of the Collectania, Hu Wenhuan published the famous works as an alternative way to present his collection of books. In effect, he had combined in his Collectanea Ming works that were similar to two types of song encyclopedias: the materials of the Taiping Xinguo era for the emperor to read and expanded records of the Taiping Xinguo era. Other, smaller Collectanea that Hu compiled also included many works from his two major Collectanea. The Collectanea for prolonging life, for example, contained a series of Ming works in which we see a nascent vitalism, or a philosophy for nourishing life, which was representative of similar currents in late Ming digests and Collectanea. 87. Late Ming Statecraft, Mathematics, and Christianity. Most of the Collectanea and practical compendia common in the late Ming were produced by lower-level gentry literati or scholar printers. In contrast to Li Shizhen's systematic Materia Medica and Hu Wenhuan's Collectanea, the scholar official Fen Yingjing while in jail compiled an important encyclopedia titled The Compendium of Practical Statecraft in the August Ming Dynasty, which was published in 1604 with a 1603 preface by Feng. A palace examination graduate in 1592, Feng was jailed for 4 years beginning in 1601, while serving as an assistant surveillance commissioner, for refusing to allow a eunuch tax collector in Huiguang free rein in accumulating revenues in the name of the emperor. 88. Also jailed with Feng was He Dongruo, who was a prefectural judge in Huiguang and had also resisted eunuch tax demands on minors in the area. Together they discussed the political chaos of their time, and each resolved to compile works while in jail that would stress statecraft policies to help ameliorate the dangers of their time. They advocated a return to the policies of the RST Ming Emperor, who had united the empire after the anti-Mongol conflagrations in the middle and late 14th century. Fen Yingjing's compendium thus returned to the repertoire of statecraft techniques and moral policies derived from the rituals of Zhou that had informed politics in the early Ming. 89. In addition, Fen Yingjing had befriended Matteo Ricci and taken an avid interest in the Christian religion and the Western studies that were associated with it. It is said that Feng would have been baptized had he not died prematurely, just 2 years after his release from jail. The Christian impact on Feng's compendium of practical statecraft in the August Ming dynasty was made implicit in the opening chapter, which comprised the RST Ming Emperor's own official writings. Under the cover of an annotation to the emperor's orthodox evocation of classical doctrines, namely that the sages and worthies had the mind-heart of a gentleman, Feng interpolated a discussion of an enlightened antiquity when the spirituality of a unit mind served the spirituality of the minds of 10,000 people. 90. Feng then turned to a discussion of the Lord on high and his rectifying power to discern right from wrong, a comforting lesson for a man jailed by a corrupt eunuch. The affinity of human spirituality with such a power, Feng contended, carried over to the founding emperor, who had been endowed with the requisite spirituality to sustain his reign. This reference to the Lord on high, a term that Ricci and the early Jesuits had settled on as a translation for Deus because of its ancient provenance in the documents classic, was permissible in Feng's notes because the RST Ming Emperor had himself used the term in his discussion of palace sacristies. Feng regarded this reference as the origins of the emperor's methods of the mind. Building on this imperial precedent, Feng could then claim that we are all the Lord on high's people. Feng's rhetorical appeal to spiritual salvation was manifest: how much heaven must love me as a person to enable me to suffer the pain of the world. 91. Feng's compendium was composed as a statecraft digest and not as a Christian tract, however. Its focus on imperial governance incorporated sections on officialdom, ritual studies, musical studies, archery, calligraphy, and arithmetic, in addition to sections on orthodox studies. Feng's inclusion of arithmetic and mathematics in the compendium was intended to correct excessive stress on belles lettres, which had emerged during the Ming, particularly since the 8-legged examination essay became a literary rage in the late 15th century. Here, too, we discover Feng's contact with Ricci and European studies because the arithmetic that Feng detailed in his digest was drawn from the systematic treatise on computational methods by Cheng Dai, which had been published in 1592 to 1593 and quickly emulated as Weizen for practical computations in Japan. 92 Cheng Da'i's systematic treatise comprised a collection of 595 difficult arithmetic problems. Designed as a general and practical arithmetic using the abacus, rather than more cumbersome counting rods used to solve higher-degree equations during the Song and Yuan dynasties, Cheng's work was widely disseminated before the Jesuits encouraged the Kangxi emperor's interest in it later in the 17th century. Cheng's treatise reeked the arithmetic language of Ming merchants, who were the key guardians of the computational methods in 9 chapters tradition. 55. One of the 10 mathematical classics, the computational methods was compiled between 200 BC and AD 300, with later commentaries added to it. Some regarded it as the most important work in the mathematics canon. It was also the model for mathematical language and the pattern for computation since medieval times, when the official canon was used at the school for dynastic students during the Sui and Tang dynasties to teach mathematics. 93 The oldest known edition of the computational methods in 9 chapters dated from the 13th century, however. Because the latter was not fully reconstituted and reprinted until the 18th century, Cheng Da'i's systematic treatise on computational methods represented the best available late Ming work in the 9 chapters tradition for arithmetic problems and their numerical solutions. Some of Cheng's problems were later adapted into a more classical style for literati in Ricci's arithmetic, which was based on European and Chinese sources. 94 Matteo Ricci's 1614 translations of guidelines for practical arithmetic, compiled with Lise Hizeo's help, adapted its arithmetic from Clavius' Epitome Arithmetici Practici. It was also based on arithmetic from the Yuan and Ming periods. Hence, Ricci's treatise on European arithmetical knowledge added problems from the systematic treatise on computational methods by following the Chinese arithmetical tradition. Although Ricci introduced the Western pen and paper approach to arithmetical calculations, overall his translations did not go beyond the limits of the Chinese traditional mathematics. 95 By including portions of Cheng Da'i's systematic treatise, Feng Yingjing's Statecraft Digest incorporated a denotative arithmetic in which problems, rules, and solutions were composed in verse with rhyming formulas for teaching arithmetical terms, computation with the abacus, and multiplication tables. Feng added that although the Duke of Zhou had in antiquity developed the computational methods in 9 chapters, its arithmetic had not developed the relational features for computing the sides of a right triangle that were later found in the Sea Island computational canon by Liu Hui at the end of 3rd century AD. Feng added that Westerners such as Matteo Ricci had mastered the computational procedures, i.e., geometry and trigonometry, necessary to measure long distances in ELDs by mastering similar right triangle procedures. 96 Feng's interest in more advanced mathematics, which went beyond the simple arithmetic of Cheng Da'i's systematic treatise, indicates that the Jesuits were dealing with literati already concerned about the need to develop more expertise in mathematics. This is shown by Feng's inclusion of earlier Ming right triangle studies in his section on mathematics. A generation earlier, for example, the Light Radu's Tang Shunzi prepared a series 56 of essays on triangles and segments of a circle that were essential in geometric calculations, which Tang precociously called studies of measured amounts, a term later selected by Ricci and his Chinese collaborator for the late Ming translation of Euclid's geometry. Before the arrival of the Jesuits, Tang Shunzi had distinguished between new and old computational methods, a division that would reappear in later discussions of Western learning. His essays preceded by several decades the earliest Jesuit transmission of medieval and Renaissance mathematics to China. The latter were essential to integrate ancient classical theory with contemporary technical expertise in order to reform the Ming calendar. 97 Feng Yingjing's stress on practical problems in mensuration involving right triangle calculations in his digest also occurred before Ricci's translation of Euclid's Elements of Geometry was completed. Moreover, problems in late Ming calendar reform that we will address in Chapter 2 increasingly contributed to the Ming reception of early modern European mathematics and computational astronomy. Consequently, Fen Yingjing's compendium foreshadowed late Ming and early Qing literati and imperial court interest in European trigonometry, trigonometric tables, and logarithms. It also pregeared statecraft collections that were compiled by convertofficials such as Su Guanqi. Collecting things in texts. The proliferation of late Ming daily use compendia, many of which Huan's collectania prominently contained, wreaked at a widening audience for information about things, phenomena, and affairs of all sorts. The accruing knowledge of things and affairs among Ming scholars was still subsumed within the moral and philosophical frameworks that informed the orthodox literati classification of the natural world and drew on the classical repertoires of knowledge outlined above. These repertoires notably included medieval masters of esoterica such as Zhang Hua, who were central to the late imperial definition of accumulative knowledge of things and phenomena. Although the classical lexicons and natural histories were the beginning points, the knowledge in ancient canonical texts and their commentaries were insufficient. 98 literati deployed things in digests and the collectania by presenting chronological or topical presentations of past glosses about them. Things, events, and anomalies were displayed textually and sometimes pictorially. In time, words as glosses, that is, the textual lives of things, took precedence over any analysis of the things cited. As a result, natural studies became a venue for Chinese textual scholars who were fascinated with the etymologies of the 57 words. Sages had created such words to encompass phenomena. Hence, they were also important as a genealogy of items in the classics. Unlike early modern European scientific culture, where natural history was increasingly displayed as concrete items in a museum, the array of entries about things included in Huan's collectania of early lexicons and digests converted natural phenomena into words in a text that needed to be decoded primarily through the analysis of language. 99 Paula Feindelin has described the new attitudes toward nature as a collectible entity and new techniques of investigation that informed natural history in early modern European scientific culture. The RST science museums were repositories of technology, curiosities, and wonders that built on Pliny's encyclopedic definition of nature in his natural history as everything that was worthy of memory. Europeans coped with the empirical explosion of materials that the wider dissemination of texts, increased travel, voyages of discovery, and more systematic forms of communication had made possible by establishing private museums, which became state-sponsored institutions from the 18th century onward. Such museum collections became symbols of prestige and power, and collectors entertained the image of knowledge without end more widely in the 17th century. 100 Paula Feindelin focuses on the linguistic, philosophical, and social matrices that gave museums a precise intellectual and spatial configuration. Museums became a venue to experience nature. From the sociology of collecting and its cultural logic, we can see that in late imperial China this sort of collecting and classifying knowledge about things occurred within the pages of collectania and encyclopedias. Just as the museum was RMLY set in the pre-modern European encyclopedic tradition of catalogues and the vocabulary of collecting, so the daily use compendia of the late Ming were sites of classically derived knowledge where individuals of privilege and learning earned the right to collect and classify the world. Others could participate in such collecting by reading about things in the texts that they purchased or borrowed. Huan's merchant scholar printer status in Hangzhou and Nanjing publishing circles allowed him to participate in highbrow activities at the same time that he published works for prose aimed at popular audiences. The RST increased the classical prestige of his collecting and reprinting information from lexicons and natural histories. Who elevated his own curiosity about things and phenomena to a virtue that was entirely appropriate for gentlemanly behavior. Likewise, Li Shizhen's much more analytic work on pharmacopoeia approximated the role of the collector of natural objects or information about them as parallel to the learning of the way scholar who investigated things, or someone who collected objects. 101. 58. If the museum became a site of encyclopedic dreams and humanist sociability in 16th century Europe, collecting information about things in the late Ming was not yet a prelude to display or manipulation. Li Shizhen certainly shared the naturalist's agenda. Moreover, his pilgrimages to collect medicines and herbs were done through eldwork and perusing texts. His natural studies remained focused on remedies. Secondarily, he was fascinated with the etymologies of terms for living things, which could then be applied via the investigation of things to classify appropriate medicines. Ming collectors of encyclopedias never expressed a penchant for purely experiential knowledge obtained in the laboratory, although medical men continued to produce empire-wide a rich plethora of medicines and accessories for traditional Chinese healing. Li Shizhen did so as well. 102 In early modern Europe, gentlemen enriched their collecting experiences by increasing the presence of animal skeletons and fossils in the museum. The new culture of experiential demonstration transformed the museum into a site of medical knowledge, within which competition over the control of knowledge between apothecaries and physicians professors ensued. Nevertheless, the modern category of natural science had no formal meaning for the European naturalist in the 16th century any more than it did in the late Ming. To compare the historical context for early modern scientific culture in Europe and natural knowledge in late Ming collectania and digests, we need to problematize the historical teleologies that turn the past purely into prologue. 103 Collecting as a research agenda rearranged the boundaries of natural studies in Europe, but the coexistence of the old and new, the occult and the demonstrable, in early natural history was as prevalent in Europe as in the late Ming. Even after the Jesuits arrived in Ming China, no one there or in Europe singled out and privileged natural science. Later in the 17th century, via Bacon, European scholar gentlemen dismantled older forms of natural philosophy in favor of a new empiricism. Galileo, Descartes, and Newton transformed such high-minded empiricism into the concrete beginnings of physical science in Europe after the Jesuits arrived in China. 104 Efforts to normalize the marvelous in Ming China turned the collection of information about things into a form of classical knowledge gained through encyclopedic research, which defended itself using the rhetoric of orthodox moral cultivation, i.e., to investigate things and extend knowledge. Rather than microcosms of nature, collections of early lexicons and Ming Digest created textual museums for their theater of marvels. Hu Wenhuan's efforts in the 1590s to collect the collectors within a single collection of books published as a set was not unique. His economic resources allowed him to produce and 59. Publish several collectania he deemed appropriate to place under the general heading of investigating things and extending knowledge. His initial reconstruction of the ancient lexical texts allowed him to use them as an orthodox base for enlarged editions of his collectania, which included domains of knowledge that exceeded the boundaries of the official canon. When the military dust settled after the Manchu victories in the 1660s, Ming loyalist scholars from the Yangtze Delta such as Gu Yanwu and Huang Zongzi took their predecessors to task for their naivete concerning classical controversies such as the Old Text and Stone versions of the Great Learning. Chen Ke in particular singled out this controversy and criticized late Ming scholars for their credulity and lack of the textual expertise needed to recognize the dubious Stone version as an obvious forgery. In general, the focus on the investigation of things in the early Qing shifted from a pathway to sagehood to a more rigorous methodology for extending all knowledge, whether moral, textual, or worldly. The Jesuit appeal to scientia in China was received by literati in the midst of a sea change in classical learning from the Ming to Qing dynasty. 105 17th century Chinese collections and digests drew on Zhu Xi's scholarly eminence, when investigating things and extending knowledge became a popular phrase among literati and the Jesuits in their discussions of the proper approach to the diversity of knowledge. In the late 19th century, literati and their Protestant missionary collaborators chose Zhu Xi's terminology to translate modern science into Chinese as the study of investigating things and extending knowledge. In opening remarks for the inaugural spring 1876 issue of the Chinese Scientific magazine published in Shanghai, Su Xiao as co-founder commemorated Zhu Xi's gloss for the investigation of things as an eloquent statement of the universal search for the knowledge of all principles underlying things and affairs. The naming of science in this way, Su Xiao declared, would empower Chinese to master the practical elds of modern science. 106. 60. 2. The late Ming calendar crisis and Gregorian reform. 2. For Chinese emperors and their officials, the mandate of heaven since antiquity measured their cosmological, political, and historical worth. The emperor as the son of heaven was ritually responsible to establish a system of computational astronomy, which made an accurate calendar a realistic goal for his government. Relying on an accurate astronomical system for a mathematized cosmos, the emperor could disseminate an official calendar. 1. The RST record of an articulated astronomy bureau with clearly delineated duties occurred in the history of the later Han. 2. The Documents Classic, one of the original 5 classics, contained a famous injunction by the legendary Emperor Yao to regulate the calendar so that celestial events could be predicted. To order the empire, literally, all under heaven, Chinese and non-Chinese dynasties required technical mastery of heavenly and atmospheric events such as non-periodic stellar novae, solar halos, and meteors and meteorites, in addition to periodic lunar and solar eclipses. Celestial events that imperial officials could not predict, as well as earthquakes, famines, etc., were portents that potentially pointed to the emperor's lack of virtue. 3. In addition, an accurate calendar organized specific economic, political, and religious rituals to demonstrate authority over the agrarian cycle, affirm the cosmic order, and normalize relations with other rulers. The calendar's astrological and ideological significance made its imperial compilation and promulgation a critical ceremonial duty. The symbolic power of the calendar to order daily life via timekeeping affirmed the effectiveness of the dynasty in place, especially a conquest dynasty such as the Yuan under the Mongols and later the Qing under the Manchus. The calendar RST and foremost mattered politically, and its impact on the agrarian cycle of seasons was secondary. 63. Mathematical astronomy, never an abstract study for its own sake, was the key to preparing calendars and horoscopes. Once a computational system was in place, that is, most of the time the annual work of calendar making involved the lowest ranking officials, computists with minimal skills. The bulk of the effort of bureau officials went into mathematical astronomy and the observation and interpretation of omens. 4. Astronomical prediction, astrological interpretation, and the auspicious performance of daily tasks and ceremonies in court and at home presumed an accurate lunisolar calendar. Both the dynasty in power and the people at large were concerned with the dates of events, actions, and rituals. It was fortuitous for the Jesuits who began arriving in Ming China in the 1580s that their order had been involved in resolving one of the major calendrical problems bedeviling the Church in Europe, namely the controversy over the date for the movable feast of Easter. Pope Gregory XIII had appointed the German Jesuit Christoph Clavius, a leading mathematician and churchman, to the Gregorian Reform Commission. Clavius ascertained the proper date for Easter, originally derived from the Jewish Passover, with the promulgation of the Gregorian calendar in 1582. The Gregorian reforms occurred before the Copernican heliocentric controversy climaxed in 1616, but astronomers such as Clavius were already aware of Copernicus's challenge to the geocentric model of the solar system. The Earth was a planet in Copernicus's system, and it orbited around the Sun with the other planets, as well as rotating daily on its own axis. This brouhaha between the Church and astronomers later affected the Jesuits' role as transmitters of European astronomy to Ming and Qing China. 5. In Ming China, the remarkable astronomical advances of the Yuan dynasty's season-granting astronomy system of 1280, which was repromulgated by the Ming dynasty after 1368, was a major factor in the stability of the calendar until the 1580s. The very success of the Yuan calendar in predicting celestial events, conversely, produced an entrenched complacency in the Astrocalendric Bureau. Fortuitously, the Jesuits, whose main base of activity was in Japan, arrived in South China. Michel Ruggieri, for example, entered Macau in 1579 and initiated a Chinese mission in 1582. Versed in Renaissance mathematics, Ruggieri introduced European mathematics, mechanical clocks, and prisms to gain favor among local elites near Guangzhou. He was joined in the Jesuit residence by Matteo Ricci in 1583. Ricci had studied law in Rome and mathematical astronomy under Clavius at the Collegio Romano. Since 1581, 1 year before the Gregorian calendar was promulgated, he had been in Macau. Many of Ruggieri's and Ricci's 64 initial conversions were via the door of mathematics. Moreover, when Ricci arrived in Beijing for the RST time in 1601, he brought with him a number of books on mathematics, and he remained in contact with Clavius while in China. Later, when he realized the seriousness of the Ming calendar problem, Ricci hoped the court would employ Jesuits to correct the calendar. Equally important, he realized that the Astrocalendric Bureau offered a place for foreigners in the court bureaucracy, with access to the top. Ricci's goal was to curry favor with the court and literati elites to gain their tolerance of Jesuit efforts to convert both elites and commoners. The success of some Jesuits such as Ricci in Beijing allowed Jesuits in the Eld to gain Christian converts openly. Less transparent, however, were their attempts to inscribe precise mathematical predictions of the periodicity of repeating celestial events, such as eclipses, with a vision of time that dated events linearly from creation. 6. Consequently, when after 300 years of use the discrepancies between the Yuan Ming lunisolar calendar and the solar year became astronomically and politically significant, the Jesuits were well equipped to participate in calls for calendar reform during the Wanli reign because of the legacy of training in mathematics with emphasis on astronomy, that Clavius had established in Rome. The curriculum at the Collegio Romano was copied in Jesuit colleges all over Europe, including the Portuguese College of Coimbra, where the Jesuits who were sent to China received their null training. They were worthy technical adversaries for the hereditary Muslim and Han Chinese officials entrenched in the Astrocalendric Bureau. The battle over the correct time was more than a technical rivalry, however. 7. Development of the Ming Astrocalendric Bureau. Because the official production of the calendar provided the institutional venue for the development of Chinese astronomy, monographs on astronomy and astrology were regularly included in the dynastic histories. Afterward, such information was also added to some medieval and late imperial encyclopedias and gazettes. Technical knowledge of the heavens mattered for the government, which is why the calendrical advantages and astronomical models demonstrated by foreigners, such as the Indians, Muslims, and Jesuits who were hired by the court, were incorporated into the Tang, Yuan, and Ming-Qing calendars. Moral cultivation was rhetorically preeminent for literati, but understanding the calendar was an important aspect of the classical tradition and thus pertinent to them. 8. Although rural life was unaffected by the inevitable calendrical errors that ensued from the anomalistic motions of the sun and moon, the official calendar 65 DAR in China was always linked to celestial phenomena. The goal of those who designed computational systems was to represent accurately the periodicity of heavenly bodies. The astrological interpretation of heavenly patterns was based RST on accurate observations and secondly on the contextualized socio-political interpretation of observable celestial events. The lunisolar calendar in place combined solar years and lunar months. Since 12 lunar months amounted to only 354 or 355 days, it was essential periodically to add leap months, or intercalary months, to maintain an average of a little over 365 days in a tropical year. Officials were needed, in addition to their more demanding tasks, for calendar maintenance and occasionally for minor modifications. The designers of computational systems marked the divisions of the tropical year, projected the locations of the VE visible planets among the stars, and predicted solar and lunar eclipses. Such expertise enabled others in the Bureau to base ceremonial dates and interpretations of anomalies on accurate information. 9. The Bureau was a mid-level agency in the Ming government. Under the courts of imperial sacristies and imperial entertainments in the Ministry of Rites, it was essentially a service organization. Dates for important events and ceremonies performed by the court or high officials required an accurate calendar. Otherwise, the political consequences for the court, and hence for the Bureau, could be volatile. Located between the court and the bureaucracy, the Astrocalendric Bureau was on par with the Imperial Academy of Medicine, the Office of Transmission for Official Documents, and the Directorate of Imperial Parks. It had less prestige than the Hanlin Academy, whose academicians often served dual roles as grand secretaries within the imperial household and as high officials within the ministries of rights and personnel. 10. The RST Ming Emperor simply appropriated the Yuan dynasty's season-granting system, calling it the Grand Concordance Astronomy System, and similarly took over its Astrocalendric Bureau intact to assert imperial legitimacy. Now called the Directorate of Astronomy, the Astrocalendric Bureau continued in Nanjing with segregated Islamic and Han Chinese sections. When the Third Ming Emperor moved the metropolitan government to Beijing in 1414 to 1415, which he made his official capital in 1421, an auxiliary Astrocalendric Bureau remained in Nanjing until the end of the dynasty. Although complete with accurate versions of Yuan instruments, its importance declined. A separate Islamic office was eliminated in 1398, but its Muslim personnel were incorporated into the main bureau to provide an accurate Islamic calendar for the many Muslims in China, many of whom had been invited by the Mongols to serve the Yuan dynasty. 11. The Ming Bureau maintained the four divisions of the Jin Yuan Bureau: astrological interpretations, timekeeping. 66. Islamic methods, and mathematical astronomy. The Islamic division and its Muslim calendar in China echoed the 9 governors system of the Tang, when Indian calendrical officials had served in the bureau. 12. Expertise in the Ming Astronomical Bureau. The staff in the Ming Astrocalendric Bureau was responsible for general observations and specific predictions that were divided into VE general duties: anomaly observation, eclipse prediction, calendar compilation, auspicious time and place selection, and timekeeping. The equipment and computational tables they employed were similar to the sophisticated observational tools that had been employed by the Yuan Bureau under Kublai Khan after 1280 and by the Mongol Ilkhans at the Maraga Observatory in Persia until 1305, an armillary sphere comprised of 3 layers of uniformly revolving rings representing the fundamental celestial circles or spheres. A sighting tube in the plane of this ring pivoted around the center to make observations and measure distances on the spheres. The simplified instrument served the same purpose but with fewer parts. It consisted of 2 rings, and the sighting tube was XED to the center to allow it to align with any celestial object. Its simplicity, based on equatorial coordinates until the Jesuits introduced ecliptic coordinates, made it a mainstay of Yuan Ming astronomy. 13. Yuan dynasty gnomon to determine the solstices when the sun's shadow produced the longest or shortest times of daylight. A water clock for timekeeping, namely, the 3-chamber Inao-type clepsydra. 14. Although the Mongols used Islamic methods for planetary computations, Kublai also used other scholars skilled in Islamic star studies, such as the Persian Jamal al-Din, in his Astrocalendric Bureau. Jamal al-Din and others came to the Mongol court in 1267 with diagrams of an armillary sphere, a parallactic ruler, a sundial gnomon, an astrolabe, a terrestrial globe, and a celestial sphere. Initially, the Yuan Astrocalendric Bureau was divided into 3 parts, with Jurchen, Islamic, and Chinese offices, although there were Han Chinese in each office. Kublai also adopted the traditional Chinese ban on the private ownership of astrological texts and private practice of astrology, but as usual made no attempt to enforce it. 15. The astronomical instruments that Jamal al-Din described to the Mongol court in Beijing strongly suggests that the astronomers at the Maraga Ob. 67. Observatory, which was founded about 1260 near Tabriz in Persia for the Mongol Ilkhan Hulagu, Kublai's brother, were in touch with their Beijing counterparts. The plans for the astronomical instruments that Jamal al-Din described at the Yuan capital were the most advanced instruments of the time for both Islamic and Chinese mathematical astronomy, as were the Ilkhani computational tables completed in 1271. 16. Yuan-Ilkhanid relations were also important factors in the physical and decorative similarities of ceramic types in both regions. These shared forms in the crafting of ceramics combine the geometric characteristics of the Near East with the oral designs of China. The Islamic experts who led Qibla's astrocalendric bureau in 1280 in Beijing were paralleled by similar developments in 1259 in the Moraga Observatory during the Mongol era of conquests in Asia. 17. The UN establishment of a separate Muslim astrocalendric bureau in 1271, which in principle used the Ptolemaic geocentric world system, segregated Mongol experts from their Chinese counterparts in the bureau. However, the claim that the Islamic Bureau held an Arabic or Persian version of Euclid's Elements and Ptolemy's Almagest remains speculative, however. 18. Nevertheless, the Islamic Indians in the design of Guo Xiaojing's simplied instrument, a simplied armillary sphere or astrolabe, and large masonry gnomon towers was clear. The reforms associated with the UN calendar introduced many innovations and represented a new astronomical synthesis in the long history of the astrocalendric bureau. 19. In particular, the season-granting astronomy system promulgated in 1281 applied new computational techniques of a prototrigonometric nature to convert the equatorial coordinates observed on the celestial spheres into numerical equations solvable using counting rods. The compilers of the new calendar also recognized the computational differences in the procedures for positioning lunar and solar movements. This led to a gradual understanding of the lunar nodes and thus of the conditions in which eclipses take place. 20. By 1478, however, a memorial from the Astrocalendric Bureau acknowledged that its observational instruments were in disrepair. A 1612 memorial from the Ministry of Rites painted a darker picture of instrument dilapidation in the Bureau, which has suggested to many scholars that before the Jesuits arrived the Bureau was unable to use the astronomical instruments bequeathed from the Yuan dynasty. Although they were excellent by 13th century standards, because the instruments were never very precise, reports on their deficiencies may have been innated later by the Jesuits and their supporters. The mandated responsibilities of the Bureau did not require precise observation until Jesuits challenged the competence of official astronomers. 68. Even then, Jesuit instruments quickly became obsolete as European standards rose. For instance, the Ming Bureau could not predict the location of an eclipse, only its time, duration, and magnitude. As the accuracy of calendrical computations improved, the standards for rationalizing errors in the calendar also heightened. Accuracy in predicting eclipses had gradually improved since antiquity, and what constituted error also changed. In the Han period, eclipses were predicted to the nearest day. During the Tang such predictions pointed to the nearest hour and gradually improved. By the Yuan, precision was possible to the nearest quarter of an hour. The Jesuits went further by predicting a solar eclipse to the nearest minute. Hence, by 1630 the Ming Bureau was considered deficient because it was unable to achieve this new level of accuracy. 21. Because such determinations occurred within the observatory of the Imperial Palace, imperial complicity with Bureau staff was unavoidable, particularly when the political stakes of an astrological interpretation were high, as when the Jesuits threatened to take over the Astrocalendrical Bureau. Such collusion usually took place, however, after an astronomical observation had been made by the staff, and they had turned it over to the personnel for astrological interpretations. 22. Accordingly, the need for accurate observations inside the Bureau usually outweighed the potential for the fabrication of celestial events based on politically biased motives. In addition, the Islamic calendric system was treated as a second opinion. Thatcher Dean has studied official Ming notices of the planet Mercury as a case example. He has found that the record of observations of Mercury in the Ming veritable records were in close accord with the planet's known position based on modern calculations. In one case, however, after the third Ming emperor came to the throne following a civil war, the mistaken record of a celestial anomaly in 1404, whereby Mercury intruded on a star, may have been fabricated to legitimize the new emperor. 23. Even though routine observations were separate from astrologic interpretations, the manipulation of recorded anomalies by those charged with astrological interpretation was not uncommon. Because of discrepancies in the prediction of lunar and solar eclipses, astrological interpretation could impact the observation of celestial events. A formal relief ceremony, for example, was enacted for solar or lunar eclipses when the predicted eclipse was visible or not. This curious ritual was more frequently performed for solar eclipses, which were the most serious anomaly. When an unpredicted solar eclipse occurred, an imperial apology on the part of the ruler and his government was obligatory. In a parallel way, when a predicted eclipse was not observed, then 69. Officials were expected to express their congratulations to the ruler for his governing achievements. 24. Procedures for computing eclipses. In the Chinese lunisolar calendar, each month began on the day of a sun-moon conjunction, when no moon was visible. Total solar eclipses happened only on the day of a new moon. The coincidence of New Year's Day and a solar eclipse, for instance, was improbable. A solar eclipse on any day other than the first of the month indicated an error of prediction, giving the event astrological significance. After 300 years of use, however, the Yuan Ming calendar in 1580 was off by one full day. This calendrical error mattered because a solar eclipse could now occur on the last or second day of the month. In addition, numerous ceremonies and events were tied to the RST day of the new month. Because of the superiority of the Islamic Ptolemaic system in computing lunar-solar conjunctions, the court authorized its use in 1584. 25. Half of the Ming Bureau's solar eclipse predictions were spurious. This tendency toward overprediction was a way to protect the Bureau from unpredicted anomalies and minimize the chances of missing a solar eclipse. Unvaried but predicted eclipses were interpreted as heaven's approval of imperial virtue. Failure to predict an actual solar eclipse, however, was a serious offense for the Bureau. A consistently correct prediction of local solar eclipses was not possible using the tables of periodicities in the Ming calendar until more accurate European geometric techniques arrived. Accordingly, the astronomical constraints within the Bureau combined with ideological issues in the court to promote a tolerable level of overprediction. An unpredicted lunar eclipse that occurred, however, was not treated as a culpable error. There were also fewer spurious overpredictions of lunar eclipses. Those that were predicted but spurious were regarded as failures, again the reverse of spurious solar eclipses. Because lunar eclipses were easier to predict than solar eclipses, higher standards were applied in such cases. A predicted but spurious lunar eclipse, however, stood out as a major error because of the higher expectation of accuracy. In other words, the Ming government treated solar and lunar eclipses differently because of the varying difficulties in computation. The court cushioned itself with ritual responses to unexpected solar eclipses because they were truly uncharacteristic, while lunar eclipses were not. 26. Timekeeping, the calendar, and the selection of auspicious dates. To overcome the limits of sundials to mark time during darkness, the Chinese created water clocks. In 1090, a northern Song government official, Su Song 70, constructed a 40-foot-high hydromechanical clock that he called the Cosmic Engine. Its interior mechanism of hooks, pins, interlocking rods, coupling devices, and locks served as a mechanical escapement that alternately engaged and disengaged to control the movement of a revolving wheel. Su's demonstrational water clock included a star globe and an armillary sphere. Each was connected by chains and turned by gears. What remained of Su Song's clock mechanism after the Song dynasty was conquered, however, nearly vanished in the 14th century, when Ming forces drove the Mongols from Beijing, and was forgotten. Hence, when Jesuit missionaries brought European clocks to China in the late Ming, such mechanical devices were welcomed by the Chinese as an ingenious invention and an improvement over their simple water clocks. 27. Nevertheless, regular operation of Ming water clocks continued in large cities with drum and watchtowers. There the daily changing of placards for the 12 double hours of every day were routine tasks, which urban dwellers could see in addition to hearing the drum rolls. Also routine was the compilation of the annual calendar for empire-wide distribution. The dating was based on the governmental assumption that calendaricizing the world of time would bring order and predictability to the sequence of celestial phenomena, which would in turn order social, political, and cultural events within the empire. the Bureau was responsible for selecting auspicious days and hours for various court and public activities such as imperial funerals. The Ming government distributed approximately 2.7 million printed calendars, or one for every 7 households, for officials and commoners to follow these determinations. Although these calendars were not doled out casually, they were available beyond most administrative units and profusely reprinted by private publishers. Neighborhood specialists trained in local yin-yang schools complemented the Astrocalendric Bureau. The government established prefectural and county schools of yin-yang divination to train functionaries to divine auspicious days and related matters of geomancy based on topography and directional orientations. Such efforts were symbolic and ineffective. A pool of hereditary families provided such personnel, but often, as in 1458, the Ming Bureau received authorization from the Ministry of Rites to initiate an empire-wide call for officials who were expert in astrological interpretation, mathematical astronomy, geomancy, and fortune-telling. The politically sensitive selection of auspicious times and days by the Bureau was tied to geomantic considerations in naming and citing venues for imperial ceremonies, selecting appropriate tombs for the dead, and bestowing honorific titles on the deceased. Geomantic service was a bureau duty in citing tombs, for instance. We will see in the next chapter that this became 71. A serious bone of contention in 1658 when the Jesuits in charge of the bureau allegedly chose an inauspicious date for the funeral of an emperor's favorite son. 28. Career patterns in the Ming Astronomical Bureau. The RST Ming Emperor's 1373 regulations for the Astrocalendric Bureau specifically excluded the descendants of bureau personnel from other positions in the government. Although this interdiction was lifted in 1458, the long-term effects of this policy lingered on. A career there was therefore likely a dead end. Given the politically sensitive nature of the Bureau's work, moreover, it was in the interests of the imperial court and the top levels of the bureaucracy to convey astronomical and astrological expertise to the Bureau. To make such positions more attractive, the Bureau granted its personnel special privileges, in addition to allowing the descendants of calendrical officials to serve in other bureaucratic appointments. Like regular officials, they were exempted from corvée duties, and likewise they faced a reduced scale of punishments when involved in civil litigation. These privileges, however, were granted to all civil examination licentiates, some 500,000 by 1600, and were not comparable to the bonnets and prestige accorded the highest degree holders who passed the triennial metropolitan and palace examinations in the capital. With less career mobility, fewer degree holders among their midst, and less governmental prestige when compared even to physicians in the Imperial Academy of Medicine, the staff of the Bureau, like doctors, were at best middle-level personnel in a system that guaranteed the dominance of those proficient in classical learning. Directors of the 5 offices in the Bureau typically served 10 to 15 years. They usually spent 10 years RST as students or yin-yang specialists. 29 outsiders were sometimes brought in to supervise the Bureau, particularly in periods of badly needed reform. In such times, the Astrocalendric Bureau became a venue for struggles over the mathematical astronomy that spilled over into the court. Below we will see that the Astrocalendric Bureau was penetrated by Jesuits beginning in the late Ming. Like Indians under the Tang and Muslims under the Yuan, the Catholic Jesuits correctly perceived mathematical astronomy as a convenient means to influence the imperial court and the emperor. The Jesuits, unlike their Indian and Muslim precursors, eventually gained control of the Bureau during the Qing and were not easily relegated to an auxiliary role. 72. Evolution of the late Ming calendar crisis. As early as 1525 officials recognized that the Ming calendar and the Astrocalendric Bureau were failing, but the prescribed remedy, as in the past, was a call for new personnel and for better management of the Bureau's offices. The reform of the calendrical system itself was not yet considered necessary. Moreover, the Bureau, because of the low prestige of its middle-level personnel, was not in a strategic position to impact calendrical debate in the court. Additionally, Ming mathematics, in general, was linked more to commerce, such as wide use of the abacus, then to further development of its rich crafts of algebra based on calculation techniques such as counting rods, which had peaked during the Song-Yuan period and which the abacus did not support. 30. Calendar reform, that is, the replacement of the computational system, remained an imperial prerogative only insofar as it received criticisms and recommendations from outside the bureau. Until officials associated with the Jesuits appealed to the emperor and his court for a substantial reform of the Grand Concordance astronomy system in the 1630s, the government was content to rely on special supervising officials or to recruit new talent for the bureau. This policy, however, opened the door for the Ming and Qing dynasties to accept Jesuits as calendrical experts, just as Tang and Yuan rulers had accepted Indians and Muslim specialists. 31. The usual pattern was for an official to send a proposal for calendar reform in a memorial to the emperor, which the Ministry of Rites would adjudicate as the chief supervising agency of the Astrocalendric Bureau. In theory, if the proposal had merit, then an official trial to compare the new proposal with the old methods would be scheduled. Often, however, the results of a debate over a new proposal were never clear-cut enough to justify a trial run. In other words, bureaucratic inertia prevailed because the Yuan Ming calendar had achieved unprecedented success, unlike in earlier dynasties where numerous reforms had been required. In 1481 the Ming court received a peculiar recommendation by Yu Zhenji, an instructor in a dynastic school, to scrap all the calendrical systems since the Han dynasty and return to the ancient 19-year rule cycle. Han dynasty astronomers had thought that at the beginning of the world cycle there had been a general conjunction of planets and that at the end of that cycle this would recur. From this XED point in a cyclical cosmos, future reckoning of seasonal solstices or lunar solar conjunctions and eclipses could begin. Han astronomers also thought that every 138,240 years all the planets would repeat their motions. This cycle was combined with another cycle to yield a great polarity superior epoch of 23,639,040 years. 32. Nathan Sivin has described the rule cycle of 6,939 3-4 days, adopted at the end of 105 BC, which had been used for intercalation before the Grand In. 73. Seption reform. This cycle was based on 235 lunations of 29.53085 days, which roughly equaled 19 solar years of 365 1/4 days. Because this rule applied ancient values for the year and lunations, its lack of rigor perpetuated obsolete solar year and lunation values, and thus necessitated continual calendar reform. Since 19 lunar years of 12 months comprised only 228 lunations, the rule cycle required adding 7 intercalary months every 19 years to equal the 235 months in 19 solar years. 19 years was the smallest interval in which the winter solstice and new moon would recur on the same day. A cycle of intercalations that repeated after as few years as possible would minimize cumulative errors. After 19 years, the errors of adding an intercalary month 7 times at an interval of approximately once every 2.71 years would cancel out because the number of months and years that had passed were both integral. 33. Yu Zhenji's claim that the placement of the intercalary months in the Ming calendar was incorrect was taken seriously, even though his views would have ended eclipse predictions. The proposal was debated but not accepted. This bit of arcane literati fundamentalism concerning the calendar may have been a caricature of Ming efforts to return to antiquity, but the 19-year cycle, which China had abandoned, was still important in early modern Europe as a calendrical tradition before the 1582 Gregorian reform. 34. The Metonic cycle. The Metonic cycle of 19 years had been used in ancient Greece and Babylon to correlate the periods of the sun and moon for calendrical purposes. Meta had discovered circa 432 BC that 19 solar years contained 235 lunations. On that basis he also computed the length of solar year as 365 1/4 days. The Metonic cycle accepted 6,940 days or 235 synodic months between observed new moons over 19 solar years. Because 19 years of 12 lunar months equaled a total of only 228 months, the metonic cycle also required an intercalation of 7 months in the cycle, the same as the rule cycle in the Han calendar that Yu Zhenji wished the Ming to reauthorize. 35. The problems that both ancient Chinese and European calendrical scholars faced were the incommensurable periodicities of the sun and moon. One mean tropical year equaled 365.2422 mean solar days, which matched the average period of changing seasons in the solar year. On the other hand, one mean synodic month equaled 29.53059 mean solar days. 36. Neither the mean tropical year nor one synodic month was an integral number of days, however, and thus neither could provide exactitude in the calendar. The incom. 74. Mensurability of the Tugers meant that the tropical year did not contain an integral number of months but, rather, an average of 365.2422 days that when divided by 29.53059 days in a month equaled 12.368266 lunar months in a solar year. This discrepancy was the raison d'être for intercalary months in both China and the ancient world. 37. Discrepancies in Easter computations continued in Eastern and Western Christendom until Victorius discovered the RST true Easter cycle, known as the 532-year Paschal cycle of 28 metonic cycles. In AD 457, Victorius used Alexandrian computations based on the 19-year cycle to improve on past calculations and accepted March 21 as the date for the vernal equinox. In the process, he discovered that Easter dates began to repeat themselves every 532 years. Armed with this Paschal cycle, Victorius successfully dated all 430 Easters up to 457 and then for 102 years into the future, although opposition kept the solution from being immediately implemented in the Latin world. 38. The Paschal cycle remained important in early modern Europe before and after the 1582 Gregorian reform. The French Jesuits Joseph de Primar and Joachim Bouvet, who arrived in China in the late 17th century, believed for example that the Paschal eclipse, which occurred upon the death of Christ, had been a supernatural event that was allegedly recorded in Chinese records. This claim was quickly challenged by other Jesuits, such as Antoine Gobel, who accepted the independent integrity of Chinese records. Similarly, the systematic identification of biblical and Chinese personages was common among the Jesuits and their converts. Some maintained that Chinese observational records came from Jewish patriarchs before the Great Deluge. 39. Such calendrical claims reveal the European chronographic mindset then in place when the Jesuits competed with Han Chinese and Muslims for control of the Astrocalendric Bureau in the early 17th century. Moreover, the 19-year metonic cycle slipped by one day in roughly 308 years because its 235 calendar months were slightly longer than 19 solar years. The pre-Gregorian calendar in Europe had not surmounted this limitation and was now 10 days ahead, while the Chinese had stopped depending on the rule cycle shortly after the fall of the Han in AD 220. The Ming calendar employed a more sophisticated approach since the Han and was significantly more accurate. The astronomical systems established by the Han, Tang, and Song dynasties all followed the precedent of the triple concordance system of 104 BC. The triple concordance system adopted a day divisor of 81, which amounted to setting the length of a lunar month as 29.53086 days, and counted accumulated days from an epoch 143,727 years in the past. It was inevitable that the small discrepancy in the constant of 75. 29.53086 minus the modern value of 29.53059 days, which equaled an error of only 1 day per 310 years, would accumulate over such a great span of time so as to become appreciable. The Yuan dynasty calendar treatise completed in 1280 by Guo Xiaojing improved upon the triple concordance system and its successors to give more precise measurements of the length of a solar year. The Mongol system adopted precise decimal constants and counted from a recent solstice rather than an ancient epoch. Ming recognition of a calendar crisis. Criticisms of the Ming calendar occurred within a climate of rising expectations of accuracy. In 1483, discrepancies in the calendar were attributed to the difference in location between the Bureau's observations in Nanjing, where the instrumentation to measure celestial phenomena had originally been designed, and Beijing. In a pre-Jesuit environment, such discrepancies were usually within the margins of permissible error. Hence, errors in computation were rationalized because the Bureau's predictions were still sufficiently accurate. No consensus was yet possible about the urgency of the problem. For instance, in 1498 a secretary in the Auxiliary Astrocalendric Bureau in Nanjing called for selection of a high-level minister to study why failures in lunar eclipse prediction had increased. The appointment of a plenipotentiary to recruit talented scholars to produce a new calendric system would have been a major undertaking, however. The emperor followed instead the advice of the Ministry of Rites that the request was impractical. After a series of inaccurate eclipse predictions in 1517 to 1518, Zhu Yu, a timekeeping official in the Beijing Bureau, contended that the secular difference in the annual difference introduced by the UN calendar to deal with the drift forward of the calendar was the root of the problem with eclipse predictions. Because of this discrepancy, the Bureau had been over-predicting solar eclipses less often but under-predicting them more often, an ominous sign for the dynasty. The debate over this proposal was argued in terms of the distinction between new methods and old methods. 40 When Zhu Yu's own prediction of a lunar eclipse turned out no better, however, Zhou Lian, another official in the Bureau, convinced the court that continued readjustments in computations would suffice. Despite the problems in the Grand Concordance astronomy system, no consensus emerged that new and more accurate observations were needed to compose a new system. The focus was still on trial and error adjustments of the old and new regimes for calculation. The introduction of a Western calendar by the Jesuits. 76. In the 1620s was perceived in light of these Ming categories of old and new methods. 41 When a new emperor took the throne in 1521, Zhu Yu, still a timekeeping official, called for new instrumentation because accurate measurements were no longer possible using the observational instruments in Beijing. Zhu called on the emperor to construct a new bronze gnomon, which was needed in Beijing to adjust for its latitude. Later in 1523 an outside overseer of the Bureau, Hua Xiang, proposed that officials be dispatched to Henan province to study the giant masonry gnomon erected there for the UN calendar. This proposal prioritized improving instrumentation for constructing a new computational system. Hua was stalemated at once, however, by another supervisory official, who contended that the Grand Concordance astronomy system should not be changed. Both the court and Ministry of Rites waived. 42 The prestigious legacy of the UN calendar promulgated in 1281 was part of the problem. Its very success for 3 centuries, coming after some 20 descent calendars launched during the Song dynasties, was a policy obstacle that reformers would have to hurdle. Ming adoption of a reformed UN calendar created an institutional constituency in the Bureau bound to oppose any major reform on the grounds that the system in place was reliable. In effect, the institutional status of the Ming calendar limited debates over its future reform. Although no major changes in the calendar occurred, the issue was serious enough to be taken up in civil service policy questions of the time. For example, civil examiners raised the reform of the calendar for approximately 3,000 candidates taking the 1,525 provincial examination in Jiangxi. In one of the policy questions, the examiners asked the candidates to think over the history of the official Ming calendar and discuss its accuracy. In this way, the examiners ingeniously solicited literati opinion about the official calendar. 43 To answer these specific questions, the candidates needed to comprehend both mathematical astronomy and its history, which was available to candidates in the Jin and Yuan dynastic histories and statecraft-oriented encyclopedias. The UN calendar developed between 1274 and 1280 gave more precise measurements of the length of a tropical year as 365.2425 days. Without the earlier sources of error, a major revision of the Ming system was unnecessary until the 16th century. 44. The 1525 policy question dealt with proposals to alter the UN Ming system because, like its predecessors, it was bound eventually to show accreted errors. The examiners raised the perennial issue of calendrical calculations in the Astrocalendric Bureau, namely the tension between prediction based on 77. Continual observation and extrapolation to adjust computational procedures on one hand, and, on the other, forecasts derived from rigorous determinate mathematical techniques that did not require continual infusions of new data. The examiners had opened the door to calendar reform through an official avenue for submitting opinions to the throne. It was also a time when an embattled emperor and his entourage of powerful eunuchs in the imperial household were increasingly faced with aroused literati factions inside and outside the court. 45. The published answer to the question by one of the highest-ranked examines focused on the chief theoretical question: creating an astronomical system is a matter of conforming celestial phenomena to what accord with them, and not forcing accord, so that predictions can be validated. This led him naturally to his answer. The orbits in the sky are not uniform, but astronomy was restricted to set methods, because they were not aware of conforming to the heavens to what accords with it. 46. Although the UN system was the RST to master it, a succession of astronomers had worked out simple empirical corrections that minimized precessional error. The candidate listed them and accurately summarized the techniques used by each. It took considerable understanding to see that these earlier adjustments had anticipated the annual difference. The candidate had obviously digested the account in the UN history of the season granting system's predecessors. 47. Writing FTY years before the arrival of the Jesuits, the candidate recommended reviving the instruments used in the UN reforms of 1280. His appeal to UN instrumentation as a corrective measure suggests that the 1525 policy question was meant to draw responses about what to do with the Ming calendar. Accordingly, the candidate argued that the dynasty should rely on instruments to reform the calendar. Rather than technical manuals, which were unavailable, the candidate cited dynastic histories as his sources of information. 48. In addition to this official airing of the 1521 to 1523 debate about the problems with the Ming calendar, private scholars, many also involved in the partisan politics that became routine in late Ming governance, also voiced their opinions about the discrepancies between the calendar and celestial events. The scholar official Tang Shunzi, for instance, had come to prominence when he niched RST on the 1529 metropolitan examination. After a turbulent political career in which he was banished twice, Tang explored his literary and statecraft interests during his forced absences from politics. Generally regarded as one of the leading scholars of mathematics in his time, his studies also encompassed Islamic traditions in astronomy. 49. 78. Seeking a resolution between AXED versus AXable system to resolve calendrical problems, Tang assessed the UN Ming calendrical system in light of what he called concrete studies. Such critical assessments of the calendar, according to Tang, had lost their vitality during the Ming. Hoping to broaden literati education to include technical learning, Tang Shunzi also sought to reintegrate mathematics and mathematical astronomy. According to Tang, calculations based on the relational features for the sides of a right triangle had been separated during the Ming from the underlying principles of mathematical astronomy. Tang wrote, "One must know both mathematical and astronomical principles. This is where I differ from literati students. One must know both XED calculations and variable calculations. This is where I differ from officials in charge of the calendar. Principles and computations are not separate things. Computations represent the concrete applications and extensions of principles. Variable and XED calculations are not separate things. Fixed computations represent the basis for variable calculations." 50. Tang Shunzi stressed the 6 arts of antiquity as the model for reintegrating calendrical theory with concrete computations. He then blamed the Ming lack of integration on its literati, who had denigrated the study of numbers as a lesser technique not worthy of their attention. thus leaving the calendar for the mediocre staff of the Astrocalendric Bureau to compute. Tang's call for a return to the more comprehensive vision of antiquity, in which the mathematical arts held a prominent place, represented a precocious effort to recapture classical antiquity in its full technical complexity. Usually we attribute this positive perspective of mathematics to Qing dynasty literati and their response to the introduction of Western learning in the early 18th century, when they called for rediscovering the Chinese origins of Western learning. Efforts to recover antiquity during the late Ming, however, had already carried over from astronomy to mathematics before the Jesuits arrived in South China. Tang Shunzi used traditional crafts of early trigonometry to solve simultaneous algebraic equations in mathematical astronomy. 51 The straw that broke the camel's back came in 1592 when the Ministry of Rites charged that the Astrocalendric Bureau had erred by a full day when predicting a lunar eclipse, which meant that the relief ceremony had to be rescheduled. An error of a full day also affected ceremonies tied to the RST day of the month, season, and the new year. In 1595, a Ming prince with exceptional mathematical talent, Zhu Zaiyu, proposed a new calendar, which he called the 10,000-year system for sagely longevity. 79. Zhu tried to combine the Yuan and Ming calendar systems, but because his synthesis was not based on new observations, it failed to make the prediction of eclipses any more precise at a time when accuracy was expected within 1 mark. 52 The Ministry of Rites, however, never tested Zhu's proposal. Zhu was later listed in the official Ming history as a meritorious proponent of reform who was unjustly ignored. His biographers were Qing scholars who had the advantage of hindsight. In 1596, Wang Honghui broached with Matteo Ricci the possibility that Ricci might contribute to the reform discussions. In 1597 the scholar official Xin Yunlu, who had written a work comparing ancient and recent calendars, claimed that the procedures employed in the Ming calendar to determine the winter solstice were in error by 1 day, thus extending the error to encompass a full season. The director of the Bureau dismissed its critics, however, and defended the calendar as a stable institution that should not be recklessly changed. 53. Gregorian Reform. The European calendar aimed at simplicity and convenience for dating civil and religious events. This was essential if hundreds of sovereign states were to accept it. To this end the Gregorian calendar reform followed the Julian, which had come roughly 1,500 years earlier, in reducing the amount of observation and computation and provided an artificial system independent of astronomical tables or observations of celestial phenomena. But, as in the time of Julius Caesar, localities continued to use incompatible lunisolar calendars, some long after the Gregorian reform. Because of its focus on physical anomalies, the Ming calendar was always linked to observable celestial phenomena such as solar eclipses. The Astrocalendric Bureau recorded celestial phenomena so that the government could deal with the ominous ones and take credit for the propitious ones. 54. Pre-Gregorian efforts at calendrical reform. For both Catholics and Protestants after the Reformation, the death and resurrection of Jesus were the most important events in a linear history. Even so, there was no agreement when the year began. Some reckoned it from Christmas Day. In the civil calendar it was January 1st. Another system had it in March, the time of the vernal equinox, as in pre-Julian and some old Germanic calendars. England used March 25 for the Feast of the Annunciation and the Old Roman vernal equinox as New Year's Day, until it accepted the Gregorian calendar in 1752. 55. 80. Victoria's 532-year Paschal cycle was successful because it was a self-repeating Easter cycle since God's creation of the world, but its computational procedures required technical improvements. When compared to the Julian calendar of 365 days, the metonic ratio of 19-year cycles of 235 calendar months was too short by 1 hour and 29 minutes. Consequently, the lunar cycle allowed calendrical slips back of 1 full day in roughly 308 years, which necessitated a lunar correction. 56. The length of the tropical year was computed as 365.242315 days at the beginning of the Christian era, compared to the Chinese value of 365.2425 and the modern value of 365.2422. The date assigned to the vernal equinox was problematical. By the year 1000, the Julian calendar had drifted ahead of the tropical year, which meant that the calendar was drifting forward one extra day in a little over 130.1 years. This discrepancy required a solar correction. In 1500, the drift was 1 day in 128.6 years. 57. Between the time of Julius Caesar and Pope Gregory, the precession of the equinoxes had shifted by roughly 15 days, a gur that made the Ming Chinese problems negligible by comparison. Paul of Middelburg had asked Copernicus to advise the Fifth Lateran Council in 1512 on proposed calendar reforms. Although Clavius had reservations about Copernicus's heliocentric cosmology, he recognized him as an authority on astronomical measurements and used his data in the Gregorian reforms. The Gregorian Commission heeded the Protenic tables of Erasmus Reinhold, which were a revised and expanded version of the tables from Copernicus's On the Revolution of the Heavenly Spheres, published in 1543. Copernicus's astronomical reforms were intended to provide an accurate prediction of the correct dates for Easter and Christmas, not just a delineation of space but also a demarcation of time. 58. The Council of Trent met in 1562 to 1563 and authorized the Pope to deal with calendar reform at a time when the calendar date for the vernal equinox had receded to March 11. Petrus Pitatus advocated that at least 14 days should be dropped from the solar calendar to bring it back to that of Julius Caesar when the vernal equinox was March 25. Curiously, Martin Luther preferred Easter as a XED day rather than a movable feast and thought that calendars were irrelevant to faith and only reeked at worldly authority. The Gregorian reform of 1582 managed to overcome these divergent views because of its elegant simplicity, which contrasted with the contemporary paralysis in the Ming court concerning elaborate calendar proposals. 59. 81. The Gregorian calendar and its reception. After serving at the Council of Trent, Gregory XIII quickly nominated a commission when he became pope in 1572, which met for 10 years until 1582 and reviewed various proposals for calendar reform. Aloysius Lilius, a lecturer in medicine at the University of Perugia, presented an ingenious plan to restore the date of March 21 for the vernal equinox through a 10-day displacement. Once Lilius's proposal was accepted by the Commission in 1577, Gregory authorized preparation of a compendium based on Lilius' original, which was circulated for review. When these outside views were received and evaluated, Clavius attended to a residual error of one more day in 308 years. Gregory then introduced the new calendar via an apostolic letter in February 1582. It was written in the form of a papal bull and represented ecclesiastical law. 60. The null rules for intercalation in the Gregorian calendar were as follows: 1. A common year contained 365 days, a leap year 366, the extra day being added to the end of February. 2. Every year of the Christian era after 1582 that is evenly divisible by 4 is a leap year. 3. Except for centennial years, which are leap years only if evenly divisible by 400. 61. In this manner, 1600 and 2000 were designated as leap years, but 1700, 1800, and 1900 were not. The Gregorian result was 97 additional days in 400 years, or 3 days less than the Julian calendar, which intercalated every 4 years without exception, i.e., 100 days in 400 years. 1 day in the lunar cycle was omitted every 312.5 years. Calendar reform was easily accomplished in Catholic Italy, Spain, and Portugal, but it became a bone of contention in the Protestant world because the papacy presented the reform as an act of the Catholic renewal to challenge the Reformation. The Eastern Patriarch in Orthodox lands was cautious, but Rome's unilateral declaration made it impossible for him to accept. In the 16th century, church and state in Europe were so interwoven that civil acceptance of the new calendar was determined by the religious affiliation of respective rulers. Criticism of the Gregorian calendar was colored by different religious and intellectual positions. 62. In this light, Protestant Germany saw the Pope as an antichrist for instituting the calendar. Others contended that Gregory had stolen 10 days from a farmer's life. Protestant sovereigns did not relent until Protestant astronomers increasingly supported it. In 1724 and 1744, the celebrations for 82. Easter in Protestant countries were 1 week earlier than for Catholic celebrations. In 1775, Germany newly adopted the Gregorian calendar by the decree of the German Emperor and King of Prussia, Frederick II. 63. In England, secular authorities were sympathetic with the Gregorian reform, but the Anglican clergy was not. The latter insisted on consultations regarding the Pope's unilateral promulgation of the new calendar, and this procedural obstacle doomed the reform in England. Scotland accepted the new calendar from 1600. When England newly passed an Act of Parliament in 1752 to enact the calendar by omitting 11 days, the Anglican clergy's hatred of Rome was no longer an obstacle. 64. The mathematical scheme used in the Gregorian reform was prudent because it was independent of physical hypotheses and emphasized instead computational mechanisms to produce the calendar. The new calendar served mainly as a puzzle solver, that is, a set of computational practices that were increasingly rule-like regardless of the nature of the cosmos. In this sense, the Gregorian reforms marked a climax of the medieval computus, which survived the Copernican revolution as a calendrical toolkit. 65. The impact of Clavius on Jesuits in China. When the Gregorian calendar reform began in 1572, Clavius was still an isolated mathematical scholar in his Roman college. By its end he was a leading mathematical astronomer. Clavius prepared a series of mathematical textbooks at the Collegio Romano, beginning with his edition of Euclid's Elements of Geometry, which included a voluminous collection of notes and commentaries. Matteo Ricci would later use this edition for the classical Chinese translation of Euclid that he helped to prepare in Ming China. Knowledge of geometry, especially the RST4 or 6 books of Euclid, became particularly important in 16th century Europe for engineers, cartographers, architects, land surveyors, and painters, while in the late 15th century expertise in geometry was increasingly valued for fortifications and ballistics. 66. Clavius also planned to prepare a work on theoretical astronomy that would revise the planetary system and provide an alternative to Copernicus's heliocentrism. He never completed that work. In his own work, Clavius still accommodated observational tables from Copernicus's work within a geocentric cosmology. Clavius's personal opposition to astrology was strengthened by the Collegio Romano's placement of mathematical astronomy separately in the Faculty of Arts and Medicine, where astrology was also important. The tension between astronomy and astrology among Jesuits would later affect 83. Their role in the Qing Astrocalendric Bureau, where astrological interpretation based on portents remained important. 67. We return below to the calendrical crisis in late Ming China, where the puzzle-solving mechanisms for maintaining an accurate calendar had unraveled. The Chinese calendar had since the Han dynasties been reformed through computational means, as in Europe, and, like European calendrical specialists, the staff of the Astrocalendric Bureau did not require allegiance to any particular view of the cosmos to employ their toolkit of computational puzzle solvers. 68. Ricci and his immediate successors in China drew on the Ptolemaic geocentric framework, which had been questioned but reaffirmed by Clavius and the Gregorian Reform Commission. Later, after Ricci's death in 1610 and Clavius's death in 1612, Johann Adam Schall von Bell and Ferdinand Verbiest were increasingly influenced by Tycho Brahe's new endings, which helped them gain say in Europe, and allied in China, the heliocentric cosmology of the Copernicans in favor of geoheliocentricity. 69. Jesuits in China quickly adapted their religious goals to the late Ming local context and accommodated their order, with some dissent, to the inescapable priorities of the Chinese imperial system, its cultural elites, and the astrological applications of the calendar to portents and numerology. 70. Jesuits and late Ming calendar reform. The Jesuits entered China during a time of heated debate and discussion about the calendar in the late Ming. Literati inside and outside the government had noted the drift forward of the Chinese date for the Lunar New Year by 1 day since the Yuan dynasty, but the Astrocalendric Bureau had not yet provided a solution. Despite some superficial similarities, the situation in which the Jesuits would end themselves in 17th century China was not really comparable to Clavius's role in Rome in the 1570s. The Gregorian calendar was formulated by a papal commission and not a sovereign state. Although there were parallels between the papal curia and the Ming imperial court, the former was in scope and magnitude a minor political authority, while the latter was not a religious organization. Nor was the Astrocalendric Bureau the haven for religious debates. Moreover, the Christian concern was to date Easter accurately in light of God's creation and Jesus' resurrection as linear events. For the Ming, however, the concern was not with linear time, which since antiquity had not been stressed. Rather, the Chinese calendricists were concerned with recurring events within a cosmology that had no beginning or end. To Domesti. 84. K-time meant to predict the periodicity of repeating celestial events and not to date them accurately from creation. The key issue for the Astrocalendric Bureau was to predict anomalous events, such as solar and lunar eclipses, whose periodicity affirmed an orderly political reign by a legitimate ruler. The auspiciousness or inauspiciousness of the present depended on its interpretive place in a cyclical calendar. Different versions of time were at stake in the interaction between the Jesuits in China, who had experienced the Gregorian reforms in Europe, and Chinese literati and dynastic rulers, who believed in cosmically recurring events in time. The calendar and time. Jesuits such as Clavius were insiders in the Gregorian reforms, whereas Jesuit missionaries were always outsiders in Ming China, opposed by native Han Chinese in the Ming bureaucracy and additionally contested by the Muslim calendrical staff in the Astrocalendric Bureau. The social positions of the Jesuits, who are dressed as Buddhists, had to be clarified and heightened before their calendrical proposals would be taken seriously by the Chinese literati, who served the imperial court as government officials and elite partners in local governance. The Jesuits had to deliver their message to intelligent and cultured elites who could appreciate their spiritual sincerity and technical prowess or would gainsay both as dangerous. Likewise, the Jesuits would have to master via language, dress, and experience the different discourses of political and cultural supremacy that informed the Ming calendar and made even a one-day error in the onset of the seasons, the RST day of the month, and New Year's Day a potential calamity. Getting the calendar right in China meant applying a cyclical blueprint to grasp recurring events. 71 Nevertheless, the Ming Bureau and the Christian Compute still shared, functionally and historically, a nexus of social, political, cultural, and religious elements that informed the calendar. Although such elements were divided up differently and integrated uniquely in Europe and China, Clavius's followers and the later students of Brahe and Kepler could understand why an accurate and up-to-date calendar mattered to the Ming and Qing state. More importantly, Ricci, Schall, and Verbiest understood the important role the new Christian calendar played in unifying the faith in early modern Europe. 72 The calendar crisis was not merely an opportunity for the Jesuits in China to enhance literati and an emperor enshrouded by a sophisticated bureaucracy. The crisis also allowed them access to the technical fundaments of the Chinese chronological construction of cyclical time, its conceptual limits. 85. Historical interpretation, and technical determination, which were woven into the ideological fabric of the imperial dynasty. Lurking in Jesuit efforts to promulgate a new calendar for China, constructed in accordance with new Western methods, for example, was an effort to Christianize creationless imperial time. For instance, Jesuits claimed, based on the biblical chronicles after the Great Deluge, that the Chinese were descendants of Noah. Chinese critics saw this as an assault on the integrity of their classical antiquity. Chinese and Manchu political power stood in the way of and transmuted the Christian agenda, triumphant in the New World and for a short time in parts of Japan, into more muted forms of technical improvement in the Chinese calendar based on Chinese time. The Jesuits had to preserve the Chinese time measurement system and the basic structure of the cyclical imperial calendar. From the Ming point of view, what needed improvement were the technical aspects of the calendar, such as the tables used in calculation. Which world system was used for cosmological prolegomena mattered neither to the non-Christian Chinese nor the anti-Copernican Jesuits, many of whom were open to change in cosmology but all of whom were prevented from teaching it. 73. The Jesuit Novitiate and Mathematics. The Jesuit era in China coincided with the 30 Years' War that overwhelmed Catholics and Protestants in bloody conflicts from northern to central Europe. European wars took precedence over concern with non-European matters. Similarly, England was beset with social and religious battles and civil wars that led to the execution of the king in 1649. Until the Glorious Revolution 4 decades later, England was not a factor in Asian affairs. The Portuguese support of the Jesuits in China, Japan, and India, and the Spanish sponsorship of the Dominican, Franciscan, and Augustinian orders in the New World and the Philippines meant that Catholics still monopolized interactions between China and Western Europe from the 16th to the 18th century. Because of growing inroads of Jewish converts after the Inquisition, however, the General of the Order in 1593 commanded that the applications of all new Christians should be rejected. Luis de Almeida, for example, was the RST Jesuit to introduce European medicine to Japan circa 1583, but because he descended from an old Portuguese Jewish family, his reputation for this was effaced in the 17th century. 74 By 1600 the Jesuit order included 8,272 members and operated 236 colleges in southern Europe and Germany, in addition to those in Spanish and Portuguese colonies. The order's growth coincided with the unification of the Spanish and Portuguese thrones from 1580 until 1640. Over 15,000. 86. Members in 1626 had been trained in 444 Jesuit colleges and 100 seminaries. Within a century of its founding in 1540, the Society of Jesus controlled more than 700 educational institutions and held a virtual monopoly over chairs of the arts faculties at almost every Catholic university. While preparing to become upholders of the Church, Jesuits such as Matteo Ricci became novices for 2 years, which was twice as long as any other religious order. Novices were introduced to the Society's rules and discipline, and they were tested for their fitness for the Jesuit way of life. For those who entered the priesthood, many but not all had several more years of academic training in grammar, dialectics, and rhetoric, typically at one of the Society's several colleges, such as the Collegio Romano. Upon completion of their philosophical and theological studies, the candidates were ordained as priests but had to finish a 3rd year of the novitiate before they were admitted into the Society. Initially the Collegio Romano was the center of the Jesuit educational system, and its evolution evinced the development of a uniform educational curriculum, the Ratio Studiorum, throughout other Jesuit colleges in Europe. For the study of mathematics, it was extremely important that the formation of a Jesuit mathematical program had been organized by Clavius at the Collegio Romano, which increasingly took shape during and after the Gregorian reforms in Rome. The focus on Euclid's elements of geometry, for instance, represented Clavius's imprint on Jesuit mathematical training. Clavius had a following in the 1570s, and Matteo Ricci studied mathematics at the Collegio Romano from 1573 to 1577. 75 Clavius's role in the promulgation of the Collegio Romano's Ratio Studiorum in 1586 was pivotal in the important role of mathematics in Jesuit pedagogy. Among the Jesuits sent to China at this time, besides Ricci, Giulio Alani studied under Clavius, as did the physician Johann Schreck and Giacomo Rò. Terenz also befriended Galileo when both studied at Padua. Schall came to Rome in 1608, when Clavius was probably too old to teach, but he also belonged to the Collegio Romano's Academy of Mathematics. Verbiest's formal Jesuit studies at the Jesuit College in Leuven, Belgium, included training in medicine, mathematics, and astronomy. Later, Verbiest also studied at the Collegio Romano and the Jesuit College in Seville. 76 The largest number of Jesuits sent to China were trained in the RST tier of Portuguese colleges at Coimbra and Évora. Moreover, the majority of Jesuits who went to China were Portuguese, although they have not received the attention they have deserved until the recent study by Liam Brockie. Most were in their late 20s or early 30s when they reached China, and who had by then spent some 15 years in Jesuit schools as students or teachers. 87. Prior to their departure, the majority were involved in the religious conversion of commoners after their arrival, and they benefited from the local toleration they gained when Italians such as Ricci and Germans such as Scholl worked among Han Chinese elites and for the imperial court. Emphasizing grammar and rhetoric, philosophy and theology, the education promulgated at Coimbra and Évora was based on the Ratio Studiorum. The curriculum, although not always strictly followed, included Greek and Hebrew and was intended to provide intellectual training and teaching experience for those assigned at home or sent abroad. Philosophy courses were spread over 3 years and included logic, ethics, physics, and mathematics. Much of the latter was drawn from Greek natural philosophy, particularly the writings of Aristotle and Euclid. Scholastic theology courses usually took 4 years. Often, however, earlier students completed or abridged training after receiving permission to sail to China. Ricci received only 2 years of training in theology before departing Portugal, for example. Giulio Alani, on the other hand, taught mathematics for 2 years before arriving in China in 1610. 77 The ideology of the Jesuits drew from Ignatius's vision of an elite corps dedicated to reforming the Church and protecting Catholic lands from the Reformation. It required a long and exacting internalization of the values and ideals of the society. Full members completed the probationary period and were accepted into the society. They were divided into 3 groups: temporal coadjutors who were lay brothers and served as cooks, secretaries, and apothecaries, etc., spiritual coadjutors, and those who professed the 4th vow, that is, in addition to the 3 traditional vows of poverty, obedience, and chastity, they also professed obedience to the Pope. The last 2 groups were ordained priests and received advanced training in theology. Only the professed could attend the Society's general congregation or be sent on a mission. Ruled from Rome by its superior general, the Jesuit order penetrated the Old and New Worlds through a residence system, which was the basic unit of organization and daily life for its members. In the Beijing and Hangzhou residences, for example, novices received their training from the Jesuits who lived there. Language learning took place in the residences. In Beijing, the residence also served as the venue for a sophisticated translation project that included the Fathers and their converts. The multifunctional, military-like organization of the Jesuit residences was flexible enough to take on secular tasks, such as the translation of European mathematical astronomy into classical Chinese. 78. 88. Outside of Europe, a provincial head led the order. Jesuit unity of purpose was generally achieved through a detailed protocol of written communication between the residences in each province and between provinces. Disagreements among the Jesuits over their engagement in mathematical studies, however, affected this unity. In 1615, for example, the order's provincial head for Japan and China, Valentim Carvalho, sent a mandate to Macau reversing Ricci's policy in China and prohibited the teaching of mathematics and scientia by the Jesuits. The mandate was later withdrawn, but it shows how Jesuit unity could be complicated by differences of opinion. When the Augustinian, Dominican, and Franciscan orders openly opposed the Jesuits in China and elsewhere, the venue for adjudicating such disagreements shifted to the Pope in Rome. Similarly, to get around papal control, which was tied to the Portuguese monopoly of Jesuit missions in Asia since 1493, Louis XIV sent VE French Jesuits to China in 1685 as the king's mathematicians. The Missions Étrangères de Paris, a congregation of secular priests, who missionized as part of the Rome-based congregation Propaganda Fide, had since the late 17th century challenged Portugal and the Jesuits by establishing a clerical hierarchy in China independent of Portugal. Louis XIV's representatives also refused to take oaths that would have subjugated them to the bishops in Southeast Asia and China. 79 As a religious order, Jesuits lived and worked as missionaries for the salvation of their neighbors. Ignatius had not intended them to live a cloistered life. Thus, they were experienced and tested before being admitted to the society. Their elevated status in the church was also based on a dedication to learning, which was combined with worldly involvement. Jesuits participated in the intellectual changes that informed the society's textbooks and commentaries. They also deemed the religious boundaries of Orthodox Catholic natural philosophy, which climaxed during the debates over the heliocentric world system developed by Copernicus and championed by Galileo. 80 Like other Jesuits sent to China, Matteo Ricci, once he had completed his training at Coimbra in 1577 to 1578, embodied the intellectual affinity between Jesuit religious values and Aristotelian natural studies and philosophy. His expertise in mathematics and scientia, drawn in part from study under Clavius, served him well in China. After Ricci, a succession of Jesuits with mathematical and astronomical abilities were sent because Valignano honored requests from Ricci in 1605 and other Jesuits in Beijing after Ricci died in 1610 that their mission required clerics with technical expertise in mathematical astronomy. They were needed to aid in the calendar reform projects then underway in the 1620s under Chinese government supervision. In effect, the Jesuits in China now served two masters, the Church and the Ming government. 81.